Once again, a very good morning to you all. And we are going to start our 2 days national level seminar. Actually, the seminar is somewhat different to other conventional seminars. The title of the seminar you already observed that it is a library book review by prominent writers. Actually, it is a belated celebration of Librarians' Day. Actually, it was to be held on 12th of August. And I proposed, Principal Sir, and discussed with other faculty members and speakers, I mean writers, actually writers. And they agreed, and they, what should I say, they agreed and মানে কি বলবো খুব মানে বাহবা দিয়েছে যে এরকম একটা টপিক ভাবার জন্য সো we have selected five topics: chemistry, physics, mathematics, botany, zoology, and plus one library and information science. Actually, library and information science, it is general, it is applied to all the disciplines. So there are 13 speakers. Actually, they are all writers of prominent books, not eminent. It's the prominent writer, you mind it, not eminent, prominent. Person may be eminent, but the books are prominent by the readers, mainly teachers and students. Here we have 13 such writers. They will speak about their books. Actually, they will speak about their books. And now I request our respected Principal Sir to deliver his inaugural speech. And I also request R.P. Sarkar sir to have your chair, sir.
So, most respected Professor R.P. Sarkar on the dais, and in front me respected Gurunath Mukherjee sir, Professor Gurunath Mukherjee sir, and also our CKB sir, and other faculty member of our college, and my very dear librarian Dr. Ravi Kumar De, and also my very dear students. So actually the students, those are present here, and they will come phase by phase. As you have heard that 6 topics: chemistry, physics, mathematics, botany, zoology, library and information science. So the books for review done by our eminent writers, which is meant for only chemistry students, but it is not meant for physics or math students, because their topics is different. So I first of all tell that we have planned this program under library and IQAC only for you, only for you. And for this purpose we have take a very challenge like this type. And to organize this program, our very beloved librarian Dr. Ravi Kumar De and also Dr. Sudipta Biswas, he is some very urgent purpose, he is not present here. But their untiring efforts and zeal For this purpose, this program is being organized. And I actually, on behalf of all librarians, because I also, one times I look after library, I like very much library books and library. So I, for short my lecture and to the point, I write up so that I can express shortly what I want to tell. The word library has been derived from the Latin word liber, which means a book. The word used in many other countries to signify a collection of books, publicly or privately, is derived from a Latinized Greek word bibliotheca, hence biblioki in the French, biblioteca in Italian and Spanish, bibliothèque in German, and biblioteca in Russia, and toso sentoso in Japanese. The library is therefore a place where books are kept. According to S.R. Ranganathan, a library is a public institution or establishment charged with the care of a collection of books and the duty of making them accessible to those who require the use of them. The contents of modern library are diverse, and most libraries of today contain much more than books. They contain, besides books, graphics, acoustic material such as periodical, pamphlets, reports, newspaper, documents, manuscripts, photocopies, musical scores, microfilm, maps, charts, atlas, so on and so forth. The library of today selects, collects, and also preserves. Simultaneously, it meets the demands of varying taste and environment. The development of libraries is directly related to the economic, health, and or prosperity of a nation. As economy grows and becomes complex, then it requires a systematic and sophisticated record-keeping library. This organizes and disseminates information in the services of the economic life of the nation. In this regard, libraries emerged a vital instrument as repositories for the records of business and research facilities. It is an important social condition necessary for the development of libraries. The large size of population and their concentration in urban centers, which help in their development, is closely linked with the growth of population and the emergence of urban centers. The urban population requires a well-organized information system. The existence of libraries in India is found from very ancient days, when India was reputed for her different seats of learnings. These ancient libraries had manuscript both in Kharosthi and Brahmi script inscribed on palm leaves and other artificial writing materials. The availability of written materials from the 4th century BC points out to the definite existence of places for stoning and making manuscripts accessible to the classes. As few notable examples are those attached in the center of learning like today's universities at Nalanda, Rajgir, Odantapuri, Vallabhi, Taksashila, Vikramshila, Tamralipto, etc., etc. The era of transformation of libraries in India began towards the middle of 19th century. It was the time when there were revolutionary changes in social, political, industrial, and other phases of life. During the first half of this century, public libraries were established in 3 presidencies: Bombay, Calcutta, and Madras. The first library in modern India was established in 1784, attached to the Asiatic Society of Bengal. Next to it was the Library of Asiatic Society of Bombay, which was established in 1804. The Madras Library Society was established in 1818 with a library open to the public. In 1830, another public library, the Bombay General Library, was established in Bombay. The Government of India, after independence, felt the need to have a national library reflect the history and culture of the nation. Hence, in 1948, Government of India passed the Imperial Library Act 1948 and changed the name as National Library. The National Library is the repository of all books printed in India. The Delhi Public Library was set up in 1951 by the Ministry of Education, Government of India, with financial and technical assistance from UNESCO as a pilot project. The Raja Ram Rai Library Foundation, RRLF, was set up in the year 1972 in the memory of Raja Ram Roy. It is an autonomous organization under the Department of Culture, Ministry of Human Resource Development, Government of India, and its headquarters is located in Kolkata. Various libraries in the field of social science and sciences established after independence. To name fewer: National Archives of India, Delhi, 1947; National Institute of Mental and Neurosciences, Bangalore, 1954; Small Industry Extension Training Institute, Directorate of Adult Education, Delhi, 1956; National Council for Educational Research and Training, NCRT, 1961 in New Delhi; Indian Institute of Management, Kolkata, Ahmedabad, Lucknow, Bangalore and Indore; Indian Council of Social Science Research, ICSSR, 1969 in New Delhi. The 7 IITs established in Mumbai, Kanpur, Guwahati, Kharagpur, Madras, Roorkee have good libraries. The libraries of science field include NISCARE, CSIR, Vikram Sarabhai Space Center, DRDO, DECI-DOC, CENDOC, NISAT, TERI, ICMR, NASDOC, etc. And recently, with the foundation of INFLIBNET at Ahmedabad of extending activities in the field of UGC InfoNet since 2004, the libraries are moving ahead. A forum or the consortium play a very important role in research activities as it forms the very first step of a research pursuit. Review of literature happens to be an important segment of the concerned topic. The literature review should be conducted in a systematic way to achieve optimum results. The review of literature provides an insight what to be done. The survey of literature is a crucial aspect of the planning of the body, and the time spent in such a survey invariably in wide investment. Efforts have been made to review the related literature by going through books, conference proceedings, journals, periodical articles, etc. Today's topic 6 and 7, this seminar topic is book review by eminent writers play crucial role for readers and library alike. Following are the important of the review of books. First, in respect of reader, first decision making. Book review helps reader make informed decisions about which book to read. Reviews provide insights into book's quality, style, themes, and whether it aligns with the reader's preferences. Second, exploration and discovery. Reviews can introduce readers to new authors, genres, or topics they may not have encountered before. They offer a glimpse into the reading experience, enabling readers to gauge their interest and curiosity about a particular book. Third, community and discussion. Reviews spark conversation among readers. They create a platform for discussing and sharing opinions, fostering a sense of community around books and literature. In respect of library, what are the important aspects? First, decision making. Book reviews help library to make informed decision about which books to read by maximum readers. Reviews provide insight into the book's quality, style, themes, whether it aligns with the reader preferences in the library. Second, quality and theme. Book review help the librarians to improve the standard of the particular library. Librarian can chalk out the correct theme of the library so that it is more acceptable, more accessible to maximum the readers. Third, more readers. Book reviews is the only way where readers can hear about the books and its main content, important aspects of the subject matter and its uniqueness from directly its author or a prominent figure in this field. This catalyzes to motivate maximum number of readers to read these books for fulfilling their specific purpose. Lastly, I hope that these small endeavors from the part of IQAC and library will go a long way for library and information system. I extend my sincere thanks once again to all respected speakers. Those are already consent. They are coming and participating in this seminar, and for their 2 days deliberation about their important books. And I also sincerely recognize the efforts and zeal of the library team, especially Dr. Ravi Kumar De and Dr. Sudipta Biswas for arrangement of this 2 days program. Lastly, I once again express my heartiest regards and welcome all the speakers, including Professor Sarkar, Professor Mukherjee and Professor Banerjee, and those will also join afterwards. And I extend once again thanks to all of you, those are present here and afterwards those are coming, for especially physics student, math student, botany, zoology and the library information science student. So once again thanks all of you. Thank you.
Now I request Dr. Ravi Kumar De to felicitate Professor Ramaprasad Sarkar. Sir, please come. Now I request Dr. De to introduce Professor Sarkar. Please.
Dr. Ramaprasad Sarkar sir did his MSc in 1967 from Calcutta University in chemistry. He did his PhD also from the Calcutta University. He started his teaching at New Alipur College till retirement in the year 2007. He wrote a book on general and inorganic chemistry in the year 1980. The book was widely accepted by the students. Now I request sir to deliver his specious lecture. ওই স্যারকে বলেছি স্যার
না না কিছু নেই পূজনীয় মহারাজ, সমাগত বিদ্বজ্জন এবং আপনারা যারা উদ্যমী উদ্যোক্তা, আপনাদের সকলকে যথাযথ সম্মান এবং শ্রদ্ধা জ্ঞাপন করছি। এইটে অনুষ্ঠানের আমন্ত্রণপত্রের সঙ্গে আমি প্রথমে একটা নেতিবাচক কবিতা দিয়ে শুরু করছি। কেন করছি তার কারণ, ঠিক এই চিঠিটা পাওয়ার সময় একটা ঘটনা ঘটেছিল যেটা সেই নেতিবাচক ভাবটা কাটিয়ে দিয়েছিল। সেই জন্যে ছোট্ট 2 মিনিটের কবি নীরেন্দ্রনাথ চক্রবর্তী, সব কিছুই কি পিছনে পড়ে রইল, সব কিছুই কি পিছনে পড়ে রইল, চোখে ধাঁধা লাগে, ভাবনায় তালগোল পাকিয়ে যায়, কোনো কিছুই যেন ঠিকমতো আর বুঝে উঠতে পারি না, সব কিছুই কি পিছনে পড়ে রইল, সব শব্দ, সব গন্ধ, সব দৃশ্য, সব স্বাদ আমার সামনে এখন দৃশ্যবিহীন শূন্যতা। আমার ডাইনে বাঁয়ে যেদিকে তাকাই, না দেখি কোনো ফুল, না শুনি কোনো গান, হাত বাড়িয়ে কোনো কিছু ছুঁতে পারি না, জিভটাও সেই তখন থেকে শুকনো আর খড়খড়ে হয়ে আছে। তবে আমি এতটা পথ এলুম কেন? আমি যা চেয়েছিলুম, যা আরও বেশি করে পাবো বলে এই এতটা পথ পাড়ি দিয়ে এসেছি, তা সব কিছুই কি পিছনে পড়ে রইল? এই মনোভাবটা আমাদের সাম্প্রতিক কি রাজ্য কি বিশ্ব, যেমন যুদ্ধ, যেমন অন্যায় অনাচার, এইগুলোর পরিপ্রেক্ষিতে আমার মনে সবসময়ই একটা আচ্ছন্ন ভাব করে রেখেছিল। এখন কেন এইটাই বেছে নিলাম হঠাৎ, যে এই চিঠিটা, এখানকার আমন্ত্রণটা যেদিন পেলাম, সেই দিনই রসায়নের নোবেল প্রাইজের ঘোষণা হলো। এবং সেই ঘোষণা হলো আপনারা সবাই জানেন, কোয়ান্টাম ডটস, ছোট্ট আলোর ফুলকি দিয়ে অনেক বেশি করে, অনেক কাছাকাছি, অনেক স্পষ্ট করে দেখার উপায়। সেই কোয়ান্টাম ডট আমার মধ্যেও যেন সেই ফুলকি জাগিয়ে দিল। আমার মনে হলো আমিও তাহলে আমার পুরনো কথাগুলো একটু আলোকপাত করতে পারি। তাই এখানে অনেক ছাত্ররা আছে, আমি তাদের জন্যে একটা ছোট্ট সাইড ইনফরমেশন আর কি, এটা অসমর্থিত, আমি গুগলে পেয়েছি, তাদের উৎসাহ দেওয়ার জন্য বলছি যে 3 জন পেয়েছেন নোবেল প্রাইজ, এমজি বাওয়েন্ডি, লুইস এবং একিমভ। একিমভ বয়স্ক, আমার চাইতে বয়স্ক, 78 বছর মতন বয়স হবে বোধহয়। যাই হোক, তার মধ্যে এই যে এমজি বাওয়েন্ডি প্রথম পরীক্ষায় কেমিস্ট্রিতে ফেল করেছিলেন। সে বলছে যে হার্ভার্ড ইউনিভার্সিটির অত বড় হল, ওই রকম বিরাট এক প্রক্টর বসে আছেন, আমি প্রথম কোশ্চেন, দ্বিতীয় কোশ্চেন একটাও উত্তর লিখতে পারছি না। পেলেন কত? 100-তে 20। তারপরে তার বক্তব্য হলো, রিপোর্টারদের বলছেন যে আমি বুঝলাম যে আমার পড়াটা পরীক্ষা ভিত্তিক পড়া হয়নি। তারপর থেকে আর কখনো তার ফল খারাপ হয়নি, এবং তারপরে তো আজকে আমরা তার ঘটনা জানি। কাজেই আজকে যারা ছাত্র, তাদের কাছে এই ঘটনাটা আমি আলাদা উল্লেখ করলাম। আন্তর্জালে এই যে উদ্দেশ্য আজকে আমরা পেয়েছি, সেটা একটু আগে অধ্যক্ষ মশাই এখানে বিস্তৃত করেছেন। আমি বাংলায় বলি যে এই যে জ্ঞান পিপাসা, বই লেখা, এগুলো তার যত কিছুই পোশাকি উদাহরণ দেওয়া যাক, একটা আমার কাছে তার শর্টকাট বক্তব্য হচ্ছে, মাথার মধ্যে কোনো একটা পোকা নড়তে হবে। মাথায় যদি পোকা নড়ে তাহলে সেই লেখা আসবে। এইটা আমি দেখেছি এখানে ছাত্ররা পড়েছে কিনা মহারাজ নিশ্চয়ই জানেন, স্বামী জগদীশ্বরানন্দের গীতা পাঠ করতে গিয়ে সেই ভূমিকায় সেই কি কষ্ট করে তিনি লিখেছেন। সেই দোতলা একটা ঘরে থাকতেন, টিনের চাল, গ্রীষ্মকালে সেই প্রচণ্ড দাবদাহের মধ্যে তিনি লিখছেন। এইগুলো আমাদের মাথার এই পোকা নড়ার সাহায্য করে আর কি। আমার ক্লাস করার ছাত্র অবস্থায় প্রথম কলেজে কেমিস্ট্রি প্রেসিডেন্সি কলেজে প্রথম দিন প্রথম ক্লাস করার কথাটা আমি এই প্রসঙ্গে এখানে দাঁড়িয়ে বলিনি, তার একটা কারণ আছে। সেই জন্যে সেই ক্লাসটা নিয়েছিলেন অধ্যাপক রামসুন্দর বন্দ্যোপাধ্যায়, যিনি এখানেও পরবর্তীকালে অধ্যাপনা করেছেন। গত বছর আমরা তার শেষকৃত্যে যোগ দিয়েছিলাম, আমি এবং সঞ্জীব বাগচি আমার সহপাঠী। তা সেই প্রথম দিনের ক্লাসে অধ্যাপক রামসুন্দর বন্দ্যোপাধ্যায় আমাদের যে পড়িয়ে যে ইন্টারেস্ট তৈরি করতে পেরেছিলেন, তার প্রধান কারণ আমার পরে যা মনে হয়েছে, আরও অনেক ক্লাস তো করেছি, যে ইংরেজির মধ্যে বাংলা শব্দ প্রক্ষিপ্ত করে তাকে আমাদের আরও কাছের শব্দ, কাছের মানুষ, কাছের বিষয় করে তোলা। এইবার আমার ছাত্র অবস্থার কথা বললুম। আমার শিক্ষকতার প্রথম দিনে গিয়ে ক্লাসে ঢুকে যে অভিজ্ঞতাটা হলো সেটা খুব করুণ। তার কারণ তখন স্কুল ফাইনাল ছিল ক্লাস 10, তারপরে 1 বছরের একটা ব্রিজ কোর্স ছিল প্রি ইউনিভার্সিটি, আর 11 ক্লাস ডাইরেক্ট ছিল, যেটা আমরা পড়েছি সেটা কম। তা আমার কলেজে আমি পড়াতাম নিউ আলিপুর কলেজে, যে বছর পাশ করি সেই বছরই যোগ দিয়েছি। তো সেখানে ছাত্ররা আসতো এই বজবজ, আকড়া, নুঙ্গি, বেহালা, এবং তারা বোর্স থিওরি বুঝবে না ইংরেজিটা বুঝবে, এটাই তাদের কাছে আমার মনে হলো একটা বিশাল সমস্যা। এবং সেইখান থেকেই সেই মাথায় এলো যে একটা বই যদি এমন করে লেখা যায় এদের জন্যে, যেটা এরা বুঝতে পারবে, যেটা করা যাবে, সেইটা হলে ভালো হয়। এবং তার মধ্যেই হঠাৎ একদিন, এর মধ্যে 8-10 বছর কেটে গেছে, 68 থেকে প্রায় 76, কাগজে বিজ্ঞাপন বেরিয়েছিল লেখক চাই বলে। তা আমি আর আমার আরেকজন ছিলেন কলেজের অর্গানিক কেমিস্ট্রি, শচীন কুমার ঘোষ বলে, তা আমরা দুজন যোগাযোগ করলাম। তো সেইখান থেকেই লেখা শুরু হলো। তো এই লেখাতে আমাকে প্রথম উৎসাহ বেশি করে দিয়েছিলেন, তাকে আমি শ্রদ্ধার সঙ্গে স্মরণ করি, ডক্টর নিত্যানন্দ সাহা। তিনি আজকে পরলোকগত। তিনি আমার প্রথম খণ্ডটা এডিট করেও দিয়েছিলেন। এবং তারপরে যেটা হলো, আমার একজন হিতৈষী, তিনি ওখানে সায়েন্স অ্যান্ড কালচার বলে একটা পত্রিকা বেরোত সায়েন্স কলেজ থেকে, তিনি আমার বইটাকে নিয়ে রিভিউ করতে, সায়েন্স অ্যান্ড কালচারে রিভিউ বের করে আমার বললেন যে, এই তোমার বইটা রিভিউ করতে দিয়েছি। আমি বললাম, সে কি, কাকে দিয়ে? বলল, ডি ব্যানার্জি। আরেকজন স্যার রাসবিহারী ঘোষ প্রফেসর, দোর্দণ্ড প্রতাপ আমাদের সামনে এখন বসে আছেন, ইনিও স্যার রাসবিহারী ঘোষ প্রফেসর ছিলেন তখন, প্রফেসর ডি ব্যানার্জি। তো দেখা গেল সেই ডি ব্যানার্জি আমার বইটাকে আমাকে উৎসাহিত করলেন, এবং কিছু কিছু ভুল, দুটো একটা ত্রুটি ছিল, সেগুলো সংশোধন করে দিলেন। এবং সেই যে উৎসাহ পেলাম, সেই উৎসাহ থেকেই আমি নতুন করে আবার লিখতে শুরু করলাম। তাতে আমাকে আরও সাহায্য করলো যাদবপুর বিশ্ববিদ্যালয়ের, তাকেও আজকে আমি শ্রদ্ধায় স্মরণ করি, আমার অনুযোগ প্রতিম ডক্টর রূপেন্দ্রনাথ বন্দ্যোপাধ্যায়। তিনি আমাকে অনেক সাহায্য করেছেন, তার কাছ থেকে আমি অনেক কিছু শিখেছি। বিশেষ করে আমার ভলিউম 2-তে যেখানটাতে কাইনেটিক্স আছে, কমপ্লেক্স আছে, সেই অংশগুলো তিনি আমাকে অনেক সাহায্য করেছেন। এখন এরপরে দ্বিতীয় খণ্ড আর বেরোয় না, আমার এই নানা রকম শারীরিক অসুস্থতা, পারিবারিক সমস্যা। প্রথম খণ্ডটা চলছে, দ্বিতীয় খণ্ডের অনেক পরে বেরিয়েছে এবং সেটাকে আর সংশোধন করে আধুনিক পর্যায়ে নিয়ে আসতে আর পারিনি। প্রথম খণ্ডটাকে কিছুটা সংস্কার করে আরও ছাত্র উপযোগী করে সেটা বেরিয়েছে 2010-এ। আর দ্বিতীয় খণ্ডটা, যেটা এলিমেন্ট অফ কেমিস্ট্রি, গ্রিনউডের বইয়ের অনুসরণে লিখেছিলাম, আমি স্বীকার করে যাচ্ছি, সেটাকে তারপরে আরও অনেক সুন্দর সুন্দর বই বেরিয়েছে, কিন্তু আমি সেটাকে কালোপযোগী করে উঠতে পারিনি, কারণ ক্রমাগত সিলেবাস পাল্টাচ্ছে। আবার এই গত মাসেও সিলেবাস পাল্টালো, এবং সিলেবাস এমন অদ্ভুতভাবে পাল্টালো, দেখা গেল এক একটা ইউনিভার্সিটির এক একটা কলেজের এক এক রকম সিলেবাস, এবং এগুলো সব সেই স্কিউ লাইন বলে, সিলেবাস, চ্যাপ্টার, কতগুলো লেকচার, সব কিছু মিলিয়ে সে একটা সাংঘাতিক ব্যাপার, সে বলা যাবে না। এর মধ্যে পাবলিশাররাও আজকাল এইসব ব্যাপারে অনিচ্ছা প্রকাশ করছে। সেই জন্যে শুনেছি যে বইটা নাকি বিক্রি হয়, কিন্তু আমি কোনো খবর 2018-র পর থেকে কোনো খবর পাই না, আমার সঙ্গে কোনো যোগাযোগ নেই। এখন আমাদের উদ্যোক্তা এবং আহ্বায়ক আজকের ডক্টর রবি কুমার দেব, উনি আজ্ঞা করেছিলেন যে হোয়াই দি থট কেম, যেটা আমি বললাম, কী করে আমার মাথায় পোকা নড়েছিল। এরপরে বলেছিলেন যে আমার বইয়ের কিছু বৈশিষ্ট্য বলতে, খুব সংক্ষেপে, নিজের কথা নিজে বলা যাবে না, এরপরে আরও বক্তারা রয়েছেন। আমি যেটা প্রথমেই বললাম, আমার উদ্দেশ্যটা ছিল ছাত্ররা বুঝতে পারে, সেই জন্যে জটিল বাক্য যতটা সম্ভব পরিহার করে ইংরেজিতেই, সরল ইংরেজিতে লেখা। আর ছাত্রদের যেখানে অসুবিধে হবে সেটা বোঝা যায়, সেই জায়গাগুলোকে আরও ভেতরে গিয়ে, গভীরে গিয়ে, যেমন 10⁻⁻10 মোলার HCl, 10⁻⁻10 মোলার হাইড্রোক্লোরিক অ্যাসিড, তার পিএইচ কত হবে, সেটা কখনোই 7-এর ওপরে যেতে পারে না। কেন পারে না, এইগুলো সব করে করে দেখিয়ে দেওয়া ছিল। যেমন ওই ইলেকট্রোড পোটেনশিয়ালের ব্যাপারে, ওখানে একটা প্রায় সমস্যা হতো ছেলেদের, অর্থাৎ ওই স্যার বেঞ্জামিন ফ্র্যাঙ্কলিন ইলেকট্রিসিটির পজিটিভ আর নেগেটিভ ইলেকট্রিসিটি যে ক্লাসিফিকেশান করেছিলেন, সেটা একটা হঠাৎ করা, তার সঙ্গে কিন্তু এই আমাদের যে ইলেকট্রোস্ট্যাটিক পোটেনশিয়ালের প্লাস মাইনাস, সেই পোটেনশিয়াল আর অ্যালজেব্রার যে প্লাস মাইনাস, তার কোনো সম্পর্ক নেই। ফলে এইখানে ছেলেদের সমস্যা হতো। সেই জন্যে আমি ওই জায়গাগুলো জোর দিয়ে আলাদা করে বুঝিয়ে বলার চেষ্টা করেছি এবং উদাহরণ দিয়ে দেখিয়েছি। এইভাবে টাইট্রেশনের সময় বিভিন্ন পর্যায়ে কিভাবে পোটেনশিয়াল পাল্টায় ইত্যাদি। আবার যেগুলো কারেন্ট টপিক হলো, জাপানে যে পারমাণবিক চুল্লির দুর্ঘটনা হলো, সেই ঘটনাগুলোর উল্লেখ করলাম, এবং পরে আমি খবর পেলাম চিঠিতে যে ভাবাতে ইন্টারভিউ দিতে গিয়ে ওই বইটা ছিল বলে সে ছেলেটি চান্স পেয়ে গেছে। এইভাবে নানা সময়ের ভেতর দিয়ে আমরা চলেছি, দীর্ঘ বিরতি গেছে এবং তবু থেমে থাকেনি কখনো, চলেছে। এবং এইটুকু বলে সকলের দীর্ঘ ধৈর্যচ্যুতি ঘটানোর জন্যে ক্ষমা চেয়ে শেষ করছি। নমস্কার।
thank you very much, Dr. Rama Prasad Sarkar sir, for encouraging us. Actually, we encouraged from his lecture. Now I request Professor G.N. Mukherjee sir, please come and take your seats.
Now I request Dr. Ravi Kumar De to felicitate Professor G.N. Mukherjee. Okay. Now I request Dr. Ravi Kumar De to introduce Professor G.N. Mukherjee.
Professor Gurunath Mukherjee sir, popularly known as G.N. Mukherjee, an MSc PhD from Calcutta University, held the coveted chair of Sir Raj Bihari Ghosh Professor and head of the Department of Chemistry, University of Calcutta. He specialized in inorganic chemistry, did his PhD research with Professor N.N. Ghosh, the last disciple of Sir P.C. Roy, in the same laboratory where the Acharya of Indian chemistry used to guide his research scholars. More importantly, Professor Mukherjee graduated from this college. That is, he is an alumni of our college. With the very first batch of students that entered in the year 1963, the centenary year of Swami Vivekananda, when the college started its journey, and he served the college as a lecturer in chemistry during the first 5 years, that is from 1969 to 1974 of his service life. Mukherjee's research interests had been in the fields of coordination chemistry, analytical chemistry, and bioinorganic chemistry. He published extensively in reputed national and international journals and guided several PhD scholars. He also authored a few books on UG and PG level inorganic chemistry for Indian universities. His popular books are Elements of Bioinorganic Chemistry, Handbook of Undergraduate Chemistry Experiments, Semi-Micro Qualitative Inorganic Analysis, Advanced Experiments in Inorganic Chemistry, Handbook of Inorganic Analysis. Now I request sir to deliver his specious lecture. Sir, please.
Revered Principal Maharaj, distinguished professors, Dr. Rama Prasad Sarkar, like my elder brother, fellow delegates, students and research scholars, members of the staff. At this start, I like to thank the organizers for having invited me to speak in this seminar of unusual nature. Dr. Ravi Kumar actually told me what prompted us to write a book on bioinorganic chemistry. Slides for So this book, Elements of Bioinorganic Chemistry, and Dr. Ravi Kumar asked me to tell you what prompted me to write a book on bioinorganic chemistry. And as you have heard that I was a student of this college from 1963, and after passing from this college, then I did my MSc, PhD, then served this college for 5 years. Then I moved on, served another colleges. In 1977, I joined Calcutta University. And during this almost 14 to 15 years, I have never heard of this word bioinorganic anywhere. Suddenly in 1978, the then head of the department, the legendary professor, Mrs. Asima Chatterjee, called me in her chamber and asked me to move to Hyderabad Osmania University to attend a summer school on bioinorganic chemistry being held in the Osmania University as sponsored by University Grants Commission. So in the next morning I flew to Hyderabad, and then I joined the summer school held in the Osmania University under the chairmanship of the renowned inorganic chemist Professor M.M. Taqi Khan. And this summer school was actually, there are so many resource persons from India and abroad, of which most prominent was Professor R.K.M.V.C.COLLEGE Martel from the University of Texas. So I spent 1 month there, more than 1 month, then I came back, and it was month of May sometime, and the next session of MSc class was going to start from July, and Mrs. Chatterjee called me again and asked me to teach this subject in the inorganic special what I have learned just 1 month ago. Something wrong in the computer.
স্যার আমি করে দিচ্ছি
What is the no, তোমার একটা মাউস আর দিয়ে দাও, আমি মাউসে করে দিচ্ছি। No mouse? Because this is not stable. Okay. Okay. So you see, what I actually knew that time, my knowledge in bioinorganic chemistry was very poor because I learned this subject only for 1 month. And that knowledge was not sufficient to teach in a postgraduate class. I was in great trouble. What I knew that the presence of traces of certain metallic elements in biological samples were observed through advancement of techniques of chemical analysis. By analysis, because when atomic absorption was not discovered, it was very difficult to determine the quantity of materials which are present in very trace amount in any biological or abiological sample. So with the advancement of the techniques of chemical analysis, actually people could actually quantitatively determine smaller and smaller quantities of material, and from that it is found that in certain biological samples, in most biological samples there are certain metallic elements. Then certain diseases and physiological disorders could be related to the deficiency or excess of certain metallic elements in purified diet. As for example, anemia related to iron copper deficiency, bone decay related to calcium deficiency, nerve function related to sodium potassium. Not audible? Can you hear me? Last bench? Okay. ঠিক আছে. And Alzheimer's disease, aluminium, and Wilson's disease, copper. These things were known from long time. So I actually knew that much of thing. নিচে দেখবে?
হ্যাঁ স্যার আপনি এটাই করুন, আর কোনো সমস্যা নেই, এটাই এইটাই আর কোনো সমস্যা।
Now, medicinal applications of crude preparations composed of certain minerals and metallic compounds were long known. As for example, gold cyanide was being used for the treatment of tuberculosis 2500 BC in China. Then gold thiomalate, it was used for the treatment of rheumatoid arthritis. Cis dichloride of diamine platinum 2 for cancer chemotherapy, and various arsenicals for the treatment of syphilis. Toxic effects exerted by heavy metallic elements such as cadmium, thallium, arsenic, mercury, lead, bismuth. Most prominent is the Minamata disease that actually occurred in Japan 1952 due to mercury poisoning, and Itai disease due to cadmium poisoning. The question is, interpretation of these facts required multidisciplinary knowledge, which neither an inorganic man nor an organic man could actually interpret fully. And quest for unfolding the multifaceted role of metallic elements in biology initiated mutual interactions among the scientific workers from various disciplines, such as chemical science, life science, physical science, environmental science, art science, medicinal science, and even mathematics and computer science. Such interactions gave birth to an interdisciplinary area in inorganic chemistry, and that is bioinorganic chemistry. Bioinorganic chemistry's journey to in India. As you see, born in 1960s in the USA, UK, USSR, Germany, traveled to India in 1970s, and UGC identified this subject for PG chemistry in late 1970s, as I have told you, 1978, and subsequently for UG chemistry in 2002, when I was chairman in board of studies, and Professor Sarkar was also member, and we introduced bioinorganic chemistry in the undergraduate level in Calcutta University. Very small course, 10-mark course. Then during this time, 1978 to 90, several UGC sponsored summer schools, winter schools, workshops on bioinorganic chemistry were held in premier universities and institutes of higher learning for introducing the subject at the PG level in organic chemistry in Indian universities. Experts from different universities in India and abroad, USA, UK, USSR, Canada, Japan, Switzerland, Germany, shared their experiences in such programs organized at Osmania University, Hyderabad, Indian Institute of Science, Bangalore, Indian Institute of Technology, Madras, University of Calcutta, Kolkata. And ultimately, bioinorganic chemistry became a part of the PG chemistry inorganic curriculum of all Indian universities since 1980. Books on bioinorganic chemistry. Bioinorganic chemistry at Calcutta University opened in the very year 1978. when I just a few months before I have joined. As I have told you my problem, no book covering the entire syllabus recommended by the UGC on the subject was available at the beginning. Most available books were compilations of research papers and review articles by experts in certain aspects of the subject. And some advanced level inorganic chemistry books contained one chapter on bioinorganic chemistry, but those did neither cover the entire syllabus recommended by the UGC, nor were they reader friendly. Reader friendly in this sense, they contain lot of cross references, and the corresponding journals are not always available in the libraries. That's the problem. So, elements of bioinorganic chemistry. So these constraints prompted us to venture to write a reader-friendly book on bioinorganic chemistry during mid-1980s. 10 years of extensive survey of literature, attending workshops, seminars, discussions, consultations with experts gave birth to a shape of a book. The first edition of the book came to light in 1993, overcoming several publication-related constraints. Some of the constraints just Dr. Sarkar mentioned just before. Because it was going to be the first book on the subject, so both myself and my co-author, Professor Aurobindo Das, had the intention to publish the book from a Calcutta publisher itself. Because we actually were students of Calcutta University. So we went to several publishers. They heard the name bioinorganic chemistry, never ever heard of. They know chemistry, organic chemistry, or inorganic chemistry, or mathematics, botany, zoology. This was a new term. It was a new term to me a few years back, and new term to all the publishers. Then they asked, who will read this book? At which level? When I told that it is in the final year in MSc, Inorganic Special, how many students will buy the book? Next question. So in those days, it was like that if 6 lakh students appear in the Madhyamik, of which around 2000 students get admission in chemistry honors in various colleges under Calcutta University. In the first past examination, around 1200 of those students appear in the BSc Part 1 examination. And that figure goes down to around 600 when they appear in the Part 2 examination. And after passing the BSc, they get admission into various universities in chemistry department, chemistry subject. And in Calcutta, there are several types of chemistry. Pure chemistry, chemical engineering, chemical technology, and polymer science technology. Then there is biochemistry. So of these, around 100 students actually get their admission into pure chemistry, and these 100 students actually are 70 students from the University Science College itself and 30 students from Presidency College. Because Presidency College and Science College in those days, the classes were held jointly. Theoretical classes were held jointly. Presidency College students used to come to Science College for theoretical class. They used to do their practical at their own college. Similarly, Science College students also moved to travel to Presidency College for some theoretical class, and they are doing their practical class in the Science College. So combining these two colleges, only 100 students take up chemistry course in the MSc. Of these 100, least popular subject is inorganic chemistry. If you ask any boy in BSc or MSc, what subject you like to take here as a special subject, and one day or sometime we surveyed at the entry point in 1 year, we surveyed how many students, say out of 100 students, how many like to take up different subjects. 64 out of 100 opted for organic chemistry. The number of seats are only in organic, it is only 26. In science college, we have 70 students, of which inorganic is only 16. Inorganic 16, physical 16, and 10 is analytical, and remaining 28 organic. And 64 students asking for organic special. Understand? That was the position. And of this 100 students, only around 16 in science college, and another 10 to 8 students in presidency college. Altogether, there may be 30 students, 25 students with inorganic special. So starting from 6 lakhs in the Madhyamik, the figure comes down to around 20 at the stage of MSc second year. So the publisher, if he publish a book on general science for the Madhyamik, he will be able to sell around 4-5 lakhs of books. Because in school, you see, books are changing every year. Because in our time, we used to take books from the our senior students, sometimes in free of cost. But now, every year, the same subject, same thing, same author, books are changing. So why they will go to publish such a unpopular book? So no one of the Calcutta publisher agreed. Then something miraculous happened. So one of the renowned publishing house in the Calcutta University, that is the UN Dhar and Sons, that is they are the famous book of Das Mukherjee Calculus. They generally publish mathematics books and some medicinal books. So that publishing house came forward. What exactly happened? A boy from the director's family of that publishing house did his PhD under me in the early 80s. He witnessed my eagerness to learn the subject, my struggle to teach the subject to the postgraduate student, and he had a sense of the problem in and the sense of some amount of created some amount of interest in bioinorganic chemistry, some elements of bioinorganic chemistry he also had in his research work. That actually prompted him to convince his family to go for publishing this book. So this bioinorganic chemistry book was not published on its merit. It is published on its favor. Understand? So first edition came in 1993, overcoming several publication related problems. Subsequent editions, however, had smooth sailing. People loved the subject. Students, teachers loved the subject. At present, 4th edition is running and 5th edition is press ready. So that is how the subject bioinorganic chemistry comes in India and also in Calcutta, and that is how we go for writing a book on bioinorganic chemistry. Now, Dr. Ravi Kumar also requested me to highlight some of the salient features of this subject for the benefit of the students. So you see what bioinorganic chemistry is. There are so many elements. Elements of life, biomolecules, proteins, nucleic acids, lipids, carbohydrates, vitamins, coenzymes, metabolic energy source, transport and storage, metal protein interaction, metal nucleic acid interaction, metal ligand complex equilibria, acid base catalysis, catalysis by metals and metal complexes, hydrolytic enzymes, then transport and storage of dioxygen by oxygen binding proteins, metal and transport and storage, electron transport in biology, electron transporting proteins and coenzymes, redox metalloenzymes, biological redox reactions, respiration, photosynthesis, nitrogen fixation, hydrogen generation. These are the most important biological redox reactions. Toxic effects of metal ions, chemical toxicity and detoxification, metal dependent disease and metal complexes as bioinorganic drugs. And finally, chemical evolution of the origin of life. So these are the components of bioinorganic chemistry, of which in this lecture I don't like to discuss anything serious of inorganic chemistry. I like to focus on the first element, the elements of life. for the benefit of the students. So by and large, bioinorganic chemistry can be said as the chemistry of metal ions in biological system. Now look at the start from the periodic table, elements of life. As you see, this is the whole periodic table. Most of the spaces are empty. There is nothing. As you see, out of from hydrogen to uranium, there are 92 naturally occurring elements. Of these 92 naturally elements, nature actually requires only around 30 to 32 elements for doing all the functions in the biological system. As you see, the essential elements, there are 11 essential elements. As you see, colors are not prominent here. These are the essential elements. They are present in relatively larger amount. Then we have trace elements. Mostly these are 3D transition elements mostly, and there are a few other elements which are present in minor quantities, but they play a very important role. Alter trace or beneficial elements, as you see the green shaded elements, these elements are present in minute trace quantities in some life forms, not in all life forms. And even today, their biological function is not fully understood, but they are beneficial. Heavy elements, the heaviest metallic element in biology is molybdenum. And as you see, tungsten is also mentioned here. During the chemical evolution of the living system, living cell, actually nature used several tungsten containing enzymes. Subsequently, nature actually modified those enzymes by replacing tungsten by relatively lighter molybdenum. So now present day there are only few tungsten containing enzymes, not in the human system, and molybdenum containing enzyme are many, and iodine is the heaviest non-metallic element in biology. And you see, toxic elements, mercury, thallium, lead, bismuth, cadmium, these are toxic elements. Now you see the weight percent of various elements in the biological system, as you see from the screen. As you see, these 5 elements, oxygen, carbon, nitrogen, hydrogen and phosphorus, make around 97 to 98% of a living cell. Remaining elements make only around 2 to 3%, but they play very vital role. Now in terms of water and solid matter in a living cell, water is 70%, solid matter is only 30%. And in this solid matter, you see there are several types of biomolecules. Water 70%, proteins 15%, nucleic acid 7%, 1%, DNA 6%, RNA, carbohydrates 3%, then lipids 2%, small organics 2%, and small inorganics is only 1%. And bioinorganic chemistry is with the small inorganics, only 1%. Now coming to the metals of life, almost whole of the periodic table is empty. Only these few metals are doing various functions in the biological system. As you see, sodium, potassium, they do not have any novel chemistry. In the Dr. Sarkar books, you will see sodium, potassium, they mostly participate through charge interaction. Understand? So in the biology also, they participate in charge transfer and nerve function, calcium, magnesium triggering reactions, and hydrolysis, muscle contraction, phosphate transfer. Zinc, as you know, zinc is amphoteric in nature. Zinc oxide can function as a base and also as an acid, amphoteric. So similar actually function is zinc playing in the biological system, because of its amphoteric nature it is involved in pH control, catalyzes hydrolysis type of reactions. And these transition elements, manganese, iron, copper, nickel, molybdenum, they are mostly involved in redox catalysis and electron transfer, and of which iron and copper are involved in oxygen transport and storage. Now nature actually shows a lot of specificity and selectivity in choosing the elements for various biological functions, as you see. Why nature selects specific elements and compounds for specific functions? As you see, why iron is selected for hemoglobin, myoglobin, or cytochromes, peridoxins, copper for hemocyanin, cobalt for vitamin B12, magnesium for chlorophyll, while these functions could not be carried out by other elements. That's the question is addressed in bioinorganic chemistry. Now, basis of nature's choice of bioelements depends upon abundance, efficiency, basic fitness, and evolutionary ability to adaptation. Now, when a certain function can be accomplished by two or more entities, the organism utilizes the most abundant and most readily available one. Bioavailability of an element depends upon pH, temperature, and chemical form that determine solubility. Solubility is most important. As you see, if we consider the solubility of various ions, ions from essential elements, as you see, similarity, we observe similarity in concentration of essential ions in seawater, in blood, and blood plasma. As you see, the levels of concentration may be different, but the pattern of variation of concentration is almost similar. So that is why it was actually concluded that the first living cell must have originated in the ancient ocean. Now, seawater concentration is a measure of bioavailability. As you see, these elements, aluminium, chromium, iron, titanium, in the higher oxidation state, their seawater concentration is much lower than their concentration in the earth crust, because these elements, these oxidation states of these elements form highly insoluble oxides and hydroxides. In chemistry also you see ferric hydroxide insoluble, aluminum hydroxide insoluble, right? So it is very difficult for the nature to select these elements for biological function. On the other hand, these elements mostly form soluble compounds. They rarely form insoluble compounds. Naturally, their seawater concentrations are much higher than the earth crust concentration. Similarly, these molybdenum, sulfur, selenium, these elements form oxoions, which form soluble salts. That is why concentration of these elements also are higher in the earth crust, higher in the seawater than in the earth crust. And calcium, zinc, manganese, iron too, actually that they actually form soluble compounds with oxygen, nitrogen, sulfur donor ligands. That is why their concentration in the organism is higher than that in environment. And for the 3D transition metals, that because they are biologically important, that is, I show you the order of concentration of these elements in seawater. Now, essential levels in organisms strongly influenced by environmental abundance. As you see, when seawater concentration is greater than earth crust concentration, that is for sodium, potassium, they are most abundant. They control electrolytic balance. Copper, iron, zinc, molybdenum, they form the active sites of most metal enzymes because their seawater concentration is high. On the other hand, earth crust concentration is high, seawater concentration less for these types of salts, calcium carbonate, calcium phosphate. These salts mostly they are insoluble at biological pH, and they form the protective skull material and bones. As you see, the strontium analogues of these compounds are equally insoluble. But nature does not select strontium, select calcium. Because of strontium abundant is much less. That's why nature does not select strontium. Then efficiency. Organism choose the more efficient entity as long as it is readily available. As you see, for electron transport, nature should create some redox couples. Nature frequently involves more efficient or single electron inorganic redox couples as electron carriers. As for example, cytochromes, which are electron transport proteins, iron 3 heme proteins, peridoxins, they are iron sulfur, iron 3 heme proteins, they involve this one electron redox couple, iron 3 iron 2 redox couple. Plastocyanin, ceruloplasmin, they actually involve this one electron copper 2 copper 1 redox couples. Never ever the organic redox couples. Organic redox couples involve bond making, bond breaking, and that is why they are selected occasionally. Don't get annoyed, Dr. Chandra says, Chandrakanta. You see, what is the problem? Because organic redox couples require more than one step. In going from oxidized state to reduction state, most organic redox couple involve so many steps. That process is slow. As you see, if you go to any organic chemistry research laboratory, you see a series of replus condenser, and at the bottom there is a flask and something is boiling. After 2-3 days, something will come out. So if life is run in that speed, that will be a geoparody of the life system. Now you see the ubiquinone, plastoquinone. These are ubiquinone is involved in respiratory electron transport chain. When we respire, at one stage ubiquinone is involved. During photosynthesis, at one stage another quinone, plastoquinone is involved. And both this quinone actually in reality is quinone hydroquinone redox couple, which the undergraduate student read in their chemistry honors. They also do this some experiment involving quinone hydrogen electrode. Understand? And you just see the simple reaction is Q plus 2H plus 2E, H2Q. Net reaction is reduction of 4 double bonds by 2 electron and 2 proton to 3 double bond. So many steps are involved. That's why nature selects organic couples, redox couples, whenever it is actually specially required. Otherwise, mostly nature selects inorganic redox couples. Basic fitness. An inorganic element, generally a metal to be selected, should have the basic ability or potential to carry out the desired function. A certain element or a compound inherently fit to a particular reaction. As for example, nature selects nickel, zinc, magnesium to effect hydrolysis, bond making, bond breaking, isomerization reaction in the biological system, and iron, copper, molybdenum, manganese to effect the desired redox reaction. Now, what are the requirement of a metal ion to be a catalytic entity in an acid-base reaction? The requirement is that it should have high Lewis acidity, that is determined by the ionic potential. I studied that from Dr. Sarkar book. Not redox active, only acid-base reaction. Such a metal ion, should not be redox active. It should participate only acid-base reaction. Otherwise, the acid-base reaction will be complicated. Non-rigid, non-directional bonding. No configuration restriction to ligand binding. And that actually is possible if it has comparable stability of complexes with coordination number 4, 5 and 6. Then you now come to coordination chemistry. If that has to be done, crystal field stabilization energy should be 0, octahedral site preference energy should be 0, crystal field activation energy should be 0. All these requirements are met with by this zinc 2 ion with a D10 configuration. You see, zinc 2 is crystal field inactive. And these are the uniqueness of zinc as a bioelement. Now, the requirement of a metal ion for redox catalysis. Ability to exist in more than one easily interconvertible oxidation state. That's the most important requirement. And redox potential values should be within the stability field of water. I'll come to the stability field of water. Remarkably different ionic radii in different oxidation state, ability to adopt a different geometry in different oxidation state, and should not be kinetically inert. That is, you see in coordination chemistry third year, undergraduate student, you read coordination chemistry, you see mostly the Warner complexes of cobalt 3 and chromium 3, and you mostly study the isomerism. Understand? All metal, transition metals form complexes, but isomerism is shown by only the chromium 3 and cobalt 3 complexes. Never ever with iron complex or copper complex or nickel complex. Have you ever heard that? Always nickel, cobalt, always copper and chromium, or hardly platinum. Because these metal ions react slowly, when a reaction is carried out, all isomers are formed. But with isomer interconvert very rapidly, we cannot actually isolate the isomer in pure form. But if the interconversion of the isomer is very slow, so one isomer is formed, remains stable, is not easily transferred to the other isomer. Then by manipulating the experiment, we can isolate some pure form of the isomer. That is actually true for these metallic elements. So nature never ever select this type of kinetically inert metal ions for any functioning any biological system. So best fit is iron, copper, molybdenum and manganese. Now here is the stability field of water. Because as I have told you, water is in a living cell, water is 70%. So everything present in the living system should be stable in water, should neither oxidize water nor reduce water. Understand? So this is the Purve's diagram of water. The upper thick line is the oxygen water redox couple. The lower thick line is the hydrogen water hydrogen redox couple. There is upper line actually is the oxidation line of water. Lower line is reduction line of water. And all these redox couples, we can write their half cell reactions, and if we derive the Nernst equation, see Nernst equation will be of this form. E is equal to E0 minus 0.59 by N into pH. So if we plot the redox potential values at different pH, as you see, so with increase of pH, redox potential values will be lower. And you see, if we consider various biological samples, say milk, lemon juice, urine, everything, if we measure their pH, you see the lowest pH in a biological substance is 4, highest pH is 9. So between 4 to 9 is the stability field of water in which that is the range of acidity of biological samples. And this thick line and this thick line are the redox potential lines. That is, any species whose redox potential at a particular biological pH falls in this region will neither oxidize nor reduce water. So that is actually stable in the stability field of water. Understand? So E0 value within stability field of water do not oxidize or reduce water. So these things should be fulfilled by any redox entity in a biological system. Now say iron, let us consider the redox the redox stability of iron compounds. As you see here, when we dissolve iron, first of all ferrous ion is formed in acid medium, right? Then if we go on rising the pH, eventually if we oxidize this ferrous, it becomes ferric. With rise of pH, gradually what happens? Ferric hydroxide first precipitates. Even if you take more salt and dissolve in water, within 2-3 minutes you will see brown precipitate coming, not green precipitate. Ferric hydroxide is less soluble, so it comes out, aerially oxidized, understand? But you see the ferrous iron in this region, you see even in this green region is the stability field of water. So here some form of ferrous ion remains, but no ferric ion. Ferric ion actually occurs in acid medium. So when you prepare the ferric chloride solution for your qualitative test, you do ferric chloride, dissolve ferric chloride in acid medium, right? Then you neutralize. Before you use, you neutralize it. Then you use. If you keep the neutralized ferric chloride solution for some time, you will see after some time ferric hydroxide will precipitate. Understand? So you see, ferric ion is actually very toxic to the biological system. So ferrous ion remains in biological system within the stability field of water. That is why it is important. Then you see the chromium redox couples, dichromate chromium 3 occur in the acid medium. We would do the dichromate, use potassium dichromate used as a titrant in redox chemistry in 2 normal sulfuric acid medium, right? As you see, this redox couple actually occurs in acid medium. But we are here in the biological system here. So this redox couple has no biological relevance. Even if we bring down the acidity to the biological pH, as you see, dichromate is reduced directly to chromium hydroxide, which is insoluble. So this redox couple does not actually occur in the biological system. Then you see another very interesting chlorine chloride redox couple. E0 value is 1.36 volt, far above the stability field of water. As you see, chlorine is very injurious to the living system. Chlorine water we use for killing bacteria. If you subject this plant with chlorine water, it bleaches the color of the flower and leaves. Understand? Chlorine is injurious. Even bromine, as you see, redox potential value is 1.09 volt, and you see far above the stability field of water. And if we increase the pH, what happens? Around pH 8, 9, this actually undergo disproportionation. So that's 8, 9 pH means here, after this pH range, so that's not biological pH. Understand? Now you see, most interestingly, iodine iodide redox couple. Redox couple only 0.54 volt. Understand? You do the thiosulfate titration almost in the neutral solution. Understand? When you standardize thiosulfate solution, what you do? First you take dichromate in 2 normal acid medium, right? Add potassium iodide, iodine is liberated. Understand? You cannot titrate that liberated iodine at a high, that 2 normal acid medium. Thiosulfate will decompose. So dilute 4-5 times, bring down the acidity, so that thiosulfate is not decomposed. That is what you do in your chemical analysis, right? And in that acidity, you see the iodine iodide redox couple is stable. Even we use iodine as medicine. In some of the medicines we use iodine, tincture iodine we use as medicine. So species with E0 outside the stability field of water either oxidize or reduce water. Now you come to various iron containing redox couples. As you see, these shaded regions are the stability field of water. And this is a very simplified version of this previous diagram. Understand? So these are some of the redox couples which we work in chemistry. Iron, actually aqueous iron around 0.77 volt, then ferrocyanide, ferricyanide redox couple plus 0.36 volt. We still go down, becomes eventually potential is lower. If we add, consider this redox couple, iron phenanthrolene redox couple or dipridine redox couple, potential that is the redox potential increases. The ligands which stabilize the lower oxidation state increases the redox potential. You have studied that. The ligand which stabilize the higher oxidation state lower the redox potential. So this is in chemistry. Come to biology. Here you see large number of iron redox couples, cytochromes, hemoglobin, myoglobin, cytochrome P450, phosphatase, peroxidase, peridoxines, all have their redox potential values within the stability field of water. So either value of iron, various iron compounds fall within the stability field of water. Now come to copper, another biologically important metal. As you see, here is chemistry. Copper ionometric titration you do in the laboratory 1.117 volt, copper 1, copper 2. As you see here we are 0.17 volt. This is the very simplified Purve's diagram of copper 1, copper 2. And these are some of the copper 1, copper 2 redox couples. Copper glycinate, copper B-citrine, diamine, etc. These ligands stabilize copper 2 state. That's why potential is lower. Whereas these ligands, chloride, imidazole, pyridine, they stabilize the lower oxidation state, copper 1. That's why potential is increased. Coming to chemistry, these are some of the copper containing proteins and enzymes. As you see, they have their redox potential values within the stability field of water. Then look at this diagram. As you see, this is the stability field of water where we have manganese 2, manganese 3 redox couple. But you see, cobalt 2, cobalt 3 redox couple. You see, cobalt 3, cobalt 2 redox couple, redox potential is 1.84 volt, far higher than that potassium permanganate. Understand? So it has no biological relevance. It is running above the stability field of water. Now, as you see, stannous chloride, stannic chloride. We use stannous chloride in the laboratory for reducing agent. As you see, the potential value is far lower than this lower line of the water hydrogen electrode. So stannic has no biological relevance. Now see chromium 3, chromium 2. Have you ever seen any chromium 2 compound in the laboratory? Never ever. What you have seen? Only chromium 3 compounds. Cr2O3, chromium 3 phosphate, and so many chromium 3 compounds. Never ever any chromium 2 compound, because it is so strongly reducing that in order to preserve chromium 2, we have to design an experiment where always hydrogen gas is generated. So strongly reducing it is. So it has no biological relevance. But the potential field that is manganese 2, manganese 3, and some form of cobalt 2, cobalt 3 which occur within the stability field of water has biological relevance. Now, uniqueness of iron as a bioelement, as you see, the reversible redox and acid-base property. How acid-base property and redox property of ferrous-ferric system is intimately related, as you see. You are playing with this ferrous-ferric every day, unknowingly, as you see. This is the ferrous-ferric 0.77 volt. As you see, if it undergoes a acid-base reaction, as you see, pK value of this coordinated water can be determined. It is 2.2. For chloroacetic acid, it is 2.87. It is even stronger than chloroacetic acid. Acetic acid is only 4.57, 4.75. So almost 100 times stronger. Ferric ion is an acid 100 times stronger than acetic acid. Now come to ferrous ion, as you see. Ammonium ion is very weakly acidic, pK value is 9.2. If you calculate the pH of ammonium chloride, as you see, ammonium chloride solution is feebly acidic, calculate the pH, you see, this pK value will come. So as a ferrous ion, aqueous ferrous ion, is pK value is 9.5, very close to that of ammonium ion. So just one electron reduction of ferric to ferrous changes the acidity of the coordinated water. Water is 70%. Whatever we add in biological system, in a water, it will be always surrounded by water. Understand? Just do a simple acid-base reaction, simple redox reaction, acidity is altered. Now come to the second ionization. As you see, the second pK value of this ferric which there is monohydroxoferric is 3.2, which is as good as hydrochloric acid pK value. Understand? Almost as strong as hydrochloric acid. So what we see actually, acid-base property and redox property of ferrous-ferric system is intimately related. Acidity of coordinated water is altered by the redox reaction. So change of pH will alter the redox potential value of the ferrous-ferric electrode. So ferric ferrous couple, redox couples becomes more reducing at high pH. Same redox couple become more reducing at higher pH. If you like to reduce nitrate, understand what we use, stannous chloride we use. Ferrous sulfate in alkaline medium can be used as a reducing agent for reducing nitrate to amine. Now you see a very wonderful diagram, versatility of iron 2. It has comparable affinity for oxygen, nitrogen, sulfur donor ligands. In a protein, as you see, we have carboxylic acid group, amino group, amido group, we have thiol group, so many things in a protein. So when a metal ion is present in a protein environment, it has equal, ample chance to form coordinate bonds with these types of donor atoms. Now you see, if we consider in a model experiment, so this black line is for oxalate ion, and this red line is for glycinate ion, and this blue line, this one, for ethylene diamine, this green line, ethylene diamine, and this finally this blue line, this one is for 2-aminoethane thiol. That is the first one, glycinate, oxalate, it coordinates through oxygen minus, O minus, hard ligand. Then the glycinate, O minus N, that is the combination of hard and borderline, right? Then we have ethylene diamine, NM, borderline. Then we have NS, borderline soft. 4 different types of ligand. We actually study their complexes with various alkaline earth metal ions and transition metal ions. Understand? What we see, these alkaline earth metal ion, barium, strontium, calcium, they form their most stable complex with oxalate, least stable complex with ethylene diamine. Because these metal ions have no crystal field effect. They actually participate only through charge interaction. And oxalate actually, because of di-negative charge, its charge interaction is strong. So their oxalato complexes are stronger than their ethylene diamine complexes. Reverse is true in case of the transition metal ions. They have 2 charge, plus 2 charge, at the same time they have crystal field effect. Crystal field strength of ethylene diamine is greater than that of oxalate. That of glycinate is intermediate. So you see their stability order just is reversed. And most interestingly, you see in case of iron, here it is, for iron 2, stability of iron 2 complexes with all these 3 types of ligands are comparable. That is, iron has the comparable affinity for oxygen nitrogen donor ligand iron 2, and that is why absorption of dietary iron in the biological system occurs in ferrous form. Then one very important question, why enzymatic reactions are much faster than the rate of the same reaction taking place non-enzymically? Understand my point? Just consider this reaction, hydration of carbon dioxide. This simple reaction. If you pass carbon dioxide into water, within 10 minutes I will leave. Don't worry, I don't want to show. So rate is, you see, 10 to the minus 3 second inverse. But if the same reaction occurs under an enzymic catalysis in biological system, this reaction is catalyzed by carbonic anhydrase enzyme, but you see, rate is increased by almost 10 times. Now, if we prepare similar model compounds having same type of composition and study this reaction with this model compound, as you see, rates are much lower. So it is not only the metal, the protein part of the metal enzyme is also important in catalyzing the reactions. Now, the evolutionary ability to adaptation, as I have told you, that is the entheotic hypothesis put forward by Valley and Williams. They actually hypothesize that metal ions and proteins mutually modify one another's properties. Active sites of metal enzymes are distorted or constrained, and such a constrained state they have told as entheotic state. And tendency, these metal ions in the enzymes have the tendency to relaxation from such constraints, and such tendency acts as the driving force for facile promotion to the transition state for faster reactions. So results of model studies also show that metal ions can enhance the rate, change the mechanism, and even alter the nature of the reaction products of typical organic reactions. Now we consider copper. Uniqueness of copper as a bioelement, as you see, change of copper geometry on redox reaction. As you see, copper 2, because of its denine configuration, it is orbitally degenerated and undergoes John-Taylor effect. Under extreme John-Taylor effect, the copper compound becomes square planar. Understand? But when a reduction, one electron reduction takes place, copper becomes copper 1, detained configuration, no crystal field effect, and so it is tetrahedral. So there is change in geometry, change in radius, and such change in geometry initiates conformational change in the protein part of the metal enzymes and facilitates faster promotion to the transition state when copper geometry is intermediate between square planar and tetrahedral. So on plus 2 state is square planar, plus 1 state is tetrahedral. If copper remains somewhere in between tetrahedral and square planar, it can easily go to either tetrahedral or square planar. That is actually the entheotic state. Now, lability and inertness of biological metal ions. So, how fast a reaction takes place? That is measured by the rate constant. As you see, for this water exchange, the lability of these metal ions are actually determined by the rate, by measuring the rate constant of this water exchange reaction. That is, simple water containing oxygen 16 is substituted by water containing oxygen 17, and by doing some NMR technique, it is possible to measure the rate constant K. As you see, if you come to these various biological metal ions, as you see, for the D metal ions, the rate of the reaction of the D metal ions are inversely proportional to crystal field activation energy. What is crystal field activation energy? It is the energy difference between the crystal field stabilization energy at the transition state minus the crystal field stabilization energy in the initial state. And this is highest for certain transition metal ions. And if you look at the biological metal ions, sodium, potassium, and here you see the transition metal ions, for most of the biological metal ions, as you see, here we have calcium, biological metal ions are lighter and rapidly reacting. In this diagram, see book of any book of inorganic chemistry, in the kinetics chapter you see this type of a diagram by showing the rate of water exchange reactions of various metal ions. I have just selected the relevant metal ions which are relevant to biology. Understand? As you see, most metal ions react rapidly. Now, crystal field activation energy is maximum for chromium 3 and cobalt 3. If you go to coordination chemistry, you see the kinetics and mechanism of inorganic reaction. The most compounds are of chromium and cobalt compounds, and you see their rates are of the order of 10 to the minus 3 to minus 6 second inverse. The far left, not included in this diagram. So nature actually, this crystal field activation energy is maximum for this metal ion. Their substitution inert, slowest reaction, and biological relevance is minimum. Now, structural rigidity imposed by macrocyclic ligand enforces dual nature of simultaneous levelity and inertness to certain coordinated transition metal ions. This is of great biological significance. As I have told you, biological system actually requires rapidly reacting metal ion. But how a metal ion remains tenaciously bound to the enzyme protein at the same time exchange with the reactant and products very rapidly and reversibly? Understand? The metal ion has to simultaneously form two types of bonds. Some bonds chemically inert, some bonds chemically labile. As you see, by doing a very simple model experiment, this can be established. So this is a template reaction. This is a very well-known organic compound, orthoaminobenzyaldehyde. The orthoaminobenzyaldehyde is just treated with nickel chloride. They undergo intermolecular sheet-based condensation reaction, leading to the formation of this macrocyclic complex of nickel 2, facial tris aqua tris anhydroamino benzaldehyde nickel 2 chloride. Now, this compound can be isolated, and novelty of this compound is that while the nickel remains tenaciously bound to the 3 nitrogen donor ligands, 3 nickel nitrogen bonds, at the same time 3 coordinated water molecules exchange extremely rapidly. In fact, the rate of exchange of this simple nickel aqua complex, that is the simple water coordinated to simple nickel ion and water coordinated to complex nickel ion, N3 this typical ligand, are almost same rate. Understand? So 3 coordinated water of both exchange at the same rate. So nickel thus forms 3 labile NiO bonds and 3 inert NiN bonds in the same molecule. And that's dual nature of coordinated transition metal, which has great biological significance. And how it is possible? You see the structure structurally it appears very dissymmetric, this compound. And because of this dissymmetry, the dissymmetry arises because of ideal fit of 3 nitrogen donor atoms on one face of octahedral nickel 2. Understand? And for that reason, this enforces tremendous rigidity to this NiN3, this moiety. Tremendous rigidity. As a result of the dissociation involves simultaneous rupture of 3 nickel nitrogen bonds requiring very high activation energy. If this nickel complex is to dissociate, simultaneously 3 nickel nitrogen bond is to break. That requires very high energy. That's why these 3 bonds makes nickel substitution inert. But at the same time, these bonds are very good. These bonds break simultaneously. And why I mention this? The kinetically very inert to dissociation. And that is this rate of exchange of this NiN bond or rate of dissociation of this bond is that T half is greater than 42 weeks. T half is greater than 42 weeks. Now you see, structural dissymmetry at the same time kinetic inertness of this compound forces this compound to exist in non-superimposable mirror image enantiomers. Moment before I have mentioned that you have never seen any cis trans or optical isomer of compounds other than cobalt 3 and chromium 3 and platinum 2. But here is one, nickel 2, which is a rapidly reacting metal ion, but its compound is showing as optical isomer, both optically active and resolvable. The structural rigidity imposed by coordinated macrocyclic ligand induces dual nature of simultaneous lability and inertness to transition metal ions. And enzyme proteins in the biological system exert similar structural rigidity to the active side metal ions. And you see one example, the dual nature of iron 2 in oxygenation of hemoglobin and myoglobin. That's the active side structure of heme group. That is, the iron 2 is coordinated by 4 pure nitrogen atoms in the basal plane, axially coordinated by a globin, a immunized nitrogen atom of the protein chain, and all of the coordination site is vacant. So coordinately unsaturated active site of the natural oxygen carrying protein, hemoglobin, myoglobin. And this vacant coordination site is hydrophobically shielded by the globin chain. Because the moment before I have told you, ferrous is very susceptible to oxidation to ferric under polar environment. So this protein actually protects the polar ligand such as water or any ionic ligand. So they prevent the entry of ionic ligand. Only neutral molecules such as oxygen can enter. Now you see what happens when it binds oxygen. This is the globin chain. Understand? As you see the geometry, in this 5 coordinated geometry, the ligand field strength on iron is not sufficiently large. Iron remains in high spin state. As such, the high spin radius is greater than the cavity radius of the porphyrin ring system. It does not sit inside the porphyrin cavity in the deoxy form. But on binding with oxygen, it becomes coordinately saturated, 6 coordinated, and ligand field strength becomes very strong. Iron is transformed from high spin to low spin, and the radius is decreased. So that's, as you see, these 4 nitrogen iron bond, they remain actually inert, whereas this oxygen iron bond, it is actually forming very rapidly and reversibly. So iron 2 is showing dual nature. Iron 2 remains tenaciously bound to the hemoglobin heme and globin chain. Heme is this part, and this is the globin chain, this nitrogen. At the same time, rapidly and reversibly binds oxygen. That is lability. So iron 2 simultaneously form 5 iron nitrogen bonds and 5 inert iron nitrogen bond and 1 labile iron oxygen bond. Dissociation of iron from hemoglobin active site requires simultaneous rupture of 5 iron nitrogen bonds. That is why iron do not dissociate from the heme group, but at the same time exchanges with oxygen rapidly and reversibly. As you see some detail, so this is the octahedral iron, here is this splitting pattern, here is the square pyramidal geometry splitting pattern, and here is the iron nucleus, here is the outermost electron in a square pyramidal geometry. As you see, this is the electron distribution. The radius of this half spin iron is around 0.92 angstrom. When it becomes octahedral, after binding with oxygen, as you see, iron is transformed to a low spin iron, octahedral, radius is reduced to 0.75 angstrom, reduction by 0.17 angstrom, and iron sits inside the porphyrin cavity. So in this picture you will see more clearly, here is the deoxy hemoglobin and myoglobin, and this is oxyhemoglobin and myoglobin. As you see, the larger size of 5 coordinated high spin iron square pyramidal. Here it does not fit inside the porphyrin cavity. Oxygenation coordinately saturates iron 2, transform it into smaller side low spin iron 2 octahedral, which fits inside the porphyrin cavity. And one thing more must be very important, dj square orbital must be empty, because the iron atom binding oxygen with this dj square orbital and oxygen donating electron. So unless the dj square orbital is empty, oxygen cannot donate electron, oxygen cannot bind. Understand? So see which are the metal ions which can provide this environment. As you see here, iron 2 T2G6 dj square orbital empty, it binds iron oxygen reversibly and rapidly. Rho8 is at 10 to the power 6 times. Iron is a rapidly reacting metal ion. Cobalt 2 d7 electron, 1 dj square electron does not bind, oxygen is repelled, but because of this orbital degeneracy here, because there is dj square at the same time dx square minus y square, and this one is orbitally degenerate, undergoes John-Taylor distortion, and eventually this electron is lost, becomes cobalt 3, which is substitution inert. So iron 2 is kinetically labile, can bind and release oxygen rapidly, reversibly. Cobalt 2 tetragonally elongated by John-Taylor effect, kinetically labile, only 2 to 3 minutes. But readily oxidizes to cobalt 3 under biological condition. So cobalt 3 is kinetically inert, cannot bind and release oxygen reversibly. Now the other metal that you see, nickel 2, cobalt 2, they contain dj square electron, not suitable. Then we have the manganese 2, manganese 3, again not very stable complex, not very, and the manganese 3 is very strongly oxidizing, and the chromium 3 very strongly reducing, chromium 2 strongly reducing, chromium 3 kinetically inert. So manganese and chromium 2 and 3 oxidation states, they produce paramagnetic products not suitable for hemoglobin and myoglobin, and iron is the metal of choice. So that is how nature selects the particular metal ion. And you see, I skip this transparency, skip this transparency, conclusion. So metals of life, these are the metals of life. All are actually light and rapidly reacting metal ion. Nature prefers lighter and kinetically labile metal ions. Properties of the metal ions in metal enzymes are often profoundly modified by the protein ligands. Biological metal ions remain tenaciously bound to the active sites of the metal enzymes, at the same time exchange rapidly and reversibly with the substrate, that is dual nature. It is not by mere chance that the nature selects specific elements or compounds of specific function in the biological, for specific function in the biological system. Nature selections have firm chemical basis. Biological chemistry of metal ions are reflections of their inorganic chemistry in general, coordination chemistry in particular. What is bioinorganic chemistry? It is an interdisciplinary subject for studying the role of chemical elements, particularly metal ions, in the biological system through model studies with relatively simple molecules of known structure and function, often give clues to the roles of metal ion in biological system. Future prospect with development of newer techniques and methodologies for studying biomolecules, the treasure of knowledge in the complexity of biological system is ever increasing. Finally, what is life? So two distinguished people, distinguished persons from widely different schools of thought define life in their own language. See, living is increase of disorderliness, delta is positive. Non-living, increase of orderliness, delta is negative. Even Schrodinger, heard of this name? And see, Swami Vivekananda. Expansion is life, contraction is death. One from thermodynamical sense, a theoretical physicist, Schrodinger, and the other, the religious man. Both define life and in their different language, but the meaning is almost same. Now at the end of this talk, I like to pay my most respectful homage to Acharya Pramod Chandra Rai, who was my grand teacher. Thank you very much for your attention. हाँ 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 Free to ask me question. Short question.
Hello. Students, if you have any queries, you may feel to ask sir. Anyone? Please raise your hand. And also faculty members can ask any question. Please.
Don't hesitate. It does not mean that whatever you ask, I will be able to answer. may so happen that I learned something from your question. And I tell you, during my career as a teacher, each and every day, I learned something from the students. Understand? Don't get afraid. I don't mind.
Please, anyone?
Okay, thank you very much.
Okay. Since there is no question, so we are thankful to. Okay. So you may ask question outside of the room after during the lunch break. Okay. And we are thankful to you, sir, for your nice and informative lectures. Thank you, sir. ট্রেটাকে নিয়ে আসো, ট্রেটাকে দাও। So now I request our beloved teacher, Professor Chandrakanta Bandyopadhyay, to come on the dais. Please, sir. Now I request our librarian sir, Dr. Ravi Kumar De, to felicitate our sir. I request Dr. De to introduce Professor Bandyopadhyay. Please.
Dr. Chandrakanta Bandyopadhyay did his BSc, MSc and PhD from the University of Calcutta and joined Ramakrishna Mission Vivekananda Centenary College as a lecturer in chemistry in the year 1984 and superannuated on 31st of January 2023. As head of the department, at present he is working there as an emeritus professor. After doing postdoctoral research for a short time in Taiwan, he started his independent research in his college from 1996. He has successfully completed 2 minor research projects from UGC, 4 major projects from UGC, DBT and CSIR. He has published altogether 67 research papers in peer-reviewed national and international journals, of which 52 from his college laboratory. He guided 5 students for their PhD degrees from the University of Calcutta. He has authored 2 books. The first one is An Insight into Green Chemistry, and the second one is Basic Concepts on Solid Phase Synthesis and Combinatorial Chemistry. He has been awarded with Professor Navneet Rao Best Teacher Award in the year 2013 by A.V. Ramarao Research Foundation, Hyderabad, Coastal Chemical Research Society Award in 2015. He has received Certificate of Excellence in Teaching from UNICEF in 2021. Now I request our sir to deliver his spacious lecture. Sir, please come.
Thank you, Ravi, for your nice words of introduction. না গো এখানে একটা স্ক্রিন চলে আসছে ক্রস করার জায়গা নেই তো দুটো ওই দুটো মূর্তি আছে ওই মূর্তি তো না ওই তো ক্রস থাকবে তো আপনার ছবি ভূতের ছবি দেখছি তো না এক মিনিট এসো I have product key করে দিলে হবে না সাইন দিয়ে চলে আসবে এই ক্রস ছিল না সব কিছু যাবে কোনটা দিয়ে স্কিপ ফর নাও স্কিপ ফর Respected GNM sir, respected R.P. Sarkar sir, and respected other distinguished dignitaries, and my respected teachers and my dear students. At the very beginning, I like to express my sincere thanks and gratitude to our Principal Maharaj, and especially our convener, librarian sir, Dr. Robi Kumar De, for inviting me and giving me this opportunity to share a few words with you. Today, the topic of our discussion is book reviews on green chemistry. First, I like to show you the picture of the front pages of a few books on green chemistry. And before going into the contents of these books, I like to introduce before you what is green chemistry, why it has been introduced into the curriculum, and what achievements have been done after introducing this green chemistry. So let us start our business with what is green chemistry. Actually, green chemistry is a very small part of associated with environmental science. And if we make a gradation, then environmental science, then environmental chemistry, and then green chemistry. Now let us start from the very beginning, that is the environmental science. What is environment? If we consider our very common equation in thermodynamics, that is universe is equal to system plus surroundings. And if you yourself be considered as the system, then the rest is the surroundings, and that is the environment. Now, environment made up of what? Made up of some solid, some liquid, some gas, and some lives. So if we think about the solid in the environment, that is the lithosphere, that is the outer mantle of the earth. And if you consider about the liquid, that is the hydrosphere, that is the all water bodies. And regarding the gas, that is the atmosphere. And you know that is a large blanket of air which is protecting our earth. And the atmosphere is again classified into different layers, that is troposphere, stratosphere, mesosphere, thermosphere, exosphere, magnetosphere, like that. So there are many gradations of the atmosphere. And then another is the life, that is the biosphere, and this biosphere is the kingdom of the living organisms. Now the question arises, why we are going to consider about the environmental science? Practically because, and now first of all I like to tell you that if you consider to study the environment, then you have to take help of physics, chemistry, mathematics, zoology, botany, geology, everything. So almost all science subjects you have to consider, and that's why you can consider that environmental science is a multidisciplinary science. Now the question arises, why we are going to consider this environmental science? It is simply because environment is now causing suffering from some problems. As environment is suffering from problems, that's why we are so much interested with this. Now whenever I think about any problem, that is someone is suffering from problem, I always remember Swamiji and his words, that is, you are responsible for your own suffering. So if we are responsible for our own suffering, then why not the environment? So definitely that environment is also responsible for its own suffering. But how environment is going to be responsible for that? It is simply because the environment has a component, that is the biosphere, and there is a species who is very intelligent, smart, and highly equipped, and that is the man. And actually man is responsible for this type of suffering. But why? Because man is very greedy. They always wants to meet their own demands. What they want today, they want to meet it today without looking at the interest of the future generation. They don't try to think what the future generation will get. They don't think that. And they just think that what I want to do, I shall get it today. And that is the problem why the environment is now suffering such problems. Now let us first consider what types of problems are there in the environment. I can classify the environmental problems into 3 classes. Some are international problem, some are national problem, some are regional problem. What about the international problems? All of you know global warming, some greenhouse gases are responsible for that, you know. Ozone layer depletion, halogen and halogenated compounds are responsible for that. It is in the troposphere and stratosphere. Then the layer is gradually thinning up. So UV light can come here and can affect us. And there is the acid rain, you know, sulfur dioxide, nitrogen oxides, these are responsible for this. Marine pollution, all types of waste from the industries are coming to the water bodies. And practically in the water bodies, when lot of phosphates come, then some lot of phytoplanktons and some alga blooms may take place, and that release much toxins, and that affect the life of the aquatic life. And if you consider one thing, that at one time it was believed that the Mediterranean Sea turning into the Red Sea. If I look at the Mediterranean Sea, and if you look at the neighboring countries like Algeria, Libya, Egypt, Morocco, they actually took 7.5 million tons of fish in 2017 they have collected. So definitely collection of so much of fish, it is affecting the ecology. So these are some of the international problems. Now coming to the national problem. Our national problem is population. Practically 16% of the total world's population is in India, and we have only 2.4% of the land. So we are suffering from population density. And regarding the regional problem, I like to tell you about the London smog and Minamata disease. Minamata disease already Professor G.N.M. sir told it about it. I am just coming to that. That is regarding the London smog in 1952, during the first and second week of December, many people in London died because of the sulfur smoke. So, lot of sulfur oxides entered into the air, and they could not inhale, they could not breathe. Most of people were confined to room, and everything came to stand still during that time, and many people died, and that was termed as London smog. Another is Minamata disease that has been mentioned by Professor G.N.M. sir, that it was occurred in Japan. Practically Minamata is a city, and there is a bay that is a water body, and by consuming fish from that Minamata bay, many Japanese died by consuming their fish. And later it came to know, and they named the disease as Minamata disease, as it has the place is Minamata and the bay name is Minamata Bay. And actually methyl mercury is responsible. And why? Here again you see this Chiso corporations of chemical factory. This chemical factory was releasing the methyl mercury, and that causes the problem. So these are the different problems that the environment is now facing. Now the problem is, if you look carefully, that all these things are happened by the chemicals, that is by the hazardous chemicals. So we should come to the second step, that is the environmental chemistry. We should be interested with that. And what is there in the environmental chemistry? Actually in the environmental chemistry, it is the study of the chemical and biochemical phenomena that occur in nature, and we have to learn how the environment is actually functioning from the chemical point of view, and what are the constituents of the different systems from the chemical point of view, and what amount they are present in some uncontaminated environment. But now the environment is contaminated, it is no more uncontaminated. So what happened? Actually now we came to conclusion that man is responsible for this, because all these chemicals, hazardous chemicals, have been produced by man. So they are doing the harm. As man has done the harm, then the damage, So now man has come forward for damage control also. And what happened in 1970, first UN, they declared 22nd April as the Earth Day. And from that year onwards, almost all over the country, all over the world, all countries, practically they celebrate this 22nd April as the Earth Day. And but just celebrating one day, we are not going to solve our environmental problem. So then in 1972, actually 72, and a UN conference on human environment at Stockholm, they told that we should introduce environmental education among common people. What is that? It is just to enlighten the public about the importance of protection and conservation of our environment. We have to learn common people for this, and then we can get some remedy. What about maybe now, what we think that everything has happened due to some hazardous chemicals. Now what is the remedy? If we can change these hazardous chemicals to clean chemicals, if we can make some hazardous chemistry to clean chemistry, that is the only remedy to get rid of all these problems. And so what happened? Later, these terms are introduced. Some clean chemistry, benign chemistry, sustainable chemistry, and all these terms are coined, but people has taken widely green chemistry as their selected topic, and that's why we often use it as green chemistry, not as clean chemistry or benign chemistry, but these are for the same thing. Now here regarding the sustainable chemistry, I just want to mean that I have already told you that man wants to meet their own demand at the expense of the expense of their future generations' importance. What they are doing? Practically, they are now doing their developments just by using, say, petroleum products, that is the fossil fuels. If you consume fossil fuels so much, what will happen? One day it will not be available, because generation of fossil fuel takes about thousands and thousands years to form these fossil fuels. But if you can replace it by some vegetable oil or by animal fat, then it is very easy, because animal fats or vegetable oils can be readily replenished by reproductions or by cultivations. We can reproduce it. So this is the sustainable development. If you can do some development by such feedstock which are sustainable, that can be readily, that should be very good. So this is related to the sustainable, and now you will see that many seminars and symposiums are going on with that heading, that sustainable development. That is, everyone is now trying to do the sustainable developments. Now let us come to the green chemistry. Now we are coming to the green chemistry. Now how the green chemistry actually entered and how it started. In 1962, Rachel Carson, an environmentalist and a biologist, she wrote a book, Silent Spring. And in that book, she mentioned about the presence of pesticides in the eggs of the bird. And that was coming from the pesticides that is sprayed on the cornfield or paddy fields. And that is coming through the food chain and then coming to the eggs of the bird. And after that, in 1969, the US government first, they put an act, they put some rules, that is the NEPA, National Environment Protection Policy Act. And they made it. What was the motto of this rule? Their motto was that we should have to create conditions so that human and nature can exist with productive harmony. That is, nobody is going to disturb others. That is the rule of this. That was the rule. But nobody is want to follow the rule unless you impose it. And that's why in the next year, 1970, some environmental protection agency was made. And that agency, actually, what they did first, they banned DDT. You see, in 1970 in US, DDT was banned. But what I can remember that even in 1985 or 86, in our village, the DDT was sprayed. So we are lagging by about 15 to 20 years of US. Even in the case of the Drinking Water Act, if you see, Safe Drinking Water Act, they have imposed in 1974. But we are aware about it almost at the mid-90s. So again, we are lagging by this. Whatever it may be, the EPA, then second thing what EPA did, that is they told the industries that you are not allowed to throw the waste, industrial waste into the environment directly. First you have to treat it, that is you have to remove all the toxic materials from the waste, and then you can remove it into the water bodies or into the land. When this type of thinking is going on, then chemists think in some other way. What they thought? Chemists thought that if it is possible, if we can stop the formation of the pollutant, where it is going to be formed. It means, suppose I am just giving you an example, a reaction that produces A and B. If A, B is your desired product, then B is the pollutant. Now, if the chemistry be designed in such a way so that you are doing the chemistry so that only A will be formed, B is not going to form. It means the pollutant, formation of the pollutant is stopped. That is prevention of pollution. That is, they suggested instead of the remediation of pollution, that is you are developing the, you are generating the pollutant and then you are removing it. That is the remedy, you are giving some remedy. That instead of the remediation of the pollution, you just want to prevent pollution. That is prevention of pollution. It was suggested by the chemist. Then in 1990, George W. Bush, he gave another act, that is Pollution Prevention Act. Again, that is pollution, nobody is allowed to create pollution or nobody is allowed to create pollutant or generate pollutant. So what happens? Unless you give some incentive to the people, people generally do not work. And what? Practically Clinton understood this, and in 1995, he declared the Presidential Green Chemistry Challenge Award. And after that, practically many industries, many laboratories, they are so much interested with green chemistry. Now these are the different companies, they got their awards later on. And here is a book. This book is written by Paul T. Anastas and J.C. Warner. This P.T. Anastas, he was the head of the R&D, Research and Development section of the EPA. The EPA, the Environment Protection Agency. In that agency, there is a R&D department, and he was the head of that department. Practically, he first introduced 12 principles of green chemistry, and he practically these 12 principles of green chemistry actually guides the people how to do green chemistry, what should be done so that the hazardous chemistry can be transferred to the clean chemistry or like that. And in this book, History of the Green Chemistry, 12 Principles of Green Chemistry, Official Rules and Regulations, and a few examples are written in this book, because there are a few examples, because at that time, no much development, so much development was not held in green chemistry. Now these are the 12 principles of green chemistry. I am not going into discuss all these things, but just to memorize these 12 principles of green chemistry, the chief editor of Green Chemistry Journal, Martin Polyakov, in 2005, he made an acronym. This is the productively. It has 12 letters, and these 12 letters will help you to memorize the 12 principles of the green chemistry. Now the question, let us come to the field. What to do? If we want to do green chemistry, what should be our motto? Our main motto will be that development should be definitely sustainable. That is, we shall make developments which can be sustained in future. Future generations will also be able to do that. That is the sustainable development. That is the first motto. And in doing so, we shall not disturb the environment. That is, that should be done by environment friendly. That is, our motto is that environment friendly, sustainable development should be our motto. So now let us, this is a book. This is by Sanghi and Srivastav. He wrote this environmental friendly alternatives. In this book, he has contained many solvent-free reactions, microwave-induced reactions, and reactions in ionic liquids and supercritical fluids. This type of things they have introduced into this book. Mainly different examples are there. Another book in 2004 by Aluwalia and Kiduai. Aluwalia actually written many books in this green chemistry. Examples of chemical reactions involving green solvents, green reagents, green catalysts, etc. Now let us come to another thing about the solvent. If you think about, consider about the chemicals. Chemicals are the hazardous things. Now you think in a chemical reactions, if you just react 200 milligram of A, so molecular weight 200, so 1 millimole of A, 1 millimole of B, you are going to react it, and for this you are using 30 ml of methanol. and 30 ml almost 1 mole. It is 1,000 times. That means solvent is used almost 1,000 times and you are getting 1 millimole of product. To get 1 millimole of product, you are using 30 millimole of the solvents, 1,000 millimoles of the solvent. So if the solvent causes harm to the society, then that is the main source of doing harm to the society. So we have to be careful about the solvent, because in organic chemistry, commonly used solvents are methanol, ethanol, benzene, toluene, all are volatile, all comes to the air and causes inhalation problem. So we have to stop the use of the such hazardous solvents. So instead of that, if we can stop using solvents, if we can do some solvent-free reactions, that is good. Otherwise, if you have to use solvents, then you have to use innocuous solvents, benign solvents, which are not going to do any harm. That is water, supercritical carbon dioxide, ionic liquid, fluorous solvents, polyethylene glycol, these are considered as the green solvents. Actually, water and carbon dioxide is not doing any harm. But these things, the ionic liquid, fluorous solvents and polyethylene glycols, they are not volatile at all. That's why molecules are not coming into the air. That's why they have been considered as the green solvent. So these are the different green solvents that can be used. Water is the most innocuous solvents and benign solvents. But organic chemists are not interested with that, because most of the organic compounds are insoluble in water. So they don't want to use it. But if you look at the nature, in living bodies, in plants, in animals, so many critical organic reactions are going on. What is the solvent? Solvent is water. So nature is doing so many critical reactions in water. So what should people do? Should the organic chemists stop doing reactions? Definitely not. They should take lesson from the nature and should learn how nature is doing reactions. So they will try to learn from that. And practically today, many people have done many reactions in water and many developments have come out. Now this is the book that is written by Aluwalia and S. Verma, that is Green Solvents for Organic Synthesis in 2009, and here he used different chemical reactions in benign solvents like water, supercritical carbon dioxide, ionic liquids, PA, polyethylene glycol, fluorous solvents has been considered into this book. Now after considering the solvent, I like to tell you about the energy source. Practically what we do, generally when we do some chemical reactions, that is by just heating, using heat energy. And what we do, if just to warm a beaker on some water, we took some water on a beaker, we put it on the Bunsen burner, make the Bunsen burner on, and then lot of heats go outside, only a portion of it is used for heating the water. So heat loss is maximum. Instead of that, if you can use immersion heater or you can use heating mantle, that is much more beneficial. Whatever it may be, but now people are trying that alternative source of energy than the heat energy for doing the chemical reactions. And these alternative energy sources are microwave or ultrasound, that is sonochemistry, mechanical energy, using mechanical energy, that is the mechanochemistry, light, photochemistry, electricity, electrochemistry. But these last two, light and electricity, it is a very old chemistry and its domain is very large. That's why it has not been considered into this green chemistry revolution now. But it has its own domain and it has a very large field. And now microwave, ultrasound and mechanical energy, this has been considered into the green chemistry, that is the sonochemistry or mechanochemistry. Now these are, if I check another book, that is, this is the book of Aluwalia, Greener Alternatives to Synthetic Organic Transformations. And here the objects is examples of different chemical reactions along with reaction procedures are given here. Short descriptions of the basic principles of the alternative energy sources are included. Till now what we have seen, that everything is going in the laboratory. But what is going in the laboratory is not going to directly help the human being. So we have to think about the industry. What type of developments have been done in industries also. So let us consider first a few examples in the paper industry. You know, papers are produced from the wood, and wood has about 70% of the cellulose and 30% of lignin. And lignins are the polyphenolic compounds. And just to remove these lignins, it needs oxidizing agents, and chlorine was used earlier. What happens? Lot of polychlorinated phenols come out, which are toxic. So to avoid that, now people use hydrogen peroxide using some iron complex, using tetraamido macrocyclic ligand, and they use this complex, and this type of work is going on, and paper industry has benefited from this. Now secondly, I like to tell you about the marine antifoulant. what is made in foulant? Practically when ship sails, a portion of it is under water and lot of slimes gathered on it. The slimes means the lot of algae, lot of crustaceans, those things adhered on that position. That is called the hull, the bottom position. What happens? It impedes the speed of the ship. As a result, more fuel is consumed. At the same time, if you want to free it, that is called dry dock time. You have to take the ship outside water, and then you have to dry it, then you have to clean it. And so a lot of time will go on, and that is also economically not viable. So what happens? Practically, people make the color with, these are the foulants. Those slimes are the foulants. And now the people add some chemicals with the paint so that the slimes will not be formed at the bottom positions. And these are called the anti-foulants, marine anti-foulants. And earlier TBTO, tributyl tin oxide, was used. But later in 1980, it was realized that TBTO is toxic and it is bioaccumulative. And it has a high half-life period. That's why, and it is causing harm to the many marine animals. That's why now people have changed it using this DCOI, and a company Roman has, the trade name is C9R211, and they have used it, and they got the Presidential Challenge Award in 1996. Then regarding the right fit pigments, that is the pigments commonly called contain lead, chromium, and all have some toxicities. So just to remove this, now people have used calcium, strontium, using different types of systems so that the toxicity is much less. And this Engelhardt Corporation has conferred Presidential Challenge Award in 2004. Practically this Engelhardt Corporation, this company has a very good safety first type of culture. Safety first means they don't start any project unless the safety considerations have been 100% addressed, and they will not start any program. So if this happens in all industries, then definitely in future we have a golden time. Now, regarding the biodegradable polymer, we know that the plastic polythenes are the non-biodegradable polymers, and we know many whales died by consuming a lot of plastics and polythenes in the sea. And now we have got some biodegradable polymer, of which the most important is the PLA, polylactic acid. And other than that, the polyhydroxybutyrate, polyhydroxyvalerate, bacterial cellulose, those also have been developed. And this polylactic acid has great use, not only in forming the bags or something like that, but it is highly used in medical science, in doing the sutures, in bone screw, and in all our biological system can accommodate all these things. That's why if you make a screw on your bone and you don't have to remove it, earlier the threads, after sewing some surfaces, you have to cut it and you have to throw out the seam. But today we don't have to remove it because the body will accommodate all these things, and these are made up of polylactic acids. And after doing this Nature Works LLC, they got the Presidential Challenge Award in 2002. Now we are coming to the healthier fats and oils by green chemistry. You know that LDL cholesterol is bad for our health, and practically TFA, trans fatty acids, are responsible for developing such LDL cholesterols. And when some fat, that is the triglycerides, has some trans double bond, that is bad. Cis double bond is good. PUFA, you know, polyunsaturated fatty acids. But if excessive unsaturation is there, then the system becomes rancid, because those fats and oils will not stay for a long time in the room, because the oxygen, these allylic carbon-hydrogen bonds are very susceptible to this oxygen, and they form hydroperoxides, and then carbonyl types of compounds are formed. That's why they are not, they cannot be kept in a room for longer time. But instead of that, if you want to reduce those double bond by catalytic hydrogenations, there is a possibility of isomerizations of cis to trans, but trans double bond is bad. That's why what is now done, it is done by interesterification. Just if you see, here is cis double bonds, here is no. If you want to cross them by interesterification, then you can get your desired product. And in doing so, the double bond is not going to be isomerized, and that is the good thing. And that interesterification can be done by chemically as well as enzymatically. And here the lipase, phospholipase, these are used. This lipozyme TL has been developed by Nevozyme and ADM companies, and they got the Nobel, the Presidential Green Chemistry Challenge Award in 2005. Now, regarding the recyclable carpet, you know, in the cold countries, lot of carpets are used, and the carpets have the PVC back and nylon front. That is the system. And waste carpet management is a serious problem. After using the carpet, you have to throw it, and when you burn it, then lot of this type of carcinogenic compounds are developed. That's why now PVC has been replaced by PO, polyolefin, and these polyolefins are lighter, and they needs no further plasticizers. Otherwise, in the previous case, phthalates are used as the plasticizers. That's why this causes problems. Now polyolefin is good, and these soy industries using polyolefin back and nylon face, they have been able to form recyclable carpet, and that carpet can be recycled. That is, after using it, you can again get back polyolefin and nylon back, and you can regenerate the carpet. So this is very good, and this soy industries got the award for this. Now coming to the biofuels, I've already told you that we are so much dependent on the fossil fuels, but we have to replace it. How to replace these fossil fuels? Simply by doing some biofuels. The biofuels are bioethanol, biodiesels, and you can generate bioethanol by fermentation of wheat, maize, sugar beet, soybean, sugarcane, like that. And this bioethanol, you can use it with petrol to run your car. Again, there are some biodiesels. Biodiesel is the methyl ester of the long chain fatty acids, and that can be done by simply transfer esterifications using sodium methoxide and sodium hydroxide to get this one. But this was not profitable earlier. Why not? Because the other component was glycerol. This glycerol has a little use in the market. That's why when this glycerol has been transformed into propylene glycol, this propylene glycol is very good. Among the common glycols, propylene glycol is not toxic. It can be used in food preservatives, in the cosmetics. In various places this can be used, other than the glycol systems. And after formation of this, now it is become profitable. That's why now people are trying to produce biodiesel, as the glycerol can be converted into some important materials. And after doing this, practically a team led by Galen Sapes, they actually done this glycerol to this one, and the University of Mussoorie, and they get the Green Chemistry Challenge Award in 2006. So from this we can see that these are some of the aspects that has been done in the industries also. Now this is the book. That book actually contains all these things. It has been incorporated into this, and I just like to tell you why I have intended to write this book. Practically during the year 2000, like 2000 to 2005, like that, when I have attended any seminar and some lectures on green chemistry was going on, always I was eagerly waiting that somebody will tell how the alternative source of energy is functioning. Definitely some mechanism, this either by microwave or by ultrasound or by mechanochemistry, some types of chemistry, some types of mechanism they will tell us. But I was disappointed. I got nothing. Only simple thing that I got, and that gave me the impetus to enter into this field. That is a paper in JOC that is by Marcus and Zhang. Practically this paper in JOC, they actually first discussed that in organic chemistry can be done in water. Even the compounds are insoluble in water, that can also be performed in water if some conditions can be attained. Those conditions they have mentioned, and here they gave a new type of concept, that is the transphase hydrogen bonding. As Marcus done it, that's why it has been termed as Marcus transphase hydrogen bonding. That was the first thing that I got, and I became interested with that. And then in 2012, 13, 14, in this time, I got some reviews in chemical reviews and chemical society reviews. Practically during these 3 years, lot of reviews have been written in the different journals and different chemical reviews and chemical society reviews. And there I found that they are trying to penetrate how these alternative source of energy is doing these reactions. They are not just by heating it. The heat energy is not produced by those different alternative source of energy, and then the reactions is going on. It is not just like that. It is something other type of mechanisms are going on. But although it is not clear cut even today, but they have tried it. And after getting all this information, I then thought that as I have got this information, I am trying to understand it according to my intellect, and so I should forward it to my readers. And then I thought that, okay, I can write a book on this, and by incorporating all these things. And then the green chemistry actually entered into your curriculum, and then just by observing the syllabus, what they have made, then I have tried to do it. Originally in 2019 I have written it, but then in the fully 19 first edition, then I could not completely cover the syllabus, but then second edition 2021 the syllabus has been covered. And what my intention was that if we can understand the mechanism, then it will be possible for us just by sitting in the chair and looking at the structures of the compounds, and then we can predict that these reactions that can be done by microwave, these reactions that can be done by mechanochemistry, this can be done by ultrasound. So this type of decision we could take by just by sitting and looking at the structures. So for that, in this book, it is my endeavor to enlighten the inner sense of the green chemistry. That's why I have named the compound, named my book as an insight into green chemistry, not just the introduction of green chemistry or like that, an insight into green chemistry. That once, to enlighten the inner sense of the green chemistry, once a clear picture can be drawn, the use of alternative energy sources will no more remain as a trial and error method. Till today, it is a trial and error method, but after that, and after my book, particularly another book, is written by Shankar Prasad Dey and Nohim Sipai. They have also they have taken many examples. I have not included many examples because many examples have been reported earlier books. Here he has again written many examples, and also the principles involved into the different greener approaches. And finally, thank you all for your patient hearing. If anybody wants to ask me anything, you can ask me.
Students can ask any question to sir. Any students? Raise your hand, please. Any question from faculties? Since there is no question, so again we are thankful to sir for his valuable lectures. So this is a lunch break. So স্টুডেন্টরা তোমরা সবাই পেছনের গেট দিয়ে বেরোবে, তোমাদের জন্য একটা ছোট্ট রিফ্রেশমেন্টের ব্যবস্থা করা হয়েছে। পেছনের গেটে ওয়ান বাই ওয়ান বেরোবে তোমরা। For physics topics, so I request Professor Devnaran Jana sir to come on the dais. Sir, as per your views. Now I request Dr. Ravi Kumar De to come on dais and felicitate sir. Now I request Dr. De to introduce sir, please.
Good afternoon. Dr. Devnarayan Jana, a brilliant academic record holder, completed the doctoral study from Raman Research Institute in 1997 and joined the Department of Physics, Narendrapur Ramakrishna Mission Residential College as a lecturer. In 2000, he joined the prestigious Department of Physics, University of Calcutta as a lecturer and subsequently promoted to Professor of Physics in 2012. Dr. Jana has served the Department of Physics, University of Calcutta since 2000 as a distinguished teacher as well as frontier researcher in both theoretical and experimental condensed matter physics. He had visited and delivered lectures in ICTP Italy, ETH Switzerland, CERN Switzerland, and other prestigious universities, institutes in Europe. He was a visiting fellow in CCMS, Taiwan, from 2003 to 2004. His first two students obtained PhD degree from university in the field of experimental condensed matter physics. At present, about 7 students are working with him for finish their PhD research work, and 16 of them had been awarded PhD. Apart from this, he has been involved in problems with non-equilibrium statistical mechanics, such as interface growth problems. Most recently, he has been actively interested in density functional theory studies of low-dimensional systems such as carbon nanotubes, graphene, and silence. Till date, 5 UGC DS Kothari postdoctoral fellows have joined with Dr. Jana. He was elected as a fellow of West Bengal Academy of Science and Technology in 2015. He was awarded as Distinguished Scientist in Physics by Venus International Research Award in 2017. About 32 PhD theses of different Indian universities have been examined by Dr. Jana so far. He has more than 190 papers in national and international peer-reviewed journals. Along with his distinguished collaborators, he had written 6 review articles, and one of his works in JNO published as an invited review in Progressive Math Science in 2009 is highly acclaimed by the material science researchers. As recognition of his research career, he is associated as a reviewer of many high-impact journals. Several popular science lectures have been delivered in various schools, colleges, and National Science Camp, Digha Science Center, to motivate the young, talented students for pursuing research career in science. Dr. Jana is also engaged in honorary guest teacher in the postgraduate course in Narendrapur Ramakrishna Mission Residential College. His 26 years experience in physics teaching has motivated to write 15 books in physics. 2 of them are published by Lab Germany. Of late, Government of India has honored him with prestigious INSA Teachers Award in 2020. Government of India for his accomplishment as a distinguished teacher over the years. Now I request Sir Devnarajan Jana sir to deliver his lecture. Please, sir.
Okay, thank you, Dr. Dev, for kind introductions. I think this is my second time visit to Rahara Ramakrishna Mission, Rahara Vivekananda Centenary College. I think last time it was in 2013, if I do not forget that thing, that was in the conference held by the Department of Physics. And this time, I think this is a little bit different job to me as rendered by your librarian. But I do not know how will I start and how will I finish. So let me try so that you can understand at the end of our journey that certain physics can be really understood in this way. So let me start this thing with these two books which have been referred. And mostly this book is there in your course in BSc curriculum prescribed by the UGC. And I'll tell that motivations behind that writing that book. And this is a different, I think, lookout to different kind of problems. And I will share that thing with you and as we go on. So let me start my journey, and this is the university that is more than 150 years. And I think most probably this floor was not there earlier. So this floor was built in later on. And this is a heritage building. So I request the students, if you were willing to visit anytime, I'm happy to help you. And recently there will be some kind of museum as suggested by West Bengal government on three genius, Meghnad Saha, S.N. Bose and C.V. Raman. And we have been allotted with Professor Meghnad Saha. Others have been allocated chemistry department and applied mathematics department. So hopefully that museum will be ready by, let's say, end of year or the next year. I do not know exactly, but some of these papers as well as their kind of used things will be displayed there. Most of them have been catered to different places, but we will actually rely on their students who have worked on themselves and under the mentorship of three genius scientists, will relying on their some kind of reminiscence as well as their any documents held by them, so that we can display to the students and the other visitors. So okay, let me go to the topic now. So question is that why do we write books? This is a very subtle question. Do you motivate or do you write because of passions? So there are kind of different kind of books, right? Novels as well as some kind of story or kind of some kind of thriller, or it could be science fictions or something else. Here I will actually concentrate on something which is based on curricular and little bit above the curricular. I want to learn something nature. That's our whole game. So when you would like to write a book, the first thing you should ask, do you have sufficient motivation or passion to write this thing? Is it really justified? So then you will have to give some kind of outline. How do you write this book? Sometimes you are given some kind of outline prescribed by the syllabus committee or kind of UGC. But suppose you would like to write some books on yourself. There is no kind of syllabus given to you. How do you do that thing? So you have to do some kind of studying your ideas and read many, many books and journals. Find out whether this writing this book is worth compared to other available books in the market. So you have to brainstorm your chapters to find out that this book lacks this kind of concept. You would like to introduce and verify with some example, and that can be directly used to research. So that kind of a path. So that means what I would like to tell you, which is really not a kind of actually a problem in our things, the teaching and research. Will you give a research to some kind of extra marks compared to teaching, or vice versa? I feel strongly, it's my opinion, that teaching and research should go simultaneously. So if you do a good research, you can teach that subject properly to the students. It's my believe. I do not know about others. Then you will have to, another thing, you have to look out for publishers. That's a very kind of bad game in our country and other things. Nowadays, after you write several books, you can get in an invitation from the publishers. But if you are a new author, who will introduce you? And in the initial stage, there was a really problem. I had to go move around many kind of publishers, and they refused to publish this thing. Then we will not gain money. So why you will publish that thing? That's the first thing you will have to convince. And so you will have to go through this step on your life, and ultimately you will get someone. Whether that publishers will not pay you or not, it does not matter, but you will get in. And once you have a new book, then you try to talk with this book with the researchers, your teachers, your students. Actually, your students are the best who can actually tell you, criticize you, and finally give you a shape to that thing. What we do is actually, once you write a chapter, I generally give to my students. Look at from a critical angle, not like I am your teacher. Just think about it. If you could write that chapter, how will you write it? So I am free to accept their reasonable criticism as well as other things. Then first thing you should always remember that for whom you are writing the books, who are the readership. That's very important. Is it book available only for the undergraduate or little bit postgraduate or kind of researchers? So you will have to specify explicitly the researcher, readerships, or kind of general audience, something like that. And then of course, you have to believe yourself that you can do. And the ethics, you have to believe that you are not copying anything from others. That's very important. The plagiarism is a really bad thing. You might escape at a certain time, but ultimately you cannot escape. So nowadays there are many softwares which can just within 10 minutes tell you that from which thing you have copied it. So you have to be very careful. Even when you write down a review article, something, if you are copying from your own work, that will also be caught. So you will have to reconstruct your sentences, ideas in a much more lucid manner. Otherwise, it will be very difficult. And you always have to be learner, meaning that you try to learn that this is not the ultimate what I would like to do it. You are still a learner. Like whenever I have gone to many places telling that, can you tell me what's your opinion about that? Okay, this chapter is not good. Even today I asked my student that out of this nanoscience, all the chapters, which chapters do you like most? Because this book, nanoscience book, has been written by two authors. One of my colleague is there from Scottish Church College, Dr. Upendranath Nandi. So he has written some of these chapters and I have written the other chapters. But the students can easily find out who has been written which chapter. I am not telling that. Okay. So given that thing, how to do another thing, that is everyone, whoever is a writer, they will feel that the first few lines, you will always strike it, that it is not the correct. But the suggestion is that whatever you write it, you keep it attacked. You write down another way. Because you might get a better kind of language, better kind of observation later, just looking at that thing. That can inspire that languages in a many way. So you write every day whatever pages, you don't keep a complete that I have to finish within that thing. Sometimes publisher will say that when that you finish within 10 days or 2 days, do not restrict yourself, because that time your new ideas will not blossom in a very nice way. So keep yourself, do all the other things, like whenever you are writing a book, don't think I will not take classes. Even today also I have taken classes in the morning, 2 hours.
and then I have come. So whatever duties are allotted with you, you do it. It does not matter. Let that thing will come out in a nice way.
And don't edit as you write. Get rid of distractions. Sometimes you take a break.
And always you discuss with that thing with the senior most who have already written many books. Try to ask something somewhere you have stuck somewhere, you are not been able to get rid of that simplest thing from a tough calculations. Always take help of senior. There is nothing wrong in it. He will also be learning to know that whether you are writing in this capacity or not. So it is better always to talk about the senior persons who have written books. I have also consulted many books from abroad and other things. Even the senior most from Vishwabharati University, Jadavpur University, there are seniors more worker. And then we have talked about very few chapters that how do you look at it. So get all these things. And nowadays all these chapters are peer reviewed by the different class of people, and then it will be given the report, then it will be again revised it like that way.
Okay. So with that thing, I think I have been able to transfer some message for what is the motivations for that thing. So now I will go very quickly. This is a quote from Wigner. I will not go to the details of that thing. Let me go to, this is the first book written from this Lambert, in the early stages of this dimension analysis, and that was an invitation. And this is the book, I think, which that book was quite costly and people are not willing to get a copy. So then it was requested, and then we have placed this thing. So let me start with this very simple thing which you have learned in your class 8 and 10, how to prove a Pythagorean theorem from the very basic problem. So you look at this can be done very nicely with origami, and you can write down this and make it fold many times to show that the total area is really constant. There's a very nice way of illustrate. I think it is illustrated in class 7, 8 classes. But the question is that can I prove this theorem from simple dimension analysis? So you know that this area can be written as a square terms, that is c square, length square, and this is an angle between them. So we are drawing a perpendicular to that thing, and then you look out the property of similarity, and this total area is sum of these two area. And once you do that thing, we can actually do that calculation, taking that thing that f theta is a function of both theta, and you strike off this f theta from both sides, you reach these equations. Now instead of theta, you could also have an angle phi here, this small angle phi here, and this argument goes on till you believe yourself this triangle is drawn on plane surface. Suppose you draw a triangle on a balloon, that's a curved surface. Try to do yourself and find out that this argument will not work. Why it does not work? I am showing that line. So because there is this ratio will come out. So that's why because of this a by r and b by r, I cannot now strike off this f theta phi which I did it last time. So it shows that the surface, that is the planar geometry, is much more different from the curved space-time. And that's a very interesting thing. Only in the limiting case you can give rise to this thing, and then we can strike off this other thing. Now this is another interesting thing. I am sorry that this thing is not written, seen properly. This is that why there are no small animals in the polar regions. This is not a question from biology. I am trying to see from the physics angle of view. Right? Whoever has observed National Geographic Channel, you might think there is not kind of a small mouse or a small rat in the polar region. You will see a polar bear of huge size, right? Question is why is this like this thing? The answer is that heat loss is proportional to the surface area and the mass is proportional to the volume, and as a result you will find out that heat loss per mass is proportional to 1 upon L. And that's a very crucial thing for existence of this polar bear. And let me actually calculate this for you, that this polar
beer, this mouse is length is 5 centimeters, so 1 upon L is 20 meter minor inverse, and this is 0.5. So you look out that the ratio is almost 40 times. So the heat loss is huge for mouse, so it will not survive there at all. So that's a very important thing. Whatever you are staying here, that basal metabolic rate, you have learned that thing in your class 8 class and other things. So that's very crucial, and this thing is also crucial when you learned about the nanoparticles also. This surface to volume ratio is a very important factor. Nowadays this drug delivery or the cancer research is based on this simple dynamics. Okay. So there are many kind of dimensional analysis can be done. This bomb burst is another problem, which is called the Taylor problem, which you can show that this radius of blast will proportional to t to the power 2 by 5, and you can see that there is a very nice logarithmic fit of log r versus log t, and with this value, these are all real data taken from the where this bomb were blast. And you can take this ratio correctly and predict that which kind of bomb will excite that particular type of energies. So this is the way, depending upon this slope, you can actually calculate that value. So you do not have to prepare that bomb, but given that compositions and the time, you can exactly tell you what is the energy associated with that thing. Then there is also problem with gravity. This is another problem. The pressure is proportional to this rho square r square. I think these are the textbook problem. This is a wonderful problem which you have seen in your class 10 book, and this was called Isbas formula. The problem is the following. Suppose there is a large stone and there is a river which is flowing over this. It is carrying that stone. So what will be the relation between the mass and the velocity of this thing? So this problem is actually taught now in class 10 Madhyamik classes, and you will find out that mass is proportional to the 6th power of the velocity. And this problem has been already, I think, given in many competitive exam and other thing. So I do not know whether in teaching class 10 geography, people do actually do this analysis. There's a very simple thing which was already done in 1932. Okay, and there is also this kind of fluid dynamics problem, drag force. You know that Reynolds number and other things. I'm not going to the details of that thing, but you can play around that thing with this thing and find out what are the important parameter associated with that thing for the validity of Stokes' law. And this is a very interesting problem. I think whoever has visited Kerala, they must be acquainted with this snake race. And the question is, do you think the many number of rowers will give the increase of the velocity of the snake boat? So how does the velocity depend upon number of rowers? So you can actually play around this Archimedes principle and simple drag force. You will find out that's a very unusual number which you can find out that is n to the power 1 by 9th. And this number has been tested also in Olympic, and it turns out that it works very nicely. So that simple dynamics based on drag force and the Archimedes law can help you to find out this velocity. So the next part of this thing in my dimensional analysis, I have tried to focus on some problems on quantum mechanics, where it is not actually stressed that some of these calculations can be done by simple dimensional analysis. So let me actually illustrate one thing with the, if the potential has the delta function, we know that how to do exact calculations, but simple dimensional analysis can tell you that it depends upon the square of the strength of the potential. So exact result is actually half of that one, which you can find it out by the Schrodinger wave equation solution. But most importantly, that if a Vx is g to the power mod x to the power nu, you can find it out either by WKB approximation. By this method, I think it is easier that you can exactly find out this h power and g power. But n being a dimension less, you can give a simple argument via the block Bohr-Sommerfeld quantizations that it will scale as 2 nu divided by nu plus 2. I think this problem has been there in net set exam 2 to 3 times, which is given 5 marks, you can do within 2 minutes, if you know this scaling like this thing. There's a very reliable calculations which you can do it anytime, and you do not have to remember anything. These are the kind of different cases which you can check before you find out the final formula. And the Stephen's law, in a d-dimensional world, you can actually calculate what will be the form of that, and this turns out that kBt to the power d plus 1 into h cross c to the power d, and that tells you that it coincides with that thing. Not only that, you can also have degenerate electron gas, non-relativistic, ultra-relativistic, bulk modulus. All these things can be understood on the basis of this thing. And that's a very another interesting thing. You might be worried about why does this thing happen. And this was actually shown by a nice person, one of the leading scientists, expert just 2 years back, T. Padmanabhan from IQAC. So question is, I was also wondering, you must also be wondering, why this Rutherford formula is it classical or quantum? What do you say? Does it depend on Planck's constant or not? So that problem was understood in the basis of doing this Fourier transform, and a special case of Coulomb potential, it turns out that it is independent of H cross. So this is one of the very rarest problem in physics, where both the quantum mechanical result and classical mechanical result yield the same expression for Rutherford scattering cross section. And you must be wondered, this the Rutherford scattering cross sections was a wonderful way to test the nuclear size and the dimensions of this nuclear size, and also the empty space. And this thing I will show you towards the end of my talk, where I will show a simple video based on this particular thing. So let me go on to quickly to other kind of problem. I am not going to do that thing. Let me go directly to the result. This is the dimensional analysis, what you can do it and what you cannot do it. Of course, this pi factor, this numerical factors which are dimensionless, I cannot do it, but at least I can understand what are the major factors which can affect my measurements or the understanding of this particular problem. That can be understood via this thing. And now I am going to the other book which I talked about, this nanomaterials, written by another colleague, and this is the latest one, second editions, where we have corrected few things. So let me start with this. I think you know this piece sheet. I don't have to tell the name of that. So it was a talk given by this annual plenary talk, annual program of American Physical Society in 1959. He actually visualized that there could be a possibility of having nanomaterials. Okay, so he actually explained this thing that time, but it took a long time to actually experimentally observe it, and then nowadays the area is actually nano. So I'll start with that simple quotation from Leonardo da Vinci, where nature finishes producing its own species, man begins using natural things and with the help of this nature to create an infinite of species. So it was there already in the nature. Where? So let me go to the little bit brief history of that thing. So 500 to 1400 stained glass, if you visit some kind of church, you will find out the color of different types of glasses there. And with this sunlight and sunset, that color actually changes. Even the nano particles in pottery, Damascus steel swords, and also somebody who have visited, let's say Srirangapattanam. Do you know Srirangapattanam? Anyone? Srirangapattanam is famous for what? Quick question. It is Tipu's capital, Tipu Sultan's, right? So if you visit these places, Karnataka, you will find out there was a sword kept in open air. Till now there is no kind of any rust on it. So it's amazing. A small crust of carbon in a particular type of steel has made that, You look at this, how many years it has been kept in open air, there is no kind of rust. And nowadays nobody know what is the particular composition for it. That person who has prepared that sword, he also did not transcribe that thing. But we can now find it out by looking at the composition of it. And that has been found out now. What is the particular composition of carbon in steel? That particular composition has made this sword is a very nice one. Then Feynman's speech in 1959, and this nanotechnology word is actually first coined by Taniguchi, Japanese physicist, and the first atom seen in STM 1981, and then 1986 onwards, people have started talking about this nanomaterial. This is an amazing figure of Likar gas gap, Roman technology, 4th century. In reflection and transmission, look at the different color. Even if you have visited Ajanta caves, you must go once in morning and another in the late sunlight. You will see the change of color in a different way. So that's a very wonderful thing which nature has created for us. And gold nanoparticles, if you look out it will be actually different in different sizes. You may not have seen the real gold. Whatever gold you see is already mixed with something, copper or something. If you would like to see the real gold, you must visit Raman Research Institute, and there is a 5 kg old gold there, where it was found out from a very natural mine in Karnataka and was presented to Raman by a king. And you can see that thing, color is pale yellow, right? And you will see that this color will change accordingly if you change the wavelength and other things. So I will request you, sometimes if you go to Bangalore for any trip, please visit this museum. It is free. It is, you don't have to pay anything. So let me start with that. Why is nanoscience so important? So there is something called a transition to different kind of physics on it. Since the particles are very small, so you know that you have to use the quantum mechanics. So the normal classical mechanics will not give you result. So the quantum mechanics is so important. And also, you know from statistical mechanics that if the number of particles are very small, the fluctuation will be quite large. So you'll have to build with these statistical mechanics and quantum mechanics, right? And I'll be very happy to say you that just few days ago, the chemistry Nobel Prize has been given to Louis Bruce. So when I was there in Taiwan, I had an opportunity to meet him. I'll show his formula, how he adopted that thing. That was long back ago. Now he's around 83 years old, but his work has been rightly given an award, rightly detected, and he has been awarded Nobel Prize. So here is this, the different kind of structures, chromosomes, atoms. So the modern IC, which is containing this kind of magnifications with 10 micrometers, micrometers mean 10 to the power minus 6 meter. So this is the most famous nanostructure, DNA, which build almost all the activity in our body. So all these kind of structure, I will show a interesting video which will illustrate this point very nicely. And this thing which you have seen in every day, right? So this is basically a special property of lotus leaf. There is no kind of any dust on it. Self-cleansing property. And this has been rightly used by the Asian Paints company. You must have seen an ad in TV that there is a man sitting on a chair and a car is going very fast. That dust is there full over in the body of this man, but there is no dust on the walls. So there is a special kind of particles and a structure called titanium nanoxide with a specific structure. If you mixed with that thing with the paint, there will be no dot adhered to it. So it's a very wonderful control of cohesive nature of forces in and this has been really seen in nature, and the effect is known as actually lotus effect. Okay. So it has been used, and it is to deal with something like the surface tension at the nanometer scale, which is very interestingly, and I will show some kind of a computer photograph. This is the lotus leaf photograph. Look at this kind of small notches which has the nanometer size, and this has the wonderful property of this adhesive nature and cohesive nature, which has been proved. And there are also other natural objects. I have given a list of these things which have been made by men, and these are available in nature. Okay. There are many more lists. I have not done in a very nice way. But the most important thing which we'll want to bother about, that what are the typical interaction which are important for nanometry. We know that gravitational forces are not important. That's negligible because mass is small. Of course, the electromagnetic force is dominant. And quantum mechanics, as I have told you, is necessary to explain this thing instead of classical mechanics. And the other thing which I showed you earlier, that surface area to volume, that's also scale as 1 upon r. And of course, because of the statistics, you have to take into account of the appropriate random motions involve all these things. So here is also the same thing which have been illustrated. I am not doing that thing. The color is caused by basically the partial absorption of electrons in matter, and electrons are not free, they are confined. So particle in a box model can be used here, and it is nice to see that if you have a 100 nanometer gold particles, the color looks like purple pink. If you change this size to 20 nanometer, then it turns out this red. And if you go to the furthermore reduction to 1 nanometer gold particles, this color changes to brown yellow. So look at the change of this color, which is properly size dependent. And this can be understood, which I have told you, that is not free as in bulk gold. And this is the bulk gold, which looks like a yellowish color. And if you have a 12 nanometer gold particles, so it looks like red. So their interaction is completely different. So what happens if you size is reduced? So this is something like nanoparticles agglomeration. So this the discrete nature is changed, and as you go to edges and corners, clusters less than this size, you will have this. Furthermore, single particle energy levels, and the atom will have this thing. So atom, more atoms, then more atoms, and the size in 3 dimensions that will be there. And this is the thing which I was telling you for this Nobel Prize. This is the equation now is known as Bruce equations. And this term is simple particle in a box model. And only the contribution, this thing is very important. So 1.8 times E square by epsilon, some kind of Coulomb energy for that particular electrons. And this epsilon is the static dielectric constant. So look at these very simple looking equations which can be adopted for explaining the band structure of quantum dot and the observable property like absorptions and other things. So this formula, again I am repeating, this known as Bruce formula. So this is a Drexler, who actually again is one of the pioneer in this nanotechnology. This is a cartoon figure where we have used 15,000 plus atoms to have this kind of machine on a largest mechanical devices. So here is also another teeny machines which have been working in this Alex Zetelgoof. You can actually have look at this particular thing. So this is basically the carbon nanotubes, graphene and graphite. This is buckyball, fullerene. So this is 0 dimensional, 1 dimensional, and this is 2D. For this Nobel Prize was given, and this is the bulk graphite. And this is another book which I have written. that is with one of my postdoctoral fellow who is now in Vidyasagar College, Dr. Sumit Mondal. So this is a book which is for the researcher. So those who will finish MSc and then will go for research, there could be some challenging open problems are there, directly taken from the different review journals, and some hints have been given to pursue. So this is something like the PhD coursework which you will do before you start your actual PhD work. And this is the carbon nanotubes which we build in computer to calculate many properties. And this is the structure. First you have to build it before you start doing any theoretical calculations. Here is some Young's modulus calculations. I'm not going to the details of that thing. Let me show you some other things which you will be interested. So this is the quantum dots which have been used here to actually detect tumor in mice detections, and this has been very successfully to that thing, because this tumor will show different color depending upon your size of this tumor. So if you can inject that particular quantum dot into that tumor and you radiate with some ultraviolet radiation, you will find out the exact location of the tumor. That's very important. So there is another also called enhanced permeability and retention EPR effect, which is directly done for tumors kind of executions. You can actually target the tumors and which are normal blood vessels are not leaky, but tumors are leaky blood vessels from which you can swallow some kind of large nanocyte pills to enter, and then you can detect the region. So it is trying to locate your region of tumor as accurate as possible. Nowadays it is really possible. And this is another cancer therapy nanocells which have been working at a particular thing. I think I have another slide to show you exactly what happens here. Look at this video, so that I think it's not working maybe. So you first detect that cancer cell and particularly isolate that thing, and you use this, the width of this band properly, so that you can only kill those cancer cell, not the live cells. That actually is done now in Calcutta also, no problem. All the kind of radioactive source have been prepared now in Calcutta. So I am almost through with my presentations. So let me end with these famous quotations by Professor Richard Feynman. First we guess it, then we compute the consequence of the guess to see what would be implied if the law we guess is right. Then we compare the result of the computation to nature with experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it is wrong. In that simple statement is the key to science. It does not make any difference how beautiful your guess is. It does not make any difference how smart you are, who made the guess, or what your name is. If it disagrees with the experiment, it is wrong. And that is all there is to it. So this is another book which I think you'll find out some interesting questions and other for who are preparing for JAM. This has published. And this is another book from our group for CSR UGC NetSet. I think I'll present this book to librarian. So I'll now call him to come to the dais, and I'll give this book, a copy of this book to him. And this book is available in both in Amazon as well as in College Street. So with this thing, I will conclude. These are my present research scholars who are working with me. Some of them have already submitted thesis or actually working as RA and postdoctoral fellow. So thank you for your kind attention. So I'll present first that book, and then I'll show 1 5 minutes video to you. That will be interesting.
another just 5 minutes. Can you just switch off the light, please? Okay, thank you. Any questions, comments? Any questions? Any questions from audience? Please raise your hand. Yeah, sir.
So I am a layman in this area, but still I have a query in mind that once Galileo long back said that as above, so below. So how aptly it is fitting with your this presentation, and that present electronic microscope, how far it can go up to the nanoscale measurement?
Any other questions from faculties of Physics department? Okay. Since there is no questions, so sir, we are thankful to you for your nice presentation. Thank you, sir.
ফাইলটা ট্রান্সফার করে দিই ফাইলটা ট্রান্সফার করে দিই বসছেন স্যার কোনটা পুরো ফোল্ডারটা আর পিডিএফটা
hello 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 hello
স্যারকে টাইম মাইক দেবো টাইম মাইক দেবো
হ্যাঁ দিতে পারেন আপনি একটু বলুন আমি এটা
সুবিধা হবে কথা
হুম এই কর্নার ফাইল পকেটে নিয়ে
আরেকটু জানিয়ে দেবে? So we have Dr. Tilok Sinha on dais. I request Dr. Ruby Kumar De to come on the dais and felicitate him. And now I request Dr. De to address Professor Tilak Sinha, sir.
Dr. Tilak Sinha is an assistant professor in the Department of Physics at Narasimha Dutt College, Howrah. He did his PhD on nanoperturbative aspects of quantum field theory from Saha Institute of Nuclear Physics, Kolkata, and held a research position in the University of Wuppertal, Germany, before joining Narasimha Dutt College in 2007. His interests include ontological and epistemological issues in the foundations of quantum mechanics. I request Tilak Sinha sir to come and deliver his spacious lecture. Sir, please.
প্রেজেন্টেশন মোডটা কি দিয়ে করতে হয় বলুন তো? Okay, so these writings apparently are too small. Don't bother if you can't read them, because the slides are not for you, they're for me, to remind me of the content of my talk. So it's good enough if you can hear me. So I was asked to review on my book, the name of which is An Introduction to Quantum Mechanics, From Facts to Formalism. Now, I think there is something that I should say at the outset, that this was not the original name of the book. The original name of the book was Kindergarten Quantum Mechanics. And my dear friend Shankho did not like the name of the book. So in an earlier version, which I had sent over to him, he said that this name is not going to work. People are not going to take you seriously, so you had better change the name. And then I came up with this name, with this alliteration, From Facts to Formalism, which has caught on pretty well, but it has also attracted some criticism, which I want to talk about. Now, before I go into the content of the book, I would like to start with an anecdote. It goes like this. So 3 friends, some of you may be aware of this, but anyway, let's go ahead with it. So 3 friends, an artist, a physicist, and a mathematician, actually a logician, they were visiting Scotland. Now, Scotland is known for its natural beauty, lush green fields, very picturesque, and so on. So while they were walking the aisles of the farmlands, they caught a glimpse of a beautiful black sheep. So the artist immediately remarked, "Oh, mind, just see, all sheep in Scotland are so beautifully black." To this, the physicist friend jocularly added, "Beautiful, all right, that you could say, that's up to you. But beyond that, you can just say that only some of all sheep in Scotland are black, and if you like, quite beautifully so." To this, the logician, who was normally a quiet person, so he broke the silence and say, "I'm sorry, sir, I think you could just say that at least one sheep in Scotland is black, and that also on one side. So from the side they were looking at the sheep. Now, why did I bring up this anecdote? We would all expect that in real life scenarios, we would prefer to go with the physicist because he comes up with what is most plausible, what is most likely. Yes, some of all sheep in Scotland could be black. That is more likely than all the other possibilities. And almost a bizarre, impossible possibility was what the logician came up with. But the thing is, when we are actually trading into uncharted territory, then plausibility is a very tricky thing. Because plausibility, likelihood, our expectation of what something ought to be like depends entirely on our experience. And our past experience is limited by what we can perceive, our biological construct. So when we are in a new world, we could be faced with a situation where the only way out of a mesh of conundrums is to actually go with the logician and have this logical discipline to not let all our intuition, all our past experience interfere and adhere strictly to what we can see and what we have, the raw, crisp data. So I will actually start this talk while coming here. I was thinking about it, and I will actually not start from the first slide. I will actually start from the last one, because the last one doesn't talk about why I wrote the book, the title of the talk, but it's actually more about what I think is the real value of the book as I see it now after having completed the book. So let me quickly go to the last slide, and then I'll come back to the first. Yeah, so can I slide it down? Okay, so proponents of the Copenhagen interpretation, this is a jargon that we are all very familiar with. Unfortunately, if a survey is conducted as to what one means by the Copenhagen interpretation, Copenhagen incidentally was where Niels Bohr was from, and he has actually driven the view that is most practiced about quantum mechanics. So it got to be called the Copenhagen interpretation. But there are so many variants of the Copenhagen interpretation that if you conduct a survey, unfortunately you will find that there are almost as many Copenhagen interpretations as there are physicists, at least physicists who ponder about these questions. In fact, this myth was largely propagated by Heisenberg, who propagated this idea that we have a settled interpretation of quantum mechanics, which we don't. So when I talk about Copenhagen interpretation, I will actually refer to what is known as Bohr's version of Copenhagen interpretation. So this view of quantum mechanics, this view of the Copenhagen interpretation is largely and dominantly due to Bohr. So the proponents of the Copenhagen interpretation, they have always insisted on the indivisibility of the measurement apparatus and procedure with the quantum system. This means that there is no sharp boundary that segregates the quantum measurement or the quantum measurement apparatus and the system. So when I say the angular momentum of the electron, it has to be read together, the angular momentum of the electron. It's not the electron which you can identify clearly, you have a well definition for it, and you are measuring something called angular momentum on it. So it's one measurement, one hole, the whole thing is put in one bracket, so it's angular momentum of the electron. So they have always insisted, Bohr and people who have looked into it critically, I mean the entire generation of physicists, have come to accept that yes, we don't have a sharp boundary, a sharp segregation between measurement apparatus and the quantum system, the quantum measurement apparatus and the quantum system. Now, be that as it may, the idea of system is so deeply embedded in our psyche that the way quantum mechanics is read and taught actually does very little justice to clarify the fact that this measurement and system, these two concepts are inextricably intertwined. You cannot disentangle them. And the way we teach and the way we learn and the way we register quantum mechanics does very little justice to that. So when we say measurement on a system, so do I have it on my slide? I think I should. Yes. The last line on the slide, I think you can't read it, so I write measurement on a system, and then there are question marks and exclamation marks and so on. So if the system and the measurement apparatus are not different things, then how do you make sense of a phrase like measurement on a system? So what does one do from here? Actually, the way out of this conundrum was proposed by Bohr, and this was actually to take his notion of indivisible quantum phenomena. So that's the phrase he insisted on, by which he meant the indivisibility of measurement apparatus and quantum system. So why I say this is based on a lot of literature. So of course, I'm not explaining it here. I'm not explaining the part that when he says indivisible quantum phenomena, he actually means the indivisibility of the apparatus and the quantum system. To justify that, you have to look into the literature, but take me for granted on this. Now, the way around this is actually to take Bohr, the indivisibility of quantum phenomena, in all seriousness and start from there. So, this quantum phenomena is what I and the community at large refers to as quantum measurement nowadays. So the idea is to start from quantum measurement. Okay, not the quantum system, not anything else, but just measurement. In this work, the book, what I try and what I think I have at least partially achieved is that it builds the entire conceptual edifice of quantum mechanics. So all the concepts are built from a single primitive, which is quantum measurement. So everything else are emergent concepts, like system, observable, event. All these things are emergent concepts. They're all actually built and constructed from the single primitive of quantum measurement. So maybe because there are a lot of young students here, maybe I should say a word or two about what a primitive is. So for any discussion, for any discourse, you need a language. So, for example, now I am talking to you in a certain language, and you could ask me about the meaning of a particular word. So you could ask me what language means or word means. And then I would use some other words to explain that word. So I would use some sentences comprising other words to define, let's say, the meaning of word. And then somebody could ask me the meaning of those words, the words that go into that sentence, and then I will use some more words to explain them. So obviously this has to stop somewhere. The point at which they stop are called primitive notions in language. So primitive notions essentially comprise an agreement between people who are partaking in the discourse, where they agree that these are concepts that we will not ask the meaning of. So these concepts we will always, all of us, we will take it to be understood, and we will agree, we will assume that we understand the same thing about it. So the most famous example of primitive notions which illustrates this idea is the Zermelo-Fraenkel set theoretic program. So in this, everything in mathematics is described in terms of 4 primitive concepts: set, element, belonging, and equality. So this means there are 2 atomic sentences. A certain element belongs to a certain set. Let's say X belongs to A, or A equal to B. So these 2 sentences nobody is allowed to ask the meaning of, because we have assumed that set, element, belonging, and equality are 4 primitive concepts. Everything else, the integral, the differential equation, the differentiable manifold, everything that you can think of are actually expressible in terms of these concepts. Of course, if you start from these concepts and try to explain a Hermitian operator, it will be 3 pages long. That's a separate matter. But this is what it is. So much about primitive notions. So in this exercise, what I do is that I start by specifying what I mean by a quantum measurement, and then I build every other concept on quantum measurement. So in terms of quantum measurement, I define the other concepts, and then I go ahead and build the rest of the story. Okay, so it essentially provides an appropriate lexicon for BCI. BCI is Bohr's version of Copenhagen interpretation. So this Copenhagen interpretation, essentially the main idea is that it says that in quantum mechanics we don't talk about what there is, but we talk about only what we can see. So nobody has a clear idea as to what is going on between the slit and the screen when in a double slit experiment a particle is showing the interference pattern. For example, you're not allowed to ask which slit the particle has gone through. So what is happening, that is not the concern of quantum mechanics. That's not what quantum mechanics is talking about. So quantum mechanics is only about describing that what we can say about what we see. See, in the words of Bohr, he says, what we have done and what we have learned, period. So that's all quantum mechanics is entitled to talk about. So it's essentially about organizing our experiential data. And this part, what we have done and what we have learned, this totally involves what we know as classical. Okay? Because what we have done involves measurement apparatus, and what we see also involves marks and records on certain parts of the measurement apparatus. So this part is classical, and the behavior in this classical part, because of something which we don't know what it is, and quantum mechanics does not care to talk about that, at least in Bohr's version of Copenhagen interpretation, is the sole concern of quantum mechanics. So this main idea, of course, then he, in its full glory, there are some other features of the Copenhagen interpretation. So he classifies that what are the features that go into this way of looking at things, and that's not something that I wish to go into now. So the bottom line is, we are organizing our experiential data of some domain of our experience, which, quote unquote, we call microscopic experience. We don't know how microscopic, we don't know exactly at which length scale quantum mechanics comes into effect and classical mechanics stops being effective, etc., etc. But we know that there is some domain of our experience whose data falls into a certain pattern which we want to organize. Now, it's time that I came back to the first slide. So, obviously, I started writing up these notes. That was a very long time ago, because I was trying to understand the things and I could not. So, what is it that I did not understand that I think I understand now? So, it was all in this effort to understand the experiential, the pattern in the experiential data that we read as quantum mechanics. So, there are many things which are clearly understandable. So, what's the problem? We have a very well laid out axiomatic formulation of quantum mechanics. So, if we know the necessary linear algebra, so if we have the prerequisite, mathematical prerequisite, then you can even feed it to a computer. So, what is there to not understand? So, you have well-defined mathematical statements, which are the postulates of quantum mechanics. So, you just shut your mouth, do the calculations, and you know how to make your predictions. So, you make your predictions, and you're done. But the problem is that this does not give you any idea, any comprehension of what actually the axioms, the postulates, the laws of quantum mechanics are telling you. What did Einstein actually contribute in special theory of relativity? The entire content is encapsulated in Lorentz transformations. It's Lorentz transformations, not Einstein's transformations. So it was by Lorentz. So what did Einstein do? He provided the understanding. He allowed us to understand why Lorentz transformations have to be there in terms of something. So this is another premise. So principle of relativity and the constancy of velocity of light is just another premise. You could dispense with that and start from Lorentz transformations in the first place. But then they would look arbitrary. When you say it's principle of relativity, that the laws of physics are the same from all reference frames, that's much more natural. So actually, this also has to do with evolutionary biology and the way we are made. We like it more, the understanding, the derivation of Lorentz transformations from principle of relativity and the constancy of velocity of light, because it is aesthetically more appealing. It is something, for whatever reason, it's because of the way we are constructed, it's more comprehensible. So now let us come to the postulates of quantum mechanics. Slide is showing on this. It's better that I stand here. So, what sense do a young student make of a postulate like a state is a ray in a Hilbert space? Even further, an observable is a linear Hermitian operator acting on that Hilbert space. Orthogonal states. Compatibility is commutation. Degeneracy. All the different variants of quantization rules. Where do they fit into the grand scheme of things? What is the grand scheme of things? obviously nature cannot possibly unveil or reveal its nature in such a peculiar way that, well, an observable is a linear Hermitian operator acting on a Hilbert space. What sense do I make of that? What empirical fact, what experience is actually encoded in that statement? That's what I wanted to understand, and that was elusive at the time. So that's the struggle that eventually led to the book. Now, this well-framed set of postulates, the postulates of quantum mechanics, they are just a way of writing the laws of quantum mechanics, writing the content of quantum mechanics, and not the content themselves. So this difference between language and content is very important, because otherwise, if you identify the language with the content, then you don't see the power and beauty of the language. So you have to appreciate the content independent of the language. And this language, incidentally, was cooked up by none other than von Neumann, who actually wrote it up for his mentor, Hilbert, David Hilbert, who could not make head or tail of quantum mechanics. So he did not understand what was going on, so he asked von Neumann to make him understand quantum mechanics. And then it was von Neumann who actually uncovered the stuff, and he discovered that what was the underpinning mathematical structure of quantum mechanics, and the linear algebraic description of quantum mechanics that we study now is because of that. And Hilbert got his name into it, and it's on Hilbert space. So clearly, this existed before von Neumann did it. So this is only a language. With all its power and beauty, it's only a language. So it's important to understand that if this was only a choice, then what other choices were there? Why were the choices that we have made, why were those choices actually made? What would happen if we did not make those choices? For example, the additive identity vector has no counterpart in quantum mechanics. It's because we are using linear algebra, we are using vector spaces. There is no state nothing that corresponds to the additive identity vector, the null vector. But it comes to good computational use. You use annihilation, and there you know how you make the annihilation operator act on the ground state to give the additive identity vector and what comes of it. So it's important to understand the difference between content and language. And more importantly, it is important to understand what it accomplishes. So this is not a game. So what does it buy us? Why are we going to take all this trouble to write an experiential data or experience which we could supposedly write in a simple language involving high school algebra? Why shall we use functional analysis and linear algebra to express that? What does it buy us? So that is the next and most important question. Not that it can be done, but why the hell shall we do it? So that is the next question that was addressed, that I wanted to address, and hopefully I've been able to do it. So when I took it upon myself, to actually try to understand these things in a way that will give me some kind of comfort, and I was looking up Feynman, so Feynman lecture volume 3, the one on quantum mechanics, and I came across this comment where Feynman claims that the superposition principle accounts for all the mystery that quantum mechanics has to offer. But as is very common in the writings of Feynman, very rich, very dense in ideas, but quite often they are not rigorous, and he just leaves the loose ends and quits. So he claims that he gives you some ideas, but then he actually does not go all the way to establish how the superposition principle implies the entirety of quantum mechanics. So all the postulates that are there. So the totality of quantum mechanics implied by the superposition principle is what he promises, but he doesn't go ahead. So this, in some way, is the main thesis of the book that I was asked to talk about. So superposition principle implies the entire mathematical fabric of quantum mechanics. How? That's of course the subject of the book, and that's what students are invited to look into, that how I have tried to actually construct the entire quantum mechanics from this one formula that you see here, which is the superposition principle. Sometimes they use this jargon that quantum probabilities interfere. So this is not just about the mathematical fabric. It will not be too much of an exaggeration to say that at the heart of quantum mechanics is this thing, that quantum probabilities interfere. We know there are various laws of probability. Of course, they are laws of probability, so you cannot actually prove them. So this superposition principle is actually an augmentation to a law of probability. So there is a view, and some of you may have heard about it, which is called quantum Bayesianism, where the superposition principle is looked upon as an addition to the laws of probability. So this is the only thing that is different. Not that it is contradictory, and this is something that I write in the book and I explain at length, that oftentimes it is said that this is where quantum mechanics departs from classical mechanics. The superposition principle. So what is the let's quickly go through it. So how much time do I have left? Okay, so maybe I just then I quit the idea of explaining this. So normally what you have is, if there are two mutually exclusive ways of realizing a particular event, and for each of those ways you have a certain probability, then the probabilities add. For example, if you roll 2 die and you say that what is the probability that their sum is 4, then you add the probabilities of 3, 1, 1, 3 and 2, 2, these 3 possibilities. So you simply add the probabilities. In a superposition principle, you are actually not adding the probabilities, you are adding something like the square root of probabilities, which you call amplitudes, and then at the end of the day you are squaring that amplitude to get the probability. So instead of adding the probabilities, you are adding the quote unquote square root of probabilities and then squaring that to get the final probability, and as a result of which you get interference and all sorts of, all the mystery according to Feynman in quantum mechanics. So that's, and I will take just 2 more minutes before quitting. So when I committed to this task of actually constructing the entire fabric of quantum mechanics, which is reconstructing the postulates from the experiential data, where did I get the experiential data from? So you would expect that I have looked into the literature of all the experiments that actually implied the postulates of quantum mechanics. No, that's not what I did, and that's why I said from facts to formalism was kind of overstretched. Because what I have actually done is I have reverse engineered. So I have started from the postulates, and then I have worked backwards to start with an animated version of the data. So I have the postulates, and then from the postulates I derive backwards that what kind of experience could have led to these postulates. And they turn out to be the filtrate of all the experience that we have had. Now, there was a specific reason for doing that. Because if you look into the actual experiments, the details of the experiments get so dirty and so complex so quickly that they take you dangerously close to the fragile foundations of quantum mechanics. So it brings up that questions, difficult questions like, which part is classical, which part is, so you're looking at Zeeman effect, and you say that this part is quantum, but the magnetic field that you're switching on, that does not behave in a quantum mechanical way. And up to what extent, which parts of the entire setup count as the measurement apparatus and which as the system? Who is the observer? Are the photons the observers? Are you the observer? Is an ant an observer? Are the bacteria, the virus, they are observers? So all these very delicate questions, they come up. So it was always a good idea to spare the beginner of these foundational worries. So that's why I decided to go with cartoons without any compromise. Because if they are consistent with the postulates, then that's all there is to it. That must be the data. So from there, what I had done is that I have actually reconstructed everything. So here I had one example of the many. For example, this why observables are associated with Hermitian operators, but I don't think, looking at the face of my host, I think I will decide against it. Unless, of course, the House insists that I go ahead. 5 minutes. All right, then I go ahead with this one. So, the factual content without the facts. So, in facts to formalism, I talk about the factual content, but I actually don't give you the facts. So I actually don't talk about the real experiments in all their gory details. So here is an example of how I make sense of this thing, this association of observables with linear Hermitian operators. Now, it's quite usual, and this is often asked in interviews and examinations. Questions are set that why are Hermitian operators associated with observables, and you say because the eigenvalues are real and the spectrum, the outcomes of measurements are also real and so on. But this is bad logic clearly. This is something that, as young boys or girls, we have always faced, Rabindranath Ramchagol example. So Rabindranathero dadi ache, Ramchagolero dadi ache, so Rabindranath is equivalent to Ramchagol. So just because the eigenvalues are real and outcomes are also, measurement outcomes are also real, so, but that can't be good logic. So the way to go about it, so if I have to establish that observables are linear Hermitian operators, then what should I do? What I should do is that I should first, in a very natural, acceptable, experiential language, express what an observable is and what it is characterized by. For example, if it's an observable, then, or measurement, for example, then I associate that with a set of actions by which I perform the measurement. And there is a well-defined spectrum associated with that observable. So all the things that an observable is characterized by, I put on one side, I take on one side. And then I derive that that is equivalent to saying that an observable is a linear Hermitian operator. And this is how it goes. So the way we understand an observable of course has associated with it a spectrum. So a well-defined list of possible outcomes. That's its spectrum. Now, of course, this part I don't go into here in the talk, but it's there in the book and it's elementary, that corresponding to every member of the spectrum, that is corresponding to every possible outcome, there is a quantum state. and there is a guarantee that if you make a measurement of this observable, and if you find an outcome, and immediately afterwards if you repeat that measurement, then you will get that same outcome. The same outcome would be reproduced. And this means that the probability of getting the other outcomes are 0. So all these states, so I said that to every member of the spectrum there is a state, and because this state is sustained upon an immediate measurement, therefore these states must be orthogonal, because the probability, the inner product gives you the probability, the square of the inner product gives you the probability. So these states must be orthogonal. But if these states are orthogonal, then they must necessarily be independent. If they are independent, and if this spectrum is complete, that comes from the superposition principle, so then I have a set of, this is an assumption at this part, that the number of orthogonal independent states that I have associated with the spectrum of an observable, they are complete. Why they are complete? Of course, I don't explain here, but take me for granted on this, that if you are saying that every single outcome gives you a state, then that actually guarantees that if you collect all those states, then you get a complete set of states. So that means what you have associated with an observable is an orthonormal basis. Okay, so far so good. So if this is something that we accept, that corresponding to every observable, naturally there is always an orthonormal basis. Then let us come to operators. If an operator is a linear operator in particular, then it is enough to specify the action of the linear operator on the entire space just by specifying its action on the basis elements, because it's linear. So any vector which is a linear combination of the basis vectors, the action of the operator is well defined on that because the action is linear. So if I know the action of the operator on all the basis elements, if I specify that, then I have specified the action of the operator on the entire space. So at this point, I am in a position to actually define a linear operator associated with the observable. And this is my choice, my construction. How do I define it? I define it by the eigenvalue equation. So I just choose that when I make this operator A hat, which corresponds to the observable A, when I make this A hat act on A1, which is the state associated with the outcome A1, then I get the same state A1 multiplied by a real number A1. So that's just my choice and the construction. So having done that, I have actually been able to associate a linear operator with the observable. But why is it Hermitian? Linear algebra again. Because of two reasons. One is that by construction, by choice, the eigenvalues, so the eigenvalue is how I define the operator by the eigenvalue equation, that's a construction. The eigenvalues are real, and the eigenvectors of this operator, again by construction, form an orthonormal basis. So in the entire literature, you will see the converse of this theorem, which is just wrong. That does not establish the thing. So for a Hermitian operator, the eigenvalues are real and the eigenvectors form an orthonormal basis. This is something that we've been answering in questions since our childhood. But that is not the important theorem here. The important theorem is the converse theorem, that if you are given an operator A, and if you are told that its eigenvalues are real, and if you are told that its eigenvectors form an orthonormal basis, then it is guaranteed that that operator is Hermitian. So it's the converse theorem that is important, and that is the subtle point. See, it's all about getting the fine points right. So what we've been able to imply is that an observable which is characterized by a well-defined spectrum to each member of which there is a state which respects sustained states. If that's what an observable is, then it is equivalent to saying that an observable is a linear Hermitian operator. So I think before I get beaten up, I'll call it a day. Thank you very much for your patience.
Any questions from our audience? Okay. Sir, since there is no questions,
thank you.
So thank you, sir, for your energetic lecture. Thank you.
Thank you.
Now I request to come on as Professor R.K.M.V.C.COLLEGE, Professor of Library Science, University of Kolkata. चार्ज है ना
Hello.
তুমি দিয়ে শুরু করে দেবে এই আমি বললাম না So I request Dr. Ravi Kumar De to felicitate Professor P.S. Mukhopadhyay. Professor Mukhopadhyay will talk on open access. I will request Dr. De to introduce him. Please come.
Professor Partho Sarathi Mukhopadhyay is a professor in Library and Information Science and the head of the Department of Library and Information Science at University of Kolkata. Professor Mukhopadhyay, a recipient of the Best Young LIS Teacher Award, YesLeak, is an open source enthusiast and has worked as a developer and promoter of many open source projects. He is presently a member of the Koha and WhoFind international developer teams, two of the most visible open source solutions in the domain of library and information science. He has more than 150 papers in journals and conference volumes and 5 books in his beeline. His recent book on interoperability and retrieval was published by UNESCO in pairs. Professor Mukhopadhyay acted as a metadata consultant for the NDL, National Digital Library, hosted by IIT Kharagpur. He is presently a member of the advisory committee for the National Virtual Library project of the Ministry of Culture, Government of India. He developed Vidya Online as an e-learning portal for Vidyasagar University in 2006 and is currently running 3 online courses on the Shyam platform. He is presently an associate editor for the Journal of Information and Knowledge, one of the oldest LIS journal in India, initiated by S.R. Ranganathan sir, the father of library and information science in India. I now request my beloved teacher, Professor P.S. Mukhopadhyay sir, to deliver his lecture on open source.
So, thank you, Robi. And I am quite amazed by the energy level of the audience. We started with nanoscience, passed through quantum physics, and still you people are full, full house almost. So really, really salute to the audience. So as Robi requested to format this particular presentation in such a way that every author should talk about their book and mainly discuss the major content and major facets in that particular book. So I am talking about this book published by UNESCO, launched by UNESCO, and a series of books. One is for the researcher and students. Anyone can download. This entire book series are available as open access sources and anyone can download. It has got, there are 2 curricula, one for the librarians and library schools and another for the researcher of any discipline, irrespective of arts, humanities, social science, science and technology, does not matter. And it is based on some principles. I will be talking about that principles. And this particular curricula UNESCO designed by using an array of experts from different parts of the world. For example, I participated on behalf of my university, Kolkata University. There are people from different prestigious institutes from Argentina, South Africa, UNESCO Paris headquarters, Commonwealth of Learning. So we sat together throughout the week in Delhi and in one place in Sri Lanka, Colombo, and we came out with a series of books that anybody can utilize to know the concept and facets related to open access. So apart from being a part of this curriculum design committee on behalf of UNESCO, I also produced one particular book under it, interoperability and retrieval, related to this particular series, library school series, what I actually given here, this particular book, interoperability and retrieval. And like rest of the series, this book is also available under Creative Commons license. Anyone can search UNESCO open access curricula, they can download and they can utilize, they can learn the concept. But why, the question comes that why should we learn this concept of open access? So let me explain the philosophy of open access and how you people as students, be it UG student, PG student, researcher, faculty members, everybody can be benefited by this concept because we are consumer of information, we read information to contribute to the knowledge pool. Why do we people read? Why do we people write? What is the motivation behind it? Two authors actually explained their motivation. But one thing is that we are consumer as well as contributor of information. That's why we read, that's why we write. Now, do you agree with this particular definition of research? Research of any kind, it can be quantum physics, it can be nanoscience, it can be arts, humanities, social sciences. It starts with an existing piece of information and ends with a new piece of information, often in documentary format. You read a book chapter, you read a journal article, then you mix up with your own intuition, intelligence, with your own field work, lab work, and then you again tend to publish a particular
article or a particular book chapter. So every research of any kind starts with an existing piece of information and ends with a new piece of information. If you agree with this statement, then there is a point we can continue. If no, then the presentation ends here. Yes or no? Give me a binary answer. Do you agree with this definition? Okay. Okay. So if you go through this, the entire research output of India, in fact, the success of educational system of any given country is measured by the number of research articles produced by that particular country. So we analyzed the biggest bibliographic database called Scopus and found that in the last 25 years, last quarter of century, 1998 to 2022, India still manages top 10 position, even if it is basically in the 9th position, but it's actually light year away from US, 1.2 million, seconds come China, 0.6 million almost, India is only 0.16 million paper produced in the last 25 years. Still we manage 10th position, but positions wise we are decreasing every year by the number of research articles we produce. Why this happening actually we discussed in that particular book and what is the requirement. But before that you need to know one particular thing. In case of scholarly communication, the paradigm shift already happened. We generally talked about different kind of revolutionary changes and everything. The paradigm shift already happened because of these 4 factors. Right from the introduction of internet in the public domain in the year 1995, if you take that particular year as the cutoff year, then the paradigm shift already happened very quickly after that introduction of internet in public domain. First of all, this is acting as the platform for scholarly communication now. The entire internet is built on the top of open source software and open standard. On this top of these 2 ingredients, we are getting 2 beautiful products. One is called open access publishing system, another is open learning system. So today I will be discussing only open access, which basically the major or sole concern of the book I discussed about. Now you see this particular graph. From 1991 to 2006, because after 2006 the same story continues, that's why I have not given data. This blue bar indicates number of new print journal introduced in a given year covering all disciplines. Be it physics, chemistry, from alchemy to zoology, everything you take into account. The number of new journals, not the all journals, only new journal introduced, say in 1991, 1500. Then maroon bar indicates number of online journal. Online journal first we introduced 1996. Within 4 years it outnumbered the print journal, and you see the situation in 2006 and onward. Now the new online e-journal or online journal actually reached up to 3000 per year, and print journal reduced to 4 to 5. Complete paradigm shift in publication pattern. If you take into account another major device that we use for education and research, books. How books are changing. Particularly during this COVID period, the upper part of this slide you can see the revenue generated by e-books from 2017 to 2024, and almost an exponential increase, and the below part says how users of e-books are increasing. So 2 of the major important element of education and teaching, teaching and research are changing like anything. One is the journal. 90% of the research communication still takes place through journal. Another, the recent trend is e-book. E-book is also, books are also changing shapes. And experts are in the opinion that by 2040, every knowledge object will be available through the open access channel. The motto is that publicly funded research must be available in the public domain. 98% research we conduct in India supported by different kind of governments, central government, state government, local self-government, but 90% of the copyright we produce in India, the intellectual property rights, belong to 5 companies. Can you believe it as an author? And I am going to give you a lot of other shocking facts. That actually builds the blocks of that particular book. So by 2040, everything will be open. But the problem is that this is so distributed in nature, you should have a very good retrieval tool. Otherwise, you cannot access. These are distributed. Institutes are holding their repository, different institutions. So institutionally, geographically, and content-wise, subject-wise, these are getting distributed everywhere in every server, and we still don't have any clue how to accumulate that those intellectual properties and intellectual output of researcher. So that's a very big problem. I will try to give you some solution. Second problem, major problem you people are facing as a student and researcher of future, information overload. Recently, one internet survey company called PEW survey, it's a very important survey, interesting survey they conducted, that in a given minute, in 60 seconds, this is the production of information at the global scale. As an average global citizen, if you are connected to the socio-academic web space, different kind of social networks, your mobile phone, your laptop, then as an average global citizen, you are receiving 2 gigabytes of textual data per minute. And just imagine, can a human process 2 gigabytes of textual data per minute? Not possible, quite impossible. So this particular stage, what we are passing through, our present generation of student and researcher, this is called information overload. We are living in an age of information overload. We simply do not know what information to take, what is authenticated, what should I admit for my research and education, and what should I discard. We simply do not know. We do not give training to you people to judge the authenticity of information. That is not part of our curricula, unfortunately. So, too much of information, what your generation is actually going through is as bad as too little of information, what people of my age actually pass through. During our research time, for one research article, we need to move from this library to that library, and now everything available in your fingertip through internet. So, does that mean that your generation is much more, blessed? Not exactly. Both are bad. Too much of information is as bad as too little of information. And this actually the characteristics features of my generation and your generation. We actually suffered too extreme, but suffered, equally bad way. So, if you consider the situation of a researcher or student now, suppose if I ask you a simple question that what is your most favorite search engine? The moment you are getting something unknown, something new term, your teacher said, your friend said, your scholar said, friend said. So what do you normally do? What is your next logical step to know something more about it? You Google it. Google is so popular that it become a verb, is not it? So still you see the problem you people are facing, you spend hours and hours in internet like a search engine like Google, then finally when you are getting 25, 30 most important documents, okay, these 25 documents are most relevant for me, half of those documents are copyrighted. The moment you click, it says your library do not subscribe it, you do not have full text access, you just keep yourself busy with the abstract. Is your experience matching with it? Okay. Now, it is not possible for Robi to subscribe every journal from every corner of the country or the world because library budget is not increasing in that particular tune. So what is the solution? That is actually the main issue of that particular book and the problem associated with it. And right from the beginning of your research career, your PG studies, you should know this particular problem. So at the end of the day, you people already told me that Google is your most favorite friend, Google is there, and you are not alone. At any given second of time, 3 billion users all over the world are logged inside Google. Okay. Now the problem of Google is that So this particular interface you all know. I search Google by environmental pollution. You see the problem here. I search Google by environmental pollution. I do admit it's a very common phrase. Google produced 1,75 lakhs of document, and I took this particular snapshot before the onset of COVID, say March 2020. So now almost 3.5 years or 4 years. Now you see, I talked about information overload. Today if I search Google by the same phrase, environmental pollution, you see what happens. You will understand that what I am talking about, what is the this information overload. Let me connect. So if I connect with this one, so I am trying to connect this one, and it will take a few seconds. So what I actually mean that 3 years back it was 1,75 lakhs. Now if I search after 3.5 years the same set of keywords to Google, so what is the reaction of Google and what is the result? So that I am going to search now. So let me connect. Cannot see it. Okay, finally I got it. Fine. So if I try Google today and searching by the same keyword, say environmental pollution, I would just like to, you just forget about the result. Today you see what is the result Google giving me. Can someone do the math for us? How many? So do you think it's a library? When you go to your librarian, Dr. Ravi Kumar De, does he say that we have 1 lakhs of documents on quantum physics and you select anyone from it? If I want to search how many books are there in internet written by Amartya Sen, can you tell me how I can search that? No way. I cannot search Google by author, by subject, except this kind of key phrase. But anyway, I am just showing you that 4 techniques that can make your life easier with a search engine like Google. If you search Google like a novice, Google will respond like this. If you search Google like an expert, Google will be much more consistent in retrieval. For example, if I want to search the same environmental pollution, if you are searching Google by this kind of keyword, always try to search as a phrase. So what is the mathematics happening here? The moment you give only environment space pollution, this space Google takes as a Boolean AND operator and make a simple Boolean join. How many documents are having the term environment? How many documents are having the term pollution? And makes a note. So that's a completely a nonsense kind of retrieval system when you are making a simple Boolean logic. But the moment I enclose this one with a phrase, with inverted code to convert it as a phrase, so I am instructing Google, you search only those documents where environmental and pollution came side by side, mathematically separated by a single space. And you see the improvement. Previously you remember 61 crores. Now the moment how many now? So we are making quantum jump. 61 crores to 27 lakhs. Now again you see, if this particular phrase, Suppose in a paper, this particular phrase appeared in the title. In the next paper, in the abstract. And the third paper in the body, textual part. Which one is most relevant? Title. Why? Because title is a super abstraction. If your search phrase is there, that means that must be relevant or core paper. So now, can I restrict Google to search this phrase only in the title? So the moment I enclose this, you see here, this is called special keyword, all in title colon. When you are searching multiple keyword, if you are searching a single word like pollution, then give in title. For a single word in title, for multiple word or phrase, all in title. So now Google will search only those documents where this phrase appeared in the title of the document. You go to any of this one, last to last one, everywhere you get the phrase environmental pollution, and then result is now 24,000, again a quantum jump. Now, I'm just trying to make this popular as there are many researcher, students present here so that you don't feel bored. Suppose, have you observed any pattern in your internet retrieval? In case of book chapter, academic resources, most of them are available in PDF format or doc format. Am I right? So can I restrict or tell Google that, okay, you have retrieved everything with environmental pollution, can you restrict this retrieval to retrieve only PDF? Because I have observed that most of the cases academic people like PDF format as it is open format. So give a space and use another special keyword, file type colon extension of that file. It can be doc, it can be PPT, it can be PDF, and suppose if you want that, no, okay sir, I want both PDF and doc. So within nested boolean, you can add an OR operator, something like this. File type colon PDF or file type colon doc, or in this way you can increase. So this is called nested boolean. Now let me search it. How many? So you see 61 crore, and normally Google gives you result in sets, 20 document per set. You will never move from beyond set number 3, so your search is limited by top 60. And every chance that you are going to miss the most relevant documents what Google retrieve for you. Google is having it, but you fail to retrieve it. So when you are searching Google, do not waste time. In research or education, time is very valuable. Do not waste time in searching. Always starts with the most specific thing that is in your mind. All in title, keep it in within phrase, then use this kind of special keyword. And suppose I want to retrieve everything from India. And here you see everywhere you go, the file is PDF file. Everywhere, PDF file. Now you see here another interesting thing. So first one is coming from .org domain. Second one is coming from .in domain. Third one is again coming is .org domain. I want to retrieve everything from India. Everything related to environmental research conducted in India. This is basically the result from the globe, world, entire world. So I can restrict again, give a space, site colon in. Everything is now from India, 170. Now you go to the last of the last. Any set you can go, view all. And you will see everything is coming from .in domain. Everything is coming from .in domain. And you can also restrict that, okay, I want only from academic institution. You all know that academic institutions are registered under AC.in. AC stands for academic. .in is for India. Every country is represented by 2-letter alpha code. That is called ISO 3166 standard. BD for Bangladesh, PK for Pakistan, IN for India, JP for Japan. So you can restrict to anyone. Now I want everything from AC.in domain. Sometimes Google may say, you are asking me a lot of advanced level question, are you a robot? Only 7. Can you imagine from 70 crores, we actually landed into 7. And by using how much of this kind of spatial quality? Only 4. Phrase operator, all-in title operator, file type operator, site colon operator. Only 4. There are 32 special keywords. I don't want to jam your head, but only these 4 can save 10,000 hours in your life, because for a researcher, for a student, 70% of your valuable research time goes for searching alone. Okay. Very good. Now you are confident that, okay, little bit of the idea what that book deals with we are getting, but again, that is the role of a teacher. When you think that you understand a particular thing, that is our duty again to drop you back on the same square one. Okay. So that is the typical role of a teacher. I am again coming with all of you to the square one, because that is not the solution. Still, the problem what I said before you, that knowledge objects is under copyright. So internet or Google, you can search search smartly. You can get a series of relevant results very quickly. But how can you ensure the result is available in full text? So I often tell my student that internet is a kind of restaurant where menu card is available, not the food stuff. The search engines are menu cards. You are searching whether this menu is available or not. As a student or researcher, your actual menu is the full text document, either the book chapter or the journal article. But you can search smartly, but I cannot guarantee that in every cases, suppose you got that 17 documents, and in every cases you will be getting the full text of the document. That there is no guarantee. Okay. So our main problem is not solved yet, although we know how to search smart. Main problem is the copyright. And here I am sure a few faculty member, researcher are there who writes paper in different journals regularly. My question is that when you write a paper or book chapter for a reputed journal, do they pay you? Yes or no? Again, give me a binary answer. When you write for a reputed journal, commercial like Elsevier, Taylor and Francis, do they pay you? No. Your paper goes to your senior colleague for review. Do they pay them? No. Finally, it is passed by the editorial board member. Again, super seniors and the subject expert, do they pay them? No. Then the question comes, if at any point of time they do not pay a single paisa for procuring raw material, then do they give those journals free of cost? Or even at the cost price, that this is the production cost, you give me that price? Not at all. Situation is completely different. So that book what I talked about, what we wrote through UNESCO, actually talks about that kind of serious thing also, apart from this kind of game what we played with Google. So this is a typical research scenario. We do research in the field or lab, write manuscript, send to the peer review process. Every journal, they are very hard people, twice or thrice they will return back your paper. Finally, your paper got published in a very reputed journal. Something like that, Elsevier journal, high impact factor journal. You gave treat to your friends and colleagues in the lab and department. Have you ever thought what happened to your paper? You are again busy writing the next paper. Have you ever thought what happened that paper you have wrote earlier? That basically now comes to Robi. Here, what is the research impact? Your paper, we library professionals, just suppose every journal has got a volume. Volume has certain number of issues. After the issues we have completed or received, then we bound them together. This is a very common place for a researcher. It is called back volume section of a library. Journal papers are journals are actually, we bound them together. Then again one fine morning, one of your junior researcher opened up your paper. He or she read your paper, mixes with his or her own intelligence and intuition, wrote another paper and went through the same procedure what you have followed long back. So research is a cycle, And this we call research information transfer cycle, like any other natural cycle. Nitrogen cycle, carbon cycle, this is also information transfer cycle. Research is a relay race. Earlier generation gives baton to the next generation. You all know that. What's the problem? Why? What the nonsense I am talking or that particular book is talking? The problem, my dear friend, comes here. You see this particular research conducted long back, in fact 2004, the report published, which we called an eye-opener paper. Peter Suver and professor of University of California actually gave this idea. He said if 1986 we take as a base year, up to 2002 he calculated, and he shown us that during this period, this yellow dotted line, consumer price indexed in the tune of plus 64%. During this period, government of US, the most affluent government of the world, their R&D expenditure increased in the tune of plus 120%. During this period, journal price increased in the tune of plus 222%. Nobody knows the reason. They do not pay a single paisa for procurement of raw material. Rather, we fight with each other to donate our intellectual property to them free of cost. Peer reviewed or quality control process is completely free. We donate voluntarily our time and labor. But why this? No commerce can explain this one. 222%. Have you ever heard there is a Elsevier chair professor in any universities of the world? Do you know any of the scholarship to student and researcher, this huge publishers actually giving back to the education and research? Have you ever heard that Elsevier contributed a huge sum of money to the large scale experiment like LHC or Human Genome Project? A big no again. So what they do with this kind of obscene amount of profit? That the question this particular book actually raised. Again in the same line, one Harvard researcher, Brian Resnick, conducted the same research from 1986 to 2010. During this time, CPI increased in the tune of 108%, but journal price increased in the tune of plus 400%. The last study in this series conducted by Association of Research Libraries, a very prestigious organization, they said up to 2014, the result published in 2016, CPI increased 118% and journal price increased in the tune of 521%. Are you increasing your library budget in the tune of 500%? Not possible in any of the libraries of the world. So how a library can cope up? How as a user, do you think libraries are suffering? Robi is suffering? No, academia is suffering. You people are writing paper, your colleagues are editing it, but you do not have access to that particular paper. It's a very, very important question we should raise, during this one. Another shocking information. The entire, there is a term in economics, oligopoly. Oligopoly means a set of 5-4 major players are dominating the market. Monopoly means a single player, and oligopoly means a 5 or 6 major player. The entire business, as I said, you people write your paper, you present your research, copyright belongs to 5 companies. So I calculated on the basis of 2014 to 2018 data, this annual volume of this business of science writing, what you people are writing free of cost, burning your midnight oil, that goes to $26.2 billion per annum. Not a matter of joke. What we are writing, that makes business of $26 billion per annum. Journal alone actually having the largest share, 6.8 billion, and 5 major publishers are enjoying the largest profit or the lion's share. Elsevier 16%, Springer Nature, Wiley, Taylor and Francis. And as I said, they never give back anything to the community, to the education and research. Now, Elsevier, let us take the example of Elsevier as the largest, shareholder of this profit. I calculated the Elsevier annual reports from 2002 to 2019. And believe it or not, a large part of this time, the entire world passed through the global recession, and their profit to revenue ratio is always higher than 30%. This is the only example. If someone from economics and commerce, they will understand there is only one kind of industry in the world which enjoys this kind of profit versus revenue ratio, that is the oil industry, 20 to 20%. But publishing industry is higher than that, and never recession touched them. Even oil industry got affected by the recession. But here you see, it almost reaching to 40% for LZBR. And the shocking is that LZBR is not the parent company. The parent company is called Reed LZBR. And Reed LZBR is a New York Stock Exchange listed company. And you see their net profit, because it's a public company, they are giving the data, almost $6 billion per annum. A publishing company is receiving $6 billion profit, pure profit per annum, on the basis of our intellectual labor, our intellectual property. We give them free of cost. And what they do with this kind of obscene amount of profit? They actually has a direct link with the weapon industry. Another bomb I am going to place here. LZBR has a direct link with weapon industry. If you don't believe me, do not take my word in face value. Open your laptop or mobile, search LZBR Arms Trade Fair. And every year in the London, in the January, they conduct in open daylight Arms Trade Fair. And there are a lot of paper published against to protest this particular behavior of Reed LZBR. LZBR is the most profitable company under Reed LZBR. Reed LZBR is the parent company. This is their stall, and just behind the stall there is a protest by the scientist and the academician. So do you believe this kind of things going on? We think our field is very transparent, but open access first produced that kind of thing, that do not believe this commercial greedy publisher. They are commercial sharks. So try to have an alternative model of scholarly communication process. That actually that book talks about. And here you see, this is the BMJ Publishing Group, a very reputed publisher in the life science world. So can you read the last line they have given in this particular journal? In light of revelations regarding the involvement of the giant publisher Reed Elsevier with arms industry, we want to assure our readers and contributors that our publisher, the BMJ Publishing Group, have no such links. Again, how shocking it is. A fellow publishing agency is giving open disclaimer that Elsevier is connected to the arms industry. We are not. Unbelievable. First time when I came with this kind of facts and figures, unbelievable. And they took the bullet bandage principle. You know, one of the high impact factor of Elsevier is called Journal of Clinical Injury. So on the one hand, I will publish Journal of Clinical Injury. On the other hand, I will invest money in landmines, which alone is responsible for the 65% of physical injuries of the world. This is called bullet bandage principle of economics. First I will sell you bullet, you fight with each other, then I will sell you bandage also. That kind of principles actually this publisher company is taking. So how to get rid of this kind of things? Finally it reached to serial crisis. That means you people are writing, your colleagues are editing, but journal is out of your hand. You cannot read it because of the price constant or toll based access. India is suffering a lot. Two reasons. We failed to create a good publication system in the country. Second is that our colonial hangover. If you go through different UGC regulation, they always say that your journal must be Scopus Index journal or Web of Science Index journal. What we have not prepared an Indian index journal? We have not prepared. That is the colonial hangover. And because of this reason, every promising Indian research we tend to publish in foreign journals, and government of India is paying twice for every research. First they fund me, to do or conduct my research. Because of this faulty policy, I tend to publish my paper in a foreign commercial journal. My library is again buying that paper journal, and that library is again running on the public money. So government is funding me to do the research. Again, they are buying their own funded research by paying to the publisher. So that's a typical scenario, and young mind should understand these questions. That's why that book is important. And we have an alternative model that is called open access to knowledge. So I already understand that we are going late. So I'll just show you that what does it mean, how you can take part. So open access can be two types, self-archiving and open access journal. Either you directly publish your paper in an open access journal, or still you can publish it in commercial journal, but remember, a published journal paper has three versions. One is the preprint before submitting to the editorial board. One is the exact published version with the publisher logo and the stamp. Another is the postprint that got published, you change something in the abstract, conclusion, data set, it become a postprint publication. Preprint and postprint belongs to the author. So if that belongs to the author, you can upload your preprint or postprint any of the global archiving system so that other people can read it. And there are a lot of universities are coming. So this is called Gold Path and this is called Green Path. Gold Path, you are directly publishing your paper in open access journal. Green Path, you are archiving your preprint or postprint in open access archives. University of Lund came up with a very good tool called DOAJ. It is actually, there are 21 quality parameters. If one open access journal passed that will be listed in DOAJ. And University of Nottingham and University of Southampton, they came up with two very good directory service. One is called ROAR, another is called Open Door. So this is created by University of Nottingham, which is listing all the open access repositories in different disciplines. Suppose you want to know how many repositories there are in chemistry or physics or education, you will be getting this, and all over the world you can see how exponentially the number of open access repositories are increasing. Okay. But the question is that, is it legal? When you upload your paper in an open access repository, is it legal? So there is a project called Sherpa Romeo, through which you can check the publication policy of a given publisher, and Sherpa Juliet, where you can check the publication policy of a given funder. For example, if I want to know that whether a particular publisher is how open access friendly it is, suppose I am searching by this BMJ, it will give you the idea whether you can archive the preprint or not, whether you can archive postprint or not. If you can archive both preprint and postprint, then there is a Sherpa color code. So if it allows both preprint and postprint, it is called green, only postprint blue, only preprint yellow, and nothing white. So according to the publication policy, you can open up your paper. And what is your material benefit? The more and more your paper is available openly in online full text, book chapter and papers, more and more citation it will be attractive. So this is already proved by a series of articles published in Nature, the highest impact factor journal by Steve Lawrence. He proved categorically that if papers are available in open access, chances of getting citation is much more higher. So India is doing quite good in open access. We have a lot of premier institutes coming with open access repositories. If you go to DOAJ, we have nowadays 333 index journal. Indian Academy of Science opened up all of their journal as open access. INSA. So that is my last slide. Thank you very much. Set focus on open access.
Any questions from audience? Okay, Sir has one question.
It
was a very nice presentation.
Thank you.
For us, like faculty members and postgraduate students. So I have one question about open access journal. So most of the open access journal demand money or we have to pay for publication. So what about open access in this regard?
Okay. Very good question actually, but this is a misnomer, misconception what I can say. For example, in case of what sir said actually, be aware of the predatory journal. There is a difference between the predatory journal and open access journal. Predatory journal will publish anything you give in lieu of money. Okay. So if that open access journal is not listed in DOAJ, do not publish there. DOAJ is a global index which presently is having 19,000 plus journal, and these are all past 21 quality parameters what we call DOAJ quality seal. So if a journal listed here, that means it passed through it and it's a quality open access journal. Now I am coming to your next question, that most of the cases journal demands money. That is called APC, article processing charge. Now suppose in this DOAJ I am searching this 19,000 journal altogether. So I am browsing this journal, say all 1900 journal, say I am searching all journal. What's your domain? Physics. Physics as subject. So it will retrieve all the journals available there. How many are there? 423. Then it's a global thing. So I again give another filter that please select only English language journal. So this 389 index journal in English language available in DOAJ. Now you see, if I search without fees and with a DOAJ seal, so if I search how many of these 389 without fees, without APC, the moment I click it, it will tell me out of 389, 132 journals are without APC. So if you are not in a position to provide that APC, you select this journal. And 132 in 389 means how, what is the percentage? Slightly higher than 50%. So almost 50%, you know, if you go by overall, almost 65% of listed journals are non-APC journals.
Any other question? So since there are no more questions from audience, we are very good morning to all of you. Today we assembled here for a 2 days national workshop on book review. So now I request Professor Bhava Sharma to come on dais. Sir, please come. Yeah, sir. And now I request our librarian sir, Professor Dr. Robi Kumar De, to come on dais and felicitate sir. Please. Now I request Dr. De to introduce Professor Bhava Kumar Sharma sir. Please come.
Very good morning. Dr. Bhava Kumar Sharma, currently a professor, and he has been working in IIT Guwahati since 1999. prior to that, he worked in teaching positions in Ramjas College of Delhi University, Cotton College Guwahati, and Guwahati University. He did his PhD from the University of Delhi in 1996. He works in the areas of graphs and matrices and produced 3 PhDs and about 25 research papers. Dr. Sharma has been active in the promotion of mathematics at different levels for the last 3 decades. He is associated with Mathematics Training and Talent Search Program, popularly known as MTTS, founded and led by Professor S. Kumaresan. Apart from this, he is actively engaged in various activities of Assam Academy of Mathematics and Mathematics Teachers Association, India. He has written the book, A Foundation Course in Mathematics, with co-authors Ajit Kumar and S. Kumaresan. Now I request Professor Bhavo Kumar Sharma, sir, to deliver his specious lecture. Sir, please come and deliver your lecture, sir.
Good morning. Respected Principal Maharaj, respected librarian, organizer of this program, my friends in the Department of Mathematics, and the dignitaries and all students and teacher friends present in this program. I'm not very sure how many who are present here today actually pursue mathematics, but it seems that many of you are here from the stream of mathematics itself. So it's a privilege to be here again. Probably this is my 4th or 5th visit to this college. I'm very thankful to Principal Maharaj and the Department of Mathematics and the college for giving me the opportunity to visit this premier college, one of the best colleges in the country. And it's a very nice occasion that, I'm here. So discussing books. So today is a situation across the country. The students, they do not even see books. Okay? Forget about reading and learning from books. Okay? I see even when I walk in IIT Guwahati, I see that not many students, they go to the library. Not many students, they purchase or read from books. So that's not very encouraging. But nevertheless, another fact is that also thing is that whether we have books from which you can learn. Okay? Many books are written. In every subject, you'll see books. But having a very appropriate book for a course, okay, which enables the students to learn, which enables to guide the teacher to teach. Okay? So those kind of books, those are actually scarce. Okay? So I think we need good books. And that is what the theme of this workshop or these seminars really it was very tempting to visit and participate in this program. Though as far as I'm concerned, I may not be termed as famous writers. Okay, no. So I have some bit of contribution in writing book, and that is also one book, of course. So, but I grabbed that occasion. Okay, so I was reading yesterday, probably day before yesterday, in Hindu, The Hindu. So there was one article. Article was written by one of the recent, prize winners, Bhatnagar awardee. Many of you may be knowing in mathematics last year or this year, actually, Apurva Khare is from ISC Bangalore. So he has received Bhatnagar award. Okay. And there was an interview. So this, he also said, it is said that, mathematics is not just something which is required for day-to-day life, it is all pervasive. Okay? So everywhere, mathematics is everywhere. Okay? This is what he has told. And in fact, many people say this, yes, we do not see mathematics, but it is there everywhere. Whatever you do, there will be mathematics. Okay, that's a fact. But point is, why someone needs to do mathematics? Okay? At times, you also, if you are doing mathematics, then probably you hear, you see that question, you face that question, why you are doing mathematics? What's the use of mathematics you are doing, right? Or you may also have, many students, they have this question, why I am doing this mathematics? Okay, in some sense, in day-to-day life, if you want to see the application of your mathematics that you are doing, that's not happening. But same thing is also for physics, chemistry, biology, everything. No, I'm doing physics. Okay, in physics and in school itself, we were talking about Newton's law of motion and everything. Do you use Newton's law of motion in your daily life? You don't. Okay? So that applicability, so far as applicability is concerned, that's a different paradigm. Okay, so it's not just because I will use trigonometry and calculus in my day-to-day life in the evening. Okay, so that's why I should learn. No, there is other thing. Okay. So in some sense, mathematics is different from other branches of sciences. Okay. Probably anyway, that can be expanded. See, whether it is mathematics, whether it is physics, any branch at undergraduate level, when you learn a branch of any science or humanities or social science, you learn. Okay? That is basic level. Okay? It is basic. When you talk about higher thing, okay, at higher dimension, that is master's program. In my opinion, your whatever subject you learn in your undergraduate programs, it's all the same. It's all the same. That is actually whatever area you choose for your undergraduate program. Okay? So that is a medium. That is a medium how you see the world. That's a mirror. Okay? You see yourself. That's a prism through which you look at the world, the physical world, okay, the universe, and society, human life. Okay, so this is some, a sense of undergraduate program is actually that. You may do it through physics, you may do it mathematics, maybe political science, maybe history. Okay, so you try to, so maybe, every subject, every branch has its own way of this, but that is essentially to develop your mental faculty. Okay. Why I am saying this? I have seen that many students. I just one example. It came to my mind. I know one fellow. I know a student, he did his BSc in mathematics, and he is one of the prominent journalists in Assam today. Okay? Prominent journalist. Not just because of, okay, I mean, he has many others, there are many others capable of that, but doing because he did mathematics, his undergraduate program was mathematics, his writings are different, his analyses are different, and that's why he is, okay, so that's why he's a different kind of journalist, and then he's very prominent and he is successful. Just to give an instance. So my point is that whatever subject you are taking in your undergraduate program, that will actually prepare you how you think. It is not necessary that what you learn in your undergraduate program, that will be your bread and butter. It's not required. And it actually, that is the fact in most of the cases. Today, the mathematicians, if you talk about mathematicians, okay, those who do research, okay, or those who teach in either college or universities, okay, the number of teachers, number of researchers, number of mathematicians, if you count, and you compare with at their time how many people, okay, they learned their undergraduate program, even in master's program, how many were doing mathematics, then this number is much smaller. Okay, so it's not necessary that you are doing undergraduate program in mathematics, that will mean that you are going to be a mathematician. You need to be a mathematician. If you do not become a mathematician, then your studying in undergraduate program is futile. No. Okay, so this is my understanding, and this is a fact. Now then, what mathematics has to offer you? When you do undergraduate program in mathematics, what mathematics offers? It has a unique character. The character is that it gives you, it gives you certain capability. If you learn undergraduate mathematics well, that means you are going to gain certain things. What? First, you learn how to analyze. Okay? You learn, given certain things, given certain information, how to analyze them, okay? How to get things out of that. Okay, that you learn. You learn to observe. Okay? You see various things, various examples. Okay? You see various examples. You see various situations. From this, you can generalize. You can understand what's going on. Okay? What is going on, and then you try to generalize. You speculate. You make hypotheses. Okay? And then you state a result, you make a result, and you prove it. Okay, this is what mathematics does, which other things they do not do. Okay, it is very typical characteristic of mathematics, right? So that's why mathematics is different from others. Now, point is that how this will help. Okay, one thing, when Apurv Khare said that it is all pervasive, it's going to be all pervasive in the sense that it's going to be that the fact is that mathematics is going to make more its influence in the mankind in the coming years. Why? You see that we are going to be dependent more and more to machines, artificial intelligence. Okay, so our day-to-day problems, okay, whatever our day-to-day problems, the solutions, okay, no more. It's not required. I mean, human brain not required to solve the day-to-day problems. It will be the artificial intelligence which will give you the solutions. Okay, the danger of doing that. Okay, so this is fine. I cannot compute certain things in maybe in 3 days, in fraction of a moment. This will be given by computer programming, everything, right? But a problem, what's like say artificial intelligence, the dependence on that kind of science and technology, what is going to make our life different is this, that if suppose tomorrow all of us we dependent on the machine which uses artificial intelligence. If that is the case, then the solution of I have a problem, you have a problem, same problem, okay, the same solution will come. Okay, it will be universal. And how the solutions will come? Okay, different data, different these things, different solutions are taken care of. Okay, a machine will give you the solution. Okay. So that means diversity will be finished. Everyone, all will be thinking, all will be doing things the same manner. I'm talking about a very simplistic manner. Okay, so that's going to happen if we are dependent on that. In that situation, which will save us? The analytical ability, the reasoning, the thinking, okay, the intuition, which can see beyond what is seen by artificial intelligence. And that point of time, the importance of mathematics will be manifold. Okay? So the importance of mathematics will also change in that sense. Let me come back to the situation, ground situation. As I said that the undergraduate mathematics has certain objectives. It teaches you, okay, various subjects, linear algebra, real analysis, differential equation, okay, abstract algebra, maybe numerical analysis and various things. Okay. So through this you are trained. Through this we train the students, okay, how to analyze, how to make results, how to prove results and various things. Now, as I said, just now I said at the beginning, that the situation is that the system is happening something like this, that we are learning very stereotype. Okay, not from books. Okay, notes are given by teachers, so I'll mug up and I'll vomit in the exam. I'll get good marks and I'll get good results. Okay, the purpose is lost. Why mathematics? You are doing mathematics. If you are doing mathematics in this way, which sexually it's happening. I'm not talking about you. I know that many of you do not follow that. But what we have seen across the country, through our different programs, different kind of meetings with students, what we have seen that this is all pervasive. That whatever teacher is saying, writing in the board, okay, I have to write, I have to note down. Okay, I'll note down all those things, ditto word by word, and then I'll try to, if I understand, fine. If I do not, I'll just memorize, okay, and write the exam. Okay, so then what is the training? Training of enabling you to analyze, okay, observe, generalize, proving results. Where we have enabled you? Okay, see that. Many of you must be knowing the program MTTS, right? So can I see how many of you know about, at least heard about MTTS program? Raise your hand. Mathematics Training and Talent Search Program. Students, I'm basically talking about students, yes. Yeah, so many of, yeah, thank you very much. Thank you very much, yeah, okay. So you see that this MTTS program, the ground reality, what is today, it was, okay, probably it was not like that 50 years back. Of course, mathematics was also slightly different, okay, problem solving kind of things. But now that knowledge, that this purpose, this kind of purpose of learning mathematics, okay, that also has transformed. So 33 years back, okay, 33 years back, we are very grateful that Professor Kumarishan is with us. Okay, so he in some sense, he left behind, okay, something which was very lucrative, okay, for being someone in mathematics field, okay, research is taken to be a very essential or very this thing, high. He left a lot of things and he dedicated himself for the cause of this part of mathematics. Okay. So this MTTS program is started in 1993. Right? Single-handedly Professor Kumaraswamy started. Of course, some people helped him. But there is, you look at across the wall you try to see, is there a program which is not by any institution? It is by certain people, persons, led by one person. Okay? 30 years, okay? Not only it is continuously running, okay, non-stop it is running, but it is expanding. This MTTS is by now it is almost like a movement. It is reaching nook and corners of the country. Okay? Not a single bearing one or two states. Every state has almost regularly has a camp from mathematics. Of course, I mean even then, it's that the number of students MTTS can reach to, it's not say I mean a big percentage wise, but number wise, yes, it is a large number. And purpose is this. The purpose of MTTS program is essentially that whether undergraduate program or master's program, what mathematics should teach, why you should learn mathematics, not just job. That job will come to you if you can acquire that objectives mathematics has. Okay? To learn how to analyze, to learn how to observe, okay, generalize, make statements, okay, prove. So this is a very simplistic way, essential part of mathematics. Okay. So that has MTTS been trying to, and of course, I mean, it is a public knowledge that MTTS is a very successful program. So why I'm talking about this MTTS? I was supposed to talk about a book, right? So this is a book, a foundation course in mathematics. So this book is actually the outcome of one aspect of MTTS. Okay. So from this program, from the experience of program, there are many books that have been written. Professor Kumaraswamy himself, he has written several books. He will present, I mean, he will say something about one or, in fact, about all the books. I would like to hear from him. Now, point is, what we see, what we observe, the nature of learning mathematics at school level, at higher level. So higher level, I'm starting at undergraduate program. Okay? And you know that there is a distinctive difference between the mathematics at school level and mathematics at undergraduate and postgraduate level. Right? Now, there is a perception. There is a perception that mathematics, it is not the cup of tea of all, any student. Even if you like mathematics in school level, it is not a cup of tea for you. That is the perception. What it says that, and the other perception, even I tell you the people at a very high level who determines the policies about education and say mathematics, they have this opinion. Several of them I heard on my own. That, okay, don't worry, I mean, undergraduate level, if a student is capable, he will learn. Don't worry about that. Okay? So that means what? So if a student is capable, so he will learn on his own. Okay, he will start learning on his own. So you don't have to bother. And see the ground situation. Situation is something like this. I said that the characteristic that the character of mathematics you learn at school level and undergraduate level are different. How they are different? In school level, even up to your class 12, whatever you learn, those are mostly algorithmic, like algorithm. Differentiation, okay, these are the rules. Okay, these rules, this function has derivative, this function has derivative, this. Or integration, if function is this type, in integration you put this substitution, that substitution, rules. Okay, mostly. And okay, those who like these rules, can learn these rules, they apply these rules, they do fantastic in school level. Okay. Now, the character of the demand of undergraduate mathematics is something else. So this just learning rules, okay, applying rules and solving problems will not help, because the purpose is what? Purpose is to make you understand, analyze, okay, all those things. It has a completely different language. Okay. Now you see the student who knows what is a limit of a function. Okay, fx, f is a function. As x tend to c, limit of fx, okay, L. When, okay, I know that as x approaches a or c, fx approaches L. So I understand, this is my intuition. I know that I can find out limits of many functions. Now when you are doing real analysis, then you will be giving that fx converges, fx limit is equal to L as x tend to c if given epsilon positive, there exists some delta positive such that this is this. Okay. Why should I know? Right? Okay. Why that definition? Or okay, somehow teachers tells that, okay, this is the definition. Oh, that was only some intuition. Now basic, actually, if you want to say in a very proper format, then this is what you have to say. Okay, you have to say, okay, you also agree. But then, perceiving that, why, how, and not only that, dealing with this epsilon delta. Okay, dealing with epsilon delta. Why for every epsilon there should be delta? Why not every delta there should be epsilon? Okay, you ask yourself, and you see how many students will be able to tell why not. Similarly, convergence of sequence and various things, right? And then proofs of different results. Okay, a function which is continuous on a closed interval is bounded. Okay, ठीक है, graph से तो दिखाई देता है. Okay, I can see that if I draw continuously from A to B, okay, it has to be bounded. But that perception will not work. Now see that the demand from the student in the undergraduate programs is completely, very different from the demand from a school student. Okay, there is a gap, right? There is a gap. So we all, almost all of us, we have come across this. We have faced that problem, and there was no hand holding. Okay, because what people, so those who are at the helm of affairs, they probably say, okay, mathematics, student will understand. Those who will good, they will only do mathematics. No, so they will understand. So don't worry. So they did in school level, they did this way. Now this is language, so they will learn. We learned. Their main logic is that I learned. No one said that this difference has some, okay, is a problem. No one told. I could learn, so why not others? Okay, and that is the hindrance. Okay, that is the hindrance. What is the hindrance? That the way you learned mathematics in school and now in college, there is a difference. But how to cope up with this difference, that is not taken care of. Okay, that was in most of the university programs, undergraduate program, it assumes that the student will learn, will understand real analysis on their own. You don't have to worry. Okay. And that this problem, this gap, this was seen, it was observed, and it was, okay, it was diagnosed as early as 1993. When Professor Kumarishan started the empty test program, he could see that there is a very, problematic this here, okay, gap here. So this gap, that this algorithmic to understanding of logic, understanding of, okay, this language, this gap, if it is not bridged, then student will always find difficult, and they will be used to mugging up and doing things. So to make student learn, to make student capable of doing mathematics, then you have to do something, what we call now as the foundation course. Okay. So foundation course, that has been practiced for last 30 years. Okay. So foundation course, what it does, it tries to, okay, make up that gap. From you have some basic idea of sets, some basic idea of functions, okay, maybe relations, okay, maybe some how to deal with statements, because in mathematics you keep on writing statements. So dealing with statements, how to deal with statements, how to deal with sets, functions. Okay. So the gap is required to be, okay, filled. And precisely because of that, there is a course. There is a course called foundation course. Okay. Foundation course in MTTS, that when the students are brought to the MTTS program at the lowest level, after, when they are doing their second year of graduation, so that is the eligibility for level O for MTTS program. So in that level O, a 2-week program, a 2-week course, it's not a full course, but 2-week course, that itself, it makes a hell lot of difference. Okay. So what are taught? Statements, okay, logic. This logic is not, okay, logic, for logic you do not, so to deal with to learn your real analysis, linear algebra, abstract algebra, you do not need to learn your propositional calculus and, okay, this in formal logic, that is not required. That is a different purpose. That will have, okay, you are doing, say, automata theory, you are doing some computer science, other things. Then you will be needing those kind of, okay, those kind of logic. But logic, day-to-day life, that we use, okay, and that we use in mathematics, that should be taken care of. Okay. So that was one part, then dealing with sets and dealing with functions. So this course, now what we see, that after that course, 2-week course, the ability of students, it's revolutionary change, you can see, a drastic change. Okay. So that is, so we could see the utility of this course, and you have some other, recent experiences. This course is not only given to the primary students. Primary students means the second year students. Now even in some kind of crash course is given also at higher level, after even graduation, after master's degree. Okay, at the level of master's degree also this is actually many things. Personally, I come from IIT Guwahati. Right now I am teaching real analysis course. Okay, and believe me that before I started real analysis, okay, it's a packed course, right? Packed course, I have 40 lectures, I have to finish the course. But I started with 4 lectures. 4 lectures means 4 sessions with logic. Foundation. Logic, set theory, sets, functions, relations. 4 sessions. Okay, that made a very good level playing. Many students, they say that now we understand what we learned in graduation, why this epsilon delta, why this convergence of sequence has this thing, how to negate this, now we understand, in 4 sessions. Of course, they are PG students. So that means what I am saying, that gap requires to be addressed. The other thing is that we not only practice in these MTTS programs, last 3 years, we have, so third year we had this time, we have one online program called Online Foundation Course in Mathematics. Okay? Online Foundation Course in Mathematics. And theme is this. Theme is sets, functions, statements, okay, logic. So it is very, you may look like everyone knows. But once you experience, once you go through the course, you understand that, okay, I mean, yes, now I have a better understanding of what I did. Okay? So this is, so, and this program, OFCM, Online Foundation Course in Mathematics, we had last 3 years, and we could see the difference. Every year through this program, OFCM program, we train, so around, say, I mean, 300 to 350 students every year in 6 different camps. Okay? So, and we see the effect. We have seen the effect. Right now we are having programs in 24 colleges, okay, from MTTS, 2-day programs. Those colleges who had shown a lot of interest in sending students from MTTS program, we selected 24 colleges, and then we are having 2-day programs in those colleges. Okay? And right now, at this moment, there are 5 colleges programs going on. Okay? So the feedback just yesterday evening I received is that, so in colleges, these colleges, they also have some participants who came from OFCM. OFCM means who participated in OFCM, Online Foundation Course. And the quality, the kind of involvement for these students, understanding, maturity they are showing is completely different from the students, the rest of the students. Because they had this exposure, right? Exposure. So my point is that this foundation course programs, they are really, really fruitful and successful in MTTS program. Now let me come to the book. See that for a long time, this whatever, how the course will be done, okay, we need some material, right? We needed some material. So one of my colleagues also at IIT Guwahati, he also contributed to Professor Kumarishan's writing. Okay? Certain things, okay. I mean, in this course, so we'll be doing these things on sets, functions, on statements, logic. So these are the certain things we'll be doing this. So these are essentially some notes. Notes means, okay, points. So these are points. Okay. And then at a later stage, we also started giving students some books. Okay. After the program, at the end of the program, we provide a very 2 or 3 some basic books to the students. Okay. Of course, for number theory, there are good books with low price. Okay, low price. These books, some books are there. In analysis, there are some books. So those books, okay, I remember. So yeah, anyway. So certain books we used to give to the participants at the end of this program, before Professor Kumarishan wrote some books. Definitely on sets, functions, because that is a prime concern. So Professor Kumarishan would have liked to give a book on this kind of thing for foundation. But forget about in Indian market, across the world, there is no book which is suitable for this course. There is no book. Okay. So at one point of time, it was very recently, of course. So very recently, 2 purposes. Writing of this book was 2 purposes. One is that, okay, I mean, we just whatever course we do, so do some more things, okay, include some more things so that students can go and read and they can master. Okay, so they're helped with the course. And the other thing is that in MTTS program, if you see that today, the number of students across the country doing mathematics honors, okay, It's a huge number. How many students we can cater to? Okay, so we can. So, but in a year, how many secondary students can get an MTTS program, okay, to attend? So not more than 1200. Okay, so about say 1200 students they get the chance. But there are many more students, okay, many more students doing mathematics honors. So who will fill up the gap between school mathematics and undergraduate mathematics? So we need to provide something. Okay, we need to offer something from the MTTS itself. So the course we had been doing with that idea, whatever outline we had. Okay, so then Ajit Kumar is Professor Kumarishan's student, a research scholar, and he is right now one of the pillars of MTTS program. And Ajit and me, we proposed to Professor Kumarishan that let's write a book. And he said that it's a good idea, so go ahead. So with his guidance, with his supervision, we wrote the book, this a foundation course in mathematics. When this book came, I could see that it was available. It was available in Amazon. Okay. One fellow, he writes about this book. Who needs these things, these lousy things? This is the comment. Okay. Anyway, people are free to write in online. Definitely, okay, they are free. But the fact is that even the premier institutions, IJRs, several IITs, many universities, they have incorporated a course on foundation, okay, and this is the textbook now. In economics, something is, okay, I mean, in some sense, it says that supply creates its own demand. Now that the book is available, now they can see that, oh yes, if this is taught to the students, then it will be helpful. And they agree that yes, I mean, teaching this book, taking this as a course, maybe half course, maybe 2 credit course, but this course, it makes a hell lot of difference. Okay? So that is, it is not my credit. Okay? So it is a credit of the MTTS program. Okay? We learned how to tell certain things, tell mathematics, tell problems, tell ideas to the students because of MTTS program, that long association. And that must have been reflected in the book itself. Okay? And so definitely the students have found this book as student friendly. Teachers have found that yes, it is easily followable and easily it can be taught. And of course, some comments we have received that probably if after each of the chapters, if we have some more questions for practice and all, we are thinking, okay, let's see if we can have a second edition for this book. But we are very happy that this book really has made an impact, not just for the book, for mathematics. Okay? For mathematics in the sense that for undergraduate program, for undergraduate students, some hand-holding. Okay? Otherwise, there was none. No one was cared whether a student can understand analysis, abstract algebra. Okay? It was almost like up to him. If he wants, if he understands, fine. If he doesn't, then let him just mug up and do exam. Okay? So I think, I mean, this book has, the success is that it could give first the students some relief, and more than that, it has striked many that yes, there is a need to fill the gap between school and undergraduate mathematics. Thank you again for being here, and I thank the organizers for giving me a chance to speak. Thank you.
Any questions from audience?
Thank you, sir, for your nice lecture. So myself, I have attended SMIT course, mini MTTS course at SMIT.
Yeah.
So nice to see you. So I have one question. So I have completed my BSc and MSc in mathematics, but I am now switching in machine learning like this. So how can I visualize in this area from the mathematics background? So
Visualize, you say, I mean, you are doing data science or what?
Machine learning.
Machine learning.
Yes, sir.
So, I mean, in the context of machine learning or in the context of?
No, sir. Being a student of mathematics, how can I visualize that?
How can you visualize?
Yes, sir.
Visualize what?
Logically or analyze?
No, don't worry. You don't have to visualize. Point is that because in your program also there was a course in foundation, right?
Yes, sir.
Okay. Now tell me, that course definitely helped you. Whether it helped you in this undergraduate program?
Yes, sir.
Right? Okay. Now my point is that whatever you do, so your training in undergraduate program is to do those things. No, the objectives I have said. Okay. So the objective of this book or this course is to make you understand your mathematics. If it was successful in doing that, okay, now whatever mathematics or whatever ideas you will be doing in your this thing, machine learning, okay, so this will have some bearing, but the logic will be handling in machine learning, okay, the sets, functions, okay, anytime, so that will have a bearing with this course, no? Right? Yes. So that it will come when you need to analyze things. It will come automatically. You don't have to look for, okay, how I will use this to this. The need will tell you how you use it. It's, yeah? Okay. I think that much I can say. Yeah.
Any other question?
Good morning, sir. Sir, I have done my UG and PG in mathematics and currently I'm doing PhD in mathematics, precisely in complex analysis. So in the recent years, I have seen some development, as he said, in machine learning and data science. So how can I implement this after having PhD in some real, in pure mathematics or in complex analysis? So how, is there any space of switching from this to that or something like that?
I think I'm not an expert in that, but point is, it depends what you want to do, no? What I have seen just now, as I have said, that, I mean, my friend who did undergraduate in mathematics, now he's a journalist, okay? He is not looking at what calculus he did, what analysis, linear algebra he did, but whatever he is doing, the analysis he is doing, that training is actually from the mathematics what he did. So again, I mean, whatever you do now, after your, I mean, masters, after your PhD, whatever you do, whatever training you had, that will tell you how things to be done, right?
Yes. But actually, I was thinking that this is a new space for some of us. So that's why I was thinking, is there any some space?
No, machine learning, because I'm not an expert in machine learning, or I do not have much exposure in that. So probably I'll not be able to tell.
Yeah, sir,
yeah, I think Professor Kumaraswamy has.
It is recording, na? Yeah. Then people can see it later. Yeah. So
it's okay. It's okay.
So you want me to do now or later?
No, sir. Just
yeah, it's all right. You can. Yeah. That's
easier. Otherwise, this will be fluctuation. But I want you to be around.
No, I'm here.
Yeah. This is to answer both the things. The people who ask the question, are you able to hear me better? No problem? Okay. The kind of questions which you ask, very natural. In fact, I address it in almost every gathering of math students and general population also. Let us just start with a question. Do you think there is a difference between education and training? Or are they same? The words are the same? They convey the same meaning? How many of you think these two are distinct? Education and training. Those who think they are distinct, raise your hand. Right, very less. This is the confusion not only among students, with teachers, policy makers and governments and across the world. They are different. Training is a specific goal oriented. I am training you for this particular job, for this particular thing. Whereas education is some kind of a preparation of mind. That's what Professor Baba said. Okay, when you talked about his journalist friend, I know whom you are talking about, yes. Yeah. So that is the first thing you have to understand. And second thing, specific machine learning. It's strangely enough, for about a few months I was involved with that. Okay. But let me give a background. I'm a pure mathematician. I like mathematics because it allows me to think without much expense. Okay. And also pays me handsomely. So few of my students who are in IT industry, who are doing national machine learning, deep learning, you want to call it artificial intelligence, natural language processing, okay, all these things. It's a big company, I don't want to say because there is a confidentiality class which I have signed. I don't want to say what I did. Okay. They came and asked me, I said, I'm a pure mathematician, I do not know anything about programming. If you ask me to write a code in any simple language, find the maximum of 2 numbers, I don't think I can succeed. Okay. So I said, what can I do? Okay. But finally they convinced me. I went there. To understand their problem, it took just about a week's time for me. Then I understood the math which they needed, I explained to them. And after a couple of weeks, they came with a very huge code, runs lines after lines after line. But then there was a bug, they couldn't solve it. Remember, I could not write a simple program to find maximum of 2 numbers. So I told them, you tell me, explain your program. They are all experts who are working in the field for a long time. Within about 45 minutes, I was able to find the piece of code which was causing the problem. What helped me do that? This is not bragging. I am trying to tell you the thing. Maths, as he said, which I keep saying, ever since I started teaching career, the first class I always spent. You can hate mathematics, well and good, no problem at all. But maths teaches you how to think, ask you to ask questions. Okay, it allows you to challenge things, and it teaches you problem solving. This is what is going to help you, not a plus b whole squared is a squared plus 2a plus b squared, as common people you always ask. I learned it, what is the use? Okay, that's not the one. So it's the education. That's what helps. Okay. How many of you go for gym, physical exercise, or do yoga? Most of you, right? Ought to be, okay? Right. Why do you do that? Does it help your career? No. Doing this weightlifting does help me? But what it does is it prepares my physical and mental thing, because it releases endorphins, so that it allows me, without stress-free life, I can do my work better. Okay? It doesn't have a direct impact on your career or your job, but it helps you do that. The same way education helps you, prepares you to do these things. Do critical thinking, ask questions, learn how to adapt to changing situation, and to solve problems, look for solutions. Any kind of education will help you. That's what maths also does. Okay. So you don't think that just because I learned Liouville's theorem or Navalena theory, is it going to help me in machine learning? It does not. It may, I do not know. But it taught you how to think carefully. That is what is going to help you. And as he said about journalist front, I can quote hundreds of my students who are in very many fields, criminology, forensic science, Bangor, everything. They all said about the same thing. What you said in the first lecture. Okay, we did not do that well in course, but the way of thinking helped me. So I'm sure it will help you too. I'm sorry, Baba.
Any other question from audience? Okay. Since there is no question, sir, we are thankful that you are coming here. Thank you, sir. Now we have among us Professor Kumaresan, the director of MTTS program. So now I request sir, please come on dais. So I request Dr. Ravi Kumar De sir to felicitate sir. Please come, sir. Now I request our librarian sir to introduce Professor Kumaresan sir. Please.
Professor Kumaresan sir is a former professor, School of Mathematics and Statistics, University of Hyderabad. At present, he is the director of MTTS Trust. Professor Kumaresan is the first recipient of Indo-Canadian Mathematics Forum Award for Excellence in Mathematics category. He worked for his PhD at TIFR Mumbai and then served as a professor at University of Mumbai and University of Hyderabad. He had been a visiting professor at many leading institutes in India and abroad. He is known for his association with the Mathematics Training and Talent Program. He is currently Distinguished Professor at Geetham University, Visakhapatnam. Now I request Sir to deliver his spacious lecture. Sir, please come.
Sir, do you need a laptop or presentation in kind? No. Okay, sir.
This has to be our system. Are you able to hear me now? Let me just wear it on my. Okay? Last bench? Okay. Good morning, everybody. It's really a pleasure to come here. And after coming here only, I saw all NIR of ranking certificates. It's really excellent. That's good. So when I got the invitation from Professor Vikas Chakravarti, you see that I'm going to make this kind of mistakes often. Okay. I was a little puzzled. This is the first time I am asked to talk about my books, not first time, Kareleaf has already interviewed me, but that was a little more different kind. So I was not sure what I was supposed to talk about. Because I have always seen book releases, author will sit on that, somebody will cross check, ask question, then everybody get autograph, edition, whatever it is, right? So I was a little worried, am I fit for such things? Can I do something? But luckily this is a different tone. I should thank Professor Baba Sharma who set the tone, okay, for the lecture. He already talked about our book, joint book about foundation course in mathematics. I just want to say only two things about that before I move on to another topic. He very well explained why there was a need for that. So I just want to make 2 points about that book. One, the course is not for foundations of mathematics. Foundations of mathematics has a very technically different meaning in mathematics. Okay. Because some people who think they are logicians, okay, have problem with that. Okay. So that kind of logic didn't help them to understand the title of the book. A foundation course mathematics does not talk about foundations of mathematics. Number one. Number two, publisher was reluctant to publish the book. Because that's a point I am going to start with. That's why I thought it will be a kind of not only foundation course book is a bridge to high school mathematics and college maths, even that topic, that book is going to be a bridge between Baba's talk and my talk. You see, publishers are there just because it's a business for them. So the first question he asked me is, sir, which of the universities are teaching this course? I said, no university. So naturally, as a businessman, he doesn't want to touch the book. He doesn't want to publish. Then I have to assure him, you know about my books because he has already published few of my books. So I said, wait, in 3 years' time, this will become a textbook and they will create a course for this book and they will teach it all across the country. That's what Professor Baba also mentioned. And it is happening. So, as I said, that's going to bridge, going to serve as a bridge between Baba's talk and my talk. Because whenever I write a book, I don't write it keeping anything in my mind. Whether it's going to serve as a textbook, okay, that's not at all my concern. I never worry about that. Okay. And second thing I don't worry about is there are already a lot of good textbooks. Okay, we will mind compete with them. I don't worry about that. Even professionally, I don't compete with anybody. I compete with myself. Commemoration of today should be better than commemoration of yesterday. That's it. Okay, I don't compete with anybody. So I don't expect my book to compete with anything else. So I don't never worry about such things. Then why do I worry about writing a book then? Any book. I think all authors, as a rule, have something. They think they have something different to say. That's why they write. Including a novelist, okay, fiction writers. They have something, some way of thinking, something they want to convey. Forget about pulp fiction, even there their purpose is to make money, that's fine. So, when I write a book, my first thing is, I think of only the subject. Okay. The second thing I think about is going to be what I consider as a core subject, or it is going to be catering to somewhat advanced learners. If it's a core subject, I want to say what are the limitations. If I think of something like topology or analysis or geometry or whatever the course, I try to see whom it is going to serve, in what way. So that's how I designed my thing. So if it's a core subject, that means essentially some of the basic, as I said, that it's a kind of cultivation of mind, okay, in that discipline, perhaps outside the discipline also. If that, with that mind, then the next question I ask is, this subject, if it's used elsewhere within the discipline or even outside, what are the basics, most often used facts, results, concepts, or examples which they need? Okay, I try to understand it from from my own perspective. Then only I start writing. I don't worry about, okay, this is the title, this title, he has written, A has written, B has written, C has written, so I should cover the same material. Otherwise, people will not accept this as a book. But remember, I never write it as a textbook. I write any book for the subject, depending upon what it is supposed to show, whether it's going to be a core subject or it's going to be some kind of advanced level thinking. This is the way usually I write. Once I write that, then as I said, what are the basic results and concepts and examples which will pervade all through the subject, which will help them to master. Okay. So sometimes I even create newer examples which are not found in other textbooks, books rather. So this is the way I usually try to do things. That's now do you understand why I said about Baba's thing? It's a bridge between his talk and mine, because I never wrote a book with whether it will be prescribed as a textbook in any university or whether it is going to be compete with some other existing book, or these are the standard textbooks of this particular course, so that material should reflect in mine also, maybe in a different way, but you should. No, I don't care. Okay, and many of you, I think most of you are doing mathematics. Yeah, I would be surprised except one or two. Okay, I would be surprised if others are there. So I know, for example, two of the books which almost all of you must have seen. Linear algebra, a geometric approach. Yeah. Do you think it's a textbook of any? You have the other textbooks in linear algebra. Would you consider my book as a textbook? I will not. But I know a lot of students like it. In fact, some universities wrongly had prescribed as a textbook, in my opinion. It should at best be a reference book for me. So this is what I meant. It caters to some kind of a thing which is missing. That's the way we do that. So did I make my point clear? Okay. So the first thing I want to say is, never ever I write a book as a textbook in mind, and it should be prescribed as a textbook, or it should replace or compete with any book. That's the first point I want to make. And second thing is, I consider as something what is supposed to be core, what are the basic results, concepts, or typical example which will help the reader master the subject. These are the things I consider first. Third, I do not worry about if that be the standard course anywhere. Okay, the other standard textbooks or whatever books you have, okay, do these things, so I have to do that. I never feel compelled. Okay. As a last thing, again, many of you must have seen my real analysis book. Yeah. But now tell me, any university course anywhere in the world, in a real analysis course, they don't talk about metric spaces. Yeah, my book, you won't see. I know that. There will be a lot of resistance. People will say, in fact, many people say, I like your book, but we don't want to prescribe as a textbook because metric spaces are not mentioned. I said, you don't know. But I will be happy if you give it as a reference book so that students come to know how to learn real analysis. Why? This is another point. I always go with a conviction. Okay. It may be right, it may be wrong. I don't want anybody to accept my convictions. Okay. So, for example, in real analysis, my conviction is introduction of points into metric space topology or whatever it is at an early stage kills analysis. Okay, students don't learn how to estimate things, look at the behavior at some special points of functions, how the sets behave, how they are dispersed. This kind of analytical, critical, quantitative analysis they don't learn. What you learn is qualitative. You try to hide behind open set, okay, closure, this kind of things, rather than I have to estimate. When I want to say it's an open set, what does it mean? I have to say some point is there, then some open ball which is contained that. Then that means I have to point the radius of the ball. That means an estimate. I have to make sure. Okay, everywhere. So what I have found, people who are fed on metric space concepts at an early age, when in the first course in real analysis, they find difficult to do what one calls as hard analysis. Estimates, inequalities, they find it very difficult. They hide behind open sets, etc. But when you need hard analysis, they don't know what to do. So based on this experience, I said I decided I will not introduce, even though I could have done easily, okay, just introduce a definition of metric space, and whenever the inequality comes, right, instead of f from R to R continuous, you simply say x to y, metric space to metric space continuous. It's same epsilon delta or sequential definition in my book. I could have done that. I refuse to do that. Because how I am going to show, how do I show some function is continuous? By using epsilon delta. In the general metric space, you don't. Okay. So this is the background of general kind of my principle with which I write books. Okay. Just because there is a kind of tradition, okay, I don't feel compelled to subscribe to that. What I am convinced, I will do that. So with this background, let's come to, I think, I was very surprised sorry, I don't recall your name immediately. Our librarian called me, sir, I want you to come and give lectures. Then you know what he said? He rattled off 3 of my books. Okay, linear algebra, real analysis, metric space. Then he said, sir, I would like you to talk about metric spaces. See, a librarian keeping track of all these things is very, very surprising. He did that. Thank you. Because I was not sure what I should talk about, then he gave me an idea. Okay, very specific topic also. So let's come to metric space book. Why I wrote, okay, and how I wrote, what does it contain? Why I wrote as 2 reasons. One is personal, the other one is professional. But first thing is professional. As Baba said, in MPTS, we have a course on metric spaces for what we call level 1. That's our final year BSc students. Because what we found, students only learn the jargon, what I call jargon, that is technical terms. Metric space, triangle inequality, open ball, closure, continuity, completeness, this kind of thing. But if you give a very compactness also on the way. So if I give a specific set, whether it is open, close, or dense, nowhere dense, they have no idea. Just the definitions, XD, they never give concrete examples, never try to develop geometric intuition. They are all very abstract. And that's what happens in real analysis, you can't spend more time on that. Okay, you want to do analysis, so you just introduce only the abstract definitions and leave with that. So when they go next level, what happens is they immediately go to points topology. Okay, points topology, X is a set and tau is a topology, subset of power set, do something, and again set theoretic manipulation, what prevails in the general topology course. So metric space topology is the most important thing purely from analytic point of view. Very rarely you need points topology there. And so students don't learn how to visualize objects, how to work with them, And there also, because there is a metric, that means a real valued function, there are estimates involved, how to use that. These are the things which they lack the skill in. So what I wrote was, I wrote some kind of, I don't remember, about 15-20 page outline. So I used to send it to the prospective teachers of the course in our summer camps of MTTS. And they used to follow. So this was the professional aspect. Now, why I wrote it up as a book? Later I turned it into a book. That's what you must have seen. I didn't bring a copy, but most of you might have seen it. Why I wrote it as a book? That is where the personal thing comes. This I want to say because all of you, human life is always full of problems. Okay? There will be certain points of time in your life where you feel very low, very depressed. Okay? Or you are a lot of challenges. So you should learn how to overcome. And this book is an outcome of such an attempt. Okay? So at that time I was head of the department with the university, and there was some colleague of mine, through him there was a lot of problem, and there was a university inquiry committee. Okay? In spite of the problem which this guy created, I wanted to protect him and try to do a lot of things, and he didn't understand. Just think of it, there is a story of Zen story. How many of you have seen, read it? I do not know. There is a rock, a scorpion was caught in that. Okay? A Zen master or a monk was passing through. He wanted to help the scorpion. He tried to remove that so that the scorpion will come out. But whenever he tried, the scorpion stung. Okay, he does not realize that fellow was trying to help you. This is what happened in my case. So with that, I had very severe problem. I could not sleep well. I used to get up, go to bed around 11, get up around 1:32 because of this problem. Then I thought I should do something which takes away my mind from that problem, do something which I enjoy. Okay? That's when I wrote this book. The book was written in 3 weeks' time. What you see as topology metric spaces, 150 odd pages. It is out of about 15 pages. Outline, of course, I expanded the book in 3 weeks' time. So all night, no problem. I get up and did that work, and very surprising, it's a very successful thing. Lot of students and teachers like that book. Okay. So this is the 2 reasons how the book came into existence. One is professional, because I wanted to help MTTS teachers, and second thing is I wanted to help myself. Okay. That's the way the book came. And I should also acknowledge, and it took my dear student, colleague, friend and son, Ajit Kumar. He drew all the pictures in 1 week's time. Okay, he was at the time in Delhi, I guess. I was in Mumbai. So I sent in all the pictures, hand-drawn pictures through mail. Speed post was working better those days. Okay. So he got it. Within a week's time, he sent me the computer-generated pictures for that. So the whole book took just about maximum 5 weeks. Okay. So the book was written, we published, fine. Next thing, what is different in the book? Why I want to do? Again, as I said, the first thing I attended to that book is the kind of geometric intuition which students miss. It's not only working with symbols. When you see something, as said, you should be able to say open, close, you see a function, you should have some kind of built intuition. Because no subject in the world, leave alone mathematics, you can master or you can excel unless you start having an intuition. Intuition may be right or wrong. That's very important. If you want to do anything, including machine learning, okay, don't think of it as a bag full of tricks. That's what everybody does in every subject. Don't do that. You should build an intuition. Okay. In the beginning, it will be hit or miss. Most often it will be misses, about 70–80%. You may not get correct one. But as you keep doing, you will see success rate will become higher. Then you will excel in that subject. This is the way. Forget mathematics. Even in your job, this is the one. You should have some kind of intuition what you want to do. Okay. So I wanted to build intuition in the subject. That's why you will see a lot of such examples which are nowhere found in any book. From the beginning, you want to consider something as an open ball, how you do that. Okay. For example, just if you have just doubt, you ask yourself, given an open trouble, is there any book which shows it's an open ball? Look for a book. You will find no other book. See, these are kind of thing. See, slowly build. Okay, if I want to show what I have to do, I have to find the center, then I have to find the radius. This kind of intuition I build. How do I find the center? How do I do that? These are kind of we build. And similarly, we will see that I go against the stream also. One of the thing is, look at density. Okay, everywhere when the density talks about, be it in metric space topology or point set topology, A closure is full set. Okay, and I find that students don't have any intuition. When you say A is dense in X, if A closure equal to X, has no intuition. Why? This is the first thing, whenever I write something, I try to understand. The problem is, in new subject, there are certain primitive concepts. In the metric space setup, the primitive concept is open ball. In the context of general topology, the primitive concept is open set. So whatever new concepts you explain, if it is brought down to primitive concepts, it's easier for us to understand. Whereas, if you use a secondary concept, you have to figure it out. Think of it as some kind of involved programming, routine, subroutine, sub-subroutine. It will be difficult for you to understand, even though it makes it very effective. Okay? I'm not saying don't do that, I'm just saying. Okay? So kind of layers after layer after layer, it's hidden. Okay? So if you say A closure equal to X, then I have to understand what is the closure of a set X. Then I will be worried about only the closure, I will not worry about why the density comes. Whereas look at my book, it just gives us a simple definition. Every open ball must intersect A. I can immediately imagine what it tries to say. Much worse is the nowhere dense set. Interior of A closure is empty. Now you see that closure is a secondary concept. So I take a set A, I have to understand what is a closure, and then I have to understand interior, then I have to say it's empty. Does it say anything? Okay. Whereas look at my book, it simply says this. Look at plane, look at a line, I take any open set, it may intersect the line. But what I say is, I can find a non-empty open set contained in that which does not intersect the line. I have this intersection, take this one, it's not going to intersect. That immediately gives you, that's what it means by over dense. So this is the kind of thing. See, this is what I said, going against the trend. Just because every book in the world talks A is dense if A closure is X, A is nowhere dense if interior A closure is empty, you will see they come as exercise or a remark. It is equivalent to standard definition you find in other books. This is what I meant. I am ready to go against the trend if I believe it will help my students, my readers understand better. This is one of the kind of tenets of my book writing. I don't care. I don't know to prove I'm an expert. I don't know to say that other experts should approve that the book is good. As Baba said, why should Raman write? What is that? Trash? Okay. I'm sure he is a logician. Because as I said, he did not understand the difference between foundations of mathematics, foundation course in mathematics. Okay. So if that logician could not understand this logic, you know where he stands. I'm sorry, it's personal, but anyway, I can't help it. So, coming back to this, as I gave an example, the third thing which really you will see in my book is compactness. Now, because of points of topology, you ask anybody what is compactness, every open cover must admit a finite subcover. It's like a mantra, right? You understand why these definitions are very powerful. Everybody uses. It is easier to chant like mantra. A is dense if A closure is X. A is nowhere dense, interior A closure is empty. Yeah? And K is compact if every open cover of K admits a finite subcover. It's easy. You understand? Whereas, according to me, A is dense, give me any non-empty open set in the general topology, or here, any open ball, it will intersect A. You have to say a lot. And A is nowhere dense, you give me an open set U, it may intersect A, but I can find a non-empty open set such V of U, such that V intersection A is empty. Now you have to say a mouthful, but I can draw a picture and explain. You draw a picture for me, interior A closure is empty. You see that? So, the same thing with compactness. It's a beautiful thing. When I wanted to get compactness in the general topology case, that's the best definition. Every open cover admits a finite subcover. But that's the bad definition in the case of metric space. I took a stand. Even in my real answer book, you will see just a passing remark somewhere. In the context of metrics, in fact, compactness came because of analysis. Why did it came in analysis? That's a very simple. You want to solve find a solution of something, okay? So let us say solution is F. I may not be able to find F. What I do is I find something like approximate. Do not understand, say intuitively understand. There I find approximate solution Fn. Okay, Fn is closely approximate to F. Fn is not a solution. Then if it converges, then I may get a solution, possibly. It may not, but I find there is a subsequent it converges to solution. How many of you remember your Picard's theorem? Rather, Peano's theorem, Arzelà-Ascoli. Okay. So compactness arose out of analysis. That is, you give me a sequence exam, I can find a subsequent which converges. Why did they make that as a definition there? That's precisely for the reason. I want to find a solution F, which is an ideal candidate. I may not be able to get. But what I can do is I can find Fn which are as close to the ideal solution F as I want. So next thing is, visual thinking is, if Fn converges, it may not, then what do I do? If it has a convergence subsequence, I am still getting through. Okay? This is the way metric space, compactness, any result which uses compactness in metric space, you can prove using this. Okay. How many of you are doing master's degree? All of you have done the general topology, right? Now it's a test for you. No, I am not going to ask a serious question. Don't worry. Test for your course rather than for you. If you have done compactness, tell me whether it was proved how to characterize compact metric spaces. They will never do. Okay? But when you go to functional analysis or complex analysis, okay, even higher aspects of analysis, you need to deal with functional spaces which are given some kind of metric or norm, and then you have to talk about compactness there. When you go to functional analysis, you have to talk about compact operators, Schroeder theory of compactness or self-adjoint compact operators, everything. Your open cover definition is not going to work. If you start with that, you will not be able to prove results easily. So you want characterization of compact metric spaces. Usually what I find is in MSc course it's never done. And in metric space topology it's never done because part of real analysis, what they did is they talked about only very basic things: open wall, open set, closure, continuity, completeness, compactness in the open set category. That's it. But the equivalence is never proved. The important thing for compactness of metric space are two things. One is every sequence has a convergent subsequence. Other one is theoretically it's very powerful. That one is it must be a complete metric space and it should be totally bounded. Okay, these are the two results where whenever you need the analysis in the context of metric space and compactness, these are the one. Tell me whether it is proved. When your functional analysis teacher comes, he will simply quote it and run away because he has a portion to cover, he will not do that. Okay. Now, right, now I understood it's needed. There are people who will simply accept and go ahead with that, that's fine. But if you are one of the curious, okay, doubting Toms, you want to understand the proof. Where do you look for it? Look at any of the classical books, okay, you will go mad. I went, okay, in MSc. Okay. There will be something like 15 to 20 page proof. They talk about everything. Compactness is second countable, this is separable, that is, there is a limit point compactness and what is it? Whatever the word, okay. All kinds of things they will keep talking. And all of a sudden, okay, that lemma, this theorem, that proof, this exercise, that example, this follows. You never understood. Okay. You will see that there is a beautiful one-page proof in the book. The 4 equivalent conditions. In fact, the 4th equivalent condition is not needed. First equivalent condition is standard topology definition. Every open cover admits a finite subcover. Second thing is every sequence has a convergent subsequent. Third thing is complete and totally bounded. Fourth one, I am yet to find its use in my life. I have done 50 years of mathematics, or a little more than that. Every input set has a cluster point. I will not call it the limit point, I will come to that. Where Kumaresan also goes against the trend there also. Okay, I have not used it. I don't, okay. I have done it, all kinds of analysis, topology, okay. I have differential equations. I have never used that characterization of compactness. What is it? What they call limit point compactness. I have done not done. So compactness also I took a stand. The emphasis should be metric characterization, okay, in topological interpretation, and give examples. In fact, there will be very good examples in my book which you won't find in any book about how to use compactness, these characterizations. In fact, I also say this characterization will be useful for this kind of problem, the other characterization will be useful for different kind of problems. And fourth, another point where I took a stand, there is also a very interesting history about that. You know, whenever all of you know what is a limit point, as you across the world, all except me believe what is a limit point. Okay, limit point is X is a limit point of set A if every open neighborhood, right, or open ball if you want to say X, okay, intersects A at a point other than X. That is, it has a point A, deleted neighborhood, intersection A should be non-empty. How many of you will believe somebody wrongly called this as a limit point? Unfortunately, that book became popular and everybody sticks to that. Okay, the original definition of limit point, see what is there about limit point? Just imagine. I call it a cluster point, accumulation point, because the set accumulates or clusters around that point is what it says. Any small neighborhood, apart from that also it contains somebody there, like a celebrity. Like a celebrity, if you know, nowadays who is a celebrity in Bollywood? Earlier day I used to say Amitabh Bachchan, later it became Shah Rukh Khan, now I do not know. Okay. Or let's say I am coming from South India, so I can say Rajinikanth. Okay. You put Rajinikanth in any crowd, there will always be people around him. Okay. You put Kumaresan, people who knows about my books or somebody, there will be crowd. You put me in an airport, nobody cares about Kumaresan. So, cluster points are people around them, set clusters, accumulates around. Okay, that's what it is. So, it's somebody without understanding wrote it as a limit point and it got stuck and everybody believes that. So, I took a stand, for me limit point is X is the limit point of A if every open set containing X intersects A. I took a point. And what is the history of interesting episode, just as a kind of a side remark. see, there is a National Board for Higher Mathematics, NBHM, all of you must know, right? MTT is supported by that. So there is a textbooks, there is a book distribution scheme. One of the person reviewed my book and said, no, this person calls it a limit point, okay, wrongly, so we should not distribute the book. Till date, I don't think it's distributed by NBHM. Maybe I should thank them because it's more popular than other books. Okay? So, I'm also telling you the price I pay for my convictions. Okay? So, I'm ready to take a stand if I'm convinced of something. In fact, in the topology book, which recently published book, which I had, you want to hear? No, it's okay. I just want to talk about it. Okay. I take a stand there, it is going to backfire. The stand I have taken is what I just now said about cluster point. Okay, whatever you think of as a cluster limit point, I don't want to call it. I think of it as cluster point, accumulation point. I said for topology you don't need it. Okay, lot of topologies, even dead topologies will turn in their grave. Okay, I said that. I stand by that. Okay, I have given cluster point is the creation of analyst. Only analysis needs it. Topology doesn't need it. Okay, I'll stand by that. I'm ready to be challenged any time. See, this is the kind of stand I take always. I don't want people to accept, readers to accept what I'm saying, but I want them to think. That's what is the hallmark of education. Okay. Why does he say that? Is there anything? Then you try to think about, where did I use cluster point? Where did I use it? Could I have avoided that? Try to see, so that you learn much better. Okay. On your way to challenge accumulation, you will learn better, you know. That's the way. Yeah. So that is the kind of things I always do that. So these are the basic things. Next to two things where it differs, as I said, bare category theorem, and that also is a personal thing. So I was in TAFR as a researcher, then I shifted to University of Mumbai, and when I was at TAFR itself, some student joined me as a PhD student, but she was working with the Mumbai University. Then I gave her a problem. She is extremely good. She tried. After a few days, she came and said, "Sir, I could not even get an idea how to attack the problem." Then I told her, "Oh, it's an easy bare category theorem." Do all of you have heard that word? Bare category theorem? At least master's degree students should know that, right? Bare category theorem. Category 1, category 2, Meagher set. Yeah? Don't ask me the definition, I do not know them. She said, okay, I will try. After a week, she comes back and says, no, sir, I do not. I said, what? What is bare category theorem? She said something like, a complete metric space is a bare space. I said, no, naturally you can't solve the problem. Then she said, I do not know, it's a complete metric space category 1, category 2 or whatever, I don't know, exactly know that. And the point I'm trying to say is I never needed that. Whereas bare category theorem says only two things for me. One is very thin sets, countably many, cannot be equal to the full space, their union. That's one thing. Second thing is, if I have countably many open dense sets, their intersection is still non-empty. And both have a reason why they are there. In my book, I would explain. Not metric space will explain that. And they always, just because everybody says a bare category theorem, they have to say category definition, category 1, category 2, Meagher set, whatever it is, then they would have to say that. I never said that. Only these two aspects, a countable union of something is not going to be the full space, or countable intersection of open dense sets is non-empty. These two have immediate applications. You can see which one is needed where. For example, if I give a plane, countable union of straight lines, will it be equal to the plane? No. Try that. Okay. I have to stop time. Yeah, I'm going to stop. Okay? No. Still, it will be reaching, so don't worry.
No, sir. Actually, sir, question answer, I just.
I'm going to take, yeah. So, it's all right, don't worry. So I took a point, I will explain what those two equivalent versions are. That's it. I'd never bothered about. That's why I even didn't call it Bayer category theorem, I call it only Bayer theorem. Okay. So everywhere I look for what it's supposed to mean, where it is going to be used, in what way it will be useful, and attend to that. Don't worry about what the tradition demands. Okay. If you think everybody does, in the past everybody was like that, it was a glorious era, so I will stick to that today also. God save the subject.
Any questions from audience?
Sir, how to understand the theorems? Because
how to understand
theorems in any kind of topic or etc. So this is.
Yeah, that will be deviating from my talk, but it's okay. I will attend to that.
Because you tell Bayer category theorems.
See, the first thing is, when you read a theorem, don't worry about the proof. Okay. First, understand the theorem. Naturally, every theorem depends on previous concepts. Don't worry about previous results, previous concepts. Try to understand whether you understand the concept. Okay. Next thing is, try to see, even without a proof, try to see what kind of application it can have within the subject itself. Don't worry about outside. Okay. Either for machine learning or psychiatry or criminology or auditing. Don't worry about its application. Try to see within the subject. If I read a theorem, does it down. So that is the way you will appreciate the theorem. Okay. Proofs are important because it teaches a lot of tricks. That kind of tools will be applicable to solve problems of later. But if you want to apply theorems, then you have to understand the theorem, not the proof. Okay. So the best thing is try to understand and make the simpler case. If you simply say about metric space, I would think of only R and RR. Try to understand it there, whether I can try to do that. The next thing is, can I think of immediate applications? After that, yeah. That's a short answer.
Any other question? Yeah.
I have just one request that so many courses we have learned from you through YouTube channel, and I have personally learned reanalysis course from you at University of Hyderabad. So I request you to deliver some lectures and so many courses like algebraic topology or differential geometry, and I hope that you will do that quickly.
Thank you very much. Again, I go by my principle. What? Yeah, thank you. Please sit down. I again go by what I consider as core subjects. Okay. I think you might have even made a request. I do not know because there are many people who would ask for algebra, topology, differential geometry, etc. For me, I went to cover the basics. For example, functional analysis, measure theory, and even algebra I want to do. I have done parts of algebra like group action, etc., but including up to Galois theory. After that, if my health is there, I will do that, but I do not know. But my thing is, I want to cover what I consider as core subjects there also. Basic, very elementary number theory up to Chinese remainder theorem, groups, rings, and fields up to perhaps Galois theory is separate. That also is not essential for me, even though I love that. Okay, just because everybody will say this, I don't know to do that. Okay, and so reanalysis I have done, several variable calculus I have done, and I have done metric space, general topology. Then I have to do measure theory and functional analysis and general algebra. After that, if my health permits, I may come to that. Not now. Thank you.
Other question?
Sir, I have a question. So, in several times, I have, I think many of us faces same issue, that we are going through the proofs, but we are big proofs, we are getting our motivation, we are lost. So, sometimes we cannot track on what we are going to do. So, what should be our intuition to go through the proofs?
See, go through the proof. I will tell you my way of learning any proof or learning any book. What I do is I do a very quick reading. You understand? Like think of yourself, you have only 24 hours, okay? You are in Rome, okay? You are connecting flight is after 12 hours. Then now you are in Rome, what will you do? You will go through quickly, right? Sightseeing. So similarly, I do mathematics. After that, I sit think over. So naturally, I would have got everything correct. Then I find where I missed the points. Then I go back and read, then I understand better. So the very quick way is, I think it will turn into learning mathematics, and I think we are running behind time. We can take it later. The quick thing is, try everything is built out of few steps. Try to identify them. Okay, each is a small problem. Just if you look at my books, you will see that I will write as a strategy, main steps. That is the way you have to develop. Okay, don't worry about the details of the proof. Try to understand what are the main steps. Each step is a small problem. You try. If you don't get to read it, then you understand better. Therefore, the 5-page proof, you will see only 3 ideas, then you can build on your own. Okay, with the expert kind of experience and training yourself, usually it takes less than a month's time to acquire that skill. Yeah. Maybe we should. Are we running out of time?
Sir, some few more questions. Actually, they are from.
No, I am open. But the point is, there are other speakers who should not do. Yeah.
Yeah. So, okay. Yeah. So I have read many real analysis books. Okay. So I have also read the book written by you. And one thing that I've seen, that before many theorems or chapters, that you have written some kind of motivations or some things. So I just wanted to ask, like, what was the purpose behind that? What was the thought process behind doing that? Because I haven't seen that in many other books that you do.
Well, the purpose is very simple. That's the way I learned, and I think it made me wiser. So I want my readers also should be wiser than I am. That's the reason.
Sir, one more question.
Yeah.
Good afternoon, sir. Your words were really intriguing, and I'm really honored to talk to you at this moment. I'm shivering at the moment while talking to you. So, I just had one question to a BSc Mathematics student. What would be the things that you'd like to share on the field of research? On the field of research, like if I want to do research on mathematics, what would the things which you'd like to say to a BSc Mathematics student?
See, research is actually easy if you know what to do. Okay. In fact, recently in Kerala, I showed what a research is by using only high school mathematics. The thing is, try to understand why certain things happen. First one. Second thing is, you use some kind of logic thinking tools. Next thing is, you try to understand, like a businessman, what is in it for me. Now that I got it, can I use it elsewhere to get something more? Okay, all right. And third thing is, it looks almost similar in this situation. Also, can I do something? Right. These are I'm saying vague, but you see that this is all you have to look for. Okay. You say something about something similar. In this case, can I prove something similar? Okay. That is the starting point. That is how you will get original results also. So, just you have to be curious, and never ever be satisfied just because you learned the proof. Try to analyze the proof, whether you can push the proof more, or you can modify that argument, or the same proof gives much better result, or used elsewhere. These are the basic tricks you have to learn. Yeah.
Thank you so much for your time, sir.
Any other questions? Okay. So this is the last question, since we are running out of time. Okay, just sit down. So, sir has a question.
Oh,
sir, this is rather a request in the deceive appearance of a question. So, whenever we think Amul, we have in our mind Varghese Kurian. If we think about MTTS, we have some name in mind. But if we want to know about Varghese Kurian, we have a cinema called Monthan. We have a good book called I Too Had Dreams. But if I think about the MTTS person, we earlier had a block which stopped 10 years ago. After 2010, it stopped. Sir, is there any way to know about that thing, sir?
You are talking about block?
Sir?
What are you
There
talking?
was a block which stopped after 2010.
Block.
Block.
Yeah. See, in fact, when I started, I thought I have a lot more time, basic retired life, so I thought I will be able to continue that. But every time when I moved to Hyderabad, I thought I will have a lot more time. When I retired, I thought I will have a lot more time. Okay. When I stepped down from MPTS Trust, I thought I will have a lot more time. But every time somehow, the more I want to give up, the more seemed to be on me. Okay, now I got into too many things, but I would certainly love to write that. There are a lot of things which I want to share, okay, for people like you, but I don't think I am going to revive that, because whatever energy I have, health I have, I want to spend on MPTS and finishing some of the books and my videos on the core subjects, what I consider as core subjects. I think they are my top priority, not block. Okay, thank you.
Sir, we always eager to listen to you, but we have some time bound. But one announcement for the mathematics students that we have Professor Kumaran with us for some days. Okay, and we have an interaction session. I mean, a whole evening. If you want a whole night on 12 October. So Professor Kumaran is with us for a whole evening and night. So we will talk, and if you have any questions, sir will answer the question on 12 evening. Okay? Thank you, sir, for your nice and motivating lecture, sir. Thank you, sir.
Thank you very, very much for all your questions. A lot of things were mentioned. And as he said, I will be here on 12th after 2 o'clock onwards. Okay? So if you feel free, you can come here. We can discuss as much as you want. Thank you very much.
ছাত্ররা তোমরা ধীরে ধীরে পেছনের দরজা দিয়ে যাও, তোমাদের জন্য একটা স্ন্যাক্সের ব্যবস্থা আছে, পেছন দিয়ে ওপাশ দিয়ে যাবে কোনো রকম। আর বাইরের যারা তারা নয়, মানে স্টুডেন্টদের বলেছি, শুধু স্টুডেন্টরা মানে আউটসাইড পার্টিসিপেন্টসরা আপনারা থাকুন, স্টুডেন্টসরা যাও। আমাদের পরবর্তী ছাত্ররা ওদেরকে বলো সেকেন্ড গেট দিয়ে ঢুকতে, সেকেন্ড গেটটা দিয়ে ঢোকো, সেকেন্ড গেটটা দিয়ে ঢুকতে বলো।
যেখানে জ্যাম হয়ে গেল কেন? রান্না করো।
So now this is a session for botany. Now I request Professor Timi Borun Jha sir to come on dais. Now I request our librarian sir, Dr. Ruby Kumar De, to come on dais and felicitate sir. Please come. I request Dr. De to introduce Professor Timi Borun Jha sir. Please.
A very good afternoon. Professor Dr. Timir Borun Jha is a professor of botany, West Bengal Senior Educational Service. He served different government colleges in the capacity of lecturer, assistant professor, and associate professor. He joined West Bengal Senior Educational Service as a professor of botany in 1995 and served as professor and head Department of Botany, Darjeeling Government College. He served as additional director of administration, Higher Education Directorate, Government of West Bengal for the period 1998 to 2002. He served as professor and head Department of Botany, Presidency College, for the period 2002 to 2013. At present, he is associated with the Department of Botany, Maulana Azad College, Kolkata, as an honorary researcher and teacher. He has an experience of more than 4 decades of teaching and research in the field of plant biotechnology, genetics, and plant chromosome research. He handled many funded research projects, guided PhD students, attended many international conferences, and to date he published more than 90 research papers in national and international journals. Presently working on molecular cytogenetics with valuable Indian crops. He authored a book, Plant Tissue Culture, Basic and Applied. Now I request Professor Jha to deliver his specious lecture. Sir, please come.
ঠিক আছে, আমি বাংলাতেই বলবো, কারণ আমার মনে হয়েছে যে আজকের এই অনুষ্ঠানটা এটা একটা নভেলটি রয়েছে। তো প্রাইমারি অবজেক্টিভ যাওয়ার আগে প্রথম যে কলেজে এসেছি সেই কলেজে আমি ঠাকুর রামকৃষ্ণ, মা সারদা দেবী এবং স্বামীজিকে আমার সশ্রদ্ধ প্রণাম জানাচ্ছি। আমি আমার রিগার্স জানাচ্ছি এই কলেজের প্রিন্সিপাল মহারাজকে এবং আজকের এই অনুষ্ঠানের যিনি কনভেনার বা সেক্রেটারি আমাদের লাইব্রেরিয়ান সাহেব ডক্টর দেকে, যে আজকে আমাকে এখানে কিছু বলতে বলার জন্য। এবং বলতে বলাটাও খুব অদ্ভুত, মানে এটা হচ্ছে আমাদের টিপিক্যাল কনফারেন্সের লেকচার নয় যে একটা টপিকের ওপর আমি বলবো। তো এটা বলার আগে আমার যেটা মনে হয়েছে, এখানে তো টপিক সিলেক্টেড নয় যে একটা আসপেক্টের উপর আমি বলছি, এটা একটা জেনারেল আসপেক্ট। যে এবং অবজেক্টিভটা আমার খুব ভালো লেগেছে যে কেন আমরা বই লিখি, কেন বই লিখতে হয়, এবং বইয়ের কেন বইটা যারা লেখক তাদের কাছে এটা স্পেশাল হয়। তো তার আগে আমার মনে হয়েছে যে আমাদের এই যে দেশটা না, আমাদের দেশটায় সে একটা দ্বিজেন্দ্রলাল রায়ের গান আছে যে এমন দেশটি কোথাও খুঁজে পাবে না গো তুমি। আর কেন আমি বলছি, কারণ এই যে শিক্ষা, শিক্ষক, বই, এগুলো কিন্তু সব ওতপ্রোতভাবে যুক্ত। এবং এই ওতপ্রোতভাবে যুক্তর সঙ্গে আজকে যারা আমরা শিক্ষক ছিলাম বা এখনও কিছুটা পড়াই, আর সামনে যারা বসে আছে তারা কিন্তু ভবিষ্যতের শিক্ষক। তো সুতরাং এই যে বন্ডেজটা, এই বন্ডেজটা কিন্তু আজকে থেকে শুরু হয়নি, যুগ যুগ ধরে চলে এসেছে। এবং আমাদের দেশে আমি কয়েকটা নাম বলছি যে আমাদের এই দেশেই তো জন্মেছিলেন ঠাকুর রামকৃষ্ণ দেব, আমাদের দেশেই জন্মেছিলেন মা সারদা দেবী, আমাদের দেশেই জন্মেছিলেন স্বামীজি। এদের কিন্তু প্রত্যেকের নিজস্ব চিন্তা ভাবনা, নিজস্ব চিন্তাধারা, শিক্ষা বিষয়ে তাদের কিছু বক্তব্য, এটা কিন্তু আজও আমাদের পথপ্রদর্শক হিসেবে চলে। এগুলো হচ্ছে আমাদের ব্যাকগ্রাউন্ড, কিন্তু এগুলো একজন ছাত্রের ব্যাকগ্রাউন্ড, একজন মাস্টারমশাইয়ের ব্যাকগ্রাউন্ড, এই ব্যাকগ্রাউন্ডে আমাদের এগুলো থাকে। আরেকজন মানুষের নাম করতে হয়, রবীন্দ্রনাথ ঠাকুর। মানে তিনিও বলেছিলেন যে আমাদের যে শিক্ষাটা, সেই শিক্ষা মানুষ নির্মাণ করে না, তার উন্নয়ন ঘটায়।
মানে তার ডেভেলপমেন্ট করা, একটা শিক্ষার মাধ্যমে আমরা ডেভেলপড হই। আর বলেছিলেন যে যদি তোমার প্রশ্ন না থাকে, ওই যে ক্লাসে আমরা যখন পড়াই তখন আমরা বলি তোমাদের কোনো প্রশ্ন নেই। এখন কিন্তু ছেলেমেয়েরা প্রশ্ন করতে চায় না। তো রবীন্দ্রনাথ বলছেন তখন যে তোমার যদি প্রশ্ন না থাকে তাহলে উত্তর তো খুঁজে পাবে না। আর স্বামীজি বলছেন যে শিক্ষক সে তো অ্যাকচুয়ালি তোমাকে ডেভেলপ করছে, সে তো তোমার আসল গুরু। তো গুরু এবং শিষ্যের সঙ্গে বইটা তো অবশ্যই যুক্ত হয়ে যায়। তো সেই বই আমরা কিন্তু বোধ হয় অনেকেই জানি, আবার হয়তো জানি না যে বুক, BOOK বুক কথাটার অ্যাক্রোনিমটা কি। সেটার অ্যাক্রোনিমটা কিন্তু হচ্ছে যে বায়ো অপটিক্যাল অর্গানাইজড নলেজ। এবং এটা কি করে না, এর মধ্যে রেকর্ড করা হয় ইনফরমেশন ইন দ্য ফর্ম অফ রাইটিং অর ইমেজেস, এবং তারপর সেটাকে বাঁধানো হয় এবং তারপর সেটা আমাদের হাতে আসে। এই বই কিন্তু ছাত্ররা দুটো জায়গা থেকে পায়। এক হচ্ছে তারা নিজেরা পারচেস করে, আরেকটা যে একটা কলেজের বা স্কুলের, যেটাকে আমরা ট্রেজার হাউস বলি, সেটা হচ্ছে লাইব্রেরি। লাইব্রেরি না থাকলে কিন্তু একটা কলেজ সম্পূর্ণ হয় না, কারণ লাইব্রেরির মাধ্যমেই কিন্তু এই বইয়ের আদান প্রদানগুলো চলে। এবং পার্টিকুলারলি এই কলেজটা, এই কলেজের লাইব্রেরিটা যতটা অ্যাডভান্সড, আমাদের পশ্চিমবঙ্গের খুব কম কলেজ বা বিশ্ববিদ্যালয় রয়েছে যেখানে এত সংখ্যক বই এত সুষ্ঠুভাবে এবং অ্যাডভান্সড ওয়েতে ছাত্রদের হাতে পৌঁছতে পারে। কিন্তু ঘটনা হচ্ছে যে আমাদের প্রথম যিনি আজকে বক্তব্য রেখেছিলেন তার একটা কথা আমার ভালো লেগেছিল, যে উনিও বলছেন, উনি আসাম থেকে এসেছেন, উনি বলছেন যে এখন খুব কম ছাত্র তারা বই পড়তে ভালোবাসে। এটা কিন্তু আমার নিজেরও অভিজ্ঞতা, প্রায় 4 দশক ধরে পড়াচ্ছি। তা আমি প্রথম ক্লাসে যখন জিজ্ঞেস করি, পোস্ট গ্র্যাজুয়েট হোক আন্ডার গ্র্যাজুয়েট হোক, যে তোমরা কি বই পড়েছো, তা আমি বলি এটা তোমাদের ত্রুটি নয়, ত্রুটিটা আমাদের। কারণ আমরা তোমাদের বোঝাতে পারিনি বইটা পড়াটা দরকার। আমরা ভেবেছি যে না, ওই জেরক্স হলেই হয়ে যায়। এখানে কিন্তু মাস্টারমশাইদের একটা রোল থাকে যে একটা বই যখন লাইব্রেরিতে আছে বা পাওয়া যাচ্ছে, সেটা আমি কেন পড়ব না। আর এখন বই তো ভার্সনেও এসেছে। আমি কিন্তু ব্যক্তিগতভাবে হার্ড কপিতে অনেক বেশি বিশ্বাস করি, কারণ ওটা যেন হাতে নিলে একবারে আমি 50 পাতা থেকে 90 পাতায় চলে যেতে পারি। আর মোবাইল দিয়ে কিন্তু বই পড়া যায় না। আমি এটা আমার পার্সোনাল ওপিনিয়ন। এটা আমাদের তো একটা গণতান্ত্রিক অধিকার থেকে ডিফারেন্স রাখার, তো সেটা রেখেই আমি বলছি, একজন শিক্ষক হিসেবে আমি মনে করি যে ছোট মোবাইলে বইয়ের লেখাগুলোকে না ভালো করে চোখে দেখা যায় না। তো সেটা বোধহয় আমাদের ইচ্ছাটাকে আরেকটু ডিস্টেন্সে ফেলে দেয়। তো এরকম একটা জায়গা থেকে আমরা একটা বই লিখেছি। আমরা বলছি এই জন্য যে আমি আমার এই শিক্ষকতার যাত্রা শুরু করেছি মানে সরকারি কলেজে। সরকারি কলেজের একটা সুবিধে হচ্ছে যে আমাদের একটা কলেজে থাকতে হয় না, মানে আমাদের ঘুরতে হয়, এবং আমাদের এই ঘোরাটা সারা পশ্চিমবঙ্গ জুড়ে। তাতে যদি কেউ লাভবান হতে চায়, আমি লাভবান হয়েছি পার্সোনালি, যে আমি বিভিন্ন অঞ্চলের ছাত্রদের দেখেছি, তাদের নিডটা দেখেছি এবং তাদের কি দেয়া যায় সেটা চিন্তা করেছি। এই চিন্তা করে সুদূর ঝাড়গ্রাম থেকে শুরু করেছিলাম আমার টিচিং প্রফেশন, তারপরে দার্জিলিং, একদিকে ঝাড়গ্রাম একদিকে দার্জিলিং, ছাত্রছাত্রী এক, কিন্তু তাদের রিকোয়ারমেন্ট ডিফারেন্ট, এবং আমরা তাদের কতটা দিতে পারছি। সেই দিতে পারতে গিয়ে আমি দেখলাম যে তাদের রিকোয়ারমেন্টের একটা আমাদের যে সামাজিক অবস্থা, সেই সামাজিক অবস্থাটাও কিন্তু আমাদের ছাত্রদের আমাদেরই কনসিডার করার কথা। তো আমি ক্লাসে গিয়ে এটা আমার অভ্যাস যে আমি প্রথম দিনের ক্লাসে একটা বুক লিস্ট দিয়ে দিই যে দেখো এই বইগুলো আছে, এই বইগুলো তোমরা লাইব্রেরিতে দেখতে পারো। কিন্তু সেই বইগুলো যখন দিই, সেই বইগুলোর হয়তো অধিকাংশই বাইরের লেখকদের বই থাকে, এবং সেই এক একটা বই আমি একটা ছাত্রকে বলতে পারি না যার একটা কলেজে পড়ার টিউশন ফিটাও জোগাড় করতে কখনো কখনো প্রবলেম হয়। এটা আমাদের দেশে হয়, সবাই তো আমরা সবটা করতে পারি না। কিন্তু ওই আমাদেরই একজন মানে অত্যন্ত বিখ্যাত কিন্তু অত্যন্ত সিম্পল জীবনযাপন করতেন প্রফেসর আব্দুল জে কালাম। তিনি একটা ভয়ানক চমৎকার কথা বলেছিলেন। ওই যে প্রথম যেটা আমি বললাম যে এমন দেশটি কোথাও খুঁজে পাবে না কো তুমি, উনি বলছেন যে আমাদের the nation's best brains may be found in the last benches of the classroom. আমরা কিন্তু এই যে চন্দ্রায়ন হলো না, আমরা তখন কিন্তু এটা বেশ উপলব্ধি করছিলাম। আপনারাও নিশ্চয়ই এগ্রি করবেন যে আমাদের বেস্ট ব্রেইন গত 2 দশক ধরে জেনারেল একাডেমিক্সে কিন্তু আসে না, এবং আমাদের যে আইআইটি আইজার এখানকার যারা টপার তারা কিন্তু ইসরোতে যায় না, তারা কিন্তু বাইরে চলে যাচ্ছে। তাহলে প্রফেসর আব্দুল জে কালামের যে কথাটা যে আমাদের ট্যালেন্ট কিন্তু শুধু ফার্স্ট বেঞ্চে নয়, আমাদের ট্যালেন্ট লাস্ট বেঞ্চেও থাকে। তো সেই ট্যালেন্টের জন্য যে তথ্য, সেই তথ্য তো আমাদের পৌঁছতে হবে। এবং সেখানে উনি বলছেন, আমি আমার বইয়ে আসার আগে আমার খুব ভালো লেগেছে ওনার কথাগুলো। উনি বলছেন যে all of us do not have equal talent. সত্যি তো, আমরা যেখানে সবাই বসে আছি we are diverse, আমাদের ট্যালেন্ট সবার এক নয়, কিন্তু আমরা তো এক অপরচুনিটি দিতে পারছি। একজন মাস্টারমশাই যখন ক্লাসে তার লেকচার ডেলিভার করেন তখন তো তিনি বাছবিচার করে করেন না, ভালোবাসা থেকে করেন না যে আমি সামনের বেঞ্চকে ভালোবাসি তাহলে আমি সামনের বেঞ্চের জন্য একটু বেশি জোরে বলবো, আমি পেছনের বেঞ্চকে কম ভালোবাসি তাহলে কম জোরে বলবো। প্রশ্নটা তা নয়, প্রশ্নটা হচ্ছে অপরচুনিটিটা কিন্তু সবার কাছে সমান থাকতে হবে। আমি যখন আমার বইয়ের কথা আসবো আমি এই জায়গাটাতেই ফিরে আসব। তো এবার প্রায় 2 দশক ধরে যখন বিভিন্ন কলেজে এরকম পড়াচ্ছি তখন আমার বারবার মনে হয়েছে যে আমি আমার বটানির বদলে প্লান্ট সায়েন্স বলতে একটু বেশি ভালোবাসি। আমার মনে হয় প্লান্ট সায়েন্স বললে ব্যাপারটাকে আরো সুন্দর করে বলা যায়। তো প্লান্ট সায়েন্স এমন একটা সায়েন্স যে আমার খুব ভালো লাগতো যদি এখানে অন্য ডিসিপ্লিনের ছাত্ররাও থাকতো। আমরা ফার্স্ট হাফে ম্যাথামেটিক্স নিয়ে আলোচনা শুনেছি আমি। তো আমি আমার ছাত্রদের সবসময় বলি যে জানো তো এই যে প্লান্ট এরা কিন্তু ইজ এ ভেরি গুড ম্যাথামেটিশিয়ান। ওরা কথা বলে না, ওরা চলতে পারে না, কিন্তু কখনো কি আমরা অবজার্ভ করেছি যে একটা প্লান্ট যখন গ্রো করছে তার প্রত্যেকটা পাতা ইকুয়াল সানলাইট কি করে পায়? ইজ ইট নট ম্যাথামেটিক্স? যখন একটা প্লান্ট আমরা খাবার কথা ভাবি, আমরা বাসে টাকা দেবার কথা ভাবি, তখন কিন্তু সেই ঘুরে ফিরে আমাদের প্লান্টই চলে আসে। এবং আজকে যে ক্লাইমেট চেঞ্জের আলোচনা হচ্ছে, যেটা আমরা প্রত্যক্ষদর্শী, তার প্রথম ভিকটিম কিন্তু প্লান্ট। তো এই প্ল্যান সায়েন্স আমাদের যে স্কুল এডুকেশন এবং যে কলেজ এডুকেশন, আমাদের স্কুল এডুকেশনটা মানে প্ল্যান সায়েন্সটাকে এমনভাবে প্রেজেন্ট করা হয় যে ওটা গাছের নাম ছাড়া আর কিছু নয়, কিন্তু প্ল্যান সায়েন্সের ফেস কিন্তু সেটা নয়। তো এই জিনিসটা যদি আমরা মাস্টারমশাইরা ক্লাসে তথ্য দিয়ে আমরা দিতে পারি, তাহলে কিন্তু এই মিলেনিয়ামের বেস্ট সায়েন্স প্ল্যান সায়েন্স, কারণ এটাই কিন্তু একমাত্র জায়গা যেটা আমাদের মানে বাঁচার জন্য আজকে থেকে 50 বছর 100 বছর পরে বাঁচার জন্য এটাই কিন্তু একমাত্র ভরসা। এবং এরকম একটা জায়গা থেকে আমার মনে হয়েছিল যে এই তথ্যগুলো যে ছাত্রদের অ্যাফোর্ডেবিলিটি, যে একটা বাইরের বই তার দাম 10 থেকে 12 হাজার টাকা, আমি কোনো ছাত্রকে বলতে পারি না যে তুমি না ওই বইটা কেনো। লাইব্রেরিতে বলতে পারি না এই বইটা 10টা ভলিউম কিনুন, 10টা কপি কিনুন, বলা যায় না। কারণ সব একটা কলেজ মানে প্রত্যেকটা ডিপার্টমেন্ট আছে, তাদের একটা অ্যালটমেন্ট থাকে। তা আমার মনে হয়েছিল একটা অ্যাফোর্ডেবল বই যদি করা যেত, যেটা ছাত্রদের কাছে পৌঁছতো, যেটা লাইব্রেরিতে থাকতো, এবং সেই জায়গাটা যেহেতু আমরা প্ল্যান সায়েন্সের বিভিন্ন আমাদের ব্রাঞ্চ রয়েছে, আমার কাছে কিন্তু কোনো ব্রাঞ্চ অবসোলেট নয়, কোনো ব্রাঞ্চ আলাদা নয়, যদি আমরা মডার্ন অ্যাডভান্সমেন্টটাকে ইনফিউজ করতে পারি, যদি আমরা সেইভাবে ছাত্রদের কাছে প্রেজেন্ট করতে পারি। তো সেখান থেকেই আমি যখন ভাবলাম প্রেসিডেন্সি কলেজে এসে যে একটা বই লিখব, তো তখন আমার মনে হলো যে এই বই একা লেখা যাবে না, এটা একটা ইন্টারডিসিপ্লিনারি ব্রাঞ্চ, যেখানে আমাদের প্ল্যান সায়েন্সের একদম অ্যালগি থেকে ফিজিওলজি, জেনেটিক্স সব যুক্ত হয়ে আছে। কারণ যে জায়গা থেকে এই সায়েন্সটা গ্রো করছে, সেই জায়গাটাই হচ্ছে প্ল্যান সায়েন্সের আসল জায়গা। তো তখন আমার মনে হলো যে আমার একজন সিরিয়াস, সিনসিয়ার, লাইক মাইন্ডেড আরেকজন মাস্টারমশাই দরকার, যার সঙ্গে ডিসকাস করতে পারি যে বইটার শেপটা কি হবে, নিডটা, ছাত্রদের নিডটা কি হবে। তো তখন এই কলেজেরই একজন মাস্টারমশাই ডক্টর বিশ্বজিৎ ঘোষ, উনি আমার কো-অথর, আমরা দুজনে মিলে প্লান্ট টিস্যু কালচার বেসিক অ্যান্ড অ্যাপ্লাইড বলে একটা বই আমরা লেখার শুরু করি 2002 থেকে, এবং ফাইনালি 2002 থেকে আমরা যখন বইটা লিখছি, তখন কিন্তু আমি সেই বইটার কন্টেন্টটা ছাত্রদের পড়াচ্ছি। এজন্য পড়াচ্ছি যে ওদের কোনো প্রশ্ন থাকে কিনা, আমার লেখার কোনো ত্রুটি থাকে কিনা, ওদের কাছ থেকে নতুন কোনো ফিডব্যাক পাওয়া যায় কিনা। এইভাবে কিন্তু আমাদের বইটাকে আমরা ডেভেলপ করার চেষ্টা করেছিলাম, এবং তারপরে 2005-এ প্রথম বইটা পাবলিশ হয়। তারপরে আমরা দেখেছিলাম যে 6, 7, 9 এটা রিপ্রিন্ট হয়েছিল। তো এবার এই বইটাকে আমাদের আবার আমরা হয়তো একটু অন্যরকম অথর, এবার 5-7 বছরের মধ্যে কিন্তু সায়েন্সটা অনেক ডেভেলপ করে যাচ্ছে। আমরা যেগুলো লিখছি মনে হয় তার চেয়েও বেশি ইনফরমেশান ক্লাসে পড়াচ্ছি। তো ক্লাসে তো আমি 30 জন ছাত্রকে পড়াচ্ছি, কিন্তু স্টুডেন্ট ফ্যামিলিটা তো 30 জনের নয়, এ তো অল ইন্ডিয়া ফ্যামিলি। সেই অল ইন্ডিয়া ফ্যামিলিকে যদি ক্যাটার করতে হয়, তাহলে তো অ্যাকর্ডিংলি টাইম টু টাইম বইগুলোকেও আপগ্রেডেশন দরকার। তা আমরা আমাদের পাবলিশারকে বললাম যে আমরা বই আপডেট করতে চাই, আমরা রিভাইজ করতে চাই, আমরা ইনফরমেশন অ্যাড করতে চাই। পাবলিশারদের তো চিন্তাভাবনাগুলো অন্যরকম থাকে। শেষে খুব মজা হলো, তারা রাজি হচ্ছে না, এরকম সময় আমি বললাম যে আমি বইটা উইথড্র করে নেব, কারণ এটা আমি রিভাইজ করব, আমি বইটা উইথড্র করে নেব, আপনারা আমাকে নো অবজেকশন দিন। তারা বললো আপনার বই এখনো 200 কপি পড়ে আছে, আমি পার্সোনালি পারচেস করে নেব। And I purchased all the books. পার্সোনালি। ওরা 200 কপি বই আমার বাড়িতে এনে দিয়েছিল, আমি তাকে চেক দিয়েছি, অনলি টু রিভাইজ দ্য বুক, যে আমি রিভাইজ করতে চাই, ইনফরমেশনগুলো ছাত্রদের কাছে যাওয়া দরকার। তারপরে আমাদের সেকেন্ড ভলিউমটা ফাইনালি কলকাতারই একজন পাবলিশার, খুব নামি দামি পাবলিশার নয়, তারা ধরলো যে না আমরা পাবলিশ করব। ঠিক আছে, ইনফরমেশনগুলো তো ছাত্রদের কাছে আসুক। এবং এই ইনফরমেশনগুলোর কথা বলতে গেলে এবার যে বইয়ের মধ্যে আমি আসি, প্লান্ট টিস্যু কালচার বেসিক অ্যান্ড অ্যাপ্লাইড, এটা স্কুল থেকেই, এখন স্কুলের সিলেবাসেও রয়েছে টোটিপোটেন্সি বলে একটা কথা, মানে পোটেনশিয়ালিটি। মানে ওই যে আব্দুল কালাম বলেছিলেন যে আমাদের লাস্ট বেঞ্চেও ট্যালেন্ট থাকে। তো এই যে একটা প্লান্ট তো হাজার হাজার সেল দিয়ে তৈরি, কিন্তু তার শুরুটা হয় কিন্তু একটা সেল থেকে, এবং সেই একটা সেল, তার মধ্যেই জেনেটিক্স, তার মধ্যেই ফিজিওলজি, তার মধ্যেই বায়োকেমিস্ট্রি, তার মধ্যে সব কিছু, তার মধ্যে জীবনের ব্লুপ্রিন্ট, একটা প্লান্টের ব্লুপ্রিন্ট। আমরা বলি দ্য মোস্ট পোটেনশিয়াল সেল, টোটিপোটেন্ট সেল, যে সেলটা থেকে একটা গোটা গাছ তৈরি হতে পারে। এবং এই প্লান্ট টিস্যু কালচার, এটা কিন্তু বায়োটেকনোলজি কথাটা শুনলে আমাদের অনেক বেশি আমরা ফ্যামিলিয়ার মনে করি। তো বায়োটেকনোলজির বেসিক যদি আসি, মানে এই 4 তলায় ওঠার বেসিকটা তো একতলায় না ঢুকলে তো আমি লিফটে উঠতে পারবো না বা সিঁড়িতে উঠতে পারবো না। তাহলে সেই বেসিক পয়েন্টটা কিন্তু হচ্ছে টিস্যু কালচার। কি না, তার পোটেনশিয়ালিটি অফ ইচ অ্যান্ড ইন্ডিভিজুয়াল সেল। এবং সেটাও বললেন 1902 সালে একজন বিজ্ঞানী, যে দেখো কোনোভাবে যদি ওই গাছ বাইরে যেগুলো আছে তার থেকে যদি ল্যাবরেটরিতে নিয়ে আসতে পারো, ওদের কিন্তু এই পোটেনশিয়ালিটি আছে। এবং সেখান থেকেই কিন্তু এই জার্নি শুরু হলো। প্লান্ট সায়েন্স একটা অন্য ফ্রেমে, একটা অন্য উইন্ডোতে চলে গেল, যে উইন্ডো কিন্তু ফিউচার ওয়ার্ল্ডকে সারভাইভ করার একটা হাতিয়ার হয়ে দাঁড়াচ্ছে। কদিন আগেই আমাদের বিখ্যাত সায়েন্টিস্ট M.S. স্বামীনাথন, উনি মারা গেছে। ওনাকে আমরা ভারতবর্ষের গ্রিন রিভলিউশনের ফাদার ফিগার বলতাম। তো গ্রিন রিভলিউশন তো প্লান্টকে নিয়েই হয়েছিল। 1960 একটা ফেমিন আটকে দিয়েছিলেন তারা সারা পৃথিবী ব্যাপী। বিহাইন্ড কি ছিল না, হাই ইল্ডিং ক্রপ তৈরি করতে হবে। অ্যাট দ্যাট মোমেন্ট, অ্যাট দ্যাট পিরিয়ড অফ টাইম, the best weapon, the best method was mutation breeding. তখন আমরা জেনেটিক মডিফিকেশন অন্য ফর্মে জানতাম না, কিন্তু মিউটেশন ব্রিডিং করে তারা যে ধান এবং গম গাছ তৈরি করলেন, সেটা অনেক হাই ইল্ডিং হলো, মানুষ ফ্যামিনের হাত থেকে বাঁচল। আজকে প্রায় 50 বছর পর আমরা রিঅ্যানালাইজ করছি, রিভিজিট করছি। এই 50 বছরে কিন্তু উই হ্যাভ এনাফ টেকনোলজি, এবং আমরা যে ড্রব্যাকসগুলো, একটা লিমিট, একটা টেকনোলজির, সেই ড্রব্যাকসগুলো কিন্তু আমরা অ্যাসেস করতে পারছি। অ্যান্ড হোয়াট ইজ আওয়ার অ্যাসেসমেন্ট? আওয়ার অ্যাসেসমেন্ট দ্যাট টু মাচ incorporating the insecticide, pesticide, এটা ultimately crop save করছে, it is all right, but it is hampering the humankind. It is hampering the nature. কেন না, এগুলো মোস্টলি নন বায়োডিগ্রেডেবল। তাহলে সেই টেকনোলজি কিন্তু আমরা অবসোলেট বলতে পারি না, কারণ তারা ম্যানকাইন্ডকে সেভ করেছে। কিন্তু সায়েন্স থেমে থাকে না। উই মে ডিফার, আমি একটা সায়েন্স অ্যাপ্লাই করবো কিনা এটা নিয়ে আমার ডিফারেন্স থাকতে পারে, আমি একটা খাবো কিনা এটা আমার অপশান হতে পারে, কিন্তু সায়েন্স অলওয়েজ টেলস আস দ্য রাইট পাথ। তো সেই সায়েন্সের যে জায়গা থেকে আমাদের বইটা তৈরি করা হয়েছিল, ইট ইজ অলসো এ স্কিল প্রোগ্রামের পার্ট, যে একটা প্লান্ট থেকে হাজার হাজার প্লান্ট তৈরি করা যায় ল্যাবরেটরির মধ্যে উইদাউট কিলিং দ্য প্লান্ট। তার মানে বায়োডাইভার্সিটিকে ইনট্যাক্ট রেখে আমি বায়োডাইভার্সিটিকে এনরিচ করতে পারি, এটা কিন্তু আমরা এই বইয়ের মধ্যে দিয়ে ছেলেমেয়েদের কাছে পৌঁছতে চেয়েছি। সো একটা ফিউচার অ্যাওয়ারনেস, যে দেখো অল্টারনেটিভ মেথডোলজিগুলো কিন্তু এসে গেছে, আমরা এগুলোকে ইউজ করতে পারি। এবং জেনেটিক মডিফিকেশন, এবছর যারা নোবেল প্রাইজ পেয়েছে তারা নোবেল প্রাইজ পেয়েছে মেডিসিনে, কিন্তু ওই কোভিড ভ্যাকসিনের ওপর। এবং কোভিড ভ্যাকসিনের সেই mRNA ভ্যাকসিন, it is also a sort of modification in one base. জেনেটিক্সের যে 4টে বেস, ডিএনএর যে 4টে বেস, তার একটা মাত্র বেসকে ইউরিডিন আরএনএতে তাকে চেঞ্জ করে দিয়ে সিউডো ইউরিডিন করে দেওয়ার ফলে এই mRNA ভ্যাকসিনটা এত সাকসেসফুল হয়েছিল। তো ইটস এ সর্ট অফ জেনেটিক মডিফিকেশন। প্লান্টেও এই জেনেটিক মডিফিকেশনগুলো করা যায় কি? যায়, এবং এটাই ফিউচার। এবং এখন আরও দিনকে দিন যত প্রোগ্রেস করছি আমরা, তত কিন্তু আমাদের কাছে এই জিনিসগুলো আরও পরিষ্কার হয়ে যাচ্ছে যে ওয়াই প্লান্ট সো ইম্পর্ট্যান্ট। এবং আমরা প্লান্ট সায়েন্স পড়লে আমরা ম্যাথামেটিক্স করতে পারবো না, এটা কিন্তু ঠিক নয়। আমরা কেমিস্ট্রি করতে পারবো না, এটা কিন্তু ঠিক নয়। প্লান্ট সায়েন্স পড়া, কেমিস্ট্রি পড়া, ফিজিক্স পড়া, একটা জায়গায় গিয়ে কিন্তু সবটাই একসঙ্গে এসে যাচ্ছে, কারণ প্যারামিটারগুলো আমরা ডিফারেন্ট হয়ে যাচ্ছে। তা আমরা আমাদের বইগুলোর মাধ্যমে চেষ্টা করেছি যে ছাত্রদের এই জিনিসগুলোতে আরও নিয়ে যেতে, এটা যেন ভবিষ্যতের একটা স্কিল বেসড, এটা যেন ছাত্ররা যদি মনে করে যে না সবাই বিএসসি করবে, এমএসসি করবে, নেট কোয়ালিফাই করবে, তো দরকার নেই, সবার তো দরকার নেই। কেউ যদি মনে করে না আমি করব না, আমি একটা ল্যাবরেটরি তৈরি করব, আমি প্রচুর গাছ বাড়াবো, কীরকম রিকোয়ারমেন্ট আমাদের ওয়েস্ট বেঙ্গলে? আমরা তো বেনানা যে প্লান্টেশন, সেই বেনানা প্লান্টেশন যা রিকোয়ারমেন্ট, আমরা দেখি প্রচুর কলা গাছ আছে, কিন্তু অ্যাকচুয়াল রিকোয়ারমেন্টটাকে কিন্তু একদম সাপ্লাই দিতে পারি না। আর সেটার জন্য কিন্তু পিএইচডি না করলেও চলবে। সেটা কিন্তু একটা বেসিক স্কিল, একটা বেসিক টেকনিক, একটা বেসিক ল্যাবরেটরি, এবং এগুলো কিন্তু এই বইগুলোর মধ্যে দিয়ে আমরা ছাত্রদের কাছে পৌঁছে দিতে পারি যে দিস আর দ্য অল্টারনেটিভ। এগুলো অল্টারনেটিভ তোমাদের সামনে আছে, তোমরা যদি মনে করো গভর্নমেন্টের কাছ থেকে গ্রান্ট নিয়ে স্টার্ট আপ প্রোগ্রাম। সুতরাং বই শুধু কিন্তু ওই টিচিংয়ের জন্য নয়, একটা এক্সপার্টাইজ ডেভেলপ করা, একটা আইডিয়া দেয়া, একটা নতুনত্ব নিয়ে আসা, এ সব কিছুই কিন্তু বইয়ের মাধ্যমেই মাস্টারমশাইরা দিতে পারেন ক্লাসে। এবং সেই জন্যই এই যে আজকের অনুষ্ঠানটা, এটা ব্যতিক্রমী অনুষ্ঠান। এই জন্যই ব্যতিক্রমী যে এ ধরনের আলোচনা সাধারণত হয় না। আমি একটা বই লিখেছি, সেটা খুব বড় কথা নয়, কিন্তু আমি যাদের সামনে আমার কথাগুলো বলতে পারছি, শুধু বইটা নয়, তাদের টোটাল ক্যারিয়ারের জন্য, একটা স্কিল ডেভেলপমেন্টের জন্য, একটা এক্সপার্টাইজ ডেভেলপমেন্টের জন্য, এবং মাস্টারমশাই হিসেবে বই পড়াটাকে এনকারেজ করানোটা দরকার। ছাত্রদেরকে কিন্তু বলা দরকার যে হ্যাঁ আমরা টিচিং ম্যাটেরিয়াল দেব, কিন্তু তুমি বইটা একবার দেখো, হাতে নিয়ে দেখো, কারণ তোমাকে তো কোথাও গেলে জিজ্ঞেস করবে যে তুমি কি বই পড়েছো। তুমি একটা ইন্টারভিউ দিতে গেলে মাস্টারমশাই কিছু বলছেন না ক্লাসে, তুমি জেরক্স করে এসছো, কিন্তু ইন্টারভিউ দিতে গেলে তো তোমাকে জিজ্ঞেস করবে তুমি কি বই পড়েছো। তখন অন্তত 4-5টা বইয়ের নাম তো বলতে হবে। তাহলে সেই বইগুলো তোমার লাইব্রেরিতে আছে। আমাদের তো এত সময়াভাব নেই যে একদিন আধ ঘন্টা গিয়ে আমি প্ল্যান সায়েন্সের 10টা বইয়ের নাম লিখে রাখতে পারলাম না, আমি 10টা বই হাত দিয়ে দেখতে পারলাম না। তো নলেজ নাই বা লাগলো আমার কাজে, কিন্তু কালকে লাগবে না এরকম গ্যারান্টি তো নেই, এরকম গ্যারান্টি তো নেই। তাহলে বই পড়া, বই যারা লেখেন, আমাদের তো অজস্র লেখক আছেন যারা বই লিখেছেন বিভিন্ন বিভিন্ন ব্রাঞ্চের। আজকে এর পরে যিনি বলবেন তিনি তো আমার ছাত্র সম, এবং তিনিও সরকারি কলেজেই তার জার্নি শুরু করেছিলেন। তো এই যে আমরা বিভিন্ন জন বিভিন্ন রকম বই লিখছি, আমাদের ভারতবর্ষের এত বই লেখা হয়েছে, সব বই না পড়ি কিছু বই তো দেখব। ই কপি দেখে কিন্তু লাভ হবে না, কারণ ই কপিতে সব বই সময়টা অনেক বেশি লেগে যায়। একটা হার্ড কপি বই নিয়ে আধ ঘন্টা অন্তত আমি সব পাতাগুলো একবার ছবিগুলো তো দেখতে পাই, কিন্তু মোবাইলে সব ছবি কিন্তু দেখা যায় না বাবা। এটা আমার এতদিনের অভিজ্ঞতা থেকে আমার মনে হয়েছে। তো সেই জন্যই আমি বলছি যে বইগুলো লেখার পেছনে যেমন আমাদের একটা অবজেক্টিভ থাকে যে ছাত্রদের যেন আরেকটু তারা এনরিচড হয়, নলেজেবল হয়, তেমনি তাদের ইচ্ছেটাও যেন বাড়ে যে তারা যেন বইগুলো পড়ে, এবং সেই বই পড়ে যদি তারা যদি যারা লিখেছেন তাদেরকে যদি লেখে যে এই বইতে না এই ডেফিসিয়েন্সি থেকে গেছে, তাহলে কিন্তু ছাত্র, শিক্ষক, শিক্ষা, বই সব মিলিয়ে আমরা আরো অনেক বেশি এনরিচড হতে পারি। আমার মনে হয় আমি এর চেয়ে বেশি সময় নেওয়াটা ঠিক হবে না। আমি সবাইকে ধন্যবাদ জানিয়ে এবং স্পেসিফিক্যালি আজকের যিনি আহ্বায়ক ডক্টর দে, তাকে আরেকবার ধন্যবাদ জানিয়ে আমি আমার বক্তব্য শেষ করছি। ধন্যবাদ, থ্যাংক ইউ। আমার মনে হয় না
Any questions?
ওরে বাবা, তাও প্রশ্ন হবে? হ্যাঁ বলো বাবা।
গুড আফটারনুন স্যার। একটাই কোয়েশ্চেন ছিল, আমি ইউজিতে আপনাদের কলেজে পরীক্ষা দিতে গেছিলাম, বায়োটেকের পেপারেরই সিট পড়েছিল। এবার তখন ওখানে ভাইভাত আমাকে একটা কোয়েশ্চেন মানে কোয়েশ্চেন না, ভাইবার পর আমাকে ওখানকার জেনে ভাইবার নিয়েছিলেন, তিনি বলেছিলেন যে যদি কখনো টিস্যু কালচার করো কাজু বাদামের ওপর করবে। আমি জিজ্ঞেস করলাম কেন কাজু বাদাম কেন? তো আমাকে বলছিল কাজু বাদামের সারফেস স্টেরিলাইজেশন করা যায় না। আমি তারপর জিজ্ঞাসা করেছিলাম যে কেন করা যায় না, আমাকে কিছু বলেনি। আপনি বলবেন কেন হয় না?
কে বলেছে হয় না?
মানে সারফেস বলেছিলেন যে কোনো কারণে করা যায় না।
না না, ঘটনা যে এমন কোনো কিছু নেই যেটা করা যায় না। আমাদের সমস্যাটা কী হয় জানো, আমরা ওই খুব সময় কেন্দ্রিক। তো ধরো তোমাকে বলেছে ক্লাসের 2 মাসের মধ্যে, না স্যার বলে দিয়েছেন 2 মাসের মধ্যে এটা ডিসার্টেশনটা কমপ্লিট করতে হবে। কাজ তো সময় মানে না বাবা। আর আমাদের তো পরীক্ষা সেন্ট্রিক, পরীক্ষার সময় তো কাজু বাদাম কি আর পরীক্ষা বোঝে? আমি নিজেই কাজু বাদামের উপর কাজ করেছি, কেন হবে না? তোমাকে একটু সময় দিতে হবে, কারণ এই যে টিস্যু কালচারটা, এটা তো এমন একটা ব্রাঞ্চ যেখানে তুমি 1 সেন্টিমিটার একটা পাতাকে, 1 সেন্টিমিটার একটা রুটকে, 1 সেন্টিমিটার একটা স্টেমকে কমপ্লিট আসেপ্টিক যদি করতে পারো, তাহলে তুমি অফুরন্ত গাছ তৈরি করতে পারবে। 1 সেন্টিমিটার লিপ মাটিতে ফেলে দিলে কি গাছ হবে বাবা? হবে না তো, তাহলে ওখানে তো টাইম লাগবে না। তাহলে ওই যে তফাৎ, এই তফাৎটুকু যদি মাথায় রাখা যায়, এখানে মানে তোমাদের এই কলেজে টিস্যু কালচারের যে ল্যাব আছে, মানে পশ্চিমবঙ্গের খুব কম কলেজ আছে, আমি কিন্তু সব কলেজ আমি জানি। আমি প্রেসিডেন্সিতে যখন ছিলাম তখন আমরা একটা ল্যাব তৈরি করেছিলাম, এখন কি অবস্থা আমি জানি না। কিন্তু এখানকার যে ল্যাব আছে এটা কিন্তু যে কোনো জায়গার ল্যাবের সঙ্গে কম্পারেবল। এবং আমি যতটুকু জানি এই কলেজে ছাত্রদের জন্য কোনো সময় নেই, কারণ আমি একটা সময় এই কলেজে পোস্ট গ্র্যাজুয়েটে কিছুদিন পড়িয়েও ছিলাম। তো ছাত্রদের বলা হয় তোমাদের জন্য সময় নেই, তোমরা যদি সময় আরও বেশি দিতে পারো সেটা তোমাদের ব্যাপার, লিমিটেশনটা কলেজের তরফে নেই। এরকম জায়গায় পড়লে কিন্তু কাজু বাদামের গাছ হবে।
ওকে স্যার, থ্যাংক ইউ।
আর কেউ? থ্যাংক ইউ স্যার।
Thank you, sir, for your lecture. And now I request our next speaker, Dr. Krishnendu Acharya, sir, to come on the dais. I request Dr. Robide to felicitate our next speaker. Now I request Dr. De to formally introduce our next speaker.
Dr. Krishnendu Acharya, he is an MSc in Botany and M.Tech Biotechnology and PhD holder. At present he is the Professor, Department of Botany, University of Calcutta. His research interests include microfungal diversity and medicinal prospects, innate immunity in plants and micro-nanotechnology. Almost 19 research scholars has been awarded degree of PhD under his supervision, and at present 8 research scholars are pursuing their PhD. He has an research experience of 25 years. He has published 465 research articles. Already 8 books have been published and 2 books are in press yet to be published. He has 3 patents. Total Scopus citations 8,625. H-index 48, I-10 index 193, total Google Scholar citations 11,861, H-index 55 and I-10 index 246. It is of the Google, and the earlier word is Scopus. He has many recognitions. He was enlisted in Stanford University lists world's top 2% scientists for 2020, 2021 and 2022 and 2000 in the year 2023 also. He is the Scientist of the Year 2019, Fellow of West Bengal Academy of Science and Technology, Fellow of the Linnean Society of London, Fellow of the Indian Mycological Society, Fellow of International College of Nutrition, Canada, Fellow of the Mycological Society of India, Sir Edwin John Butler Memorial Award, Patel Memorial Award, Global Achievement Award in the field of Philosopher Biology, and Professor K. Natarajan Memorial Award. Professor Acharya is an academic editor of PLOS ONE, and it is a journal, and associate editor of the Journal of Environmental and Sociobiology. He has also participated as a resource person for different national and international seminars and refresher courses. He is also a reviewer for reputed journals published by Elsevier, Springer, Nature Publishing Group, Taylor and Francis, Wiley, Blackwell, Royal Society of Chemistry, and many more. Now I request Professor Krishnendu Acharya sir to deliver his spacious lecture. Sir, please come and এইটা একটু দেখে দাও ওটা তো অন করাই আছে
এই পাসওয়ার্ড লাগবে খুলছে না this is an unique experience for me. এতদিন সায়েন্স নিয়ে বক্তব্য দিয়েছি, যেদিন উনি প্রথম আমাকে অ্যাপ্রোচ করলেন আপনার বইয়ের উপরে বলতে হবে, আমার কাছে এত ভালো লেগেছে যে বই আমরা লিখি যারা তারও একটা ফিলসফি আছে। এটা একটু কম্পিউটারে পাওয়ার পয়েন্ট আছে, কম্পিউটারটা পাসওয়ার্ড ওকে। So আমি thankful to Robi sir for his invitation, এবং সেই ইনভাইটেশনটা খুব ইম্পর্টেন্ট, মানে উনি হয়েছে ওকে। হ্যাঁ কি হলো ওকে। কারণ হচ্ছে আমার কাছে খুব ইম্পর্টেন্ট এরকম একটা প্ল্যাটফর্ম পাওয়া, যেখানে আমাদের সুযোগ দেওয়া হয় ভবিষ্যতের আমির সামনে দাঁড় করিয়ে দেওয়া। তো আমরা যারা মাস্টারমশাই তাদের ভবিষ্যতের আমির সঙ্গে গল্প করাটা খুব সৌভাগ্যের, এবং সেই সুযোগটা দেওয়ার জন্য রবিবাবুকে ধন্যবাদ। সেকেন্ডলি, এটা আমার কাছে নস্টালজিয়া জায়গা। আমি অ্যালামনাস অফ দিস কলেজ, আমি এখান থেকেই আমার যাত্রা শুরু অ্যাজ এ বটনিস্ট। তোমাদের হয়তো যারা জুনিয়র রয়েছে তোমাদের জন্মের আগে এখানে হয়তো আমি বেরিয়ে গেছি। এখানে যে লোকটা তোমাদের সামনে দাঁড়িয়ে রয়েছে, আজকে যা হয়েছে, যা বলছি, সামনে কথা বলার যোগ্যতা অর্জন করেছি বিকজ অফ রামকৃষ্ণ মিশন বিবেকানন্দ সেন্টারি কলেজ। গাছতলায় পড়া লোক, স্কুলে ভর্তি করতে কেউ নিয়ে যায়নি, যেতে যেতে ভর্তি হয়ে গেছি। সেই কোনো ক্রমে এসে পৌঁছে গেছি রহরা রামকৃষ্ণ মিশনে। অনাথ আশ্রমে থাকতাম, সেটা বন্ধ করে দিয়েছে, সেটা আমাদের কাছে খুব পেনফুল, কারণ ওটা না থাকলে হয়তো এখানে পড়তে পারতাম না বিকজ অফ মানি অ্যান্ড আদার থিংস। ওকে, আর লাইব্রেরিটা আমাদের কাছে প্রাণের জায়গা, কারণ যেখান থেকে এসেছি অত বই কেনার পয়সা ছিল না। লাইব্রেরিতে 4টে বই এক্সট্রা পেতাম, probably unique in India, probably unique in India. তো সেইগুলো কোনো ক্রমে ঘাঁটতে 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 পথ চলা শুরু। স্যার বলছিলেন, স্যার গুরুর মতন নয়, স্যার গুরু একজন আমার, কারণ আমি এমএসসির পরে এমটেক করেছি, পিএইচডি করেছি। তখন যে লাইনে পিএইচডি করছি সেটা হচ্ছে সেই লাইনে নোবেল পাচ্ছে। মানে আমি যে বছর পিএইচডি আমি জমা দিয়েছি, নাইট্রিক অক্সাইড রিসার্চ ইন মেডিসিন। সো দ্যাট ইয়ার 3 pioneer worker in globe, Fazkod, Ignoro and Moncada got Nobel Prize in Medicine for nitric oxide discovery. সো একটা লুক্রেটিভ লাইনে কাজ করছি, প্রচুর অফার ছিল বিদেশে যাওয়া, কিন্তু ছোটোবেলা থেকে স্যার ভগবান দেখে বড় হয়েছি, নাহলে আজকে এই জায়গা হতো না। জীবন্ত ভগবান, যারা নিজে না খাইয়ে আমাদের খাইয়েছে, ছেঁড়া চটিটায় সেফটি পিন মারা, ধুতিটা হাঁটুর উপরে, কিন্তু আমাদের জন্য যদি কোনো পাশের দোকান থেকে কখনো খেতাম পয়সা কেউ না দিতে পারতো, তাহলে ওখানে স্যারেরাই পয়সা দিয়ে দিতেন। মেদিনীপুরের গ্রামের ছেলে। ওকে, সো দ্যাট আই হ্যাভ সিন লাইফ সেই ওয়েতে। তো জীবনে স্বপ্ন এখনও ক্যারি করি, আই ওয়ান্ট টু বি এ টিচার। এখনও যে টিচার শব্দটা আর টিচার হওয়াটা দুটোর মধ্যে আকাশ পাতাল মানে দূরত্ব। আমরা নামে হয়তো টিচার হতে পারি, টিচার হয়েছি কতজন, তোমরা তো অনেক স্কুল থেকে পড়ে এখানে এসছো। যদি আমি জিজ্ঞাসা করি তোমাদের টিচারের নাম বলবো, তোমরা দেখবে হাতের একটা রেখা আঙুলের মধ্যে হয়তো শেষ হয়ে যাবে নাম, অথচ কতজন পড়িয়েছেন। বাট হাউ মেনি টিচার্স ইউ হ্যাভ? অনলি ফিউ অফ দেম, রাইট? তো আমি সেই করতে করতে বিদেশে 5খানা অফার ছিল, 3,500 পাউন্ডের অফার ছিল। দ্যাট টাইম আই গট জব ইন গভর্নমেন্ট সার্ভিস। স্যার সেই সার্ভিসে আমি প্রথম অফার পেলাম দার্জিলিং গভর্নমেন্ট কলেজ। তো আমি যে অফার পেয়েছি তখন স্যার ছিলেন এডিপিআই। তো আমি পাওয়ার পরে স্যারের নাম জানতাম, স্যারের ঘরে বুকে সাহস নিয়ে ঢুকেছি। মানে ঢোকার আগে একজন সেক্রেটারি থাকে, তাকে বলেছি আমি এরকম পেয়েছি, একবার স্যারের সঙ্গে দেখা করতে যাবো। আই ওয়েন্ট দেয়ার। স্যার আমাকে দুটো কথা বলেছিলেন, সেই জন্য আমার কাছে স্যার গুরু। আজকের আমিও ওই দুটো কথারই হচ্ছে ট্রান্সলেশনাল কাজটা করেছি বলে আজকে আমি এখানে। ওকে, এবং জীবনে প্রথম আমার যে পিঠ যে আমাকে বড় হতে সাহায্য করছে, তার ডায়াসে দাঁড়িয়ে উল্টো দিকে দাঁড়িয়ে কথা বলছি, এটাও আমার কাছে বড় প্রাপ্তি। আর আমরাও তোমাদের মতো একদিন ওখানেই বসে থাকতাম, একদিন বসে কথা শুনেছি, স্যাররা বলেছেন সেই কথা শুনেছি। স্যার আমাকে দুটো কথা বলেছিলেন। একটা কথা বলছেন, কৃষ্ণেন্দু তোমাকে দার্জিলিং পাঠানো হচ্ছে বিকজ ইউ উইল ডেভেলপ মাইক্রোপ্যাথো সেকশন দেয়ার, নাম্বার 1। নাম্বার 2, উনি আমাকে আরেকটা কথা বলেছিলেন, ভালো করে পড়িও কিন্তু, দ্যাটস এ লেসন ফর আস। ওকে, এবং সেই লেসনে রেজাল্ট আজকে এই আমার পথ চলা, এই বই লেখার পেছনেও তার কিছুটা ব্যাকগ্রাউন্ড আছে। এবং আরও ভালো লাগে আজকে যখন দেখি আমি যাদেরকে তৈরি করার জন্য তাদের পেছনে লড়েছি, এক্সাম্পল আছে। হ্যাঁ, আমার গুরুকুল ছিল, তাকে টেনে নিয়ে গিয়ে স্কুলে যাবে বলছিল, আল্লাহ স্কুলে গেলে চামড়া খুলে দেবো। আস্কিং জয় স্যার, ওকে নিয়ে গিয়ে আমার ঘরেই ওখানে রেখেছিলাম, গুরুকুল বানিয়েছিলাম। বলে স্কুলে যাবি এই কথাটা ফার্দার বলবি না, হ্যাঁ তুই ওখানেই থাকবি, খেতে না পেলে আমি খাওয়াবো, বাট ইউ শুড বি দেয়ার। ও গুঞ্জন ইন ইউনিভার্সিটি, বিদ্যাসাগর ইউনিভার্সিটি, ও হচ্ছে কলেজে। এরকম অনেক আছে আর কি। এখানে আরও ছাত্র আমার রয়েছে, এই যে সামনে স্যাররা রয়েছেন, হ্যাঁ প্রচুর ছাত্র। এটা আরও একটা বড় প্রাপ্তি, যখন যেখানে বলতে যাচ্ছি সেখানে তার ছাত্র একজন মাস্টারমশাই। এটা একজন মাস্টারমশাইয়ের কাছে সবচেয়ে মানে যখন কোনো গুরু ছাত্রের নামে উজ্জ্বল হয় না, তখন বেশি বড় প্রাপ্তি। ওকে, রামকৃষ্ণ দেবকে বিশ্বের দরবারে কিন্তু স্বামী বিবেকানন্দ যতটা নিয়ে গেছেন, সেটা হচ্ছে রামকৃষ্ণ দেবের বড় প্রাপ্তি, উনি একটা সঠিক ছাত্র তৈরি করে গেছেন। তো আমাদের কাছেও সেটা বড় প্রাপ্তি, যখন হচ্ছে আমাদের ছাত্রদের দেখি তারাও বিভিন্ন জায়গায় গিয়ে আলোকিত করছে, তখন আমাদের বড় প্রাপ্তি। তো দার্জিলিংয়ে গেলাম, দার্জিলিংয়ে গিয়ে স্যারকে বোধহয় যেতে হবে, স্যার খুঁজখুঁজ করছে। হ্যাঁ, স্যারকে আমি আটকে রেখেছি, স্যার একটা মিটিং চলে, বললো স্যার একটু থেকে যান, কারণ আপনার ছাত্র আজকে আপনার সঙ্গে একই প্ল্যাটফর্ম শেয়ার করে গল্প করছে, এটাও মানে আমার কাছে বড় পাওয়া। তো তো দার্জিলিংয়ে স্যারের কথা নিয়ে গেলাম। দার্জিলিংয়ে গিয়ে দেখলাম দ্য ইনস্টিটিউট, যেখানে মিডিওকার স্টুডেন্ট ভর্তি হয় মার্কসের দিদি দিয়ে, মেন্টালিটিতে মিডিওকার না, মেন্টালিটিতে অনেক 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 গুণ হাই। তারা কলেজে ঢোকে ওই যে কলেজের গেটটাকে প্রণাম করে, ওটা শিক্ষা প্রথম। তারা রাস্তায় মাস্টারমশাইরা গেলে তার যদি ছায়া পড়ে থাকে ডিঙিয়ে যায় না, ছায়াটা ডেঙ্গানো মাস্টারমশাইকে অপমান করা। করিডোরে যখন ঢুকবেন তখন ওরা দাঁড়িয়ে আছে, গুড মর্নিং স্যার, গুড মর্নিং স্যার, ইউ জাস্ট ওয়ার্ক, দেন তোমার পেছন পেছন হাঁটবে। তো ওরকম ছাত্র পেলাম, দে আর ওবিডিয়েন্ট, কিন্তু হয়তো মার্কস ওয়াইজ একটু কম, ওখানে নেট বলে বা অন্য কিছু বলে কোনো কালচারই নেই। তখন আমার মনে হলো যে আই হ্যাভ টু স্ট্যান্ড বিহাইন্ড দিজ পিপল, বিকজ আনমোল্ডেড থিং, তাদের কাছে যদি আমি রসদটা ঠিক দিতে পারি না, আমি তাকে মোল্ড করতে পারবো। সো ওদের সঙ্গে প্রতিদিন বসতে আরম্ভ করলাম, কি করবে। আমি থাকতাম তখন মর্নিং গ্লোরি হোটেলে, পাশে প্রভা বলে আরেকটি হোটেল ছিল, যেখানে আমাদের ছাত্রদের গুরুকুল টাইপ ছিল, কি পাশাপাশি হোটেল। ওই সন্ধ্যের পরে এসে ওদের সঙ্গে বসতাম। অ্যান্ড লাস্ট 5 ইয়ার্স ওখানে 5 বছর আমি ছিলাম। সেই 5 বছরের জার্নিতে 26 জন স্টুডেন্ট নেট কোয়ালিফাইড ফ্রম দ্যাট কলেজ। প্রচুর ওখান থেকে আইএফএস আছে একজন, জনা 5 ডব্লিউবিসিএস অ্যান্ড সিকিম এফএস, আরও অনেক সেক্টরে রয়েছে প্রচুর। তো এটা হচ্ছে 5 বছরের জার্নি। এবং সেই জার্নি করতে গিয়ে তাদের কাছে গিয়ে দেখলাম তখন নেটের যে প্রিপারেশন, নেট কীভাবে দেবো। সবাই আমরা কম্পিটিটিভ এক্সামের জন্য বই পড়ি, তাতে দেখবেন মাল্টিপল চয়েস থাকে। আর মাল্টিপল চয়েসে প্রথমে আমরা, তোমরাও নিশ্চয়ই পড়ো যারা মাস্টারি কিছু, মাল্টিপল চয়েসে মেজর প্রবলেম হচ্ছে আমরা একটা কোশ্চেন দেখি, তার 4টে উত্তর। কোশ্চেন বইটা খোলার পরে আমরা এরকম করে বইটা নিয়ে মাল্টিপল চয়েসের কোশ্চেন দেখি, 1 সি হবে, মিলিয়ে নিস, তোরা তাই করিস। বি ডেফিনেটলি ভুল, ফার্স্ট থিং কাম ইন ইউর মাইন্ড, ডেফিনেটলি ভুল। দেন আবার দেখিস সি, আবার চিন্তা করি বইটা ঠিক লিখেছে দেখলি কিনা, 2বার দেখা হয়, তারপরে মনে হয় বিটা হতে পারে যেহেতু বইতে লিখেছে। এবং আমরা এমনই একটা জীব, তারা হচ্ছে দুঃখ বিলাসী জীব। আমাদের যদি এই পরীক্ষায় ওই প্রশ্নটা আসে না, তুমি সি লিখে আসবে, কারণ ওটা তোমার সাবকনসিয়াস মাইন্ডে ওটাই ফিক্স হয়ে গেছে যে বিকজ ইউ থট ইট দ্যাটস দ্য রাইট অ্যান্সার। ওকে, সো দ্যাটস ক্রিয়েট দ্য ক্রাইসিস। যে আমি যত বই দেখলাম তারা মাল্টিপল চয়েসে আছে কি, তারা করছে কি একটা প্রশ্নের এগেনস্টে 4টে উত্তর। ওকে, তো আমরা ভুলটাকেই যদি শিখে যাই, তো আমি চিন্তা করলাম যদি এরকম কাণ্ডটা করা যায়, বটনিটাকে এরকমভাবে একটা যদি করা যায়, একটাই কোশ্চেন তার একটাই উত্তর, একটাই কোশ্চেন তার একটাই উত্তর। ওকে, সো ওদের সঙ্গে কথা বলে দেখলাম তার রেজাল্টটা কি। ওকে, নেক্সট। ওকে, আমি এই 10টা বই লিখেছি, এখন অবধি 8টা বই পাবলিশ হয়েছে, এই 2টো এখনো বাকি আছে। ওকে, দেখাবো পরপর, বই নামগুলো পেয়ে যাবে, বই ছবিও পেয়ে যাবে। সো দেন আমি এক্সপেরিমেন্ট করলাম যে এটা করলে কেমন হয়। তো আমি প্রতিদিন 40টা 50টা করে কোশ্চেন লিখতাম ওদেরকে শুধু বলার জন্য কিভাবে পড়বি। লাইকেনের একটা চ্যাপ্টার ধরো, তাতে কি কি কোশ্চেন হতে পারে, হ্যাঁ, তোমার রিক্সিয়ার উপরে কত রকমের কোশ্চেন হতে পারে। তাতে কি হয়, ওদের কাছে রেডি টু ইট একটা ডাইজেস্টই থাকে। প্রথমে সাবজেক্টটা পড়, দেন রেডি টু ইট, দেন আস্ক ইয়োরসেলফ কত ডাইমেনশনের প্রশ্ন হয়। এই করতে করতে আমার একটা কোশ্চেনের পুল হয়ে গেছিল। তো আমার সেই পুল হওয়ার পরে আমার একটা খ্যাপা ছাত্র ছিল, তার নাম হচ্ছে সৈকত, এই যে সৈকত কুমার বাসু। এ আমাকে প্রতিবারই বলতো, ও হচ্ছে, আমি যখন কলকাতায় ছিলাম, ও আমার জুনিয়র ইন ক্যালকাটা ইউনিভার্সিটি, ও প্রায় প্রতি সপ্তাহে এসে আমাকে একবার বলতো, কৃষ্ণদা কি করবো বলো তো, এইটা দেবো, হ্যাঁ কি পড়বো বলো। আমি বললাম এইটা পড়ে আয়। হ্যাঁ স্যার, স্যার ভালো থাকবেন স্যার। তো ও এসে আমায় বলতো, কৃষ্ণদা কি পড়বো বলো। ওকে আমি বলতাম তুই এই চ্যাপ্টারটা পড়িস। বিলিভ করবে না, 1 সপ্তাহ বাদে সে আমার কাছে এসে আমাকে পড়িয়ে চলে যেত, অসাধারণ। তো ও সবসময়, আমি 2টো মাস্টার ডিগ্রি করেছি, ওরও জীবনে সব, আপনি 2টো করেছেন, আমি কেন করবো না। ও 2টো নয় 3খানা মাস্টার ডিগ্রি করেছে, 2খানা ইন্ডিয়া, 1খানা কানাডায় MS। হ্যাঁ, তো আপনি 2টো করেছেন, আমি করবোই 2টো। ওকে, তো সেই খ্যাপা আমাকে বলতো, আপনি স্যার আপনি কৃষ্ণদা এত লিখছো, তুমি আমাকে শুধু পাঠিয়ে দিও। হি টাইপড অল দিস থিং। আলটিমেটলি এন্ড অফ দ্য ডে একটা বই পাবলিশ হয়েছিল, সেটা হচ্ছে কম্পিটিটিভ বটনি। তখন তো জানতাম না, আমাদের যারা পাবলিশার তারা তো তাদের পয়সাটা বোঝে, ICBN পর্যন্ত দেয়নি বইটা। নিউ এজ ইন্টারন্যাশনাল বই, ওদের গোল্ডেন এজ বলে একটা, নিউ এজ ইন্টারন্যাশনালের একটা সিস্টার কনসার্ন করে, যাতে ট্যাক্স ফ্যাক্সের কিছু ব্যাপার আছে, আই ডু নট নো। আলটিমেটলি দে পাবলিশ দ্য বুক, অ্যান্ড আলটিমেটলি এই পাবলিশ বুকটাকে আমরা আর হচ্ছে পরে রিভিশন করতে পারলাম না, বিকজ ওরা হচ্ছে এইটার কোনো ICBN নাম্বারও দেয়নি। ওকে, দেন ওই সময় আমি দার্জিলিংয়ে গেছি এবং এই বইটা জয়ের কাছেও কপি আছে বইটা, কারণ অনেকেই সবার কাছেই মনে হয় তখন ছিল বইটা, সবার কাছেই প্রায় কপি আছে নেটের জন্য, এবং নেট আইএএস ডব্লিউবিসিএস আইএফএস এর জন্য যে ধরনের এগুলো হয় তাতে আমরাই চেষ্টা করেছি। তো আমাকে আরেকটা মন্ত্র দিয়ে পাঠানো হচ্ছে, আই হ্যাভ টু ডেভেলপ দ্য মাইক্রোপ্যাথো ডিপার্টমেন্ট ইন দ্য দার্জিলিং গভর্নমেন্ট কলেজ। দ্যাটস গ্রেট। তো এবার মাইক্রোপ্যাথো ডিপার্টমেন্ট ডেভেলপ করতে হবে, মাইকোলজি আমাকে শিখতে হবে। শিখতে গিয়ে আই স্টার্টেড সার্চিং যে এখানে ফাঙ্গাসের ডাইভার্সিটি, ও দার্জিলিং তো হেভেন ফর দ্য বটনিস্ট, ওকে। তো হেভেনে গেছি, তো একটু ঘুরে ঘুরে বেড়াই, প্রতি সপ্তাহে প্রায় 35 কিলোমিটার আমি দার্জিলিংয়ে হাঁটি, হ্যাঁ চক্কর কাটতাম, ঘুম থেকে উঠে একবার ঘুরে টুরে এসে খেয়ে একদম ডিপার্টমেন্টে। দেন আই ফাউন্ড লটস অফ ম্যাক্রোফাঞ্জাই, মানে বড় বড় ফাঙ্গাস দার্জিলিংয়ে পাওয়া যায়। তো আমার মনে হলো আচ্ছা এগুলো নিয়ে একটু কাজ করলে কেমন হয়, কারণ ইনফ্রাস্ট্রাকচার কিছু নেই। আমি গেছি ফ্রম বায়োটেক, আমি ভালো ভালো ইনস্ট্রুমেন্ট ইউজ করে গেছি, ওখানে গিয়ে শুধু বসার একটা টেবিল পেয়েছি, তো আর কিছুই আমার নেই। তো মানে আমি ওখানে স্টার্ট করব কি করে জার্নিটা। তো এই করতে করতে ম্যাক্রোফাঞ্জাই করলাম আর স্টার্ট। দেখলাম খুব ইন্টারেস্টিং ডেটা। আর আমি যে ঘরটায় ছিলাম সেই ঘরটা হচ্ছে, সেই রাস্তাটার নাম হুকার রোড, আর আমি যে ঘরটায় ছিলাম সেটা হুকার থাকতেন, জেডি হুকার, ওকে। তো ফলে আমি সবাইকে খুব মজা করেই বলতাম, আমাকে যদি কোনোদিন একবার হুকারের ভূত ধরে তাহলে যেগুলো করা হয়নি করে দিয়ে বেরিয়ে যাবো, ওকে। তো আমি এটাই মনে মনে ভাবতাম যে হুকারের ভূত যদি আমাকে একবার ধরে, বাবা ধরুক রে, ওকে। তো সেই ভূত ধরেছে কিনা জানি না, তো আমিও খুঁজতে আরম্ভ করলাম। দেন আই ফাউন্ড ওয়ান ইন্টারেস্টিং ডেটা। হুকার এসেছিলেন 1845 থেকে 1851 সাল অব্দি দার্জিলিংয়ে ছিলেন, ফ্যান্টাস্টিক, মাত্র ক বছর। উনি দার্জিলিং থেকে 119খানা ম্যাক্রোফাঞ্জাই রিপোর্ট করেছেন। হুকার এখানে তুলতেন, ওটা পাঠিয়ে দিতেন কিউতে, বার্কলে ওখানে ছিলেন, উনি বার্কলে হুকারের সাইটেশন দিয়েই, অথর সাইটেশন দিয়ে ওটা পাবলিশ করতেন। যে হুকার্স বট ওখানে পাবলিকেশন অনেকগুলোই আছে, কটা 119টা। তারপরে ওই দার্জিলিংয়ে স্বাধীনতা হয়েছে, আমাদের মতো প্রচুর মানুষ ওখানে গেছে 150 বছরে। হোয়াট ইজ আওয়ার অ্যাচিভমেন্ট ইউ নো? অনলি 9। 150 বছরে আমি 1999 সালে ওখানে জয়েন করেছি। এজ অফ 29 আই গট দ্য জব ইন দার্জিলিং গভর্নমেন্ট কলেজ। মানে আমার প্রথম ব্যাচের স্টুডেন্ট মোটামুটি কাছাকাছি পিঠোপিঠি আর কি আমরা। তো ওখানে হচ্ছে মাত্র 9টা। সো ডিউরিং দ্যাট টেনিওর তারপরে আমি সারা পশ্চিমবঙ্গের টোটাল এখন 5000-এর উপরে ম্যাক্রোফাঙ্গাস কালেকশন আই হ্যাভ রাইট নাও। এই যে ম্যাক্রোফাঙ্গাস যারা বটনির আছো, এটা একটা ইম্পর্টেন্ট ডেটা given by Hawksworth, living legend in the taxonomy, okay, fungal taxonomy. তিনি দিয়েছেন সারা বিশ্বে, তখন আমি দেখলাম একটা ডেটা আছে, সেই ডেটা বলছে সারা বিশ্বে তখন পাওয়া হিসেব প্রেডিকশন অনুযায়ী 15 লক্ষ ম্যাক্রোফাঙ্গাস পাওয়া যায়, তার মধ্যে তখনও অবধি মাত্র 3% ডিসকভার্ড। খুব ইন্টারেস্টিং। ফলে দেয়ার ইজ অ্যান অ্যাম্পল চান্স অফ গেটিং মেনি নিউ অফ ম্যাক্রোফাঙ্গাস রাউন্ড দ্য গ্লোব। আর আমরা ম্যাক্রোফাঙ্গাস কেন মোস্টলি ডিপেন্ড করি, ম্যাক্রোফাঙ্গাসের ক্লাসিফিকেশন ট্যাক্সোনমি উই ডিপেন্ডস অন ওই ফরেনে কি কি পাওয়া গেছে তার উপরে, ওকে। ফলে ইন্ডিয়ান সাবকন্টিনেন্টে যে ধরনের ম্যাক্রোফাঙ্গাল কমিউনিটি বা গ্রোথ পাওয়া যাবে সেটা নিশ্চয়ই ইউরোপিয়ান সঙ্গে মিলবে না। আমরা ওই দেখে বলে দিয়ে ওটা ওর মতো দেখতে, তাহলে এটা হচ্ছে ছাগল নয় রাম ছাগল, ওকে। সো দ্যাটস এ প্রবলেম, ওকে। দ্বিতীয় আরেকটা আমাকে খুব ইম্পর্টেন্ট জায়গা আমার মনে হয়েছে, যেটা আমাকে খুব তোমাদের এই ছবিটা দেখায়, সবাই এই ম্যাপটা, এর জন্য প্রচুর মার খেয়েছিস মাধ্যমিক এইচএসে। আমার চোখ দিয়ে এই ছবিটা দেখো, যারা এখানে আগামী আমরা হতে চলেছ। এই ছবিটাকে বলি আমি হচ্ছে মিনি ইন্ডিয়া। আমাদের স্টেটটা হচ্ছে মিনি ইন্ডিয়া, অনলি স্টেট ইন ইন্ডিয়া হোয়ার হিমালয় অ্যাট দ্য নর্থ অ্যান্ড সি অ্যাট দ্য সাউথ, অনলি স্টেট। গো টু ওয়েস্ট, ড্রাই, ভারতবর্ষের ওয়েস্ট ড্রাই, সেন্ট্রালি অ্যালুভিয়াল, ভারতবর্ষের সেন্ট্রালি অ্যালুভিয়াল, রাইট। আর যারা ভালো হয় ভগবান বোনাস টোনাস কিছু দেয়, পুজো আসছে, বোনাস ইজ সুন্দরবন। All these geoclimatic condition of the state made it a treasure house for the luxuriant growth of flora and fauna. Remember my words. ঘর থেকে দুপা বাইরে ফেলো, you will get millions of new things present in this world. মনে হবে দুটো নতুন ফাঙ্গাস ডিসকভার করে কি হলো, দুটো নতুন গাছ ডিসকভার করে কি হলো, ট্যাক্সোনমি করে কি হবে। সায়েন্স আর অফ টু টাইপস, মোর্টাল সায়েন্স অ্যান্ড ইমমোর্টাল সায়েন্স। ওই ক্লাসিক্যাল সায়েন্স অ্যান্ড কি অ্যাডভান্স সায়েন্স হয় না, নাথিং লাইক দ্যাট। ওকে, যারা এমএসসি পড়ো আরএপিডি নিশ্চয়ই নাম জানো। আরএপিডি যখন 1990-91 সাল আরএপিডি ফিঙ্গারপ্রিন্টিংয়ের গল্প আছে, অ্যালেক্স জাফরি, সাধারণ, হ্যাঁ, তারা হচ্ছে সায়েন্স নেচার ছাড়া পেপারই করে না, অন্য কোথাও পেপার ছাড়ে না। এখন একটা আরএপিডি দিয়ে পেপার দিও না, ধেড়ে গোবিন্দপুর জানালেও হবে না। বাট ইফ ইউ রাইট দ্য নেম, তাহলে ওই লোকটি চিন্তা করো, ওই লোকটি 1990 সালের লোক 2020-তে এসে সে নিজেকেই সাইট করে না, মানে আমি এরকম একটা কাজ করেছিলাম, সাইট করেই না। বাট ইফ ইউ রাইট দ্য নেম অফ ম্যাগনিফেরা ইন্ডিকা এল ডট, লিনিয়াস বেঁচে আছে। হু বিকাম ইমমোর্টাল? হু বিকামস ইমমোর্টাল? পৃথিবী যতদিন থাকবে, আম গাছ ততদিন থাকবে, আম গাছ নিয়ে কেউ কাজ করলে এল ডট বসাবেই। হু বিকামস ইমমোর্টাল? So that is nothing science called as mortal, classical science and modern science, mortal science and immortal science. Okay, okay. So we have collected a large number of macrofungus from this state, around 5,000. If you have get chance, please visit my fungarium. They are in Calcutta University. Okay, so সেই দেখো এডিবল মাশরুম, লোকে বলে কালারফুল হয় না, অল মাই কালেকশন, কত কালারফুল এডিবল মাশরুম। আমি সারা পশ্চিমবঙ্গ থেকে মোর দ্যান 70 এডিবল মাশরুম আমরা কালেক্ট করেছি। তার মধ্যে আমরা অনেকগুলো নাম দিয়েছি। এখানে বাঁকুড়া জেলার কেউ আছো? বাঁকুড়া, পশ্চিম মেদিনীপুর, বীরভূম আছো? সো আই ফাউন্ড মেনি নিউ ফাঞ্জাই, এডিবল ফাঞ্জাই ফ্রম বাঁকুড়া। সাদা, দিস ইজ মুরগি ছাতু। মুরগি ছাতু বিকজ ইজ লাইক দ্য মোরগের যে ঝুঁটির মতো রংটা বলে মুরগি ছাতু বলে গ্রামের লোকেরা। দিস ইজ রসুলা ইন্টারভেনোসা, উই হ্যাভ নেমড ইট। আজ থেকে 1000 বছর পরে যদি কেউ এই মাশরুম নিয়ে কাজ করে, দে উইল ডেফিনেটলি পুট মাই নেম দেয়ার। ওকে, হ্যাঁ, ওকে, দিস ইজ রসুলা কানাদি। না, দ্যাট ডাজন্ট মিন ইউ শুড স্টপ হিয়ার collecting of mushroom. I will show you. Journey start from that point. Discovering a single organism can create millions avenue for the future scientist. But that's the impact of discovering a single organism. তুমি যদি একটা অর্গানিজম ডিসকভার করো, 1000 সায়েন্টিস্টকে যাত্রা পথ দিয়ে যাবে, তার ফিজিওলজি, তার সাইটোলজি, তার সেল বায়োলজি, তার জেনেটিক্স, তার মলিকুলার বায়োলজি, তার অ্যাপ্লিকেশন, এভরিথিং। ওকে, বাট আমি একটা পেয়েছি, নিয়ে যান, আপনি গিয়ে করুন। তাহলে ক্রেডিট গোজ টু দেম। বলবে আমি বাবা এইটার না এরকম দেখেছি। সায়েন্সে ওরকম কিছু নেই, সায়েন্স ইজ ভেরি সিম্পল যদি তাকে সিম্পলি ভাবা যায়। একটা সেল চিন্তা করে দেখো কত বিউটিফুলি ফাংশন করে। তার মধ্যে কটা থার্মোসাইক্লার বসানো আছে ভাই, তার মধ্যে কটা কনফোকাল মাইক্রোস্কোপ বসানো আছে, বিকজ ইট ওয়ার্কস র্যাশনালি। ওকে, সায়েন্স হচ্ছে র্যাশনালি। যদি সবসময় মাথায় রাখতে হবে, আমাকে আমার যে গুরু সায়েন্সে পথ চলা শিখিয়েছিলেন, তিনি আমাকে প্রথম দিনে বলেছিলেন যে তোমরা যদি কোনো ভালো ল্যাবরেটরিতে যাও, ইউল সি মানে কি কি ইনস্ট্রুমেন্ট আছে, কি বড় বড় জিনিস আছে, দ্যাটস ইম্পর্টেন্ট। হ্যাঁ, কিন্তু ভুলে যাও জন্মানোর সময় ভগবান যখন ল্যান্ড করিয়েছিল তখন সবচেয়ে বড় ইনস্ট্রুমেন্ট দিয়ে পাঠিয়েছিল, তাকে ব্যবহার করতে। ইউজ দিস ইনস্ট্রুমেন্ট। আজ থেকে 100 বছর আগেও ইনস্ট্রুমেন্ট ছাড়াই এত বড় বড় কাজ করছে। যে ক্যালকাটা ইউনিভার্সিটি মাইকোলজি স্টার্ট করেছিলেন, নামটা লিখে রেখো দয়া করে, প্রফেসর সহায় রাম বোস। কারমাইকেল স্কুল অফ মেডিসিনে কাজ করতেন, যেখানে ইনফ্রাস্ট্রাকচার ইউ ক্যান আন্ডারস্ট্যান্ড। একটা মেডিকেল ইনস্টিটিউটে একজন বটনিস্ট কাজ করছে, তার জন্য কিছু থাকবে? কিচ্ছু থাকবে না। হ্যাঁ, তার জন্য একটা নোংরা কোণের ঘর থাকবে, সেই কোণের ঘরে উনি কাজ করতেন। তার স্কোপাসে পেপার আছে মাত্র 26টা, 24খানা নেচার অ্যান্ড সায়েন্স, 24 পাবলিকেশন ইন নেচার অ্যান্ড সায়েন্স। ওকে, অনেকেই জানে না তার নাম। তিনি যখন আলেকজান্ডার ফ্লেমিং নোবেল প্রাইজ পাচ্ছেন বিকজ অফ ডিসকভারি অফ পেনিসিলিন, উনি কলকাতায় কারমাইকেল স্কুল অফ মেডিসিনে বসে পেপার লিখছেন ইন সায়েন্স, পলিপোরিন ফ্রম পলিপোরা স্যাঙ্গুইনিয়াস। যখন ওয়াটসন ক্রিক নোবেল পাচ্ছে বিকজ অফ দ্য ডিসকভারি অফ ডাবল স্ট্যান্ডার্ড স্ট্রাকচার অফ দিস থিং, ডিএনএ ডাবল হেলিক্স, ওকে, তিনি কলকাতায় বসে পেপার করছেন ডিঅক্সি রাইবোনিউক্লিক অ্যাসিড অ্যান্ড রাইবোনিউক্লিক অ্যাসিড ইন ফিলামেন্টাস ফাঞ্জাই। যখন মাইটোকন্ড্রিয়া সম্বন্ধে লোকের ধারণা হচ্ছে মাইটোকন্ড্রিয়া ইজ নাথিং বাট এ থ্রেড লাইক স্ট্রাকচার ফাংশন নট নোন, যদি লাইব্রেরিতে 50 সালে কোনো বই থাকে মাইটোকন্ড্রিয়ার ব্যাপারটাই দেখো, ওখানে এরকমই লেখা। সেই সময় উনি কলকাতায় বসে পেপার করছেন এনজাইমস প্রেজেন্ট ইন দ্য মাইটোকন্ড্রিয়াল ম্যাট্রিক্স। জাস্ট ইমাজিন করা যায়। ওকে, সো দিস ইজ রসুল্লাহ কানাদি। আমরা টোটাল অলরেডি 37 খানা আমরা নাম দিয়েছি। দিস ইজ রসুল্লাহ কানাদিকে সাদা পাতা বলে, রসুল্লাহ রেটিকুলা, এটাকে জাম পাত্রা বলে, জামের মতো দেখতে বলে কালারটাকে, এটাও বাঁকুড়া পাওয়া যায়। দিস ইজ রসুল্লাহ সেনেসিস। ওকে, আমি এই ঘুরতে ঘুরতে I visited different people in different corners of West Bengal. Very interestingly, I found they are the gem. They have huge resource. শুধু আমাদের রিসোর্সগুলোকে এক পাত্রে আনা হয়নি। তো আমাকে বায়োডাইভার্সিটি বোর্ড বললে যে এরকম একটা এডিবল মাশরুমের উপরে বই লিখো। আমরা তো মাশরুমকে কি বলি, ছাতু, তাই তো? তো তার জন্য একটা পকেট বুক ওয়েস্ট বেঙ্গল বায়োডাইভার্সিটি বোর্ড বের করেছে, দ্যাট ইজ বাংলার ভোজ্য ছাতু। ওকে, দিস ইজ ডেসক্রিপশন। ওর ভেতরে এরকমভাবে তাকে কিভাবে একটা ছাতুকে করা যায়, এবং সেখানে আমরা পশ্চিমবঙ্গে যত রকমের ছাতু পাওয়া যায় এডিবল মাশরুম, তার একটা নথি তৈরি করেছি। ওকে, সো এরকম একটি সময়ে আমাদের সিলেবাসটা চেঞ্জ হলো। সিলেবাসে ফিল্ড ভিজিট ফর দ্য বিএসসি যাদের ফাঞ্জাই আছে তাদের ফিল্ড ভিজিট একটা কোর্সের মধ্যে ইনক্লুডেড হলো। Then many of my colleagues from different colleges asked me, কৃষ্ণদা একটা বই করে দাও না, অন্তত কিছু যাতে কমন ফাঙ্গাসের ছবি দেখে চিনতে পারি, বলতে পারি। So that time I write one book, that is Common Wild Mushrooms of West Bengal, 100 different common wild mushrooms of West Bengal. এই দুটো আমরা নাম দিয়েছি ম্যারাসমিয়াস মিদনাপুরেন্সিস, মিদনাপুর থেকে পেয়েছিলাম বলে এর নাম মিদনাপুরেন্সিস। দ্যাট ইজ ম্যারাসমিয়াস। দিস ইজ ম্যারাসমিয়াস ভ্লাদিমিরি। ভ্লাদিমিরি একজন বিখ্যাত সায়েন্টিস্ট ইন দ্য ফিল্ড অফ ম্যারাসমিয়াসি, ওর নামে আরেকটা স্পিসিস। ওকে, then also we published one book on proceedings of an conference, যেখানে আমরা ওই ট্যাক্সোনমি, ফাঙ্গাল ট্যাক্সোনমি, অ্যালগাল ট্যাক্সোনমি উপরে একটা কনফারেন্স, সেটার একটা প্রসিডিংস, তারপরে এটা আমরা পাবলিশ করেছি ভেরি রিসেন্টলি। দেন ইউ হ্যাভ দ্য মাশরুমস ইন ইউর হ্যান্ড। ওকে, নাও এর মধ্যেই পথ তো চলা শুরু হয়েছে, আমরা বিজ্ঞান করি, ঘরের মধ্যে বসে বিজ্ঞান করি। তো আমার সেখানটায় মনে হয়েছে যে বিজ্ঞানটাকে যদি মানুষের কাছে নিয়ে যাওয়া যায়। দেন আমি কাজ করতে আরম্ভ করলাম। ফার্স্ট অপরচুনিটি কেম ফ্রম নরেন্দ্রপুর রামকৃষ্ণ মিশন। নরেন্দ্রপুর রামকৃষ্ণ মিশনে তখন তুষার মহারাজ ছিলেন ব্লাইন্ড বয়েজ একাডেমির দায়িত্বে। তো উনি আমাকে একদিন রিকোয়েস্ট করলেন, কৃষ্ণেন্দু তুমি একটু আমাদের সঙ্গে কাজ করবে, আমরা এখানে ব্লাইন্ড বয়েজদের ট্রেনিং দিই মাশরুম নিয়ে, তো could you design something for them so that they can become an entrepreneur? It's a great opportunity for me. So I went there. এবং এই মাশরুম, এই যে ফাঙ্গাস, এডিবল মাশরুম, ওকে, এই এডিবল মাশরুম এই ক বছরে আমি এখন 300 জন মানুষ, 300 ফ্যামিলিকে এন্টারপ্রেনিউর বানিয়েছি। নাও দে আর সাস্টেনেবল। এবং যারা বিএসসি এমএসসি করছে, they can think differently. কোনো দিন যদি সুযোগ হয়, I will come, I will discuss that thing in a greater way so that you can understand how to become an entrepreneur. আমি এই লকডাউনে এখন অবধি 1650 ফ্যামিলির পেটের ভাতের ব্যবস্থা করেছি। I will tell you that story and that helps me to create some book also. Okay, দ্যাট দ্য সোসাইটি, অ্যাকচুয়ালি আমি প্রথমে সোসাইটিতে গেছি, সোসাইটি ফোর্স মি ডেভেলপ দ্য বুক অ্যান্ড দ্যাট হ্যাজ বিন ইনকর্পোরেটেড অলসো ইন দ্য সিলেবাস টু। ওকে, so in mushroom cultivation there is three side. মাশরুম বিজনেস এমনই একটা বিজনেস, আজকে 100 টাকা ইউজ করো, ইনভেস্ট করো, উইদিন এ মান্থ ইউ ক্যান গেট 500 রুপিস। কোনো বিজনেস আমায় দেখিও, আজকে 100 টাকা লাগালে 1 মাসে 100 টাকা 500 টাকা হবে। কোনো বিজনেসে আছে কিনা আমাকে যদি দেখাতে পারেন, আমি বলবো মাশরুম বিজনেস করবেন না। বাট উই নেভার সেল মাশরুম এজ এ ভেজিটেবল। Mushroom is a product. I will tell you that story too. How mushroom become a product, not a vegetable. ধরো তোমার কাছে এমন একটা প্রোডাক্ট, শুনছে সবাই শুনছে, এখন এক্সাইটেড হচ্ছে, তো কিছু কিছু জায়গা মনে হচ্ছে এটাকে ক্যাপচার করে রাখে ব্রেনের মধ্যে, অন্য জায়গাটা তখন পুরোটাকে শুনে নে, তারপরে ক্যাপচারটা পুরো পরে করবি। হ্যাঁ, তো ধরো এমন একটা প্রোডাক্ট নিয়ে আমি তোমার সামনে হাজির হলাম, দ্যাট রিচ ইন প্রোটিন, রিচ ইন ভিটামিন, রিচ ইন মিনারেলস, রিচ ইন ফাইবার। ওকে, এখন অ্যাড দেয় বিস্কিটের, এখন আবার ভালো অ্যাড আসছে তোমার কি যেন হেলথ ড্রিঙ্কসে কি ফাইবার আছে, রাইট? হ্যাঁ, আগে চিনির কথা বলতে তোমার চিনি বলে, এখন ফাইবার বলে, রাইট? নিউট্রিয়েন্ট, ফাইবারস আর নিউট্রিয়েন্ট। আরেকটা অ্যাড দেখবেন দেয়, একজন সেলিব্রিটি একটা বিস্কিটকে কামড়াচ্ছে, ডাইজেস্টিভ না কি নাম তার, কিছু একটা নাম, কামড়াচ্ছে, বলছে আমি খাচ্ছি আপনারাও খান। এম আই রাইট? রাইট? কিন্তু বলে না আমি খাচ্ছি, ওরা পয়সা দিয়েছে তাই খাচ্ছি, আপনি খান, আপনি আপনার পকেটের পয়সা খরচা করে খান। দে নেভার টেল ইট। ওকে, আমি খাচ্ছি, আমি যে কামড়টা বসাই তার জন্য আমাকে কয়েক কোটি টাকা দিয়েছে, তাই আমি কামড়টা বসাচ্ছি, আর আপনি খান আপনার পকেট থেকে পয়সা খরচা করে। সো who is going to be full? Who is going to be full? Okay, so আর এক মুঠো শাকে যা যে পরিমাণে ফাইবার আছে না, ইটস ইকুইভ্যালেন্ট টু এক টিন বিস্কিটে যা ফাইবার দেবে তার চেয়ে বেশি। কোনটা সস্তা রে ভাই? এক ওয়ান হ্যান্ডফুল শাক না হচ্ছে 1 টিন বিস্কিট? ইউ ক্যালকুলেট ইট। ওই যে প্যাকেটটা বানায় না, প্যাকেটের দামটা বেশি তার ভেতরে প্রোডাক্টের চেয়ে, দ্যাটস দ্য ট্রুথ। ওকে, রাইট? সো দ্যাটস এ প্রোডাক্ট রিচ ইন ফাইবার। কি কি জন্য ভালো? এই যে সলিবল ফাইবার আছে, সলিবল ফাইবার গুড ফর ডায়াবেটিক পেশেন্ট, good for reducing cholesterol level, good for your heart problem. Insoluble fiber improves the satiety of the foods, improve peristaltic wave of your gut, increase the gut microbiota level. Okay, কারণ it's a prebiotics. Okay, okay, it's a prebiotics, it's a increase gut, gut-কে এখন second brain বলা হয়। Okay, gut regulates many things in your physiological system. So it's a second brain. So it's control gut microbiota. Not only that, it gives, এটা হচ্ছে এখন রোগা হওয়ার জন্য অনেকে সব খাওয়ার দাওয়ার খায়, এটা রোগা হতে সাহায্য করে, বডির নর্মাল বডি ওয়েট আসতে সাহায্য করে, এরকম একটা ডায়েট। দ্যাট ইজ কন্টেন্ট ভেরি লেস অ্যামাউন্ট অফ ফ্যাট। এখন ফ্যাট খাওয়াটা কমিয়ে দিতে বলছে, ভেরি লো অ্যামাউন্ট অফ ফ্যাট, এবং যা ফ্যাট আছে দ্যাট ইজ ওমেগা 3 ফ্যাটি অ্যাসিড, এগেন গুড ফর হেলথ। এমন একটা খাওয়ার যেটা অ্যান্টিঅক্সিডেন্ট রিচ, এখন আমরা সবাই বুঝে গেছি অ্যান্টিঅক্সিডেন্ট। ইমিউনো মডুলেটার, আমরা সবাই বুঝে গেছি মানে অফ ইমিউনো মডুলেটার, কোভিডের জন্য। হেপাটিক ড্যামেজকে প্রোটেকশন দেয়, ক্যান্সার থেকে প্রোটেকশন দেয়, তোমার হচ্ছে ইট প্রোটেক্ট ইউ ফ্রম আলসার, ইট প্রোটেক্ট ইউ ফ্রম ব্যাকটেরিয়াল ইনফেকশন, ভাইরাল ইনফেকশন, ফাঙ্গাল ইনফেকশন, যার রোগ আছে, ইউ জাস্ট নেম এনি ডিজিজ, it can manage that disease. Okay, prevent you from that disease. Okay, এরকম একটা যদি ডায়েট বাজারে বিক্রি হতো কত দাম হতো ভাবো। লোকে বলে নাকি মাশরুম মাংসের মতো, আই নেভার সে মাশরুম মাংসের মতো, আমি বলি মাংস কিছুটা মাশরুমের মতো, কারণ যে মাংস খেলে যা যা অপকার হয় মাশরুম খেলে ঠিক তার উল্টো সব উপকারগুলো হয়। সো ইউ ক্যান নট কম্পেয়ার মাংসের মতো নাকি মাশরুম। ওকে, সো আই মেড এন্টারপ্রেনিউর 300 ফ্যামিলি বাই কোটিং দিস থিং। তোমার ইচ্ছে হলে নাও ভাই, নালে নিও না। 50 গ্রাম মাশরুম ডেলি ইন ইউর ডেলি ডায়েট, আমি অ্যাসিওর করছি, গ্যারেন্টি দিচ্ছি 1 বছরের মধ্যে ফ্যামিলিতে কোনো রোগ থাকবে না, গ্যারেন্টেড। এবং মাশরুম দিয়ে মেডিসিনের উপরে শুধু আমার প্রায় 175 থেকে 80 খানা পেপার পাবে। ইউ জাস্ট পুট মাই নেম ইন গুগল, ওকে, ওখানেই দেখতে পাবে কত কাজ করি, ওকে। সো এবং এনাও কোনো ডিজিজ নেই যেখানে মাশরুম কাজ করে না, শুধু বলে দিলাম, অ্যাসিওর করে দিলাম। এবং আমি তার এক্সাম্পল, আমার হচ্ছে কোলেস বিলিরুবিন লেভেল 3.4 ছিল, তো আমি 4 মাস শুধু মাশরুম খেয়ে নিজের উপরে পরীক্ষা করছি। গত পরশু দিন কালকে একটা A2B মিটিং ছিল আর কি, অ্যাকাডেমিয়া টু বিজনেস, আমাদের জুলজি করছিল, তো সেখানে আমি লেকচার দেওয়ার আগের দিনই আমি নিজেকে টেস্ট করলাম। আমার কালকে অশোকা ল্যাবরেটরিতে টেস্ট করেছি, আমার বিলিরুবিন রাইট নাও 2.4। So within 3.5 months, it goes down to this. Okay, alkaline phosphatase, SGOT, SGPT নর্মালে চলে এসছে। ইনডিরেক্ট বিলিরুবিনটা 2.78 ছিল, সেটা নেমে এসছে 1.7 or something. Okay, তো ইটস ওয়ার্কস। ওকে, সো মাশরুম নিয়ে আমরা কি কি করতে পারি, টিস্যু কালচার, জাম্পলা, এগুলো পরে, স্পন প্রোডাকশন। স্পন প্রোডাকশানে এই ছেলেটি হচ্ছে বিএসসি পাস গ্র্যাজুয়েট, বিএ পাস গ্র্যাজুয়েট। ও আমার কাছে 7 বছর কাজ করতো। ডিউরিং কোভিড আমার মনে হলো ছেলেটা কি করবে, আমি ওর বাড়িতে একটা ল্যাবরেটরি গেছি, ইস আন্দুল। ও এখন শুধু মাশরুমের স্পন প্রোডাকশন করে, ট্রেনিং দেয়, ওর সঙ্গে কলেজ টাই আপ করছে, বিএ পাস কোর্স। হ্যাঁ, এই পরশুদিন আশুতোষ কলেজ টাই করেছে, হ্যাঁ, মৌ করেছে। ও এখন ট্রেনিং দিতে যায়, নিজে স্পন তৈরি করে বিক্রি করে, প্রতি মাসে 50,000 ইনকাম করে, সংসার চালায়। ওকে, এর নাম হচ্ছে অনুজিৎ। এই বাচ্চা মেয়েটি, ওই মেয়েটি চাকরি পেয়েছিল, ও পুলিশে, ও চাকরি ছেড়ে দিয়ে মাশরুম শুধু বেচে, 1 লক্ষ টাকা টার্নওভার পার মান্থ। ওকে, এই লোকটাকে দেখে রাখো, এ হচ্ছে কমার্স গ্র্যাজুয়েট, এর নাম হচ্ছে তুষার মেহতা, কমার্স গ্র্যাজুয়েট। 1996 সাল থেকে শুধু মাশরুমের স্পন তৈরি করে, ভবানীপুরে ভাড়া বাড়িতে তৈরি করতো, প্রেসার কুকারে স্পন বানাতো প্রথম। এখন সে বেহালায় একটা পুরো বিল্ডিং কিনে নিয়েছে। ওর টার্নওভার শুধু স্পন বেচে টার্নওভার কত হয় জানো? 7 কোটি টাকা অনলি। হ্যাঁ, সো দেখো, একজন কমার্সের লোক, হি ক্যান থিঙ্ক ডিফারেন্টলি। একজন আর্টস গ্র্যাজুয়েট, হি ক্যান থিঙ্ক ডিফারেন্টলি। আমি বটনিতে 5 বছর, 6 বছর, 7 বছর রুল করলাম, বাট আই ক্যান নট থিঙ্ক, কারণ আমার দম নেই। ওকে, সো ইউ ক্যান থিঙ্ক ডিফারেন্টলি। ওকে, সো নট অনলি দ্যাট, কাল্টিভেশনে আমি নরেন্দ্রপুরে যেটা করছি, 50 টাকার বিজনেস। এটা গল্প কোনোদিন যদি সুযোগ পাই শুনিয়ে দেবো। 50 টাকার বিজনেস স্টার্ট করো, কোনো বিজনেস হবে না। প্রথম মাসে 4 মাস বাদে প্রতি মাসে 40,000 টাকা ইনকাম আছে। আই উইল প্রুভ ইট। ওকে, করে দেখো তোমরা, যদি মনে করো নিজে করবে, করতে পারো। ইউ ক্যান ফোর্স ইউর ফ্রেন্ডস, তোমার বাড়ির কাছে যারা বেকার বসে রয়েছে, যারা সন্ধ্যের সময় রাস্তার আলোর নিচে তাস পেটায়, গ্রামে যারা আছে দেনো, হ্যাঁ, এটা কমন, হ্যাঁ, তাদেরকে অন্তত মোটিভেট করতে পারো। বাট ডোন্ট সেল মাশরুম অ্যাজ এ ভেজিটেবল। মাশরুম ক্যান নট বি এ ভেজিটেবল, ইটস এ প্রোডাক্ট, ইটস এ ডায়েটারি সাপ্লিমেন্ট, ইটস এ ফাংশনাল ফুড, ইটস এ নিউট্রাসিউটিক্যাল। নেভার সে ইটস এ ভেজিটেবল। এই কথাটা নিয়ে দাঁড়াবে। ওকে, অ্যান্ড দেখো নরেন্দ্রপুর রামকৃষ্ণ মিশনে এটা প্লিওটাস জ্যামর, দিস ইজ ভলভারিয়েল্লা, ক্যালোসাইভি ইন্ডিকা। আমার সব ওখানে যারা ব্লাইন্ড পার্সোনাল রয়েছে, দেখো সবাই দেখতে পান না, ওরা কিন্তু করেন। তারা জানে স্পন বানাতে, তারা জানে খড় কাটতে, তারা মাশরুম বানাতে, তারা মাশরুম হারভেস্ট করতে, মাশরুম বেশি হয়ে গেলে ড্রাই করতে। এবং আমার প্রথম এন্টারপ্রেনার হচ্ছে দিস জেন্টলম্যান, এর নাম হচ্ছে বাবুরাম গোচরণ, ওনার বাড়ি। উনাকে বাড়ি থেকে বের করে দেওয়া হয়েছিল, বাড়িতে বসে বসে খাস, ট্রেনে ভিক্ষা চা, 2 পয়সা হবে, তাও আমার সংসারটা চলবে। তো সামহাউ দ্যাট পারসন রিচ টু নরেন্দ্রপুর রামকৃষ্ণ মিশন। হ্যাঁ, উনাকে ট্রেনিং দেওয়া হয়েছিল। উনি এখন প্রতিদিন 15 কেজি করে মাশরুম তৈরি করেন, বিয়ে করেছেন, সংসার চালান, 2 সন্তানের বাবা। উনাকে আমাদের ওখানে ইন্টারন্যাশনাল কনফারেন্স হয়েছিল, নিয়ে এসেছিলাম, পোডিয়ামে তুলে, এরকম পোডিয়ামে তুলে ওয়ার্ল্ড সায়েন্টিস্টের সামনে বলেছিলাম, জাস্ট সি দিস পারসন, ইনার চোখ নেই কিন্তু দৃষ্টি আছে। আমাদের বড় বড় চোখ আছে, দৃষ্টিটা নেই। সো ট্রাই টু কনভার্ট ইট ইনটু আ ভিশন। You become a visionary, you can design your life in a way. So in the meantime, আরো আছে, this is medicinal mushroom, 6,000 টাকা প্রতি কিলো। This is another medicinal mushroom, যদি ওয়াইল্ডে পাওয়া যায় 13 লক্ষ টাকা প্রতি কিলো, কডিসেপস। কাল্টিভেশন এখন আমরা স্টার্ট করেছি, উই আর ট্রাইং টু ডেভেলপ, দিস ইজ কর্ডিসেপ। আরে নামটা লিখে রাখ, গুগল ইট, ও উঁচু করে দেখতে হবে না, গুগল করলে সামনে, গুগল বাবা সব জানে, ওকে, দ্য অনলি বাবা, হ্যাঁ সব জানে। তো গুগল করবে কর্ডিসেপস, এটা আমরা ট্রাই করছি, কর্ডিসেপিন কনসেন্ট্রেশন এখনো রিচ করতে পারছি না, উই আর ট্রাইং টু রিচিং দ্যাট লেভেল। এটার দাম হচ্ছে, কাল্টিভেটেডের দাম হচ্ছে 3 লক্ষ টাকা, 2 থেকে 3 লাখ টাকা, ওয়াইল্ডের দাম হচ্ছে 13 লক্ষ টাকা। নট অনলি উই হ্যাভ নট স্টপড হিয়ার, সো উই ওয়েন্ট ফার্দার টু ডেভেলপ প্রোডাক্ট ফ্রম দিস থিং, although this is not my hardcore research part, okay, রিসার্চ পার্টটা অন্য জায়গায়, এটা হচ্ছে সোসাইটাল ট্রান্সলেশন। কারণ আমার মনে হচ্ছে এন্ড অফ দ্য ডে উই হ্যাভ টু রিচ টু দ্য সোসাইটি, আদারওয়াইজ মনে হবে ওই কিছু পেপার করলাম, কিছু কাগজে ছাপলো, হ্যাঁ সায়েন্টিফিক ফোরামে গিয়ে হাততালি পেলাম, কিন্তু এই জামাটা পরে আছি যে চাওয়ালাটা চা খেয়ে, তার জন্য আমি কিছু দিনের শেষে দিলাম না। সো আই মেড 1650 ফ্যামিলি entrepreneur up till now. My target by 2030 I will reach to 1 lakh family. So I have developed product from them, mushroom based product. This is noodles, this is pasta, papad, then bori, then mushroom tea. Mushroom tea তোমার গুগল করে দেখে না মাশরুম টি বাজারে দাম কত। Then mushroom pickles, mushroom cosmetics, anti aging cosmetic, 4000 টাকা মিনিমাম দাম একটা স্যাশে, অনলি দাম অ্যান্টি এজিং 4000 টাকা একটা স্যাশে। মাশরুম সোপ, mushroom achar, so different. So in the meantime syllabus এসে গেছে mushroom cultivation technology, so I translated that societal knowledge and the benefit to the in form of book, that is the mushroom cultivation technology, where I have tried to incorporate all the corners of mushroom cultivation technology. As I said, mushrooms have strong medicinal property. আমাদের ল্যাব থেকেই এত রকমের মাশরুম নিয়ে এতগুলো কাজ আমরা করেছি। It has antioxidant, anti-diabetic, immunomodulatory, anti-cancer, antimicrobial, cardioprotective, hepatoprotective, anti-ulcer, nitrioxide, anti-inflammation, so many medicinal properties. So you just take any mushroom you like to that have the medicinal benefit. Now we are এই দুটো বই এই মাসের শেষে আসবে, this will be published by Taylor and Francis Group, CRC Press, that is based on the Ganoderma যেটা দেখালাম, ওই যে 6000 টাকা কিলো, তার Ganoderma cultivation, chemistry and medicinal application, probably ফার্স্ট ভলিউম এই বছরের শেষে এসে যাবে, সেকেন্ড ভলিউম নেক্সট ইয়ারের 2-3 মাস বাদের মধ্যে এসে যাওয়া উচিত। And it covers all the corners related to the Ganoderma. Ganoderma উপরে সারা ওয়ার্ল্ডে এখন যদি সার্চ কেউ করো তাহলে অন্তত 7 থেকে 8000 পাবলিকেশনস পাবে। তো we have tried to compile, this is one edited book. Okay, so again একটা দিক দিয়ে এন্টারপ্রেনার হওয়া যায়, সেকেন্ড ওয়ে অফ এন্টারপ্রেনার। সেকেন্ড এন্টারপ্রেনার হচ্ছে যেটা নিয়ে আমি কাজ করছি আর একটা, সেটা হচ্ছে কুমারগ্রাম অ্যাট আলিপুরদুয়ার টু কাকদ্বীপ, 24 পরগনা, 25খানা জায়গায় আমি চাষিদের সায়েন্টিস্ট বানিয়েছি। মাই ফার্মার্স আর নাও বিকাম সায়েন্টিস্ট, দে আর এবল টু প্রডিউস 24 প্রোডাক্ট বাই দেমসেলফ। কারণ হচ্ছে আমরা এই একটু আগে বলছিল যে স্বামীনাথনের কথা, স্বামীনাথনের কথা সবাই বলেন, but nobody talks about Richaria's book. পারলে একবার স্বামীনাথন ভার্সেস রিচারিয়াকে দেখে নিও, ওকে। স্বামীনাথন অ্যান্ড আদার্স, অ্যাকচুয়ালি গ্রিন রিভলিউশন আমাদের এসছিল, ওকে, ফর ফুড সিকিউরিটি, মনে রাখিস, পেটে দানার জন্য। সো উই ডেভেলপ হাইব্রিড প্ল্যান্টস। হাইব্রিড প্ল্যান্টস নিড হাই এনার্জি। হাই এনার্জির জন্য উই সো কল্ড সায়েন্টিস্ট ডিসকভার্ড ডিফারেন্ট টাইপস অফ কেমিক্যাল ফার্টিলাইজার। Chemical fertilizers increase the cell volume, water content increase করবে, মোটা হয়ে ফুলে গেলে রোগ হয় বেশি, গাছেরও রোগ হলো বেশি। যেই রোগ হলো বেশি, সঙ্গে সঙ্গে আমাদের মতো সায়েন্টিস্ট উর্দি পড়া বেরিয়ে পড়লো, দে ডিসকভার সার ওষুধের দোকান জীবনে বলবি না, সার বিষের দোকান। কি দোকান? সার বিষের দোকান। ওগুলো ওষুধ নয়, ওটা এক চামচ খেলে তুই এইখান থেকে এইখান যেতে পারবি না, তার আগে পটকে যাবে। সো দ্যাট শুড নট বি এ মেডিসিন। That should not called as a medicine. So we discover toxic compound to kill the pathogen, but pathogen develop resistance against it. So we develop more toxic compound, more resistant, more toxic, more resistant, more toxic. এ বছরই বীজ দিয়েছে 12,000 টাকা প্রতি লিটার, গরিব চাষি পাবে কোথায়? 12,000 টাকা প্রতি লিটার বিষের দাম। আর নেক্সট আসছে ওই মাল্টিন্যাশনাল কোম্পানি প্রডিউসিং বিষ 16,000 টাকা প্রতি লিটার, মনসেন্টো। ওকে, আসছে, ক্লিয়ার? সো আলটিমেটলি উই ডিস্ট্রয়েড আওয়ার সয়েল। সয়েলকে আমরা বাংলায় কি বলি রে? বড় কর, মাটি, দি মাদার। We the killer of the mother. Last 60 years, প্রতিদিন সকাল বিকেল বীজ ঢালতে ঢালতে, সার ঢালতে ঢালতে, we killed our mother. মাটি, destroyed environment. We the culprit responsible for carbon footprint, increase of carbon footprint. We the culprit actually responsible for global warming. অন্য কোনো অ্যানিমেল করে না। We the greatest pathogen ever produced by Mother Nature is the human being. Okay? So, standing in this scenario, we cry for, go for organic, go for organic. Fantastic. To whom we are asking for that thing? The poorest among the poor. নুন আনতে পান্তা ফেরো। তুমি চিন্তা করে দেখো, আমরা যে যাই ইনকাম করি না কেন, এন্ড অফ দ্য ডে উই প্রে টু গড, দুটো ভালো খেয়ে পড়ে থাকবো। এম আই রাইট অর রং? এর বাইরে বেশি চাহিদা আছে? চাহিদা নেই না? তো ভগবান যেন দুটো ভালো খেয়ে পড়ে থাকি। ঠিক এই মুহূর্তে ভাবো, আমরা একটা এসি ঘরে বসে কথা বলছি কিংবা কথা শুনছি, আমার ভগবান মাঠে ঘাস বাসছে আমার পেটে দানা দেবে বলে, তার ঘরে দানা নেই। দ্যাটস দ্য ট্রুথ। তারপর আর গামছাটুকুও নেই ছেঁড়া, তার ঘরে ফুটো দিয়ে জল পড়ে, শোয়ার জায়গাটুকু নেই। হাউ মেনি ডেজ দ্যাট ভগবান উইল ফিড ইউ? আজকে কথা বলছি পেটে দানা আছে বলে, আজকে কথা শুনছো পেটে দানা আছে বলে, যে ভদ্রলোক দানা দেয় তার পেটে দানা নেই। হাউ মেনি ডেজ দে উইল ফিড ইউ? গ্রামে যদি বাড়ি হয়, ইউ ক্যান অবজার্ভ অনলি ফিউ ওল্ড পিপুল স্টিল ওয়ার্কিং ইন দ্য ফিল্ড টু সাস্টেন আস। ওই লোকগুলো মরে গেলে কি হবে? পকেটে পয়সা থাকবে, ছবিতে আলু বেগুনের ছবি দেখবি, হাওয়া খেতে খেতে বলবি আহা কি খেলাম। That's the truth. Think differently. You are the future of the globe. So try to think differently. রুটি কাপড়া মাকান। আমাদের কাপড় ছিল না আদিপুরুষের, ঘর ছিল না আদিপুরুষের, আমরা কিন্তু বেঁচে আছি পেটে দানা ছিল বলে। ওকে, সো রেসপেক্ট দিস পিপল। সবাই মানে খাওয়ার আগে অনেক কিছু মন্ত্রতন্ত্র বলে নমস্কার করে। আমি খাওয়ার আগে I always close my eyes. I pray. কিছু পোড়া মুখওয়ালা লোক, মানে এই রোদে ঝলসে যাওয়া মুখ, প্রত্যেকটা পাঁজরা গোনা যায় 1 2 3 4 করে নাম্বার। প্রতিদিন 150 কোটি ভারতবাসীর মুখে সকাল বিকেল সন্ধে খাবার তুলে দেয়, তার ঘরে খাবার আছে কিনা ভেবে দেখো একবার। So I make a strategy. Through this strategy, I made more than 1,600 family to become entrepreneur. And I develop a technology for the farmer, যেখানে বেগুন চাষে 1 বিঘেতে খরচা হয় 22,000 থেকে 25,000 টাকায় 1 কেজি বেগুন 1 বিঘেতে চাষ করা। পটল চাষে খরচ হয় 28 থেকে 32,000 টাকা। I have developed a technology for the farmer where my farmers are able to produce same more than that. মানে লোকে বলে নাকি অর্গানিকে প্রোডাকশন হয় না, দুটো গোবর সার দিলে অর্গানিক হবে না, দুটো অ্যাজাটোব্যাক্টর পিএসবি দিলে অর্গানিক হবে না, ভুলে যা। ওকে, কারণ বীজ দিয়ে সবাইকে মেরে দিয়েছি। দুটো ট্রাইকোডার্মা দিলে অর্গানিক হবে না। অর্গানিক ইজ এ হলিস্টিক অ্যাপ্রোচ। দিস ইজ দ্য অ্যাপ্রোচ। মাকে দশভুজায় সাজাতে হবে, দুর্গা পুজো আসছে। অসুর বধের জন্য সব দিয়েছি, ত্রিশূলটা দিনি, অসুর মরবে। বজ্রটা দিসনি, খুঁজে বের করে আনবে। সাপটা দিসনি, তাড়িয়ে নিয়ে আসবে। দেবতারা কি গাধা ছিল? আর আমরা যারা বড় বড় বিজ্ঞান করি বলি দুটো গোবর সার ঢেলে দাও। আরে যে গোবর সারগুলোকে গাছের জন্য তরলীকৃত সরলিত করতো, গাছের উপকারী জীবাণুগুলো 60 বছর ধরে আমরা খুন করেছি। উই দ্য কিলার। মিলিয়ন্স অফ অর্গানিজমকে আমরা দিনের দিন পর দিন বিষ খাইয়ে খাইয়ে খুন করেছি। নাও উই আর আস্কিং আওয়ার মাদার, মা বেশি খাবার দাও, ভালো খাবার দাও। মা বলবে সকালে বীজ দিস, বিকেলে বীজ দিই, পারলে দুপুরে একটু বীজ দিই। বাবা আমি কোত্থেকে তোকে খাওয়াবো? হাউ মেনি ডেজ? থিঙ্ক ডিফারেন্টলি, ওকে? সো আই হ্যাভ ডিজাইন, দেখো দশভুজায় সাজিয়েছি। সো ইফ আই গেট টাইম আই উইল টেল ইউ দ্যাট স্টোরি, কিভাবে এবং চাষের খরচকে নামিয়েছি কোথায়? 7 টাকা 1 কাপ চায়ের দাম পার ডে পার বিঘা। They are able to produce 17, 18 different types of, সময় হয়ে যাচ্ছে না? হ্যাঁ 5 মিনিট, ও এটা একটু ওকে 2:45, ওকে ওকে চলো তাহলে তাড়াতাড়ি শেষ করে দিই। ওকে হ্যাঁ কত 5 মিনিট? আচ্ছা ঠিক আছে। তো আই ডিজাইন মেনি ইনস্ট্রুমেন্ট, বটনি পড়লে শুধু বটনি জানলে হবে না। ফার্মেন্টার 20 লক্ষ টাকা, আই ডিজাইন এ ফার্মেন্টার ফর মাই ফার্মার্স, যেটা হচ্ছে 10,000 টাকা। অটোক্লেভ 1 লক্ষ টাকা, আই ডিজাইন এ ফার্মেন্টার ফর মাই অটোক্লেভ, দেখো 3,500 টাকা। প্রেসার কুকার ফার্স্ট সিটি 30 মিনিট, সো ইউ ক্যান স্টেরিলাইজ ইট। ল্যামিনার এয়ারফ্লো 1 লক্ষ টাকা, 100 টাকায় ল্যামিনার এয়ারফ্লো। ইঞ্জেকশন সিরিঞ্জ অ্যান্ড নিডল, আমার চাষি সাইন্টিস্ট 16খানা ব্যাকটেরিয়া ফাঙ্গাস তৈরি করে উইদাউট এনি কন্টামিনেশন। আমি দেখাচ্ছি ফাঙ্গাস, ওকে? সো এইটা দিয়ে কত জায়গায় আমরা হতে পারি, এতগুলো সেক্টরে ইউ ক্যান বিকাম অন্টারপ্রিনিয়র। সো উই হ্যাভ ট্রান্সলেটেড দিস থিং ইন মার্জিনাল ফার্মার্স। বলাগড় হচ্ছে ফার্স্ট জায়গা, ফার্স্ট দিন নিয়ে এসেছিলাম। দেখো আমার সায়েন্টিস্টদের, দেখো তারা প্রোডাকশন করছে, তারা নিজেরা প্রোডাকশন করছে 24খানা প্রোডাক্ট, 7 টাকা পার ডে পার বিঘা। সো ডিফারেন্ট প্রোডাকশন, এক দানা সার নেই, এক দানা বীজ নেই, এবং যে কোনো জমি দিলে 1.3 টাইমস হায়ার প্রোডাক্টিভিটি আমি দেখিয়ে দেবো উইদিন এ ইয়ার, এনি ইনঅর্গানিক ওয়ে অফ কাল্টিভেশন। সো দিজ আর দ্য ডিফারেন্ট প্লেসেস। আমার ফার্মার নাও সুটেড বুটেড, গাড়ি কিনেছে, বই পাবলিশ করেছি, দ্যাট ইজ বায়ো ফার্টিলাইজার অ্যান্ড বায়ো পেস্টিসাইডস, ওকে? অ্যান্ড অলসো প্রিসিশন এগ্রিকালচার অ্যান্ড সাস্টেনেবল ক্রপ ডেভেলপমেন্ট। Then also omics approach in abiotic stress. So আমরা ব্যারেন ল্যান্ডকে কনভার্ট করে দিয়েছি ইন্টু গোল্ড মাইন, বাঁকুড়ায় সালতোড়ায়, যেখানে কোনোদিন চাষ হয়নি। এখন যদি বিগ বাস্কেট থেকে কেউ ড্রাগন ফ্রুটস কেনো, ওখান থেকেই পাবে। সো সেখানটায় ফলে ছবি দেখানোর সময় রইল না। সো মেনি বুকস আই হ্যাভ পাবলিশ, বাট end of the day I have taken lesson from the society. Society needs us to stand behind them. শুধু পড়াশোনা করলাম, অনেক দূর এগোলাম, আমি একটা এসি ঘরে থাকলাম, হ্যাঁ বাড়িতে ভালো মন্দ খেলাম, মিনস নাথিং ইন লাইফ। বিফোর ইয়োর ডেথ পুট ইয়োর স্টেপ ওভার দ্য গ্রাউন্ড ইন এ স্কার ফর্ম। সো তোমার যে ট্রেলটা তৈরি করে যাবে না, রাস্তাটা জঙ্গলের মধ্য দিয়ে, সেই জঙ্গলের রাস্তা ধরে মিলিয়নস অফ পিপুল হাঁটবে, যাতে আগামী দিনে তোমার রাস্তাটা ভালো থাকে। আর সবাই মোটামুটি যদি তোমাদের এই কথাগুলো মনে হয় ইন্সপায়ার্স ইউ, প্লিজ থিঙ্ক ডিফারেন্টলি। যে লোকটা এইখানে পড়েছিল বলে আজকে তোমার সামনে দাঁড়িয়েছে, তোমরাও হয়তো কোনো দিন এরকম জায়গায় এসে দাঁড়াবে, আমরাও হয়তো ওরকম জায়গায় বসে তোমার লেকচার শুনবো, শুনে লেকচারের পরে হাততালি দিয়ে বলবো ফাটিয়ে দিয়েছিস। তো সেই আশা, সেই আকাঙ্ক্ষা, সেই ইচ্ছে, সেই উৎসাহ নিয়ে আমরা এখানে আসি, তোমাদের সামনে বারবার দাঁড়াই, নিজেদের ভবিষ্যতে নিজেদেরকে দেখতে চাই, দেখতে পাই। চলে আয়, একদিন আমরাই বদলে দেব। এই বড় সেতু বন্ধে আমরা বড় বড় হনুমান হয়ে পাথর ফেলে না হলে সেতুটা নাও মারতে পারি। ক্যান বি এ কাঠ বিড়ালি, মুখে দুটো করে দানা করে বালি নিয়ে যাই, একদিন সেতুটা বেঁধে দেবো। বিকজ একটাই গ্রিন প্ল্যানেট এখন অবধি ডিসকভার, তাকে বাঁচিয়ে রাখার দায়িত্ব আমাদের সবার। আমরা বুড়ো হয়ে গেছি, তোমরা আগামী, তোমাদের হাতেই বাটন দিয়ে গেলাম, লড়ে দিস। থ্যাংক ইউ।
এনি কোশ্চেন? আমার তো একটা কোশ্চেন আছেই।
আচ্ছা ঠিক। Good afternoon to all the respected dignitaries, faculty members and dear students. Welcome to the post-lunch session of library book review by prominent writers organized by IQAC and Library Department of Ramakrishna Mission Vivekananda Centenary College. Now, I'd like to request Dr. Somnath Mukhopadhyay to please come and the dais. Please, sir. Now, I'd like to request Dr. Ravi Kumar De, sir, please come and give the welcome. Felicitate Dr. Somnath Mukhopadhyay and now I'd like to request Dr. Ravi Kumar De to please the welcome address to the Dr. Somnath Mukhopadhyay.
Very good afternoon. Dr. Somnath Mukhopadhyay at present is the principal. I am coming later. He is M.Phil in Environmental Science in 1988. He completed his PhD work in Drosophila genetics in 1995. He served Bangabasi College from August 1990 to April 2008, and presently he is serving Dinabandhu Andrews College as principal from April 2008. He is also serving West Bengal College Service Commission from February 2020 till date. He has acted as a member of different committees of the Department of Higher Education, Government of West Bengal. He has published many papers in national and international journals. Now I request Professor Somnath Mukhopadhyay sir to deliver his specious lecture. Sir, please come.
Thank you very much. The dignitaries in the dais, other officials, and my dear students. It is a great opportunity for anybody to speak on his own creation. I think my book is my creation. I started my career as a zoologist in 1990 as a student, as a teacher of Bangabasi College. Earlier, I was a student of Ashutosh College, and in Ashutosh College, while during my studies in Ashutosh College, I came across some prominent teachers who inspired me to go deep into the subject and learn the subject with love. So I continued loving the subject zoology. But in the middle of my journey as a teacher, I took a wrong decision, and I am suffering for that. In many occasions, my friends introduced me as a zoologist. But I regret that at present I am not a zoologist. At present I am academic administrator. I will recall one program in which some official introduced our ex-Prime Minister, Dr. Manmohan Singh, saying he is Dr. Manmohan Singh, the eminent economist and the Prime Minister of India. So I think it is very pertinent to me because I do agree that, yes, I am a principal of Dinabandhu Andrews College and a zoologist. But as the Prime Minister said, no doubt I am the Prime Minister of India, but I am an extinguished economist. I also feel so. I am an extinguished zoologist, although I have same love and pathy for that subject. I will share some idea what inspired me from to write a book in the midst of a situation when lots of books were available in the market. Still then, we were dared to take the endeavor of writing a book, and that was published by a very prominent publisher, Macmillan India. In course of our studies as a student of zoology, we found it very difficult to get a very good text on practical curricula of the subject. There are plenty of books available in the market, in the libraries. You can see lots of books, and most books are on theoretical aspects. Thousands of books have been written on different chapters of the subject zoology. But you can seldom find any book of significance in the libraries of any college, any institution. In research institutes, you can have certain manuals for doing experiment, but practical curricula is somewhat neglected. If you just compare the syllabi you study in your undergraduate course or postgraduate course, you will see that the theoretical part of the syllabus, theoretical part of the curriculum is very well crafted and has contemporary significance. It is significant at the present day. But if you very clearly study, very cautiously study the items which are there in the practical curriculum, you will see that lots of practical items will have no bearing with the theoretical part of the syllabus you study. Moreover, the topics which you need to deal with in practical classes are not covered in the theoretical syllabus. As a result, the students get bored and do practical classes mechanically, which is sheer wastage of time, and that cannot help any student to grasp over the subject. This is the main thing that drove us to think of writing a book when lots of books, popular books, are available in the market. I am not going to take any name of the book, any title, but I will say certainly that when we tried to took the endeavor of writing the book, a plenty of books were also available in the market, but I don't recognize those books as textbooks. Those can be helpful in the practical laboratory, no doubt, but that cannot be a supplement of a textbook, because the things that are dealt with in those books are not covered, the theoretical part are not covered, the other parts are not covered. I will show that in a few slides I have prepared. Tanmay, you may please project the first slide, please. Oh, that is there. This is the book, the Advanced Laboratory Manual of Zoology. Tanmay is my student at IQAC College, and he requested me to share with you the idea behind writing this book, the genesis of the book. I am not going to take a zoology class, the students here. I will just mention what are the uniqueness of these books, what kind of thinking is behind this book, and why it is so that after 22 years the book is still active and is in the mind of the students. It's a very pleasant experience for me, for any author. The book was published in 2003 for the first time by Macmillan. It has 7 reprints signifying its sellability and acceptance in the market. And in 2015, the book was taken over by the another global press, Trinity Press, London. Next slide, please. I take the opportunity to introduce the co-authors. The first author was Dr. Tapan Kumar Poddar, who was the principal of Vivekananda College, Kolkata. Earlier, he was my colleague at Dinobandhu Andrews College, and he is a renowned entomologist and marine scientist. He is just retired in May this year, only 31st May this year. Myself, I am acting as a principal of Dinobandhu Andrews College, and of course, I am a teacher of zoology. Although I seldom get opportunity to teach students and take classes, because the moment I go to class, some problem crop up, and that drive me out of the class. Pandada can well realize that. Then one of my students was also co-author, Dr. Swapan Kumar Das, who is at present Associate Professor, Wake Forest School of Medicine. He was a student of genetics in Kolkata University, and thereafter he was a technician. He acted as a technician in Shishu Mongol Hospital, Kolkata, in the hematopathology laboratory. After that, he migrated to the United States of America, where he is still working as a professor. As you all know, the students, my address is mainly for the students. As you all know, there are 3 major divisions of our study: arts faculty, science faculty, and commerce faculty. In arts faculty and commerce faculty, the problem is not that serious, because there is nothing like practical and theoretical aspect. But in all science streams, we sharply divide the curriculum into practical aspect and theoretical aspect, and there lies the problem. For reasons not known to me, why the persons who are responsible to prepare syllabus, why they are so reluctant in framing the syllabus with love as that of the theoretical part of the syllabus. I think it is because the books are available in plenty when we talk about theoretical part, but books are not available in the market when we talk about practical part, and that is the reason the practical curricula is somewhat neglected, I think. I still believe that practical curricula is somewhat neglected in our country. Now, if we talk about the modernization of syllabus, we see that there are many things which have no bearing with the practicals we deal with. The subject remains zoology, but the syllabus makers just are dropping day by day the dissection part. If a student cannot have any idea about the anatomy of the animal, how they can learn ABCD of zoology, I don't understand. Why a student in the first go should learn a technique like RAPD, RFLP, gel electrophoresis? Why? I don't understand. I purely understand. I am sincerely, I feel that all these things should be learned after one student have a grasp of the subject. You must know the ABCD of the subject first, and then only you can migrate to a greater world. But in our country, in particularly in West Bengal, I see with regret that the syllabus is not in that tune, and that is the reason we at that age 20 years back, we took the endeavor of writing a book. Next slide. Now you can see, I tried to differentiate the main points, how a practical book and theoretical book differs in most cases. When we talk about a good quality theoretical books of any make, any country, any authorship, centrally there is a historical part of the subject, conceptual development of the subject matter. The book very well deals with that. The conceptual development, historical aspect of the conceptual development of the subject. Then comes definition of terms, of the key words, of which the concept is to be built. Then the concept, treatment of the subject matter and its applicability. What is subject all about? How it is relevant to our present day life, like that. And finally, discussion and questionnaire. So, when we talk about any theoretical book, that it be genetics, that it should be ecology, that it be any other book, all these 4 parameters are very well met. But if we take at random any practical book on practical career, exceptions are there, of course. First we'll say, historically, any topic is not dealt with in that way. Abruptly, the book writes about the technique or method, how we can do that. In most cases, the keywords are not defined prior to giving the protocol or methodology of performing the experiment. We can seldom find any part, even a sentence, even a paragraph in the book dealing with the concept behind the experiment. And discussion and questionnaire are also mostly absent. These were our observation. I don't know whether it was correct or not, but this was the thing we observed in the middle age of our as a teacher, as a teaching life. As a result, we find that students have a great loss, which can be shown in the next slide. The academic loss the students suffer, particularly science students, because of the poor treatment of the syllabus. It is my opinion. Students try to perform experiments mechanically without realizing the relationship between the theory and practice. As I told you, if you don't have any idea about the subject, if you don't develop concept, if you are not aware of the keywords and their genesis, how can you be interested in that particular item other than performing the experiment and get good marks? That is not the aim of studying, aim of education. That should not be. I don't think that fetching good marks is the only thing we should do. If we learn the subject well, can you show me in the society anybody who actually learns a subject better, is lying idle, unemployed? I don't think so. Our problem is we consider employment as a permanent government job. That is the only definition in our dictionary of a job. It's not that. Anybody who is acquainted with the particular type of job, work, he or she can have bread and butter well. No doubt about that. আমাদের হাউজিংয়ে দুটি প্লাম্বার আছে, একজনের নাম প্রবীর, একজনের নাম অশোক। প্রবীর বাড়ি গেলে আমাদের যদি প্লাম্বিং লাইনে সমস্যা হয়, আমরা সেই সমস্যা সহ্য করি, প্রবীর ফিরে আসা না পর্যন্ত অশোককে ডাকি না। এইটা বুঝতে হবে। অশোক শেখেনি, প্রবীর শিখেছে। যে শিখেছে তার ভাতের অভাব নেই। আমি পড়ানো শুরু করলাম ফার্স্ট সেমিস্টারে, প্রথমেই চাকরির দিকে লক্ষ্য। কেন? আই হেট দ্যাট। আগে শেখো, চাকরি আপনি আসবে। এই যে আজকাল, আমি ন্যাক বিরোধী নয়, কিন্তু ন্যাকের কতগুলো প্যারামিটার আমার অত্যন্ত বিরক্তির কারণ ঘটে। প্লেসমেন্ট সেল ইন দ্য কলেজ, হোয়াই শুড দ্যাট বি ইন দ্য কলেজ? ইজ কলেজ an employment exchange? College is a place where students should learn. If they learn properly, their employment will come into them, toward them, no problem. So if a student don't have any idea, don't develop any concept, that student will not be able to learn the practical curriculum too. Another problem the student face, I think, the student fail to benefit themselves from the practical curricula. They perform the experiment, write down in the practical notebook, pass the exam, get good marks, ends there, matter ends there. Entire wastage of 3 years endeavor. It should not be. Toil should not be wasted in that way. Often the student lose interest in the practical curricula. Next slide. I am presenting a quote of a renowned author. Everybody knows that, Marshall. Do you know that the textbook of zoology, have you heard the name of Marshall and Williams? Yes, thank you. Marshall wrote in the second volume of his textbook of zoology, volume 2, vertebrates. In the preface, he wrote, the elimination of Neoceratodus as a lungfish type and the substitution of Protopterus needs brief explanation. During writing the book, Marshall realizes that he wanted to change the type from Neoceratodus to Protopterus in the type study. That has been deleted nowadays. No syllabus really caters that. Type study আছে? পান্নাদা আছে কি? টাইপ স্টাডি নেই তো? টাইপ স্টাডি নেই। তোমরা যারা ছাত্ররা বসে আছো ওদেরকে বলি, আমরা ছোটবেলা ফাইলা ধরে ধরে টাইপ স্টাডি করতাম। ধরো পিজিয়ান, এভিয়ান অ্যানাটমি বোঝার জন্য, বা ক্যালোটিস ভার্টিব্রেট অ্যানাটমি বোঝার জন্য, ফ্রগ অ্যান্ড টোড অ্যাম্ফিবিয়ান বোঝার জন্য একটা মাছের কিছু পড়া হলো। তো এখন এটা উঠে গেছে, এটা পুরনো জুওলজি। অনেকের ধারণা এটা পুরনো জুওলজি বর্তমানে এটা সম্পর্ক নেই। লাফিয়ে গিয়ে প্রথমেই একটা মলিকুলার বায়োলজির দিকে লক্ষ্য। তাতে না হলো মলিকুলার বায়োলজি, না হলো জুওলজি, মাঝখান থেকে কিছুই না শিখে একটা স্টুডেন্ট পাস করে ক্লাসে পড়ানোর যোগ্যতা অর্জন করতে পারছে না, স্কুলে পড়ানোর যোগ্যতা অর্জন করতে পারছে না। তার কারণ ছাত্ররা দায়ী নয়, আমরা দায়ী। I take myself responsible for that. আজকে আমরা শিখতে পারছি না নানা রকম ভাবে। একটা সিলেবাস ছিল, প্রফেসর পান্নাদা যখন পড়েছেন, আমি যখন পড়েছি, 2.5 পাতার সিলেবাসে পুরো স্টোরি ছিল। এখন 100 পাতার সিলেবাসে স্টোরি হারিয়ে গেছে। সিলেবাসই ছাত্র মনে রাখতে পারে না, তো পড়বেটা কি? আনফরচুনেট, কিন্তু এটা হয়েছে। যাই হোক, এটা অন্য প্রশ্ন। তারপর উনি বলছেন, the former মানে Neoceratodus is so rare and rigidly protected that not even an Australian student can confidently hope ever to dissect one. এই কথাটা মানে বুঝতে হবে। কেন মার্শাল এই কথাটা লিখলেন? এই জন্য যে ওর ভাবনায় Neoceratodus তার অ্যানাটমিক্যাল ডিটেলসটা তার বইয়ে তিনি লিখছেন। উদ্দেশ্য কি? ছাত্ররা ওইটা ল্যাবরেটরিতে ডিসেক্ট করে ওই অ্যানাটমিটা বইয়ের সঙ্গে মিলিয়ে শিখবে। থিওরিতে যেটা পড়লো প্র্যাকটিক্যালও সেটা সে করবে। কিন্তু উনি দেখলেন যে অস্ট্রেলিয়াতে নিওসেরাটোরাস প্রোটেক্টেড, ওয়াইল্ড লাইফ প্রোটেকশন অ্যাক্টে এত ভীষণভাবে প্রোটেক্টেড হয়ে গেল যে লিখছেন ইভেন অ্যান অস্ট্রেলিয়ান স্টুডেন্ট ক্যান ইভেন কনফিডেন্টলি হোপ ফর টু ডিসেক্ট ওয়ান। মানে অন্যদের তো বাদই দিচ্ছেন, অস্ট্রেলিয়ায় এটা পাওয়া যাবে না। তাই জন্য তিনি যেটা বাজারে পাওয়া যায় সেই মাছটাকে টাইপ করে ফেললেন। কতটা সিনসিয়ার এফোর্ট ইন ফ্রেমিং দ্য সিলেবাস অ্যান্ড সিলেক্টিং দ্য টপিক, বিকজ দে used to write the books for letting students learn, not doing business. Next. এই রিয়েলাইজেশন থেকে একটা আম্বল এফোর্ট আমরা তৈরি করি। দ্যাট আম্বল এফোর্ট 1 by 1 চারটে এফোর্ট আমি দিয়েছি। Need-based treatment of the theoretical fundamentals beyond the experiments to be performed. In all the experiments, be it identification, be it physiology, be it biochemistry, be it genetics, be it histology, be it embryology, whatever, in every chapter, all the theoretical details are there. We tried to accommodate theoretical part of the curriculum in a nutshell. Then we tried to provide etymology of all the technical terms, because you know in zoology and in biology particular, most of the scientific terms have been derived from old European languages, Greek, Latin, etc., old French. So we sincerely picked up each and every term and added its etymology into it within bracket. Every term. We use 36,000 terms. You can count. And that put a lot of energy, that required a lot of energy. Since most of the scientific terms have been derived from old European languages, elaborate etymological treatment have been included. You can, if you have ever seen the book, we will try to have all the terms have the derivatives. I have an example দিয়ে বলছি। A platypus animal, সবাই জানে তার নাম কি? Ornithorhynchus anatomos। এই যে বম্বাস্টিক ওয়ার্ডটা Ornithorhynchus anatomos যদি ছাত্রকে মানেটা বুঝিয়ে দেওয়া যায় তাহলে কিন্তু খুব আনন্দ করে সে মনে রাখতে পারবে, এটা আমার মনে হয়েছিল। অর্নিথ মানে কি? পাখি। রিংকাস মানে কি? রিং মানে রিনাল, নাক। ওদের ঠোঁট আছে তো, তো আমাদের নাকটাকে রিনাল বলে, এই রিনাল নস্ট্রিল, নস্ট্রিল রিনাল, নেজাল। তো অর্নিথোরিঙ্কাল পাখির মতো ঠোঁট বিশিষ্ট অ্যানাটিমাস, অ্যানাটমির দিক থেকে। তো অর্নিথোরিঙ্কাস অ্যানাটিমাসটাকে মুখস্থ না করে যদি এইটা মানেটা বোঝা যায়, আমার মনে হয়েছে, তোমরা বলবে সত্যি কি ভুল, ঠিক কি ভুল, তাহলে ছাত্রের পক্ষে সেটা মনে রাখা সম্ভব হবে, অনেক সোজা হবে। The procedure of the experiments have been designed in proper order with explanation whenever required. এটা বইটা লেখার সময় আমরা খেয়াল করেছিলাম যে স্টেপ 1 টু স্টেপ 2 যখন যাচ্ছি, কেন স্টেপ 2 এ পারফর্ম করছি, কি হয় ওই স্টেপে, সেগুলো পরপর লেখার চেষ্টা করা হয়েছে। প্রয়োজন হলে নোট দিয়ে বক্স বানিয়ে ওর মধ্যে ওখানে থিওরিটিক্যাল কোনো একটা পার্ট থাকলে সেটাকেও বলে দেওয়ার চেষ্টা হয়েছে। For better grasp of the student on the subject, the experimentation and elaborate glossary of all relevant terms. যখন প্র্যাকটিক্যাল পার্টটা লেখা হচ্ছে তখন যে টার্মগুলো লাগবে সেই পার্টটা তো লেখা হলোই, কিন্তু ওর আনুষঙ্গিক যত কিছু আছে ওই বিষয়ে সেইগুলোর যতগুলো সম্ভব তার টেকনিক্যালগুলো বেছে 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 আমরা ওই গ্লসারিটা করে দিয়েছিলাম। নেক্সট স্লাইড। তার ফলে মনে হয়েছে এটা হওয়াতে আমার ক্রিয়েশনটাকে এইভাবে আমি ভাবতে চেয়েছি, সফল হয়েছে কিনা ছাত্ররা বলতে পারবে, যারা বইটা পড়েছে তারা বলতে পারবে। এই থিওরিটিক্যাল ফান্ডামেন্টাল ড্রাইভ করছে এক্সপেরিমেন্টাল মেথোডোলজিকে। থিওরিটিক্যাল ফান্ডামেন্টালস ড্রাইভস দ্য experimental methodology, which again drives a student to conduct the experiment with love, with better understanding, এবং সেটাই আমাদের লক্ষ্য। নেক্সট, আমরা মোটামুটি 12টা চ্যাপ্টারে এই বইটাকে ভাগ করেছিলাম। এটা বলা অপ্রতুল, যারা বই পড়েছে তারা জানে, তাও আমি বলে দিচ্ছি কি কি ছিল। ইন্ট্রোডাকশন টু দি লিভিং ওয়ার্ল্ড। এই লিভিং ওয়ার্ল্ডে আমরা প্রথম চেষ্টা করি যে ওয়ার্ল্ড আমাদের যে সারা পৃথিবীতে যে চলে, যে ক্লাসিফিকেশনের ব্যাপারটা চলে, তোমরা নিশ্চয়ই জানো যে ক্লাসিফিকেশন সবসময় প্রভিশনাল, প্রত্যেক সময় প্রভিশনাল। এটা আমার কথা নয়, রোমারের কথা, যে ক্লাসিফিকেশন ইজ অলওয়েজ প্রভিশনাল। সেইটাকে মাথায় রেখে বিভিন্ন যে মাইনর ফাইলা আছে, মেজর ফাইলা আছে, সবগুলোকে অ্যাকোমোডেট করার চেষ্টা হয়েছিল ইন দ্য থিওরিটিক্যাল ফান্ডামেন্টালস বলে যে পার্টটা ছিল প্রত্যেকটা জায়গায়, সেটা দেওয়া হয়েছিল। ডেভেলপমেন্টাল বায়োলজি, সাইটোলজি অ্যান্ড জেনেটিক্স, ফিজিওলজি অ্যান্ড বায়োকেমিস্ট্রি, প্যারাসাইটোলজি অ্যান্ড মাইক্রোবায়োলজি, অস্টিওলজি। আমার মনে হয় আমাদের বইটাতে মধ্যে সবথেকে বড় চ্যাপ্টার এবং সবথেকে কেয়ারফুলি ডিজাইন চ্যাপ্টার ছিল অস্টিওলজি, কারণ আমি ছাত্র অবস্থায় মনে করেছি এটা অত্যন্ত একটা গোঁজা মিলন চলে এখানে, আমরা পারি না, সব জায়গায় পারি না, কারণ সব কলেজে অস্টিওলজি মাস্টারমশাইয়ের অভাব আছে নানা রকমভাবে, নানা কারণে। হিস্টোলজি অ্যান্ড হিস্টোকেমিস্ট্রি, এই সম্বন্ধে আমার একটা কথা বলার আছে। ছাত্ররা যারা অলরেডি হিস্টোলজি সেকশন ট্রেনিং করেছো তারা বলতে পারবে, তারা বুঝতে পারবে। যখন আমরা খুব ভালো একটা স্লাইডও দেখি, সেটা মনো লেয়ার হয় না, দেখবে মনো লেয়ার হয় না, অনেকগুলো ওভারল্যাপিং লেয়ার থাকে। কারণ যত পাতলাই করি না কেন সেটা একটা সেলের থেকে বেশি মোটা হচ্ছে। সেই জন্য এই স্লাইডগুলো যখন আমরা দেখে ওখান থেকে ক্যামেরা লুসিটাতে ড্রয়িং করেছিলাম, আমরা চেষ্টা করেছি ওটাকে মনো লেয়ার করে দিতে, যাতে কনসেপচুয়ালি স্টুডেন্টদের বুঝতে সুবিধা হয়। অর্থাৎ একটা 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 সেলের টিস্যু সেকশন খুব পাতলা করলেও, আলট্রাটোম দিয়েও কাটলেও মনো লেয়ার সেকশন হবে না। পান্নাদা আমার থেকে ভালো বোঝেন ব্যাপারটা, তাই তো? সম্ভব নয়। সেই জন্য আমরা চেষ্টা করেছিলাম, ওটা আমি বললাম এটা স্পেশাল ব্যাপার। অ্যাপ্লাইড জুওলজি, যখন আমরা এই বইটা লিখেছিলাম তখন এই অ্যাপ্লাইড জুওলজির পার্টটা কিন্তু কোনো প্র্যাকটিক্যাল বই থাকতো না, সেটা চেষ্টা করেছিলাম। এনভায়রনমেন্টাল স্টাডিজটাও কিন্তু অনেক নতুন এসছে, তখন আমাদের যখন ছাত্র ছিলাম তখন আমরা পাইনি এগুলোকে। তো এরকম স্ট্যাটিস্টিক্স ইন বায়োলজি, ডিসেকশন, সেখানেও সমালোচনা থাকতে পারে, কিন্তু আমরা বলছি যে উই পার্সোনালি ডিসেক্টেড দি অ্যানিমালস অ্যান্ড ড্রিউ দি ডায়াগ্রাম বাই আওয়ারসেলভস। কোনো আর্টিস্টের হেল্প নেওয়া হয়নি, যাতে করে স্টুডেন্টরা যখন লিখবে তারাও, আমি যেহেতু আর্টিস্ট না হয়ে আঁকছি, স্টুডেন্টরাও এখানে তো ফাইন আর্টের ক্লাস করতে আসেনি, তারা জিনিসটা শিখতে এসেছে, সে যেরকম পারবে সেরকম আঁকবে। রিয়েল লাইফ আঁকার জন্য চেষ্টা করা হয়েছে। অ্যান্ড এক্সটেন্ডেড ক্লাসরুম, অর্থাৎ এক্সকারশন, এক্সকারশনে গিয়ে কী করতে হবে, কি করা উচিত, কিভাবে প্রত্যেকের সঙ্গে সমস্যা শেয়ার করা উচিত, কিভাবে স্টাডি করা উচিত, এগুলো দেওয়ার চেষ্টা করা হয়েছে। নেক্সট স্লাইড। আরও কতগুলো ফিচার্স আছে যেটা আমার মনে হয় যে কোনো, যদি কেউ প্র্যাকটিক্যাল বই তোমাদের থেকে লেখো ভবিষ্যতে পরবর্তীকালে এইগুলো মনে রাখলে ভালো হবে। একটা হচ্ছে অল ফিগার্স আর ড্রন বাই দ্য অথার্স দেমসেলভস, কোনো আর্টিস্টের সাহায্য নিইনি। কারণ আর্টিস্ট কি করবেন, তিনি আর্টের দিকে মনোযোগ দেবেন, সাবজেক্টের দিকে মনোযোগ দেবেন না। আঁকা খারাপ হলেও আমরা নিজেরা আঁকার চেষ্টা করেছি যাতে ছাত্রদের সুবিধা হয় আঁকতে। দ্য ইন্টেন্স ট্রিটমেন্ট অফ থিওরিটিক্যাল ফান্ডামেন্টাল, আগেই বলেছি এটা। নন ইনভলভমেন্ট অফ আর্টিস্ট, এটাও বললাম। এবং সব থেকে বড় কথা, বইটার কস্টটা ডাউন করার জন্য, কস্টটাকে নামিয়ে আনার জন্য আমরা তিনজনই কোনো অর্থকরী ব্যাপারে কোনো রকম সাহায্য নিইনি, অর্থাৎ পাবলিশারদের কাছ থেকে আমরা কোনো পয়সা নিইনি। এইটা করে আমরা ছাত্রদের হাতে একটা বই 250 টাকায় তুলে দিতে পেরেছিলাম আজ থেকে 20 বছর আগে। তো থ্যাংক গড ছাত্রদের সেটা ভালো লেগেছে, সেটা আজকের দিনেও চলছে। তো এইটুকুই বই সম্বন্ধে আমার এইটুকুই বলার। আমাকে তন্ময় এভাবেই বলতে বলেছিল যে বইটা যে কেন লিখলেন, কি বৃত্তান্ত, কি বিশেষত্ব, আমি এটুকু বললাম। যদি আপনার ভালো লেগে থাকে বলবেন, না হলে পরিত্যাগ করবেন। হয়তো কিছু সময় নষ্ট করলাম আপনাদের। আমার এইখানেই বক্তব্য শেষ। আর ঠিক আছে।
This session is now open for any kind of queries and questions. Any questions?
So if there is no question, so thank you, sir. Yeah. Yes, sir.
আমি একটু আগে বলে দিই, পান্নাদা তোমাদের মাস্টারমশাই স্যার আমার কাছে পান্নাদা, এবং আমার মানে যারা যে কজন আমাকে ভালোবাসেন আর কি, শ্রদ্ধা করেন টরেন নয়, ভালোবাসেন ভাই হিসেবে, তার মধ্যে পান্নাদা অন্যতম। এইটুকু আমার বলার মানে দরকার বলে মনে করেছি আমি। পান্নাদা বলুন।
না ঠিক আছে, আমি এই বইটা সম্পর্কে বলতে চাই।
হ্যাঁ,
তোমার ছাত্র তন্ময় এখানে আছে, ওর সঙ্গে আমি একটা প্র্যাকটিক্যাল ক্লাস শেয়ার করি।
হ্যাঁ,
আমি প্রতিদিনই এই বইটা চাই, ওর কাছেই চাই।
আচ্ছা,
আমার পার্সোনাল কপিটা বাড়িতে থাকে, এখানে এটা আছে, ওর কাছে আছে। আমি ছেলেদেরকে সবসময় এই বইটা দেখতে বলি, তার কারণ হচ্ছে এখানে ওই যে তুমি একটা কথাই বারবার বলেছো যে থিওরিটিক্যাল অ্যাসপেক্টসটা ভালো করে ট্রিট করা হয়েছে। এবং আমিও ক্লাসে প্র্যাকটিক্যাল যদি 3 ঘন্টা রয়, 1 ঘন্টা থিওরি পড়া।
ঠিক ঠিক তো ঠিক করেন, ঠিক করেন।
আর তার জন্য থিওরি ছাড়াও উইদাউট থিওরিটিক্যাল বেস প্র্যাকটিক্যাল করার কোনো মানে হয় না, এবং তারা অন্ধের মতোই কাজ করে।
যদি থিওরিটিক্যাল না জানে।
আর একটা ব্যাপার, যে সমস্ত বই তোমরা যখন বইটা লিখেছিলে বাজারে প্রচলিত ছিল, এখনও চলে, সেখানে পরীক্ষার কথা মাথায় রেখে, ছাত্রদের সুবিধার কথা মাথায় রেখে লেখা হয়েছে।
ঠিক বলেছেন।
মনে করো হিস্টোলজিক্যাল স্লাইডের আইডেন্টিফিকেশন ক্ষেত্রে 7 or 8 ক্যারেক্টার্স, ভেরি পার্টিনেন্ট ক্যারেক্টার্সগুলোকে মেনশন করা হয়, কিন্তু তোমাদের বইতে কোনো কোনো স্লাইডের ক্ষেত্রে 12টা পর্যন্ত ক্যারেক্টার দেওয়া আছে। এবারই মাইনর ক্যারেক্টার্স থেকে আরম্ভ করে এবারই প্রাইম ক্যারেক্টার্স। এটাই দরকার, তারপর ছেলেরা বুঝতে পারবে কোনটাকে বাদ দেবে, কোনটা ঠিক ঠিক মতো রাখবে। আর এই কাজে আমি বইটাকে সবসময় আমি প্রেফারেন্স দিই।
থ্যাংক ইউ ভেরি মাচ।
এবং আমার ইগনোরেন্সের কথা জানাই, আমি তোমাদের লেটেস্ট রিপ্রিন্ট না এডিশন হয়েছে কিছু?
না, এডিশন হয়নি, তার কারণ অনেকগুলো আছে আর কি। আমরা একজন রিটায়ার করে গেছেন, একজন বিদেশে চলে গেছেন, দলটা ভেঙে গেছে, করা যাচ্ছে না, সমস্যা হচ্ছে। আমিও বললাম না এক্সটিংগুইশ জিওলজিস্ট, আমি অ্যাডমিনিস্ট্রেশনে চলে গিয়ে যে ক্ষতিটা হয়েছে জীবনে আমার।
এবং তোমাদের অবগতির জন্য জানাই যে সোমনাথ মুখোপাধ্যায় ইজ এ ব্রিলিয়েন্ট ক্যারিয়ার ডিউরিং হিজ স্টুডেন্টহুড, এবং রিসার্চ এক্সপিরিয়েন্সও খুব ভালো জানি। আমি ওর থেকেও অনেক সিনিয়র, কিন্তু তা সত্ত্বেও মানে ওকে দেখেছি আমি সায়েন্স কলেজে বহুদিন, আমি যেহেতু কাজকর্ম করেছি, তো কাজেই তখন থেকেই পরিচিতি। তবে এটা সেই প্ল্যাটফর্ম নয় বলার। বইটা কিন্তু ইউনিক প্র্যাকটিক্যাল বই হিসেবে, তোমরা দেখো বইটা।
Thank you, sir. Thank you.
কোন ফোল্ডারের মধ্যে আছে না আমি বলে দিচ্ছি অনেক ফোল্ডার হয়েছে
অনেকগুলো ফোল্ডার আছে
হ্যাঁ আমি করে নিচ্ছি Okay. Hello. Now I would like to request Dr. Paulumi Maiti to please arrive at the dais and now I would like to request Dr. Ravi Kumar De to come over the dais and felicitate Dr. Paulumi Maiti. Now I would like to request Dr. Ravi Kumar De to please give the introduction to the Dr. Paulumi Maiti Madam.
Thank you, Tanmay. Dr. Paulumi Maiti is an MSc PhD and she is an associate professor of Lady Brabourne College, Kolkata. She has more than 20 years of research experience and more than 15 years of teaching experience. Dr. Paulumi Maiti is the life member of Indian Science Association, Kolkata, and member of Executive Council of the Zoological Society. She has published numerous articles and research papers in journals of national and international repute and presented many research papers in seminars and conferences. I request Dr. Paulumi Maiti ma'am to come and deliver his valuable lecture. Ma'am, please come.
Respected dignitaries, a very good afternoon to all of you. I really take privilege in speaking before you in this institution of repute. Thank you, Dr. De, for inviting me. And today I'd like to speak on a book which we had written in 2011. Of course, we have 3 editions of it. Biodiversity, Perception, Peril and Preservation. Okay, to start with, let me say that actually we live in a system of house. So this system is basically a house where all the members of the house are working as an unity, And if one declines, the others will be affected. So the function, everybody has a function in running the house, and we all work in a concerted manner. The most important thing is that the diverse organisms that are present in the ecosystem, be it plants, animals or microbes, they work in a concerted manner together to form this ecosystem, which is also called ecosystem service, and finally it transforms into ecosystem functions. Now, what are the ecosystem functions? Let me explain. Like the soil formation, the nutrient release, then the microbes, they release nutrients in the soil. That nutrients are taken up, micronutrients are taken up by the plants. The plants are taken, eaten by animals. The animals are in turn eaten by other animals, and the energy flows, so on and so forth. Ultimately, this forms a closed cycle. Now, this is something which is very important because it frames the very habitat of man. And human being, the existence of human being will be at stake if this cycle breaks at any point. And so, this is the most importance of biodiversity, that is the entire plethora of fauna, flora and microbes that work in unity in the entire ecosystem. So you can see here that every work that individual plants, animals or microbe does is for the betterment of human being, and it frames the habitat of human being, which is most important. If one breaks, the human being are the elements who are going to be in trouble. So keeping in this mind, we have tried to conceptualize this idea of biodiversity, which started in the 80s. But in Indian context, there were not too many of conceptual books. And then biodiversity or ecology, you all know that being a bit neglected in the syllabus, but now it's gaining ground, and the syllabus has tried framing biodiversity conservation because the world is threatened with the currently, of course, and that is too by the anthropogenic effect. The world today is threatened by unprecedented loss of biodiversity. So, keeping this in mind, we have tried to frame this concept, and of course I have been invited here, thank you for that, and I felt that the concept of my deliberation today is a bit unique in this sense. So, taking, in the name of Thakur Ma and Shamiji, I start to speak a little about my book, which has already 3 editions. So conservation is a priority, as I have said, because all the organisms, they work in unison, and this is what biodiversity is. And secondly, there was not too many of the conceptual books for the students, especially from the undergraduate and postgraduate, and as you all know that molecular biology or immunology, these are the topics, or these are the subjects which have gained more grounds and have been received more attention. So biodiversity ecology is being neglected. Now we have a very good syllabus of ecology, but when we were in college, university, the ecology syllabus was not that good. So we tried to put together all the aspects of biology, finally leading into the conservation part. So, what is the most important thing about biodiversity? That it provides bioresource, and this resource for the existence of human being. And keeping this in mind, in 2011, we started this book, or rather, and then it was published by the Prentice Hall of India. It was written by me and my father, late Dr. Prabodh Kumar Maiti. And at that point of time, we could see that at that point, the syllabus we had biodiversity and conservation. So I think in a way that the book has a little bit helped the students and the teachers as well, because this is all for the undergraduate, postgraduate, and even for the students of pursuing for different examinations and competitive examinations as well. This book, of course, we have tried to write it in a very lucid form so that to make a better understanding for the students. And then, of course, we started having some diagrammatic pictures, some true photographs, and all this. And then at the end, we had those question answers, multiple questions, and of course, the glossary. So there has been 3 editions for this book, thanks to the student and the teacher community. This is in 2011, 2017, and 2023. Now this year we have the 3rd book on our hand. And this was rather a dream project of my father, late Dr. Prabodh Kumar Maiti, who actually dreamt of writing this book for quite some time. And then ultimately we could have done that, but at that time he was quite sick and ailing. So I tried to put the things together. So I'll start from what we have done, because from the concepts of biodiversity, as you all know, the perception, the concept of biodiversity to the importance, and finally we move on to the conservation part, which is actually the target for what the human being, we are targeted, because there should be a method of, stopping of this species extinction. Why? Because as I have said, that we work as a concerted manner, and at any point, if one species is extinct, then of course the entire food chain and the energy flow will stop, and there will be a problem. So we should all aim to for conservation, and in the student community as well, we should aim to spread this message of conservation across, so that from our own little way we could help in the conservation of various elements of nature. So the first chapter, it includes the concept of biodiversity, and this biodiversity basically with it three things are tagged to it, the term biodiversity. One is the species diversity, as we all know, the variety of the species and the variability. Then the genetic diversity. Genetic diversity means every species has their own unique characteristic which is framed by the genes. And then the habitat diversity. Now this habitat diversity is something which is very important, because habitat determines the richness or the poverty of species. In a habitat, suppose in the tropical rainforest we have, very rich species, and in the desert or in the open sea, the species abundance is quite low. So life started 3.5 billion years ago, and the Greek philosophers are the proponents of biological science, although biodiversity, this term is very new. It's a recent origin in 1980s. The term biodiversity came, and of course the subject zoology or biological science, as you may see it, started gaining grounds and popularity after Darwin. But the problem started that when when man started agriculture, he started clearing down forest for this practice of growing crops. So this was the first time when biodiversity loss was, the loss of biodiversity started, because the natural systems were there which is full of species. But when man started manipulating nature, and as you all know, we are the most intelligent and manipulative species, when we started agriculture, clearing of forest, and of course started fishing and all, so at that time there started the decline of species. And the final breakthrough came out after the industrial revolution, when when the human dominated earth started growing. As a result, the other species declined. And as soon as these other species declined, then only the philosophers, the thinkers, the scientists, they started thinking of conservation. So when one started thinking of conservation, then only the concept of biodiversity sprung up, and the concept of diversity spread. You know, this awareness started spreading through seminars and all, and it was Rosen who actually framed this term diversity. Then afterwards it came up to biodiversity, and towards the beginning it was Dr. E.O. Wilson who actually popularized this concept, and he worked and he has beautiful books on biodiversity, and he was the first one who had explained biodiversity to the scientific world. So biodiversity started gaining grounds, and biodiversity, you know, started getting into the syllabus, so that there has to be the student and the awareness has to be there. So the first chapter deals with all these regarding the history of biodiversity. We come to the second chapter. The second chapter is systematics. As you all know, taxonomy, systematics, classification. The students of zoology, you must be all knowing about all this. So if you don't understand taxonomy, you won't be able to classify species. You won't be understand the essence of biodiversity. See, to understand the essence of biodiversity, we must always put forward taxonomy and systematics, so that this is the first step of learning biodiversity. And now we come to the third chapter. This is assessment of biodiversity. Now, what is assessment of biodiversity? As I have already mentioned, that all of us work in this house, in this ecosystem, in a concerted manner. But some animals are more important, like a butterfly, the keystone species, like the hornbill among the birds. The top predators, they are the keystone species. Then there are ecosystem engineers, there are unique species. So some animals or plants are more important, some are less, and we got to understand this. If we don't understand the relative importance and the relative, because also at the same time we have to see the relative abundance and the relative, you know, how many species are there, or how many species are, if in a taxon, maybe the number of species might be low. So we have to see the assess. At the same time, assessing includes monitoring. So the third chapter deals with the monitoring of biodiversity, and this is where we have you know, put forward certain different ecosystem, like the tropical rainforest, where we have a very rich biodiversity. Then there we have the wetlands, where we have rich faunal diversity, not the floral diversity. And of course, on the other side of the pole, we have the desert, the polar ecosystem, where the diversity level is quite low. So we have tried to analyze the various habitats, so that we can come across, you know, individually in a very intricate way, that which places are more important in a biodiversity wise. Now the fourth chapter, this is quite interesting, because there is a gradient of biodiversity. It explains the gradient. Like if you climb a mountain, you always find high diversity towards the base. Then as you move up, the diversity decreases. So why? There has been the environmental factors, there has been the soil factors, there has been the wind and temperature, so everything has to be there. So the community changes. This is very important. The community is very important in the biodiversity term. So as you move across a gradient, like from the saline water to the fresh water, from the fresh water to saline water, from the lower stretches of a mountain to the higher altitude, from mid-latitude to the higher latitude, that is from the equator to the pole, you always see that there are differential distribution of biodiversity. So biodiversity is not always, what should I say, equally distributed throughout the surface of the earth. It is always, there has been a skewed distribution throughout, and we had tried to analyze that. In the 4th chapter, you can see here, even if you consider aquatic system, a lake or a pond or whatever, you have this, the diversity varies. Even in the, so we tried to put forward diagrammatically towards the student to understand this distribution of diversity. Next, we have, of course, some points regarding the hotspot and the mega diversity countries, because these are the places where the concentration of biodiversity is maximum. So if you want to conserve, and these are important for conservation, if you want to conserve biodiversity, this is very important to understand the hotspots and the mega diverse country. And India is, of course, a mega diverse country. It's an equatorial belt, and we have 4 very important hotspots, global hotspots. So the final thing in the 4th chapter is the endemism, and endemism is one of the indicator of diversity. Endemic species are very important part of diverse organisms, and a diversity of a particular area is always measured in terms of endemic species. Now we come to the 5th chapter, where we have elaborately laid down the different aspects of biodiversity, as we have given only short introduction of it in the chapter 1, and this is the species diversity, genetic diversity and ecosystem diversity. Now the genetic diversity or the species diversity, there are other fundamental points in it, like how we measure them, like we can go for an alpha diversity, beta diversity or gamma diversity studies in order to measure diversity. Now, as we know that only theoretical study will not help. We have to go out, and as students of zoology, I think you have already started, doing alpha diversity in your own way, because it is included in the syllabus. And if you go into research, you will be doing gamma and beta diversity as well. So here in chapter 5, we had tried to put forward the various practical aspects, how to measure diversity, the biodiversity index, and what is genetic diversity, what is basically ecosystem diversity, which actually has 2 components, the structural component and the functional component. And these days we have this functional diversity, it's being very much popularized because we are on the verge of loss of functional diversity in the ecosystem because of the various species loss. The function, like the pollinators, the food dispersers, the predators, in one sectors, because of pesticides, these insects, butterflies and bees, they are on a decline. So we are losing some function. Now if one species of bat, butterfly or bee dies, then 5 species of plants will not be able to produce. If a predator dies, the entire forest health will be at stake. So we have explained all these things in our own lucid way, of course. That would, of course, students say, but we have quite a good feedback. Now we come to the value of biodiversity. Now human being as a part of nature, as we all know that we are also a part of the animal world, we fail to appreciate other organisms. This is very unfortunate, because appreciating the work of other organisms is only by the scientists and the researchers or the students of zoologist or environmental science. This is because the general mass fail to appreciate. What we appreciate is what we get goods in terms of our economic benefit. So this value of biodiversity is very important, and it has an implication on the awareness, public awareness of biodiversity studies. And as you all know, you must be knowing, of course, that biodiversity has, the value of biodiversity have 2 components, one the direct use and the other one is an indirect use value. Now the direct use is the food, the medicine, you can go around, all things, food, medicine, clothes, even other things what we use on a daily basis are from the elements of diverse organisms, be it plants or animals. The medicines, of course, are very important, food also, the clothes. So this is the direct thing. Then we have the ecotourism. This is also a direct benefit from which we get the economic output. But there are other indirect benefits as well. And these are, now you can see this current status because so many organisms are used as food, and you know, biodiversity is a very strong point of food security. If biodiversity loses, then we actually lose the options for food. You can, if you see the different varieties of rice, paddy, the varieties of different fruits, the varieties of vegetables, if one variety, you know, go extinct because now we are on a move to produce more, so there has been some genetic erosion, you know, loss of varieties. So we are losing options. So this is what the human being are going to face, all the threats. So food security is one very important implication for biodiversity conservation. And what we see that besides this direct benefit of biodiversity in which human being actually earn money, economic benefit, we can see there are other benefits also, the indirect ones, the aesthetic value. You know, the value of the beauty of nature. Then see there are options value. Then there are bequest value. You know that there is beauty in the nature. So this ethical value that every organism should live. We are not there to harm the organisms. So all the values itself is very important, and of course this is to spread this awareness, spread across this message to the non-zoological or students or general mass. So looking into nature not from the anthropocentric view, but looking towards nature in an ecocentric view. And that is the first step of conservation. First step to protect the entire environment. So finally, the most important thing is the ecosystem service with which I started. That ecosystem service is the function of individual organism. What the function each individual organism functions, be it a plant, animal or a microbe, that is translated into ecosystem service. This is soil formation, then pollination, seed dispersal, and the energy flow that happens, the biogeochemical cycle. So all these things. Now suppose if there is a sea storm, the mangroves are there to stop the sea storm. So the human being living into the interior of the continents are protected. You can see the wetlands. When the flood water flows through the wetland, the plants and all these things, they stop the flow of water. As a result, the water that flows out into the other watershed region, they are necessarily much purified, and because the wetland act as a kidney. So this is a function. So all the organisms, they act as they function to provide service, and this service to the mankind. Now we have tried to put this into various forms and elaborate on this concept. The next chapter is very interesting because this is biodiversity in peril. So how biodiversity is being threatened. We all know that we are all being now we are being quite upset with the loss of diversity around us, but we have tried to put all these things together, like the natural disaster that is caused is slow, but the anthropogenic disaster, which is actually threatening thousands and thousands of natural species, is something that has to be stopped. So this is quite a big chapter in my book, in our book rather, and we have tried to jot down all the points. In brief, let me say that the most important factor for biodiversity loss is habitat destruction. So which again have two components, one habitat fragmentation, So human being is always there to fragment any habit into pieces and destroy the habitat of man, and when the animals are in danger, they blame the animals. So this is what happening, and the habitat degradation, that is lowering the quality of life or the environment. So that is how animals and plants are being affected. So one thing is habitat fragmentation and another thing is habitat degradation. They are actually degrading the quality and quantity of the habit that the other species occupy. The other things are, of course, climate change. Then the overexploitation, very important. If there is a economically important species, they are going to be overexploited. The population rise is above all, because the more the population, the more you have the problem. So now finally we have this climate change. But climate change, you know, it works in concerted way with the other drivers. So all these drivers together, pollution, overexploitation, population rise, overfishing, almost 60% of marine resources have been depleted. So you can see this urbanization, industrialization, rise of technology. You go out fishing and you catch 1 or 2 fish or 1 kg, 2 kg fish. But now we are not content with it. We go out for fishing in trawlers. So when you go out for fishing in trawlers with high technology, you actually is destroying thousands and thousands of food species besides the non-food species. So what you do when the trawlers enter, the fish which are not being economically important or not marketable, those are thrown out. So those add to, you know, those pollute the environment, pollute the waters, leading to the problems and asphyxia and whatnot in the aquatic organisms. So 60% of marine resources has been already depleted. 30% of tropical rainforest has been depleted. So there are two factors. One, of course, the overpopulation, and the other one is the greed of the rich sector and the need of the poorer sector. So this is what is basically destroying the biodiversity around. And we are actually, the ultimate problem is this, that human being is on, the existence of human being is on the stake. We are going to be in trouble. So understanding, see, 75% of the food crops have been extinct. So the biodiversity loss is affecting human health as well. Now you can see that there is a, you know, quite a rise of dengue, malaria these days, the vector-borne disease. This is because climate change. Then we have destroyed all the larvivorous fish, the tadpoles. So all these things are computing together to increase, you know, to put human being in a problem, the health problem. So this is, now we are at the crossroad and we should understand and be aware of the biodiversity loss around us. So this is what we have to do. We have to go a little bit traditional way. So let me speak about, and then of course hunting. Hunting has been stopped legally these days after 1972 Wildlife Protection Act. But hunting was something that actually almost wiped out thousands and thousands of wildlife, you know, because of no use, because it's a sport, it's a fun for human being. So you can see here in this picture that what was world in the previous years. Now one example I can give you, that the number of tigers in the, towards the end of 18th century was 40,000, and now we have almost 3,000, but that is also in paper. We are not sure whether really 3,000 tigers exist in India or not. So we are heading towards the 6th mass extinction. All as a students of zoology, you must be knowing that we have already faced 5 extinctions, and the 5th is a rapid one, and which is the 6th rather, is the rapid one, because it's framed by human being. It's an anthropogenic extinction. Now I have just this chapter 8 is about global warming, although this is a huge area, and we have just put into some salient features of global warming, because it's very difficult to fit global warming into a very small chapter. So this chapter has not been elaborated. It has only some certain points, which is not not a full comprehension type. So climate change, you know, they are affecting every ecosystem, every species, indirectly or directly. So this is something also, one point where the species loss is the one of the major factor of species loss. Now looking into this devastating loss of species, now after 1972, Indian government, of course, backed by IUCN, WWF, and other international agencies, they have started, you know, framing laws, and these laws have aimed to protect the environment and species. So we have tried to put the laws together into this chapter. Of course, the Indian ones, not the other ones, only those of the Indian origin, and these environmental laws are the ones which have been implemented. We don't know, of course, how much they are working out well, but anyway, those are implemented. Now, the Biodiversity Conservation Law is the Biodiversity Act. You know, there was in 1972, the Stockholm Convention, it was held, and then it was a bit failure. Not much was done in Stockholm. So after that, in 1992, of course, we have this United Nations Rio Convention, and in that Rio Convention, it was a bit fruitful. The Biodiversity Conservation Act was framed. So in India, we have this Biodiversity Act 2002, and then you have the Biodiversity Rules 2004, and there we have, you know, comprehensive ideas how to protect biodiversity, how to protect the patent and of a country and all, and they had framed 3-tier system. The one tier is the National Biodiversity Authority, which is at the national level. Then we have the State Biodiversity Board, which works in the state level, and we have in West Bengal also one state biodiversity board. And then at the local level, that is at the village level, we have the Panchayat one, and it is the Biodiversity Management Committee. This Biodiversity Management Committee acts in local level, you know, and these are the people who actually work, and they actually spread the message of awareness. So this is a very important thing, because this Biodiversity Management Act So this Biodiversity Management Act, they have, you know, this, they go out and they document the local diversity. So this is a very important step. Local people, they aim to actually document the local fauna, their importance and their conservation. So you students, you can also do it yourself. So by the guidance of State Biodiversity Board. Now the chapter 10 is on the indigenous knowledge and sustainable development. So this is one very important thing which we don't understand, that biodiversity conservation cannot be done only legally by the government or the forest department and so on and so forth. We have to do it ourselves, and there has been the aboriginals, the tribal, the local people around the world who have through years understood the mystery of nature. They gathered knowledge about nature, and they are the ones who have conserved nature in their own local area and own little way they have. So this is one of the very interesting thing where we have this idea of sacred groups, the indigenous knowledge. The indigenous knowledge, you know, because of this urbanization and then westernization, these people, these aboriginals or the first people as we call them, they are becoming declining. They have become modern and they have shifted to the societies with the education and all. Now the by law our government is trying to conserve these sort of people, gather knowledge from them and putting them down, documenting down this knowledge, and this is one very important way we can document biodiversity, save biodiversity from extinction. And so these people have, they have sacred groups, they have sacred landscape and everything. So all these things are very important to conserve the biodiversity at the local level. So these are the points. So here you can see how the maintenance and sustainable development of local resource, biological resource can be done through conservation of these sacred groups. Those are maintained by the local, tribal or the indigenous people. This is what afterwards we have tried, not we, the government of course, who have tried to done is the People's Biodiversity Register. This is to register the local knowledge, as I have just said. So even the students of school, colleges, they can also go for People's Biodiversity Register. The final, the chapter 11, we have 12 chapters. This chapter 11 is the biodiversity and biotechnology. I'm not going into detail because I've been asked to make my speech shorter. And this is biotechnology is on the rise, as you all know. So we are using biotechnology for conservation, for food production, and many other things, even the warfare, even this biological warfare, spreading virus and bacteria and all these things around. So this is what biotechnology and biodiversity has a relation in increasing food crop production and everything. The final one is the conservation chapter, the conservation practice. Conservation can be of two types, in situ, ex situ, and in situ conservation is of protection, of setting up of protected area as it is being proposed in the 1972 by Wildlife Protection Act. So in India we have done it quite happily, and in our book we had tried to put in this idea of conservation of protected area, the formation of corridors, then the community reserves, the conservation reserves and all, which are very important, with the participation of course with the local people, because conservation cannot be done without the help of the local people around, and this conservation has to be done in conjunction with the government, the forest department and the local people. And so we have this idea of joint forest movement springing up, and it was by West Bengal, IFS officer from West Bengal. So he has started this, and this has been implemented not in India but also in other Asian countries as well. And this is a wonderful place, wonderful concept where the local people, they save the bioresource, save their forest, save their local biological diversity. So this is something very nice and good. Of course, if we continue to conserve, then the world will be a happier place, and the human being will be saved from this, because we are going to be in trouble, along with the other animals and plants also. So in our book we have tried to put a summary, the MCQ questions, and of course the bibliography is there, and this is also this will help the students to make a comprehensive understanding of the topic. So the ultimate objective of this book is to conserve, to save the earth from the declining biodiversity, and develop a love for nature and its element. Even if we don't love them, we should not harm them. And studying, taking up biodiversity and other such environmental studies in the curriculum would really help the students to spread across the awareness, and even now those are being included in the various syllabus as well. So we have three things. In each edition we have we have aimed for updating the general information around, because science is something, it's not static, it's always on the move. So we have tried to keep pace with the the modern research on biodiversity and whatever. So we have to put them into a book. Let's see. Thank you. And these are some of the other books from the other authors from this subcontinent. Thank you for your patient hearing.
Any questions from audience? Any question from faculties?
তোমাদের কোনো কোয়েশ্চেন নেই? তাহলে আমার কোয়েশ্চেন থাকবে তোমাদের জন্য আর কি। আচ্ছা, আমি এই বইটা নিজে পড়েছি, আমাদের লাইব্রেরিতেও 5 কপি বই আছে। সো নো কোয়েশ্চেন ফ্রম মি, কিন্তু আমার রিকোয়েস্ট ফর ইউ যে তোমরা লাইব্রেরিতে যখন যাবে, যখন তোমাদের সিলেবাসে 6 এ আছে তো আছে, এছাড়াও তোমরা এই বইটা লাইব্রেরিতে দেখবে। আর আমি অথরকে একটা রিকোয়েস্ট করব, সেটা হচ্ছে নেক্সট এডিশনে ইনভেসিভ স্পিসিস নিয়ে
the third edition has much about the invasive
হ্যাঁ, ওটা
species.
নিয়ে দুটো চ্যাপ্টার লেখার জন্য। তার কারণ কনসেপচুয়াল হ্যাবিটেট ডিস্ট্রাকশন সম্ভবত 10 ইয়ার্সের মধ্যে হ্যাবিটেট ডিস্ট্রাকশনকে টোপকে ইনভেসিভ স্পিসিস 1 নম্বরে আসবে। মানে আমাদের একটা জেনারেল ফর্মুলা আছে, দ্যাট ফর্মুলা ইজ কল্ড অ্যাজ হিপ্পো, HIPPO। তোমরা অনেকে জানো, অনেকে জানো না। হিপ্পো মিনস, অ্যাকচুয়ালি এই ফর্মুলাটা প্যালিওলিথিক ওয়ার্ল্ডে, মানে যখন আর কি শিকার করতো মানুষ, তখন এইটা উল্টো দিক থেকে ছিল, মানে ওটা আগে ছিল, ঠিক আছে, আর এইচটা সবার শেষে ছিল, মানে হ্যাবিটেট ডিস্ট্রাকশন ওয়াজ দি লাস্ট অন দ্যাট টাইম, বাট নাও দি হ্যাবিটেট ডিস্ট্রাকশন ইজ ইন দি ফার্স্ট পজিশন, বাট আফটার ফিউ ডেজ the habitat destruction, I think, is actually removed out by the species invasion, invasive species. সুতরাং আমার অথরের কাছে
No, this is a very important thing, because of the global climate change, range shifting is being there.
Naturally.
So obviously the invasive species are on the move, and this because this book, we have framed not only for the undergraduate but also for the postgraduate students, and we have invasive species in the postgraduate curriculum. So I have a chapter on invasive species in the 3rd edition. I guess you didn't see it. Of course, it is just released a few months back.
And another important thing, except the climate change, behind the increment of the invasive species richness in this world is the anthropogenic. কারণ ওই যে আমরা বাটারফ্লাইয়ের ক্ষেত্রে ল্যান্টেনা ক্যামেরাকে বাটারফ্লাই গার্ডেনে ব্যবহার করা, বা ফিশের ক্ষেত্রে ক্রোকোডাইল ফিশকে ব্যবহার করা।
Antenna camera itself is an exotic species.
হ্যাঁ, এই দুটো জিনিস আমরা এখানে কলকাতা শহরে বা ওয়েস্ট বেঙ্গলে হিউজ অ্যামাউন্টে, পুরো ইন্ডিয়া জুড়ে, তুমি যদি কর্বেট ন্যাশনাল পার্কে যাও, দেখবে কর্বেট ন্যাশনাল পার্কের একটা বিরাট অংশ জুড়ে ল্যান্টেনা ক্যামেরা বসে আছে। তো এই ধরনের সমস্যাগুলো হচ্ছে, এবং খুব তাড়াতাড়ি ওইটা আইটা প্রথমে চলে আসবে, মানে আই দিয়ে আমাকে শুরু করতে হবে আর কি ওই পুরো জিনিসটা। তো এইটা অথরকে অনেক ধন্যবাদ এরকম একটা বই আমাদেরকে উপহার করে দেওয়ার জন্য। থ্যাংক ইউ।
Now this is a session for library science. We have among us an eminent speaker and Professor A.R.D. Prasad from DRTC. I invite sir, please come on the dais. I request our librarian sir, Dr. Ravi Kumar De, to come on dais and felicitate sir. Please. I request Dr. De to introduce Professor Prasad among us. Please.
Sir requested me to introduce him in very brief. Actually, Professor A.R.D. Prasad is a former professor and head, Indian Statistical Institute, Bengaluru. He is a PhD in Library and Information Science. He has 37 years of experience in teaching and research. He has many contributions in digital libraries, and he has some other distinctions, like he is a member, high-level committee of National Mission for Libraries, Government of India, member, working group of libraries, National Knowledge Commission, and member, project evaluation committee on e-infrastructure, European Commission, Brussels, consultant, UN, FAO, Rome, and he has completed many projects. Among them, two is very famous. One is Living Knowledge, funded by European Commission, and another is Agro Infra, funded by European Commission. Okay. Now I request sir to deliver his specious lecture. Sir, please come.
Yeah, thank you, Dr. Dev. Good afternoon, everybody. I'll be talking about the artificial intelligence. First, I thought it would cover mostly about the library science, but later I came to know that the group is quite heterogeneous and the topics of various speakers is really wide and far-fetching. So I changed my PPT and emphasizing more on AI and less on the library and information science. In fact, I am sure I would be a pale presentation following the earlier presentation on biodiversity and other things. I have a couple of this. I am a misanthropist. Okay, I always feel man is a freak in the nature and was born only to destroy this earth. Okay, and I liked one quotation: "If all the bacteria are killed, life on earth disappears in 50 years. If all the people are killed, it thrives forever." Though it sounds very pessimistic, but I think there is a lot of reality and truth in it. Okay. Anyhow, I come to my topic about artificial intelligence. And you know, one of the philosophers, he was telling that an eye cannot see itself, and a foot cannot step on itself. Mind can never understand itself. So any funding towards artificial intelligence is going to be futile. Okay. Anyhow, in spite of all this, we know that again, to keep my own tradition of misanthropist, much of the research is funded for two reasons. Okay, that is to kill our neighbors. That is any defense research which attracts a lot of funding, and another is funded by business and industry. That is for profit making. So much of the research funding is either meant to kill people or to loot people. You know, you take any major research in physics like that, your satellites, your internet, your computers, your AI, all these men are out of defense projects. Your internet, originally defense network, then ARPA network, then internet it became. But internet also, when business people found it, they can make profit, I think it received a lot of funding. Nobody expected internet would become so pervasive, and we cannot imagine life without internet. Okay, anyhow, this is my agenda, a brief introduction on AI. I thought so, but now it is expanded, and a little of library services and library science research. Okay, so you know that one of the dreams of mankind is whether we can create robots, actually, which is the basic meaning is slave in Polish also. Okay, but again, we know the slavery is at least formally abolished, but its traces can still be found in the human society. But anyhow, our dream is if I can have a slave and the slave does everything, I can just rest and keep on eating and chatting. Okay, that is the dream. But again, it's a complex system, building a robot, because for my master's degree project, I did on a trend report on robotics. And you know, it has many technologies have to be together in this. For example, vision, computer vision, and identifying the objects, differentiating between a circle and a sphere. That means you should have three-dimensional this one. Because for children, it is so easy, this is a plant and this is a tree. So we have we don't have, but again, how to make the computer, this is the shape of a tree. We know that tree shapes are quite varied, but how to make the computers understand this is through vision system, this is a tree, but this is a plant. Very complex. And locomotion, we know that once man started being bipedal, and it gave us a lot of freedom. And we know that we can make cars faster than human beings, but how to make the computer climb. And it appears, it turned out, a single-legged robot is much easier to make than double-legged or even four-legged, because a lot of synchronization is required. Okay, which in nature, I think many animals, they do without any effort. So we know that language, which is, I think, probably animals, of course, madam should tell, they also have some communication, perhaps with limited vocabulary, but human species developed complex language system through which they can express themselves. And that is, I think, one of the challenges of artificial intelligence, how to make computers understand human languages and generative language systems. That means it should be able to speak back. You know, actually in the natural language, one of the first experiments is they made Eliza. Eliza probably, does it ring any bells? I think in Bernard Shaw's Pygmalion, no? The heroine's name is Eliza, and the hero challenges, I will make her speak Queen's language, though she is a street vendor. Okay, that is an interesting story. Later, I think, with Audrey Hepburn, they made a Hollywood movie, My Fair Lady. Okay. Anyhow, Eliza is actually simple natural language answering system. Hello, Eliza, how are you? It says, I am fine. What do you mean by fine? Okay, my health is good and today environment is good. From the questions, it tries to give the answers. Just as when you attend an interview, no, mostly the selectors will pick up the next question from your answers. If you know this trick, now you can put the next question in the selector's mouth. Okay, that is one of the tricks I use to play. Anyhow, so we know that machines can move faster than men, like cars or anything, and more weight, like cranes, and can fly like that, and can swim, better physical prowess. And last bastion is thinking. Still, we feel the machines are stupid. Okay, how to make machines think? I think of late earlier we used to feel if we can make a chess playing computer
that means intelligent computer. Actually, that is not the case. There, I think IBM developed something called a blue, I have forgotten the name. Okay. But again, Kasparov managed to win and told, okay, this is what I owe to the mankind. Okay. Now I think many chess players practice playing with the computer. Okay, because one of the key factors, good old days, the chess machines were using combinations and permutations to imagine if human beings can 4 or 5 steps, they can imagine what the opponents can make. But now I think with combinations, computers can make even 30, 40 combinations. But again, now more than that, what is more important is learning systems. Machine learning has become very important. If it can learn the opponent's moves and accordingly play, it can defeat easily. Okay. That is what I think cricketers know. No? They keep on watching how the bowler bowls and all that and try to play a better, make better scores against a particular. So that is a learning system. Just my mouth is dry. I'm sorry, I'm diabetic, so I keep on drinking water. So I think again, as I told you, my second project was on robotics. And probably some of you might have written Isaac Asimov's science fiction on robots. He did a lot. Of course, he made 3 laws of robotics. That is, a robot should not harm human beings, and it should not, he should obey orders, and it should not kill itself unless it is harmful to the mankind. Okay. Then history. I think John McCarthy, one of the Stanford professors, is the first one to coin the word artificial intelligence. Then ELIZA, which I just now described. Then they have humanoid robot by Japanese. And in '74, they realized much of AI research is not very, very impressive. So they stopped funding much of the research in artificial intelligence. Then came the Japanese launched 5th generation computers, which created waves. Then they thought, no, better, we should not lag behind the Japanese. Then a lot of research funding received. But again, actually I started working in this area sometime in '90s. And just then I think AI was in a boom. Everybody thought, but in '90s, much of the software would be AI based, but nothing happened. Okay, slowly people started losing interest in AI, and they started receiving less funding from the governments or the private industry. Then all of a sudden, recently, this chatbot make a big news, okay, which is the language learning systems, large-scale language systems, okay, models, and it tries to cull out a lot of information from internet. It doesn't mean what are all the information it generates is completely correct, because it culls out the information from internet. But internet information you have to accept, you have to take with a pinch of salt. But again, that is not is that the case with textbooks? I can find, I think, those who are senior professors, they can point out there are a lot of mistakes in the textbooks also. Okay, so machine translation. Many says, no, the machine translation is not good. I know my vice chancellor told, no, Google Translate is not good. And he wanted another software. But I used to argue with him, is it not the case with human beings? If you give a piece of information and ask some 10 translators to translate, you won't get the same translation. Some are in good quality, some are in bad quality. So, okay, much of the system we have to accept, nothing is perfect in this world, and nobody is perfect in this world. So, some may do better interpretation, some may do better translation than the others. So, even if it is, as long as whatever machine translation is acceptable, fine, it is cheaper than human translators. Okay. So the old books I read, which I like, actually, 5th generation computers, which is basically arguing, oh, Japanese are going to dominate the world with the 5th generation computers because they dominated electronics field, cars, everything. Now, if American government doesn't fund the AI research, we are going to be doomed, and AI, Japanese will dominate this world. And there is another highly semi-fictional Into the Heart of the Mind, okay, that is UC Berkeley experiments in artificial intelligence. Then Sir Roger Penrose wrote a bitter critique against artificial intelligence called Emperor's New Mind. Of course, we all know the story, no? Emperor's new clothes. Actually, there are no clothes for the emperor. Only he believes that he is having the fanciest clothes. But actually, he walks without clothes. So is the case with artificial intelligence. Probably there is no intelligence in it, but these guys are trying to be. But basic argument for him is the models on which it is developed, it cannot be, because unless we know the laws of physics of mind, after all he is a physicist, mathematical physics guy. That is his argument. Many people accepted, many people opposed him. Then there is a beautiful fiction by Isaac Asimov, Bicentennial Man. I think you can watch the movie also with the same name by Robin Williams, who played Mrs. Doubtfire. Okay, programming languages, Lisp, okay, and Prolog. I did for my thesis in 90 heavy programming in logic. Remember, no programming language you know uses logic. Okay, people used to tell me, because I had philosophy background, MA and MPhil in philosophy. And when I joined DRTC in Indian Staff, if you don't know mathematics, you cannot be a programmer, which is a nonsensical statement. Okay. Then somebody told me, if you know logic, you can do. I thought, okay, in philosophy I had some logic. No programming language uses logic. It is another flawed statement. Okay, I think what we require is analytical thinking. That is this one. You know, technology is ubiquitous. It is everywhere. And in health sector, nowadays, my observation is, if you go to any corporate hospital, much I think less is the role of medical guys. Much of it is engineering. Your diagnostic equipment, MRIs, then you can say CT scans, then X-rays, everything. I think good old days only except microscope and X-ray, nothing was engineering. But now engineering, your operation theaters, everything is equipped with engineering guys. Okay, and pharmaceutical industry is one of the worst industries because it is heavily bribed. Because pharmacy, nutrition, all these researchers are market-driven researchers, and they are heavily bribed. So much of its research is not trustworthy. Okay. Nutrition also, they say, if you take coconut oil, lot of cholesterol, your heart will blow out one day. But we know that our Kerala people, they not only drink, eat everything and sleep also in coconut oil. They look younger than the rest of Indians, and their longevity is much better than. But of late again they started saying, oh, coconut oil is good. And if they want to push sunflower oil market, they try to say sunflower oil is good or soya bean oil is good, and traditional oils are bad. Don't believe all those, okay? At least to me I feel. There is a book called Bad Science, how much science is influenced by this profit-making industry. Okay, even economists are also heavily bribed. If any economists, I know that NISO, sample survey guys, when they published a lot of unemployment was created because of demonetization, practically they were kicked out of their office. The next set of guys, oh, there is no employment, and still I think we require so many people to be employed. So you can make out how these are influenced by political and social factors. So don't believe research. Okay, we are all researchers and scientists. It doesn't mean I have always a theory called 30% theory, what I call myself. 30% of the scientists are dull fellows, 30% are corrupt, 30% are honest and intelligent. That means 2/3 of the research is not trustworthy. Okay, don't believe that. I mean, that is some of my, yeah, I know that. I think my brother worked in Fermi Labs. one of the prestigious labs until CERN labs were created. He once, as a postdoc, he used to go and he used to feel, oh, I am walking in the corridors of Fermi. Later, he joined and worked for 15 years, full of morons here like that. So you will find them everywhere, okay? Okay. Then the genesis, as I told, okay, much of it is the purpose is military purpose. I use it to, of course, I give hard statements. Every country's dream is to kill its neighbors. Okay, we want to kill all Pakistani fellows. Pakistanis want to kill us. Okay, only exception is US. You don't. He doesn't have to be a neighbor to you. He can come and kill anybody anywhere. That is the only difference, because it is driven by industry. For example, Ukraine war. My brother lives in Hawaii. When the islands were burnt, Biden went and offered. I mean, many houses were not there, reduced to ashes. And he offered $700. They kicked him out, saying, Ukraine war, you have spent $85 billion. And here you want to offer peanuts. Of course, because he has to buy from the private industry the weapons. Okay, anyhow, that is. The major areas in artificial intelligence is one is expert systems, especially rule-based expert systems. Earlier, they created what is called mycin. They named it because terramycin, all this. It gives, do you have cough, do you have fever, do you have emotions like that? And finally it decides, okay, you are suffering from malaria or some other disease. Of course, you can add even diagnostic results also, so that it can predict. Because one of the challenges many doctors face is sometimes many symptoms may be common between 2 or 3 diseases. So how to pinpointedly accurate? They have to depend on their memory. Put it in the as a rule-based system in expert systems. Then that would be, I think. I have put an alarm to stop. I will take another 10 minutes. I think 10 or 15 minutes. Okay. Then another is natural language processing. How to make computers understand human languages. Then pattern recognition. Pattern recognition is everywhere there is. Okay. I can recognize that is a glass, or this is a mic, because I have somehow embedded the patterns in my mind. Not only that, even in grammar, we use patterns. You know, in natural languages, the challenge of the grammarians is how to find the underlying rules of the grammar correct sentences. We know that grammarians did not come first. That is the case with artificial languages. But natural languages, they evolve. Finally, some Panini kind of grammarian comes out and see what are the underlying grammatical structures, syntax and semantics and pragmatics like that. Then, of course, machine learning. The reason machine learning is very important, the human kids they learn everything by imitating the others. Others are walking on 2 legs, so it keeps on attempting to walk on 2 legs. Maybe 2-3 times it fails, but after that it succeeds. So imitation, that's why they say imitation is the best form of compliment, not compliment. Praises, I have forgotten the exact word. Okay. So imitation, that means how to learn by, if we can build machines which can learn by themselves and combined with natural language, I think we have developed the systems. Because creativity is one of the big things. So how do we make the system creative? Not all human beings are creative. Okay, only some are creative. And artists are creative in one aspect, but not in every walk of life. Okay. So expert system, mycin I have covered. Natural language, morphology, syntax, semantics. Semantics is the meaning of it. And pragmatics. This is the most difficult thing. What is pragmatics? That is intentions of the sentence. For example, oh, you are a great thinker. By the tone we see it is whether sarcastic or he means it. This is pragmatics. For example, I come to your house and say, since morning I did not eat a morsel of rice. The meaning is he did not eat. Pragmatics intentions is, please offer me some food. Okay. So how to make computers to have pragmatics, that is even more difficult. Okay, there were lots of jokes on in the beginning, you know. See, Russian, in the Cold War period, Russians and Americans, they want to translate, understand each other. So, an English word, if it is translated to Russian back into English, if you get the same meaning, okay, machine translation is successful. So, there is a biblical statement, you know, the spirit is willing, but the flesh is weak. It got translated, vodka is strong, but meat is rotten. Okay. Then out of sight, out of mind. Stupid idiot. Okay, I mean, what is the blind idiot? Out of sight, you know, blind. So like that, there were many jokes, but now NLP has come a long way. Actually, translation, even on the mobile, with the Google, this one, no, you will have a small square. So you take a picture of anything and English, and you want to listen in Bengali, it reads out in Bengali. That means it has many technologies embedded. Or you take your Alexa, that is Amazon Echo. So it recognizes voice, the speech recognition, translates and acts. So there are many technologies are involved in that. Okay. Language barrier, evolution, I jump many because I am running out of the time. One of the problems with natural language is ambiguity. That means artificial languages are not ambiguous. If I give a computer programming word, statement, it has only one and only one meaning. But in natural language, ambiguity is abundant. Okay, a lot of meanings it could be. That's why we have a lot of synonyms, homonyms, homographs like that. Okay, that's why you say, old Madras we have in Bangalore, old Madras Road. Is it the old road or Madras is old? Okay, how to resolve the issues. And the dark rose or dark red rose means dark blue rose. Is it blue dark or rose is dark? Ambiguity, of course, even in speech, okay, euthanasia. It may sound as euthanasia. Okay, this is ambiguity in sound. And I ate noodles with chopsticks. I ate noodles with chicken. That means you don't eat the chopsticks, no, you eat the chicken only. So these are some of the ambiguities in this one. Okay, pattern recognition I covered. Okay, already we have audio books in the libraries, and okay, you know, the face recognition already in the airports it has come, and the machine learning is the best thing is information sources we can use AI, and information services also rule-based expert system on the lines of MySyn we can develop. And actually I feel at least a little elated to see that my own thesis in 93 is based on AI, and another 4 or 5 students of mine also. So the other day when I was searching library science and artificial intelligence, ours were the first attempts. I think others wrote almost a decade afterwards. Now of course AI, everybody is talking about AI with ChatGPT and all that. Okay, then recent tools, Google Bard, this one, and based on large scale language models. And I advise my library science students, I think we had enough of survey research, shift from there. Okay, you do some kind of a fundamental research. That is my advice. And with that I thank you. I hope I did not exceed too much time. I think my organizer, okay, fine? Okay, fine. Of course, if you have any questions, I will be more than happy to answer.
So any question from audience?
My experience, our audience are very modest, they won't ask any questions.
Sir, please give us some light on the recent application areas of AI in library science, where we can do some kind of research. Some research area, you just we want some elaboration from your side.
Yes, yes. Actually, at least 2 of my students. One is Professor Durga Shankarath, who is now presently a professor in Vijayasagar University. He did a heuristic-based expert system to identify from the book. You know, once you scan the book, how to identify this is author's name, this is title, this is the publisher, this is the place of publication. We developed some heuristics, that is some rules of thumb, and finally generates a machine readable catalog out of it. And another student, Anthony Jose, now he is the librarian of MDI in Delhi. He came out with a cataloging system. Okay, we have a lot of rules in Anglo-American cataloging rules, and we tried to put them in an expert system model. I think that is, of course, there are many. I think you can say much of our PhD thesis are based in AI side. Okay. Any other
questions?
Sir, how the students, researcher can be benefited? How students, researcher can be benefited using AI?
No, actually, see, after all, AI is not the only research area to be used by library science, nor the other way. AI can be used in many other areas. In library science, of course, definitely much of, as I told you, a rule-based expert system if you take. Okay, you know, the cataloging. Cataloging has lots and lots of rules, though I am particularly against machine-readable catalogs. In fact, while I am teaching machine-readable catalogs, the mercury touches the ceiling for its irrational way of handling that topic. But in any case, there are many, many, many rules. If there are many rules, see, after all, human memory is very slippery. We may forget some rules. That's why if a cataloger sits and catalogs a book, and he gets one catalog card, after 6 months he may get a different catalog card. That depends on how many rules he remembers. Okay, that's why it is taxing the memory. There, I think machines, no, they don't have that kind of a problem. From the store it can pull out. The reason is, do you know how do you think? Do you know how do you think? Say, for example, you saw some half a dozen Uttal Dutt movies. All of a sudden I ask you, what are the movies you have seen? You recalled only 3, but 3 you have forgotten. While you are having food or taking bath, all of a sudden you remember 1 more movie or 2 more movies. Now tell me, what is the retrieval technique you have used to retrieve 2 more movies of Uttal Dutt? We do not know how do we think. Do you know how do you think? No, we do not know. So then how to develop some kind of a behavioral models out of, when I want to develop AI based systems, how to develop a behavioral model, cognitive models out of the system? Very difficult. So intelligence is not that easy to analyze. Okay. So, but again, if we achieve something which is acceptable, see, nothing is perfect in this world. First you have to accept that. No human being is perfect, or no item is perfect, which are created by human beings. But again, whether they are acceptable level, that's why the statisticians, no, they calculate the significance tests and all that. If errors are too significant, no, it cannot be acceptable. If they are less significant, okay, we can accept that system because we don't get 100% result in anything. So that way, fine, it is okay. Okay. Oh, I mean, they are proving me wrong by asking many questions. Good.
Thank you, sir. Sir, for last few years, I was working in a news industry, and in our industry, we faced some problem regarding the processing of news clips as books and other defined resources. They have several areas for identification of that particular resources like title, author, and physical description areas. But in context of the news articles, we only know about the author and the title, and sometimes titles are vague, ambiguous, all those things that happen. So is there any existing tools that we can use to classify or subjectify a particular news articles Actually, there are several problems like news articles sometimes deals with several kinds of subjects and all, and that is one problem. And to classify or particularly put it or label it in some way is difficult. And for the same reason, it is also difficult to find or fetch it out later on. Okay, so that's my question.
You are telling about the information retrieval problem.
Yes, sir, yes,
Okay. Even in Google, if you search something, you get on an average 2 lakhs retrieved. And except in the first 2 pages, also 1 or 2, if you get relevant, you should celebrate that day. Much of it is noise. And then some 98 pages nobody goes unless somebody is mentally insane. Okay. That means as good as they are not retrieved even. Okay. Now the biggest challenge is how, see, the problem with Google and other search engines, they use word indexing, and with Boolean operators they combine. Okay. We know that in information retrieval theory, there is a huge difference between blind Venetian and a Venetian blind. Words are there. With Boolean operators, you say blind Venetian, okay, it will be, or college junior and junior college, meaning is changed. That's why that means not only the words, the order of the words also makes a huge difference. Okay. So now the question is, how do we get text summarization? Okay, for example, one of the myths for some time, the library science people in UK and syllabus and all that, preparing abstracts in any subject. Hey, this is nonsense, because even in my own library science, some areas I don't understand. If you give me on scientometrics, I run away from any mathematical symbols. Okay, so how do I extract meaning of it? Okay, I cannot. Subject experts only can do that. Subject experts of that particular narrow area only can do that. So that is important.
Okay, so we should provide manual inputs.
So that means we have to wait for text summarization techniques. How do we summarize the text? That is one of the challenges of AI. You are right. Okay. Probably soon we may find a solution. Right now, it is full of noise.
Thank you so much.
Thank you.
Is there any more question? Sir, since there is no question, we are thankful to you for your nice lecture. Sir,
yeah,
thank you.
So, lastly, I would like to thank this college for inviting me to be here and share my ideas with you. And I also thank Dr. Ravi Dev for inviting me and providing me a wonderful hospitality. And of course, I enjoyed the ambience inside the campus, though once you step out, you get the taste of Calcutta, but inside I think it's a mini Calcutta elevated above the mundane problems of traffic. Okay, thank you very much, and I thank you for your patience. Okay.
Now, now it is the time for a valedictory session. For this, I will request our IQAC faculty, Professor R.K.M.V.C.COLLEGE sir, to come on the dais and summarize two days long workshop. Sir, please.
For 2 days, yesterday and today, a national level seminar on library book review by prominent authors organized by IQAC Library was held. The seminar saw a total 13 lectures, 6 lectures yesterday and 7 lectures today. Yesterday, the seminar began with the inaugural speech from our revered Principal Maharaj, Swami Kamalastha Nandaji. He spoke about the function of the library, and also discuss about the different types of the library, academic library, public library, special library, etc. Next, we had 3 lectures in the pre-lunch session, and all from chemistry. The first talk was given by Dr. Rama Prasad Sarkar from New Alipur College. He talked on general and inorganic chemistry. He discussed the background, the history behind writing the book, the challenges he faced during publishing the book, and also the content of the book. He delivered his speech in a very poetic way. Next, we heard from Professor Guru Prasanna Mukhopadhyay, ex-professor of Calcutta University. He also happens to be the ex-professor of this college. He talked on his book, that is Elements of Bioinorganic Chemistry. He discussed many bioinorganic molecules, including metal ions, which are essential for life, essential for normal body functioning. He discussed on some metal ions which are useful to our body. Say calcium, like calcium, essential for bone formation, iron for hemoglobin formation, zinc for catalytic activity of some enzymes as prosthetic group, etc. He also discussed the disease-forming metals, like heavy metals, including mercury, lead, arsenic, cadmium, etc. He mentioned that the ferrous form of iron is more acceptable to the body, and for absorption, iron must be in ferrous form. Next, we heard from Dr. Chandrakanto Bandyopadhyay from this college. He talked on an insight into green chemistry. Today, we often spoke about the environmental pollution. So in the present day's context, this book on green chemistry is very, very relevant. He explained what is green chemistry. He spoke of the design of the chemical products and their processing so as to minimize, so as to eliminate the production of generation of toxic products or hazardous products. He also mentioned other books on green chemistry. In the post-lunch session, we heard 2 lectures from physics and 1 from library science. First lecture was given by Professor Dev Narayan Jana from Calcutta University. He talked on his book, Dimensional Analysis, and he also spoke on nanomaterials. As I missed this lecture, I cannot add anything more. Now, second lecture was given by Dr. Tilak Sinha from Narasingha Datta College. He talked on his book, Introduction to Quantum Mechanics. He elaborated the entire spectrum of quantum mechanics. In his book, he made distinction of quantum mechanics from classical mechanics. He mentioned about Copenhagen interpretation, which explains that a quantum particle does not exist in one state or another, but rather in all possible states at the same time. He also mentioned about Lorentz transformation and its derivation from Einstein's theory of relativity. He spoke about the superposition principles, which can be viewed as, which can be looked upon as extension of laws of probability. Next, the last lecture yesterday we heard from Professor Parthasarathi Mukhopadhyay from University of Kollani. He talked on open access curricula published by UNESCO. He said we are the consumers and contributors of information. He discussed about the curricular design, philosophy of open access, evolution of journal collection, role of library in open access dominant world, information overload, as well as profit analysis of publishing establishment like Elsevier, etc. He told us about how to retrieve the data from Google by writing the title in the box. A small change in the title can give you from specific to more specific data. He spoke of two types of open access. One is self-archiving and another is open access journal. He cautioned us about the predatory journals which ask for money. He advised us to opt for open access journals which are listed in DOAZ, D-O-A-Z. Now today we had a total of 7 lectures. In the pre-lunch session we had 4 lectures, 2 from mathematics and other 2 from botany. The first lecture was given by Professor Bhava Kumar Sharma from IIT Guwahati. He spoke on foundation course in mathematics. He said that the character of mathematics in the UG course, in the college course, is quite different from the school level. The demand of the mathematics at the college level is different from the school level. So there is a huge gap, and he spoke of bridging that gap to address that gap. And for this, he suggested the introduction of 2 weeks online fundamental course, which will help to reduce the gap and will make the students eligible for learning in UG level for mathematics. Next, we heard from Professor Kumaresan from Geetam University. He spoke about the writing and publishing a book. He said his basic concept, he said that basic concept and examples, he spoke about the basic concept and examples that will help the reader. He spoke on his book that is Matrix Spaces, which is a special, very important from analytical point of view. He also spoke about the primitive concept and secondary concept of matrix spaces. Next, we had 2 botany lectures. We first heard from Professor Timir Baron Jha from Maulana Azad College. He wrote a book that is Plant Tissue Culture, Basic and Applied. He said that teachers give education which leads to development. He mentioned about the acronym of book, that is Bio-Optical Optimum Knowledge. And he suggests for physical reading of book than mobile reading. He also made a quote of Professor APJ Abdul Kalam, who said that the best brain comes from the last bench of the class, because our actual best brain goes abroad for better establishment. And as the foreign books are very costly, and this instigated him to writing a book. He also mentioned about the totipotents, where a single cell can form a fully formed plant. And this property leads to the development of the concept of tissue culture. Next, we heard from Krishnendu Acharya from University of Calcutta. He talked on philosophy, writing, and character of thought. He mentioned that a list of his 10 books that he wrote. He also said that Hooker, the scientist, while staying in Darjeeling, he discovered 119 macrofungi from that region. But after that, only 9 were discovered. But when Professor Acharya went to Darjeeling Government College, he gave emphasis on this area. And at present, he has a collection of about 5,000 macrofungi in his collection at Calcutta University, and he has developed a fungarium. He also spoke about the mushroom medicines in treating our disease. And he said that with mushroom, one can opt for tissue culture, for spawn production, and with which one can earn a lot of money. He has influenced many persons, poor persons, in mushroom cultivation, extraction of products like pasta, noodles, mushroom tea, mushroom achar, etc. He also developed many instruments for extracting products from mushrooms. In the post-lunch session, we had 3 lectures. The first lecture, we heard from Dr. Somnath Mukhopadhyay, Principal, Dinabandhu Andrews College. He spoke on his book, that is Advanced Laboratory Manual of the Book, published with other 2 authors, published in the year 2003, and which went through 8 reprints. He mentioned about the inspiration behind writing the book. He said that most authors actually write the theory books, but practical books are rare. So the students cannot learn properly. They become mechanical while they go for practical work. He mentioned about the Neoceratodus, the Australian species, and which is so rare that the Australian students cannot dissect it out. So he opted for other specimens which are available in the market. He also discussed the different features of the book. He said that he provided the theoretical aspect of the topic, the experiment, then the etymology, that is scientific terms, and then the procedure. Next, we heard from Dr. Poulomi Maiti from Lady Webburn College. Her topic was on biodiversity, perception, peril, and preservation. She mentioned that ecosystem is like a chain linking the different components together. She discussed about the importance of biodiversity, the levels of the biodiversity, the conservation, its conservation, and also its laws and other things. The last lecture was given by Dr. A.R.D. Prasad from ISI. He spoke on artificial intelligence and overview. He defined what is robot. It's a machine, complex machine system having the power of vision, power of locomotion, power of language communication, as well as brain. So you can make him to do any type of work. He says it's a new slave, the product of new technology. He discussed about introduction to AI, AI in library science, AI in LIS research. He also mentioned about machine outform, 3 laws of robotics, history of AI from 1956, and other major areas in AI. That's all about my summarization.
Thank you, sir, for your summarization of 2 days long workshop. So now we are in end of this 2 days long workshop. So for that, I request our Vice Principal and Controller of Examination, Bodhisattva Maharaj, to come on dais and give vote of thanks. Maharaj, please come.
Respected speakers, respected teachers, and respected organizers of this national seminar, and dear students, just you have heard how beautifully Dr. P.K. Medda sir has summarized the entire 2 days seminar and workshop, and he has summarized all the highlights of the talk which has been going for 2 days. Finally, at the end of this 2 days national workshop to commemorate the National Librarians Day, which is on the library book review by prominent writers. So I would like to extend my heartfelt gratitude on behalf of the entire college, the Ramakrishna Mission Vivekananda Centenary College, to all the distinguished speakers who have spent their valuable time with us, sharing their views and about the books and the ideas with us. So we are really grateful to all of you for giving us time amidst your very busy schedule and enlightening our audience over here. I would like to extend my gratitude to the organizers of this national seminar, national workshop, especially Dr. Ravi Kumar De sir and Sudipta Biswas sir, and all the teachers who have helped in organizing this seminar. So they have been a great pillars for organizing this 2 days long seminar and for inviting all our distinguished guests and facilitating the seminar in all ways. I would extend my gratitude to all the staff members who have been helping in organizing this seminar for 2 days. And one of the most important thing is of this seminar is this is an interdepartmental seminar covering topics from a huge range of variations, and it has been really enriching for the entire college, for all the students coming from different departments, and many distinguished guests have come over here, and it has been really enriching, and we hope that in future also we will try to organize such seminars and workshops, and I would request all our distinguished resource person to kindly come again for enlightening us. And finally, I would like to thank our students and who have been participating in this seminar. And last but not the least, so this type of knowledge culture will definitely make us very enriched. So we always say that in the class we go for eating, and in the library we go for digesting. So for assimilation and digestion we go to the library, because that is the place where the self-study and assimilation of the topics takes place. So in the class we often the students eat and we try to feed them as much as possible, and in the library they go and try to digest it, spending their time on self-study. And that is where many great resource persons have helped us to invite the students more towards the library, more towards self-study, more towards going through different types of literature and very beautiful books on different topics. So this seminar is a great invitation for more knowledge culture, not only for the students but also for research scholars and teachers also. So as Sri Ramakrishna used to say that as long as I live, so long do I keep learning. So this learning nature is the sign of life, and let us all keep learning. Thank you very much. On behalf of Ramakrishna Mission Vivekananda Centenary College, on behalf of the library of our college, and on behalf of all the organizers, I extend my heartfelt gratitude to all of you for coming, participating and enlightening us in this workshop. Thank you very much. Namaskar.
With the end of day 2, I declare the seminar is ended here. The students, তোমরা পেছনের দরজা দিয়ে লাইন দিয়ে বেরোবে, তোমাদের জন্য স্ন্যাক্সের ব্যবস্থা আছে। ধীরে ধীরে কোনো হুটোপাটা করবে না, একদম থার্ড গেটটা দিয়ে আস্তে আস্তে বেরোবে পেছনে, ঠিক আছে?